Before you dive deep into the course, I just want to give you a few tips in case things go wrong while you make your way through everything. If you experience a code error, then the first thing you should do is check what the error is. It might just be a silly error where you type out a variable name or forgot a line. If you get hung up for more than a few minutes, then double check your code against mine. You will be provided the entire source code for the project in a later section. If that still doesn't work for you, then you have a few options. You should crack open Google and attempt to resolve the problem on your own. I would do that first simply because knowing how to Google for errors is a valuable skill and practice makes perfect. Another option would be to post about it in the course's forums and await help by either myself or other students taking the course. Please try to remain positive and report the issue with as much detail as you can. You can go to gist.github.com to post error logs or code snippets, but please don't just dump a ton of unformatted code with a "grr, it didn't work" description in the forums. There's also a chance that some errors may simply be bugs in the course's material. I did my best to get the course beta tested and went through it myself many times, but that doesn't guarantee it's going to be perfect. If you come across an issue with one of the videos, any of the source code or notes, then please report it in the related lecture with as much detail as possible. Definitely include the exact point of time when the issue happens in the video. I'm going to wrap this lecture up on a positive note and say that this course is a living and breathing thing. I will be going back to fix issues, clarifying anything that people are struggling with, and if it makes sense, even add new lectures. Good luck with the course, and I'll see you in the forums. In this section, we're going to go over what Flask is. Then, I'll go over a few types of websites that you can build with Flask. After that, we'll compare Flask to other web frameworks. And lastly, we'll wrap things up by going over a few massive companies who are using Flask out in the wild. Let's begin by defining what Flask is, and for that, I'll see you in the next lecture. In this lecture, you're going to learn what Flask is. The author of Flask describes it as a micro-framework for Python based on Werkzeug, Jinja 2, and good intentions. That's a very good definition of Flask, but it's also filled with a number of terms that you might not be familiar with. Werkzeug is a utility library for WSGI, and WSGI stands for Web Server Gateway Interface. It is a universal interface between web servers and web applications, and it's also a PEP standard. This is a really deep topic that we don't need to go into, but just understand that if we're talking about levels of abstraction, then you can think of WSGI as the lowest level, and then on top of that there's Werkzeug, and then finally on top of that we have Flask. Next up, there's Jinja 2, and this is an HTML templating language for Python. So we could say Flask is composed of a few popular libraries, and it introduces a few opinions of its own to provide a pleasant web application developing experience. That's pretty much the definition of what a web framework is. In the case of Flask, it's quite small, but it also has a rich extension system that allows you to integrate your own functionality into it. There's hundreds of awesome community-driven extensions that are well-maintained and rock solid. We'll be using quite a number of them in this course. Oftentimes, people get concerned because Flask isn't releasing new versions all the time. But it was designed to be minimal and extended. The Flask ecosystem is strong and active. So now that you know what Flask is, let's go over what type of web applications you can build with it. I'll see you in the next lecture where we do just that. In this lecture, you'll learn what type of websites you can build with Flask. But before we get into that, we need to talk about how websites differ. We'll do this by talking about real-world website ideas. For example, let's say that you wanted to throw up a landing page for a new startup. It would be composed of a home page with an email sign-up form and a couple of other pages to talk about your product. There's nothing fancy going on here at all. In fact, if you leveraged a third-party email newsletter service, you wouldn't even need to use a web framework to create a page like this. But for argument's sake, let's say that you have plans to expand on this site in the future, so you decide to use a web framework for it. Flask is a great fit here because you'll be able to leverage the power of Jinja 2 for your HTML templates, and Flask makes it easy to deal with form submissions. You could get something like this going in Flask with a single file that's about 75 lines long. That's not bad at all. You could whip something like this up in a few minutes and then concentrate your efforts on making the HTML templates look pretty. Now, let's say that you want to create a more complex website. Perhaps it handles user registrations and allows you to serve protected files to users who sign up. Well, Flask is a great fit here too. Python has one of the best database ORM libraries around, and there are Flask extensions to hook it up with Flask in a painless way. Oh, and if you don't know what a database ORM is, don't worry. We'll get into that later on in this course. Now, let's say that your application has different needs, and you want to create an API backend with a single-page web application frontend that uses whatever JavaScript framework that you want. Well, Flask is a perfect fit for that as well. There's a bunch of great API libraries to choose from. There's really no limit to what you can do with Flask. It has all the pieces you need to write complex and scalable web applications. The best part about it is, it tries to stay out of your way and give you as much control as possible while still offering a few sane opinions. You might be thinking, well, how does Flask compare to other web frameworks like Django or Ruby on Rails? That's a good question, and I'll see you in the next lecture where we go over that. I'll see you then. In this lecture, you're not going to learn how Flask compares to other web frameworks such as Django or Ruby on Rails. There's a million blog posts on that subject, so feel free to research them on your own if you're seeking that answer. Actually, on second thought, I'll give you a simple one-liner. Flask is less opinionated than Django and Rails, and there's less batteries included. I'll be honest with you, I use both Flask and Ruby on Rails. Sometimes I come across project ideas that simply work better in Rails because there are better supporting libraries in Ruby than there are in Python. Other times, I just feel like writing Python instead of Ruby because it makes me happy. Every once in a while, I'll get hired for a contracting gig, and it just so happens that another developer on the project knows Python, so I'll recommend using Flask. I wanted to include this lecture because as a teacher, one of my personal goals is to inspire you. I hope that doesn't sound too pretentious, but I have a strong urge to pass down knowledge I've gained to others. I'm going to attempt to answer the most elusive question in the history of web development, and that is, what's the best web framework? The answer to that is very simple. It's the best tool for the job, and that answer is going to be different for everyone because your personal skill set and the situation at hand is going to play a role in the answer. Your goal should be to write the most maintainable code in the shortest amount of time using the best tools that you know how to use. Most importantly, your happiness level needs to be high. The absolute worst thing you can do is not take any action, and instead, just spend all of your time comparing web frameworks. If you do that, you'll gain no experience and accomplish nothing. Chances are, you want to learn more about web development to accomplish a goal. This could be to create the startup of your dreams, get into consulting, or get hired at the most badass tech company around. None of that is going to happen if all you do is read Hacker News and get overloaded by the next best thing. Just about everything you read about Rails not scaling or Flask being terrible for large applications is false. Rails does scale, Flask is awesome, and so are a lot of other web frameworks. This course is going to be about Flask, so if you're still interested, then join me in the next lecture where I talk about a few massive companies who use Flask to serve a mind-boggling amount of traffic. I'll see you then. In this lecture, we'll go over a few large companies that are actively using Flask. The first company that we'll talk about is Pinterest. At the time of recording this video, Pinterest has been using Flask to serve their API for the last 5 years. An API engineer at Pinterest once publicly mentioned that Flask scales very well under load. Flask has helped them write dozens of well-tested API endpoints, and they are also deploying new versions of their API multiple times a day. As of January 2015, their API is responsible for serving 12 billion requests per day. The next company that we'll talk about is Twilio. Back in May 2015, they raised $100 million in funding, and at the time were valued to be $1 billion company. They depend on Flask for their public and private APIs. They're also responsible for releasing the Flask RESTful package, which is a Flask extension to help create RESTful APIs. The last company I'll talk about is LinkedIn. They are a huge advocate of using Flask for their internal tools. Back in 2014, they gave a talk about their experience with Flask at PyCon. There's a lot more companies using Flask out in the wild, but I just wanted to highlight a few well-known sites that I know of who are using Flask based on what's publicly available on the internet. At this point, you know what Flask is, what types of sites you can build, and who's using Flask out in the wild. That wraps up this section, and I'll see you in the next one where we go over the demo application that we're going to build. I'll see you there. In this section, we're going to get a high-level overview of the application that we're going to build up in this course. First, I'll go over the end result, which will show what the app does. Then we'll visualize the architecture of the application by looking at a few diagrams. I'll see you in the first lecture, where we go over the end result. In this lecture, we're going to do a 10,000-foot overview of the demo application. By the end of this lecture, you'll know exactly what type of app we're going to be building up in stages throughout the course. The app we're building is called Snake Eyes, and it's a dice rolling game where users try to guess the outcome of a dice roll. Users will be able to purchase virtual currency called coins with real money through Stripe. Then users will be able to wager coins on the outcome of the dice roll, and if they win, then they're going to receive a payout of coins. Since we're going to be dealing with users, we'll build up an entire user system. This will include signing in, registering, resetting passwords, and more. The solution we'll build will be very flexible so that you can quickly modify it to fit the needs of any project. We'll also build out a user settings area where users can interact with various aspects of their account, such as updating their login credentials or picking usernames. Users of the platform will be able to subscribe by paying a few dollars per month, and that's going to give them access to coins every month in addition to being visible on the leaderboard. After picking a plan, users simply add in their billing information. In this case, we have a custom Stripe form which even handles coupon code detection in real time. For example, I'll sign up now with a coupon code of Demo25. Then I'll supply in some fake credit card details and process the payment. After subscribing, users will be able to make various changes to their subscription, such as updating their payment information. Subscribers will be able to change their credit card details without interrupting their subscription. They'll also be able to change their subscription plan. Upgrading or downgrading plans can be done with a click of a mouse, because the payment processing system is smart enough to use their existing billing details. If a user is unhappy with their subscription, they can always cancel it on the spot. In this case, the user has one last chance to back out of canceling their subscription. The workflow both protects the user from accidental cancellation and also gives them a chance to back out of doing it, which in turn will increase your revenue. No payment system would be complete without billing details, so we'll deal with that too. Users will be able to see upcoming subscription payments as well as a full billing history. The billing history includes both subscription payments as well as one-off microtransactions. But before going into microtransactions, let's look at the Snake Eyes game itself. This is where users will be able to play the game. You guess the outcome of the roll, then wager an amount, and place a bet. In this case, I guessed a 7, but the outcome was a 10, in which case I lost. This page fires off AJAX requests to the Flask backend, and then updates various aspects of the page based on whether or not you won or lost. Everything is validated on the server side, so you'll get familiar with working with JSON responses, which will give you some knowledge on building APIs. There's even rate limiting in place here to protect your server from being flooded. Over here on the right, the recent bet history lets users know how they're doing, but they can also see a lifetime betting history too. Users will be able to see a full breakdown of each bet they make. In addition to gaining coins through subscriptions, users will be able to purchase coins as a microtransaction. They can pick how many coins they want to buy and get credited upon payment. The coin bundles are set up in such a way that you can add or remove them with a single config setting. In case visitors have questions, we'll also set up a contact form. Parts of the user system also send emails too, such as password reset links. No software as a service application is complete without an admin dashboard, so we'll build up a custom admin that suits our exact needs. You'll also learn how to modify it to fit the needs of any application that you build. You'll be able to sort and search through users, and even bulk delete them too. You'll also be able to edit various details about each user. This ranges from things like disabling their account, promoting or demoting them, as well as canceling their subscription. You can even glance at their recent login activity to help detect if people are sharing accounts. In addition to that, you'll be able to view invoice information about a specific user, or you can view invoices for everyone. We'll also go over building a robust coupon system that will allow you to create very flexible coupons. You'll be able to create % off or fixed amount off coupons, pick a custom code if you want to, and even set them up to expire based on quantity or time. If that's not enough, you can also set their duration to only be active for something like the first 3 months of a subscription. So that goes over the app we'll be building. We'll go over building up the application in over a dozen stages so you'll be able to see it start from a single app.py file all the way to dozens of well-organized files and folders. With that said, I'll see you in the next lecture where we visualize the application's architecture and talk about the technology choices. I'll see you then. In this lecture, we're going to go over the application's architecture. Links to everything we're going to talk about is included in this lecture's notes. It begins with gUnicorn. In a previous lecture, we went over what WSGI was, and gUnicorn is an implementation of a WSGI server. It's what we're going to be using in this course. An alternative to it would be uWSGI, but I prefer gUnicorn over uWSGI, mainly because it's extremely easy to set up and it's very fast. Fortunately, since WSGI is a standard, you can switch between them with basically one line of code. You might be wondering, why did I choose gUnicorn over uWSGI? And that's a valid question. Years ago when I was getting into Flask, I remember reading a blog post by Instagram which mentioned they were using gUnicorn. Their reasoning was that it was extremely simple to configure and it met their demands in the performance department. I'll admit, I never worked on a site that was as large as Instagram, but if gUnicorn runs well enough for them, then chances are it's going to run well enough for any site that you or I put together. My thought process on sticking with gUnicorn nowadays is that I haven't ran into any issues with it over the years, and it has enough configuration options to tune anything you'd ever want within reason. Long story short, it's a proven library and has a lot of community support. Next up, we have Flask. Since this is a course on Flask, it's safe to say that the web framework we're going to use is Flask. We went over what Flask is in a previous section, so I recommend reviewing that if you're unsure what Flask is. Next on the list is Celery. Celery is a task queue, or often referred to as a background worker. It runs in its own process, separate from gUnicorn. It is the de facto standard background worker for Python. The best way to explain what a background worker is through a real-life scenario. Imagine a situation where you want to generate a report, and it takes 20 seconds for this report to be generated. Without a background worker, you would end up doing this work inside the gUnicorn process when someone accesses the page that generates the report. This is really bad because the poor user will need to wait 20 seconds to get a response. During those 20 seconds, they're going to see a blank white page with a busy mouse cursor because Flask can't respond back to anything yet. It gets way worse too, because gUnicorn won't be able to process any other request until this one finishes. Now, if you have gUnicorn configured to use multiple threads and workers, it can process additional requests, but it's still a really terrible situation. A general rule of thumb is, if you can't respond to a request nearly instantly, then you should execute the task in a background worker. This way your Flask app is free to respond instantly, and you can always update the user later when the task completes. A textbook example of when to use a background worker would be to send out an email. Chances are your email server is on a third-party host, perhaps Gmail or a different service. You can't control the outcome of how long it will take for Gmail to get back to you. It might take an entire second, 5 seconds, or maybe time out. In any case, that's way too long to keep a user waiting, especially if it times out. Basically, anytime you communicate with a third-party service, you should be doing it in a background task. Not only is Celery awesome for this, but it's really great at performing scheduled jobs too. For instance, if you wanted something to happen every day at midnight, then you can tell Celery to run that code on a schedule of your choosing. This is much better than doing it with a cron job because Celery can be decoupled from your web application servers. Imagine for a moment that you had 10 copies of your Flask application running on 10 different servers. If you had a cron job running on all 10 servers, then that task would get executed 10 times. That's probably not what you want to do in most cases. You could just run one copy of Celery's scheduler, and it would only execute once, which is likely the behavior you want. Celery keeps track of everything in a backend data store of your choosing. This is great because it keeps the state out of your Flask application. If your Flask app crashes or needs to restart, then things will still be saved. In our case, we're going to be using Redis as a backend for Celery, and that leads us to the next piece of architecture in our application. Redis is an in-memory data store, and it runs in its own separate process. It has nothing to do with Python, but there's great Python packages to integrate Redis and Flask. You can think of Redis as a Swiss Army knife. You can use it to cache data, act as a message broker, or be a backend for your pub subsystem in case you wanted to use WebSockets in your application. In our case, Celery is going to use it as a message broker, but a single Redis instance can be used for many different tasks. Redis is lightning fast and super efficient. It even occasionally persists data to disk, so you can recover from errors. You wouldn't use Redis as an alternative to a relational database like Postgres or MySQL, but Redis has its place in nearly any production-grade application. Speaking of standard databases, the next piece of the puzzle is Postgres. We're using this as our primary relational database. Any data that we want to save and query later will be saved to Postgres. Postgres is considered one of the best, if not the best, relational databases around when you account for things like performance and features. It also runs in its own process too. SQL Alchemy is a Python ORM, and that stands for Object Relational Mapper. Basically, that means you'll be able to write Python code instead of raw SQL statements to communicate with Postgres. This course will go over modeling and querying data with SQL Alchemy, but it's not going to go into great depth on what SQL is and how relational databases work. However, I did link to some free information in this lecture's notes to learn more about this topic if you're interested. Doing additional research won't be essential to complete this course, but if you're serious about web development, then you should be familiar with how relational databases work. The next piece of this application's architecture is Click. Click is a Python library to create command line interface applications, or CLIs for short. It's not specific to Flask, but Flask integrates with Click nicely. We'll go into more detail on what Click is later, but for now, just understand that we'll have a bunch of CLI commands that we're going to run to perform various tasks like resetting the database, generating fake data to populate the application in development mode, and much, much more. Next up, we have Stripe. We'll go into Stripe in great detail throughout this course, but for now you just need to know that it's going to be our payment gateway. Whenever we charge someone's credit card, we're going to use Stripe's API to deal with that. This is a third-party service, and it's pretty much free to use. I say pretty much because while they don't charge you anything per month, they will take about 3% of each transaction, and I think that's a fair trade given the amount of complexity they deal with on your behalf. Lastly, we have Docker. Docker isn't related directly to Python or Flask, but it's how we're going to run everything in development mode. And if you decide to push your application to production, you could use Docker there too. In this course, you'll get a basic understanding of Docker before we even get into the Flask code, but I promise you, it won't take too long. Docker is going to allow you to run things like Postgres, Redis, the Flask application, Celery, and more without even needing to install them directly on your workstation. With that said, that takes care of the application's architecture. I'll see you in the next section, where we'll go over setting up a code editor and downloading all the material for the course. I'll see you there. In this section, we're going to perform a few things on our workstation so that you can follow along with the rest of the course. The first thing we'll do is create a course folder for this course's material. Then we'll download the source code for the project that we're going to build along with this course's notes. And lastly, we'll go over installing a code editor. I'll see you in the first lecture of this section where we create the course's folder. See you then. In this lecture, we're going to create a folder on our workstation, and this folder will be responsible for storing all the files that you'll need for this course. Feel free to create this folder anywhere you want. I'm going to make mine inside of a courses folder that's inside of my user's home directory. So go ahead and create a new folder, and I recommend naming it BSAWF. And that's an abbreviation for Build a SaaS App with Flask, and that's mainly because it's much easier to type. With that out of the way, let's continue onwards to the next lecture, where we go over downloading the course's material. I'll see you then. In this lecture, I'll point you to a few resources for installing and configuring a code editor. This course doesn't require you to install a specific code editor, but it will be expected that you're capable of opening and editing the source code that we just downloaded. If you don't have a code editor already, then please pause the video now and check out the notes for this lecture because it contains a list of a few free popular code editors that you can install on your own. Feel free to use whatever editor you want, even if it's not on the list. I'm going to be using Sublime Text 3 throughout this course. It's an awesome general-purpose code editor that works on all major platforms. The notes contain a link to this blog post which shows you every package I'm using and how you can configure Sublime to be like mine. At this point, you're good to go, and that wraps up this section. I'll see you in the next section where we will get familiar with Docker. See you there. In this lecture, you're going to download all of the course's material. It's a single zip file that will include both the source code and all of the notes. As this course progresses, you're going to be able to see how the application gets built up over time. That means there's going to be multiple copies of the source code, and as each new section is introduced, there's going to be more code to look at. Rather than make you download each section's code individually, I've zipped all of the sections together and separated them by folders. Depending on where you're viewing this course, the directions for finding and downloading supplemental resources will vary. In most cases, I'm sure you'll be able to figure it out on your own because the course hosting platform that you're using will make it apparent to you. If you're stuck and can't find it, then I recommend opening Google and performing a search. For example, if you're watching this on Udemy, you would do a search for Udemy Download Supplemental Resources, and you'll quickly find Udemy's support page showing you how to do it. If you still can't figure it out, then post a discussion in the courses forums or message me directly and I'll be happy to help you. So please pause the video now and take a moment to download the zip file associated to this lecture. Once it's been downloaded, head over to your courses folder and extract the zip file into that folder. You can do that by opening up the zip file and then selecting all the files and just dragging it over to your courses folder. You should now have a bunch of folders inside of your courses folder, along with a PDF, EPUB, and MOBI file in the root of your courses folder. The PDF, EPUB, and MOBI files all have the same content, and it's a reference book that contains all the commands we're going to run in this course, as well as links to a bunch of resources that we'll cover later on. With that said, I'll see you in the next lecture where we go over installing a code editor. I'll see you then. In this section, we're going to go over what Docker is and how to install it. This is the last thing that we need to do before getting into the Flask code. First, you'll learn what Docker is and why it's worth using. Then you'll get instructions on how to install Docker. And finally, we'll run a couple of commands to make sure that it works. Let's begin by going over what Docker is. I'll see you then. In this lecture, you'll get an understanding of why you should be using Docker and also get a feel for what Docker is. But before we go into that, I just want to say that I want us to get into the Flask application as soon as possible. However, to run even the most simple Flask application, your system needs to be capable of running Python applications. This might sound simple enough at a glance, but it's more complicated than you might think. This course is going to be very video lecture heavy, but this is one of the few times where written content will get you through it faster than listening to me narrate it with slides. I've written a blog post that I would like you to read if you're unsure of what Docker is and why it's beneficial to use. It's not absolutely essential that you read it, but if you're serious about becoming a web developer, I promise you it's going to save you a lot of time in the long run. With that said, the blog post is linked in this lecture's notes, and I'll see you in the next lecture where we go over installing Docker. See you then. In this lecture, we're going to go over installing Docker. At this point, you should have an understanding of why Docker is beneficial to use, and also have a basic idea of what Docker is. If not, please review the blog post in the previous lecture's notes. The Docker team has done a great job at showing how to install Docker on all major platforms. In this lecture's notes, I've included links to download Docker for each major platform, and I've also included installation video links that you can watch. It's only going to take you about 5 minutes to get up and running. Also, it's extremely important that you read my video-related notes. And once you have everything installed, I recommend spending the extra minute or two to follow along with the installation video's Hello World examples. With that said, go ahead and check out the notes, and then I'll see you in the last lecture of this section where we confirm that everything works. See you then. In this lecture, we're going to run a few commands together just to make sure that everyone has Docker and Docker Compose set up correctly. The first thing that you'll want to do is open up your terminal. If you've installed Docker with the Docker toolbox, then open up the Docker Quick Start terminal. If you're on Linux like me, then just open up your regular terminal. This is the last time I'm going to mention using that special terminal, so whenever you hear me say open up a terminal, just know that I mean to open up the Docker Quick Start terminal if you're using that. Once here, we can verify that we're running Docker 1.11 by typing docker -- version. Then hit enter. You should see Docker 1.11.1 or something slightly newer. If you went ahead and installed a much newer version of Docker, then I can't guarantee that all the Docker commands we run in this course will work. Now, there's a very good chance that they will work, but to be safe, I recommend going back to the installation lecture's notes and follow my instructions exactly, just to ensure that Docker 1.11 has been installed. You can always go back and upgrade later once you've completed the course. Now let's go ahead and confirm that we have Docker Compose 1.7. We can do that by typing docker -compose --version, and then hit enter. You should see 1.70 or something slightly newer. These are the only two Docker-related tools that we're going to be working with in this course. At this point, our development environment is set up and we're ready to learn about Flask. I'll see you in the next section where we create a base Flask app. See you there. In this section, we're going to get a taste of Flask by setting up a base application for the project that we're going to build up in this course. We'll begin by going over a few dependencies of the base application. Then we'll explore the Flask application file. After that, we'll run the application and check it out in a browser. Finally, we'll end this section by going over how configuration settings work with Flask. So, I'll see you in the first lecture where we go over the app's dependencies. See you then. In this lecture, we're going to quickly go over what a dependency is and what tools Python gives us to manage them. Then we'll go over the dependencies that our base Flask app is using. First off, a dependency would be a package that your application uses. It's very common for most web applications to use many different packages that provide various functionality depending on what the app does. For example, Flask itself is a third-party dependency. It's a package that was created by someone other than yourself, and the author packaged it up in such a way that you and I can use it easily. In the case of Python, the tool that we'll use to manage these packages is called pip. Pip will allow us to easily install and list dependencies of our application. One way to install a list of packages with pip is to provide a file that's typically named requirements.txt. This file will have a new line separated list of packages that your application uses. It's normally located in the root of a project. If you happen to browse around GitHub for open source Flask projects, you'll often want to start by either looking at the project's README file or the requirements.txt file. In some cases, it might be named something slightly different, but you'll be able to spot it. So let's begin by heading over to our courses folder, and then go ahead and open up section 6's folder, which is creating a base Flask app. Once here, go ahead and open up the folder in your code editor. In my case, I'm going to launch Sublime. And if you take a look here at the sidebar, you'll see that there's no README file. And I did that on purpose because I wanted us to take a look at the requirements.txt file. And that's going to be located in the root of the project. So go ahead and open up that file. We won't be doing any typing in this lecture, so feel free to just watch if you want, but I recommend following along just to practice navigating around the project. On line 1, we can see that we're using Flask. We're also using the double equals operator and supplying an exact version number. It's usually good practice to provide a version number so that if you decide to install your application months down the line, you'll get the same exact version as you would expect. If you avoid adding the version number, then you'll end up getting the latest version at the time of installing everything, which may end up breaking your codebase due to backwards incompatibility changes introduced by the package author. Moving on, as you can see on line 3, this file allows for comments, which are started with the £. Then on line 4, we're installing a package called gunicorn. We went over what gunicorn is in a previous section, so if you missed that, check out the Visualizing the Application's Architecture lecture. At this point, we've explored all the application's dependencies. This list is going to grow by a lot as we work through the course, but for now, we're good to go. I'll see you in the next lecture where we take a peek at the main Flask application file. I'll see you then. In this lecture, we're going to take a look at the main Flask application file and go over how to set up a Hello World example. If you haven't done so already, please open up section 6's folder in your code editor. Then navigate to the Snake Eyes folder and open up app.py. If you've ever looked at the Quick Start Guide for Flask, you'll notice that this looks pretty similar, but also a bit different. There's a couple of main concepts to learn here, so let's tackle them one by one. First up, we're importing Flask, and that's a standard Python feature that allows us to import a module. Then we have a function called createApp. This could be named anything we want, but oftentimes you'll see projects label this function as createApp because it's a function that creates a Flask application. This is known as the Flask app factory pattern and is a key concept of Flask. This pattern will be very handy to use later on as our application grows in size as we unlock other Flask concepts. But for now, the main benefit is that we have everything encapsulated in a single function. Then we can simply call this function to spawn an instance of the Flask app. This allows us to decouple creating instances of our app from the actual action of running a web server. For example, in the next lecture, we're going to use gunicorn to call this function to start the Flask app. But we're also going to run tests in a future lecture which uses the same exact function without depending on gunicorn. So let's go over this function now. In case you're super new to Python, The triple quote block is a doc string, and that allows for multi-line comments. Even though Python is not a statically typed language, you can use hints in doc strings to let humans and some editors know what types are being returned. This also works for function parameters too. Then on line 10, we're just creating an instance of Flask. We're also passing in the instance relative config parameter, but for now let's ignore that because the next lecture will go into configuring Flask in detail. We'll also skip over lines 12 and 13 because they're going to be covered in a future lecture. For now, just think of it as a way to load in custom application settings. The real heart of this function starts on line 15, and this is where we take our instance of Flask and create a route that maps to /. This would allow you to access the homepage of the application by going to the website's hostname. And this is how you add URL endpoints, or commonly known as routes, with Flask. It starts by providing a Python decorator where you supply the route's endpoint as a parameter, and then directly under that, you provide a function that will get executed when someone visits that endpoint. We can name the function anything we want, but it's typically a good idea to name it something short and descriptive because you'll reference it later on when doing a reverse lookup on the route. But don't worry about that for now. We'll go into that in great detail once we start dealing with HTML templates. So if we take a look here at line 22, we're just returning hello world as a string. Flask will render this as an HTML content type for us automatically and will return a status code of 200, which in HTTP terms means success. The last line of the function just returns the instance of the Flask application. If we wanted to add another route, we could do so by placing it above or below our index route, but I won't go into doing that now. At this point, we're almost ready to run the app and check it out in a browser. We just need to take a few minutes sidetrack to go over the Docker-related files. I'll see you in the next lecture where we go over the Docker file. See you then. In this lecture, we're going to investigate the Docker file. If you haven't done so already, please head over to section 6's folder and open it up in your code editor. Then go ahead and open up the Docker file, which is in the root of the project. Since this isn't a course on Docker, I won't be going into great detail on what each line does, but I do want to cover just enough so that you're not totally lost. Docker has an official Python image that we can use, and it's based on the Alpine operating system. Alpine is an extremely small Linux distribution, and the entire OS is only 5 megabytes in size, and it even has its own package manager. As you can see here, we're using Python 2.7, but the Snake Eyes codebase is compatible with Python 3. So if you wanted to use Python 3 instead, you could go ahead and change that 2.7 to 3.5. But don't bother doing that now, because in the next section it's going to be reverted back to 2.7. Just know that switching between Python versions is as simple as changing that single value and rebuilding the Docker image. If you want to know which versions of Python are supported, you can check out the Python page on the Docker Hub. I've included a link to it in this lecture's notes. Line 4 sets up the install path, and it's typically a good idea to match this with your project's name. In our case, that's going to be Snake Eyes. That defines where the application source code will be located within the Docker image. Then lines 9 and 10 handle copying over the requirements.txt file into the Docker image, and then it runs pip install on that requirements.txt file. We do this in separate steps so that Docker can cache our packages in such a way that we won't have to reinstall them unless the requirements.txt file itself changes. Long story short, it's a big time saver. Then line 12 is going to copy in the current directory into the Docker image. This is how the application's code gets inside of Docker. Then finally, the last line is the default command that this Docker image will run when you start it. In our case, it calls gunicorn with a few custom flags. First, it sets the bind address to all zeros, which means it's going to bind to all IP addresses on your local server, and it's also going to listen on port 8000. Then, the access log file being set to a dash tells gunicorn to log everything to standard out. Basically, that means all gunicorn log files will be written back to your terminal instead of a dedicated log file. That's the standard way to log things with Docker. Lastly, it calls our create app function, which we went over in the previous lecture. I want to wrap this up by saying all these steps are happening within the context of the Alpine base OS, not your workstation. This is the beauty of Docker. You could build an image on your OS X box, and then I can download it on Xubuntu and end up with an identical version of the image on my end. Now that you know how Snake Eyes will be built with Docker, Let's run it, and for that, I'll see you in the next lecture. See you then. In this lecture, we're going to run the Snake Eyes app and check it out in a browser. If you haven't done so already, please head over to Section 6's folder. Then go ahead and open up a terminal. We're going to use Docker Compose to build and run the Docker image. We can build and run Docker images without Compose, but Compose makes it easy to run multiple Docker images at once. It also saves you from having to keep typing out the same commands because you can define everything in a single YAML file. So with that said, go ahead and type docker-compose space up space dash dash build, and that's going to go ahead and build our image and then run it. So hit enter. You can see here we're starting from the very top, and it's going through our Docker file line by line. Since we don't have the Python base image, it's going to download it for us, and it's running pip install now, and it's done. The last command in our Docker file was to start gunicorn, and we can see here on the bottom that it's been started. We can see that it's bound to 0.0.0.0, and it's listening on port 8000. At this point, we can go to our browser and check it out. So please open your browser now. If you're running Docker natively, you can just go to localhost port 8000. But if you're using the Docker toolbox, you'll need to go to your Docker machine IP address. It's probably going to be 192.168.99.100, and then go to port 8000. If that's not the IP address, you can just head back over to your Docker Quick Start terminal and scroll up to the very top. Alternatively, you can open up a new terminal tab and then go ahead and run docker-machine space IP. If you're running Docker natively, you don't need to do these steps. So at this point, everybody should be looking at the Hello World app. Also, I just want to take a second to say that throughout this course, whenever I say view the site in your browser, I'm going to go to localhost on camera, and it will be up to you to go to your Docker machine's IP address if you have to. Before we dive into the Docker Compose YAML file, I just want to show you how fast things will run the second time you run it. So please go back to your terminal now. You can kill Docker Compose by pressing Ctrl-C. Also, you might want to get used to running docker-compose space stop, because every once in a while, when you hit Ctrl-C to stop Docker Compose, it actually doesn't stop the containers. That's a bug in Docker Compose, and I imagine it's going to be fixed eventually. So now let's rerun Docker Compose up by running docker-compose space up. We don't have to supply the build flag this time because it's already built. But you'll see here that it loaded in about half a second. That's pretty awesome because you just spun up an entire Python development environment in less than a second. Okay, so now let's go ahead and open up our code editor, and I'm going to open up a new tab and just open up this folder in Sublime. Once here, just head over to the docker-compose.yaml file. Let's just tackle this file line by line. The first line sets the version of Docker Compose to 2. Docker Compose is moving very fast, and the developers are moving over to a new format, and this is just letting Docker Compose know that we want to use the new format. Then line 3 is where we would define all of our Docker images. They get wrapped up inside of a services namespace. As we progress throughout this course, there's going to be additional namespaces added to this file, so that's why our images are contained in a services namespace. Line 4 defines our image name, which in this case will be website, since that's what it is. This name will end up being namespaced by Snake Eyes because if we take a 2-second break from this file, and then we open up this .env file here, we'll see that we're setting a Compose project name to Snake Eyes. This project name will be prepended to custom Docker images that we build, as well as container names, and a few other things that we'll see in later lectures. For that to make more sense, let's hop over to our terminal. If you don't have a second tab open already, go ahead and open up a second tab. If you're using the Docker Quick Start terminal, just open up a new terminal. We can see all of our Docker images by typing docker space images, and then hit enter. We'll see here that the repository name is snakeeyes_website. Also, it's interesting to note that the size of the image is only 68 megabytes. That's amazing considering what you're getting. For comparison, if you were using something like Vagrant and VirtualBox, you would end up with a box that's around 500 megabytes in size, and it would take about a minute to turn on instead of about 100 milliseconds. Okay, so there's 2 more commands that I want to run with you now, and they're going to list back all the running containers on your system. So go ahead and type docker-compose space ps, and then hit enter. Notice how the name of this container is snakeeyes_website_1. The _1 has been added by Docker Compose because we're running one instance of the image. We can also see the state of the image, which happens to be up. In addition to that, we can see that it's bound to port 8000. The next command that we're about to run does the same thing, except we'll run it with Docker instead of Docker Compose. You can do that by typing docker space ps and then hit enter. Now, my terminal font is a little bit too big, so it looks a little messy, but on your end it should all fit nicely. The main thing I want to go over here is that we see similar information to Docker Compose PS. The Docker Compose version is nice if you're running a ton of containers on your system at once. With Compose, it will only show you the containers that belong to this project's Docker Compose YAML file. With that said, let's go back to our code editor and take a look at the rest of the Compose file. Line 5 says we're going to build this image from the current directory. It's going to look for a Docker file and build it based off that. As you can see here, we have our Docker file in the same directory as Docker Compose. Lines 6 through 9 are interesting because we're running a similar command to what was in the Docker file. We need to supply this because line 9 has a different flag. And this reload flag tells gUnicorn that we want it to automatically reload when it detects a file change. If I jump back over to the Docker file, you'll notice that there is no reload flag here. Reload is awesome in development mode because we want to be able to see our changes without having to reload the server manually. But in production, we don't want to have this enabled. So in this case, the Docker files command doesn't include the reload flag. Also, in case you're new to YAML, the greater than sign on line 6 tells YAML to treat this multi-line string as a single command. Lines 11 and 12 are how we pass in custom environment variables to the Docker container. In this case, we want to set Python unbuffered to true. If we didn't do this, then the gUnicorn log output wouldn't be sent to our terminal in real time. For example, if you go back over to your terminal, and then head back over to the other tab here, you'll see that we have no output here. But if you go back over to the website and you reload the page a couple of times, and then head back over to your terminal, you'll see the requests here from gUnicorn, and those are being logged to standard out, and in turn Docker Compose is outputting them for us. So now let's go back to our Docker Compose YAML file. Next up, we have lines 13 and 14, and this is how we set up volumes with Docker. We're telling Docker to take what's in the current directory, which is our entire Flask application, and then we're mounting it into the Snake Eyes folder inside the container. If you remember back in the Docker file, we set the install folder to /snakeeyes, which is the same exact folder we have written here. This is going to set things up so that we can edit our code base and have the changes get sent to Docker without having to rebuild the image. For example, let's go to the Snake Eyes folder up here and then open up the app.py file. Then jump down to line 22 and just add some extra exclamation points to hello world, and then save the file. Once complete, head back over to your browser and then just reload it. And you'll see here that the changes took effect. So now let's go back to our terminal, and you'll see here that the worker was reloaded because it detected that app.py was modified. That's happening because of the reload flag. So now let's go back to our code editor and finish this lecture up. Lines 15 and 16 are mapping the ports. There's two sides to the port map. The left side is the port on the host, and the right side is the port in the Docker container. If you were to change the left side to, let's say, port 7000 and restart Docker Compose, then you would be able to access the page in your browser on port 7000 instead of 8000. You could also choose to define a single port instead of both, and then Docker is going to randomly assign the port on the host. This would be useful if you wanted to run two copies of the same image, because otherwise you would get a port conflict if they were both trying to use the same port. Okay, so that's enough Docker talk for now. At this point, you know enough about it to start and stop the Flask app. I'll see you in the next lecture, where we go over configuring the Flask application. See you then. In this lecture, you'll learn how configuration settings work with Flask. If you haven't done so already, please head over to Section 6's folder and open it up in your code editor. Like usual, I'm going to be using Sublime. You'll also want to make sure that Docker Compose is running, and you can do that by typing docker-compose space up. Now let's go back to our code editor. The first file that I want to take a look at is the app.py file, which is in the Snake Eyes folder. So go ahead and open that up. Then let's head over to line 10 and we'll check out this instance relative config parameter. Through a little bit of Flask magic, this informs Flask to look for an instance module that's at the same directory depth as the main module, which would be Snake Eyes. Before we go into what the instance folder does, it makes sense to look at line 12 first. What we're doing here is loading in a config.settings module. It's going to look for this module in the config folder, and then inside of that, it's going to look for a settings.py file. You could change this path to anything that you want, but config/settings.py is a reasonable choice. Line 13 is loading in a settings.py file, which is inside of an instance folder, and the silent equals true parameter tells Flask not to crash if that file doesn't exist. This is important because you might not have this file created, but you would still want Flask to be ran successfully. If you had a value defined in both config/settings and instance/settings, then the instance settings file will be used, and that's because they're loaded in the order that we define them here. In this case, it's going to load up the config settings, and then over here, it's going to load in the instance settings. And don't worry, this is going to make a lot more sense once we try it out. So go ahead and open up the config folder, and then go to settings.py. At the moment, there's only one setting, and it internally sets Flask to use debug mode. This will inform Flask to give us a detailed stack trace if there's a crash. It also allows for you to execute arbitrary code against your running instance of Flask, so you should never ever use debug mode in production. However, it's excellent to use when developing your app, which is what we're doing here. We can also add as many configuration values as we want to this file. There's a bunch that are provided by Flask, and in this course we'll add some of them here, but for now let's experiment by adding a custom variable. So go ahead and add a couple of new lines here, and then we'll just add capital hello, space, equals, space, quotes, and then within those quotes, we'll just type in hello world, question mark. After that, go ahead and save the file. Then head back over to the app.py file, and then just backspace out the hello world on line 22. Then just go ahead and replace that with app.config, open brackets, close brackets, and within those brackets, add quotes and close quotes, and within those quotes, go ahead and type in capital hello. It's case sensitive, so make sure that you put it in caps. And this hello over here is matching the setting that we added over here. So make sure that you save the file, and then go ahead and open up your browser. Once here, head over to localhost port 8000, and then hit enter. And as you can see here, we have hello world with the question mark. This is a pretty silly example, but this concept is extremely powerful. Imagine if you had a database connection string. You wouldn't want to hardcode this value into your Flask app. Instead, you would want to put it into a config setting so that you can change it without having to change your application's code. The config/settings.py file would be expected to be commit to version control, and it should only contain settings that you're comfortable sharing with the world. It's a good spot for development-only settings and for defining defaults. In a larger project, you may end up with 20 or more settings, so feel free to add as many as you need. So now let's go back to our code editor. Now let's talk about the instance settings file. This is meant to be excluded from version control, and it would contain private information such as API keys, mail logins, or database passwords in non-development settings. This file is identical to the config settings file, except values here will override their config settings counterpart. If we go over to our instance folder here in the sidebar, we'll see that we don't have a settings.py file. And instead, we have a settings.py_production example file. This is a common strategy, and it allows the project owner to show you an example of what a real production settings.file would look like in theory. This example file would not be used directly, it's simply documentation. This way it's still commit to version control, but it would be filled with fake or non-sensitive information. It would be meant to be copied by someone, populated with their real information, and then renamed to settings.py. So in the case of this file, we've set debug to be false because that's what we want in production. Let's go ahead and create a new settings.py file inside of the instance folder. If you're using the same Sublime setup as me, you can just right-click on the instance folder, go to New File, and then type in settings.py and hit enter. If you're using a different editor, you know what to do. We'll add the same hello variable as before, so go ahead and type in capital hello, space, equals, space, quotes, and then just add something here like hi. Once you save the file, then head back over to your terminal. Then just shut things down by hitting Ctrl+C. Like before, as a good measure, do a docker-compose, space, stop. Now we'll just go ahead and rerun docker-compose -up. And the reason that we need to do that is because the instance settings file is not being monitored in development mode. So we just had to restart the server. Once you've done that, then head back over to your browser, and then from here just reload the page. And in our case now, you'll see hi instead of the old hello world. So that's how application settings work with Flask. So now let's head over to our terminal once again, and we'll stop the server with Ctrl-C, and then hit the up arrow twice and rerun docker compose stop. I'm going to go ahead and clear my screen by typing clear, just so we can see. And since this is the last lecture of the section, we'll need to run 2 more commands to clean up our mess with Docker. The first one is going to remove all stopped containers. And you can do that by typing docker-compose -rm -f, and then hit enter. And that's going to remove the stop container that we just ran. If we didn't do this step, then when we move on to the next section, we would get an error with Docker Compose saying it can't create the same container name. This is because we'll be moving into a different folder and it has its own Docker Compose YAML file. The second command that we're about to run isn't necessary to run, but it's a good idea to run it every once in a while. Each section of this course has its own codebase, and we'll be building and removing a lot of Docker images. This is going to create an abnormally high amount of orphaned image layers with Docker, so we need to run a command that's going to remove dangling images. If you forget to run this command every once in a while, then you're going to notice that Docker will eat up a lot of disk space, so it's a very good idea to run this maybe once a week or so. I personally have my workstation configured to run this command every week automatically. To run the command manually, go ahead and type in docker -rmi -f $, open parentheses, close parentheses, and then within the parentheses, docker images -q f dangling equals true. Then go ahead and hit enter. In this case, we're going to get an error because it didn't have to remove any dangling images yet. But I wanted to explain it here because this will be the only lecture where I go over both of the cleanup commands. However, at the end of each section, we're always going to run the docker compose rmf command together, and the notes for each lecture includes a reference to both commands. At this point, we now have a pretty reasonable base Flask application, and in the next lecture, we're going to extend the project by introducing Flask blueprints and Jinja templates. I'll see you there. In this lecture, we're going to go over what Flask blueprints are, and then use one in our application. Then, we'll go over picking an HTML template to give our application a consistent look and feel to it. After that, we'll take a detailed look at Jinja 2 templates. And lastly, we'll go over the homepage and a few other pages as well. Let's begin by getting into Flask blueprints, and for that, I'll see you in the next lecture. See you then. In this lecture, we're going to go over what a Flask blueprint is, and then add one to our base application. If you remember from the previous section, we embedded a hello world route directly inside of the application factory function. While this works, it's certainly not an ideal solution. Things are going to get unmaintainable really quick as our project grows. For instance, if we wanted to add a custom admin dashboard to the application, we would need to add a bunch of routes in this function. That's going to get super crowded, but the real problem is, we would likely want to namespace all the admin routes to /admin. Without blueprints, we would need to add the /admin path to each route ourselves. That already sounds annoying, and we haven't even done it yet. It gets a lot worse too, because if we start adding non-admin routes, then we're going to have to come up with some type of system to order the routes ourselves so we can maintain the project in the future. Then there's Jinja 2 templates and static files to worry about. Without blueprints, everything is going to be inside of one folder, and it may become difficult to determine which templates belong to which aspects of the codebase. Imagine for a moment at how bad that would be if your application had 100 routes and hundreds of templates. Spoiler alert, it's going to suck. This is where blueprints come into play. It's a feature of Flask that allows you to break up your application into components. Using the above example, we could create an admin blueprint and namespace it to /admin in one spot. Then we could put all of our templates into the admin blueprints template folder. And then we would do the same thing for our routes. Finally, inside the create app function, we would have just one line that registers the admin blueprint. Suddenly everything is maintainable. If we had 100 routes, we would just break them up based on what purpose they serve. For example, in this course, we're going to create a blueprint for users, billing, and so on. Each blueprint is a different component of the application. It will be very easy to navigate the codebase because we'll know exactly where things are based on folders that we set up to house each blueprint. It's also very easy to share code between blueprints because it's just Python modules. There's no added complexity of using blueprints for sharing code. Now that we know what problems blueprints solve, let's start adding them to our application. Please head over to your courses folder and then check out section 7's folder. Once here, just go ahead and open up a terminal. Then open up this folder in your favorite code editor. After that, hop back over to your terminal and then start things up by typing docker-compose -up. And once it's all up, head back over to your code editor. The file that we're interested in looking at now is the app.py file, which is located in the Snake Eyes folder. You'll notice that this file has changed quite a bit. The hello world route is no longer inside the create app function. Instead, on line 3, we're importing a page blueprint. Then down here on line 17, we're registering that page blueprint that we just imported. Out of convention, I like to use singular names for my blueprints. In this case, page will be a blueprint for all pages that have static content. A good example is a privacy policy, terms of service, or your application's homepage. In fact, those are the 3 pages that we're going to create in this section. They are labeled static because they aren't loading a database resource or have forms that need to be processed. Before we check out the page's blueprint, I feel like I need to explain how most of this course will work when it comes to building up the application. As you've probably noticed by now, each section of this course has its own source code that we'll go through together. This has many benefits because you'll be able to see how the application grows as we progress through the course. You'll also be able to perform git diffs on the codebase to compare exactly what changed between sections. That sounds great, and it is, but there is one downside. You're going to be looking at code that's in its final state for the section. This will be most apparent in the earlier lectures of the section, such as this one. You're going to be exposed to code that deals with concepts that we haven't talked about yet, like rendering Jinja templates. This really isn't a big deal because we're going to glaze over those details in this lecture and then cover them in detail later on. I figured I would warn you of that now before we proceed onwards because I don't want you to open up a certain file and be like, what the heck is this? With that said, let's head over to the Snake Eyes folder in the codebase. You'll notice that I created a blueprints folder. This is also a good convention because we don't want to mix up our blueprints with other files such as templates or static assets. Then within that blueprints folder, we'll see the page blueprints we spoke about earlier, so open up that folder. First up, there's a templates folder, which can be ignored for now. Then you'll notice that there's a views.py file. I named this file views out of convention because in web development terms, there's certain design patterns that are well known and used out in the wild. For example, in Django, they use the MTV pattern, which stands for Model Template View. The model would be database models, the template would be your HTML templates, and the view would contain your routes, which map URL endpoints to HTTP responses. An HTTP response could be to render a template, but it might also be to render JSON or something else. In Rails, they use the MVC pattern, which stands for Model View Controller. You could actually create this pattern with Flask if you want, but in our case, we're going to stick with an MTV-ish pattern. There's lots of great books and free material on expanding your knowledge of these design patterns if you want to research this topic on your own. You don't need to know much more than what I mentioned to make your way through this course, but consider doing this research as an optional homework assignment. Now let's open up the views.py file, which is in the page blueprint. You'll see on line 1 that instead of importing Flask, we're importing blueprint. Then on line 3, we're creating a blueprint with the name of page. In addition to what you see here, we could also pass in an optional argument to namespace this blueprint to a specific URL path, but we don't need to do this for this specific blueprint. Then on line 6, this should look a little bit familiar to you. Instead of attaching a route to the Flask app instance, we're attaching it to the page blueprint. Then on line 8, we're returning an HTML template instead of an HTML string. Just so you don't get overloaded with too much, go ahead and comment out line 8. Then add a new line here and just type return, space, quotes, hello world. then save the file. After that, hop over to your browser, and like before, go to localhost port 8000. So that's Blueprints in a nutshell. You might think this is more complex because we're dealing with more files, but we're way better off doing this in the long run. Once the application grows in size, you'll really begin to appreciate Blueprints. Let's go over one last thing before wrapping up this lecture. Head back over to your code editor, then open up this init file here in the page blueprint. This is the missing link that allows us to import the page blueprint inside of the app.py file. We're taking advantage of a Python feature here, which allows us to initialize the blueprints automatically due to how init files work. You just need to understand that all of your blueprints will need this line. I'll see you in the next lecture, where we'll talk about how we're going to create a consistent look for our application. I'll see you then. In this lecture, we're going to decide on how the application will look. There's a lot of options to choose from. For example, we could start from the ground up and create all the CSS, JavaScript, and HTML snippets ourselves. That might be a good idea if you're a professional designer, but if you're like me, then you'll probably want to start off with a good foundation and make your own customizations to that. There's a number of projects that we could look at for this. The most popular one is Bootstrap. It contains a bunch of pre-made CSS, JavaScript, and HTML snippets, and it uses a bunch of best practices. The project originated at Twitter, and it has nearly 100,000 stars on GitHub. There's also thousands of themes built on top of Bootstrap. We're going to use the default Bootstrap theme because this is not a course on graphic design. However, using this theme is a fantastic idea because with the knowledge you'll gain from using it, you'll be able to customize it and also integrate third-party Bootstrap themes into your own projects later. Also, if you want to hire a designer instead for your own projects, chances are they're going to be very comfortable working with Bootstrap already. Bootstrap isn't just giving you a decent design from the start too. It's going to allow you to easily create a mobile responsive website, and it comes with pre-made styles for various common widgets such as forms, tab views, tables, hover tooltips, and much more. We won't be going into great detail on Bootstrap itself, but we will be using a lot of functionality that it provides. In addition to Bootstrap, we're also going to be using Font Awesome. This is a CSS library that contains over 600 vectorized fonts that we can use for free. In case you're familiar with Bootstrap already, we'll be using Font Awesome instead of Bootstrap's glyph icons. If you haven't done so already, please head over to Section 7's folder and open it up in your code editor. Then make sure that your Docker container is running by typing docker-compose --up. Once it's all up and running, then head back over to your code editor. Once here, go to the Snake Eyes folder, and then go to the static folder. This folder will contain all of our static assets. That would be fonts, images, scripts, and style sheets. By default, Flask will look for a static folder to serve these files. We could choose to name it something else, but static seems reasonable and it's a convention supplied by Flask. So let's go ahead and take a look at the fonts folder. We'll see a bunch of Font Awesome fonts. Next up, if we take a look at the images here, all we have is the Snake Eyes logo, and we'll see that later. Moving on, let's take a look at the styles folder. We'll see that inside of here, we have a vendor folder and also a main.css file. It's usually a good idea to separate your assets in such a way that you can distinguish your own custom assets to ones that you've downloaded. In this case, Bootstrap and Font Awesome are both vendor assets. Likewise, if we go up here to the scripts folder, you'll see a vendor folder for Bootstrap. We'll never have to touch vendor files directly. Instead, if we want to customize something, then we'll add a new file and overwrite it there. The new file wouldn't be in the vendor folder because it will be custom to this application. This way, if we update Bootstrap later on, we won't lose our changes. Also, in case you're curious on the versions, we'll be using Bootstrap 3.35, which we can see here. And if we go and check out Font Awesome, we're using 4.5. These happen to be the newest versions available at the time of creating this course. If you wanted to upgrade to a later release, you could simply overwrite the files in their respective folders and you'll be good to go. If you're a seasoned Flask developer, you might be wondering if we're going to be using any extensions to minify and tag the assets with MD5 file names. This way you can serve and cache them efficiently in production. The short answer is not right now. We'll complete the course without using any additional tools for asset management, but I will point you in some direction on how to use Flask Webpack at the end of the course. So that covers which front-end libraries we'll be using for the time being. I'll see you in the next lecture, where we get familiar with Jinja 2. See you then. In this lecture, we're going to go over what Jinja 2 is. Jinja 2 describes itself as a designer-friendly templating language for Python. Some of the top features of Jinja 2 are template inheritance, which means you can extend templates in very efficient ways. We'll see how that works later on, so don't worry. Another useful feature is HTML escaping. Imagine if a user submits content that's publicly viewable on your website. A malicious user could put in JavaScript that does really bad things, like try to trick visitors into giving their personal information over to him. He could design things in such a way that it looks like it came from your site. Your visitors would be none the wiser. This type of attack is labeled as an XSS or cross-site scripting attack. Our site will protect against these attacks, and that's partly due to using Jinja 2. Another main feature of Jinja 2 is that it's very fast. It compiles down to optimized Python code, and you can even optionally pre-compile templates for extra speed. The last main feature I'll mention is how flexible and extensible it is. It's very easy to add your own Jinja 2 filters and functions, and we're going to get a lot of experience doing that in this course. So that takes care of what Jinja 2 is, and why it's considered one of the best Python templating languages available, but what does it really let us do? We could go into a lot of depth here, but I'll try to keep this short and sweet. It allows us to add programming constructs to our HTML templates. That means you'll be able to add in things like if statements, for loops, and more. It allows us to transfer information from our backend Flask server to the HTML being rendered out to your visitors. For example, let's say that you had an admin dashboard that listed out all of your users in a table. Through the power of Flask and Jinja 2, we can send a list of users from Flask to Jinja 2, and then inside of our Jinja templates, we could loop over those users and write them out to an HTML table. This allows us to separate our data from how it's presented to visitors, and ultimately, that's the main purpose of using a templating language. Now that we know what Jinja 2 is, let's put this knowledge to use by checking out the homepage template, and for that, I'll see you in the next lecture. In this lecture, we're going to go over a few Jinja 2 templates which make up the homepage. If you haven't done so already, please head over to Section 7's folder in your Courses folder, and then open it up in your code editor. After that, make sure that you're running the Docker container by typing docker-compose --up. Once you have it up and running, then head back over to your code editor. Before we can check out the homepage, the first thing that we need to do is go to the Snake Eyes folder, Blueprints, then go to the page blueprint and open up views.py. In a previous lecture, we commented out rendering the template over here, so go ahead and remove that comment. Then remove the return hello world line. Once you've done that, go ahead and save the file. Now, let's head over to our browser. Once here, just go to localhost port 8000 and hit enter. And now you should be greeted by a pretty decent looking homepage. If you don't see what I see, then make sure that you clear your browser's cache. If you're using Windows or Linux, you can hit F5 to do a full page reload in your browser. So I've created us a logo by modifying a picture of some dice that I found on Google Images. The three icons in the middle are Font Awesome icons. We can easily adjust their size or color since they are being rendered as a font, not an image. But for this app, the current setup works pretty well. On the bottom, we have a sticky footer with a few links that we'll cover in the next lecture. Now let's try resizing our browser. So I'm going to make it not full screen here, and then just slowly start resizing it. You'll see that the page is responsive. The three icons collapsed into columns, and if we continue making it smaller here, you'll see that we have a little drop down here, which is going to show our menu items later on once we have a couple to show. Let's view the source code of this page first, because then we can see the end result of what the HTML looks like after it's being processed by Jinja. Depending on what browser you're using, this might be slightly different, but in Firefox you can just right-click and then go to View Page Source. I'm not going to go over this line by line, but I just want to show you things at a high level. For example, here's the head section, and this is where we define a couple of meta tags, the title tag, and we link to some of our assets. One thing to note here is the path of the assets. We have a static folder, the styles folder, a vendor folder, and there's our minified bootstrap file. And over here we can see our main.css file, and you can see that this one is not in the vendor folder. And in the case of this script tag over here, we're pulling in jQuery from a CDN. jQuery is a dependency of Bootstrap. Next up, we have the body of the document, and this has a navigation area, which right now just contains the logo, but in future sections we're going to have a navbar. Then if we scroll down a little bit here, we have a main section, and then down here we have our footer. If we go to the very bottom here, you'll see one more script tag, and that's loading in our vendor JavaScript. This is a super basic page, but now you have an idea of what the source code looks like. Let's see what we needed to do with the Jinja 2 templates to make this work. So for that, head back over to your code editor. The first thing that we'll want to do here is go to this templates folder over here, which is outside the blueprints folder, and then we'll go to the layouts folder and open up base.html. It looks pretty similar to the source code that we just looked at, except there's a few interesting things going on. On line 10, you'll see a block along with an end block. This is a Jinja 2 feature that allows us to place code from a different file into the contents of this block. In this case, it means that we'll be able to assign a custom page title to all of our pages, and we can set that title in the Jinja template for that specific page. You'll see a lot of blocks being used in this file. For example, here's one for the meta description, and if we scroll down here, we'll see one more for heading, and one last one here for body. This is going to allow us to inject code at certain points in the template from our other Jinja templates. You could think of this layout file as a shell. Then each block within the shell will be replaced with unique content provided by a different file. Before I show you how this works, let's jump down here to line 62. Here we have a Jinja 2 function called URL4, and this function is being provided by Flask. It controls outputting static assets. In this case, we just pass in a file name, which in this case would be scripts, vendor, and then the minified Bootstrap JavaScript file, and this file belongs in the static folder. That lines up to what you see here on the left. Here we have the static folder, and then we have the scripts folder, vendor, and there's the minified Bootstrap file. If we jump up over here to line 55 and 56, we're using that same URL4 function, but this time we're passing in the blueprint name along with the function for that route. It's a really bad idea to hard-code the URL path, such as /privacy, because you may want to change that in the future, but you wouldn't want to have to go back and update all of your templates. Instead, we do a reverse lookup by the route's name. In this case, we have a page blueprint, what lines up to the blueprint name that we defined, and then our route names are privacy and terms. If we go back to the views.py file, you'll see that we have them set up over here. There's privacy and there's terms. So now let's check out the home pages template to see how blocks work. For that, go to your sidebar if you're using Sublime, and then inside of the page blueprint, you'll notice that there's a templates folder here. So go there, and then expand the page folder, and then open up home.html. Now, before we take a look at this page, you might be wondering why we have to define the page folder here inside the templates folder when we're already in the page blueprint. This might look like a mistake, but it's not. By providing our template paths like this, it allows us to override a blueprints template from our main templates folder if we needed to do that in the future. For example, inside of this templates folder down here, if we were to add a page folder and then add a home.html file, then it's going to overwrite this home.html file straight from the blueprint. In our example application, we won't be doing this, but imagine for a second that you had a reusable blueprint that you used in multiple projects. And now let's say that you wanted to override just one of the templates. Having our folder set up like this would allow you to do that. Okay, so now let's take a look here at the home.html file. Line 1 is very important because this is telling Jinja 2 that we're going to be extending the base layout file that we just looked at. This is a working example of template inheritance, and it's what ties both templates together. Also, one thing to note here is that it must be the very first line in the file. After that, we just define a couple of blocks here. Here's the title block. So in this case, it says test your luck against the roll of the dice. And if we go back to the base.html file and scroll back up to the title block up here, you can imagine having that string being injected right here. Now, if you have an awesome memory, you may have remembered that there was a fourth block in the base layout file called heading. If we jump back over here to the base.html file, you'll see that block over here. But if we go back to the home.html file, there is no block for heading. In this case, we don't want to render a heading in the home page, and Jinja is smart enough to just ignore it. Also, if it helps, you can think of blocks as variables. You would define them here, and then they would be swapped out into the block in whatever file you're extending. If we continue onwards in this file, there's really not much to look at. Here we have our body block, And inside of here, we just have a bunch of Bootstrap markup. In this case, here's our multi-column setup here, where we draw out the 3 font awesome icons. Currently, the sign-up links lead to nowhere because that functionality hasn't been added to our app yet. But I wanted to include the buttons here because the homepage at the moment is already pretty empty. So that takes care of some basic functionality with Jinja 2. Throughout the course, we're going to be using many more features of Jinja 2, but for now, let's continue to the final lecture of this section, where we take a look at the privacy and terms pages. I'll see you then. In this lecture, we're going to close out this section by quickly going over the privacy and terms pages. If you haven't done so already, please head over to Section 7's folder in the Courses folder, and then open it up in your code editor. Then make sure that the Docker container is running by typing docker-compose --up. Once everything is up and running, head over to your browser. And here we are back at the home page. But now, let's go to the footer and then go to privacy policy. I'm not a lawyer, but I wanted to provide everyone a reasonable privacy policy template to use. It's what I use on most of my projects with minor modifications based on what the application does. The purpose of this file is to notify visitors of your website's privacy rules. It also protects you against potential legal action from disgruntled users because by using your website, they are agreeing to adhere to your privacy policy. So now let's take a look at the template in the page's blueprint. For that, head back over to your code editor. Then head over to the blueprints folder, then the page folder, the templates folder, the page folder again, and then finally we have privacy.html. It's basically the same as the home page, except you'll notice that instead of a meta description block, we have a heading block instead. This heading is just a simple H2 tag with privacy policy. Now, we could have included a meta description for this page, but it's not like you need to optimize this page for SEO purposes. The only interesting thing about this page is lines 9 and 10. We're using Jinja variables to access configuration data from the Flask app. In this case, we're accessing a Flask config value called server name. We haven't set this variable in our config file yet, but for now just understand that it's something provided by Flask. If we go back over to our browser and take a look, you'll notice here that the output of that link is none. We're going to talk about that setting in a future section. For now, just understand that this value will end up being the domain name, and it's something that we'll end up setting ourselves. In development mode, it would say localhost, but in production, it would end up saying your domain name. It would be a mistake to hard code this value into the template, because then we would need to change it based on development or production. This is a textbook example to demonstrate why config settings are useful. If you were to deploy this website to production later, all you would have to do is provide an instance/settings.py file with a different server name and you're done. Okay, so now let's scroll down to the bottom here and check out the terms page. This is just an example TOS page that you can use for your own application with minor changes. The purpose of this page is to inform visitors of your terms. It acts as both documentation for your visitors in case they want to know about things like account termination or refunds, but it also protects you legally. I'll leave looking at the terms.html page in the code editor as a homework assignment for you. It doesn't contain any new concepts that we haven't seen before. It's going to be located in the same spot as the privacy page. With that said, congrats on getting to the end of this section, and before we move on to the next one, let's make sure that we clean up our mess with Docker. So head over to your terminal. Once here, press Ctrl+C to stop everything, and then go ahead and type docker-compose --stop. And that's going to make sure that it's really stopped. Now let's clean up our mess by typing docker-compose --rm --f and hit enter. And that's all there is to it. In the next section, we'll lay the groundwork down for writing tests. I'll see you there. In this section, we're going to go over how to write tests with Flask, as well as run utilities to measure our test coverage and pick up syntax issues. First, we'll go over which packages were added to the project. Then we'll go over writing tests with Flask. After that, we'll run a test coverage tool against our codebase. And finally, we'll run a static analysis tool against our codebase as well. Let's begin by going over the package changes. I'll see you then. In this lecture, we're going to look at a few changes that were made to the requirements.txt file. So please head over to your courses folder and then go to section 8. Then go ahead and open up the folder in your code editor. Once here, go ahead and open up the requirements.txt file, which is in the root of the project. We're going to be dealing with 3 new packages. The first one is PyTest, and it's a very popular Python testing package that a lot of modern applications use. It's a very good idea to test your codebase because it allows you to make big sweeping changes without wondering if you broke everything. All you would have to do is make your changes and then rerun your tests and see if things still pass. We won't be going crazy with writing tests in this course, but we will ensure that we have high test coverage and that most important aspects of the codebase are very well tested. We also won't be performing a strict TDD workflow, so don't worry about spending half the course just messing around with tests. Test-driven development is a practice I'll never follow simply because it conflicts heavily with the way I write code. I'm a huge advocate of writing just enough tests to raise my confidence level up to the point where I trust the software I'm writing. This is going to vary from project to project. This is, in my opinion, a good way to write tests. Oftentimes, people get hung up on writing too many pointless tests, when in reality, having fewer well-written tests is both easier and more maintainable. Next up, we have a cool little package called PyTestCov, and it will help notify you what percentage of your codebase is covered by tests. This is quite useful when your project grows in size. At a glance, you'll be able to see a bunch of different metrics about your test coverage and which code paths are untested. Lastly, on line 9, we have Flake 8. This is one of many different static analysis tools available for Python. It's oftentimes called a linter. It will help you make sure that the code you write is consistent and well-formed. It does this by analyzing your code and then warning you about all the mistakes it found. There's hundreds of predefined rules, like functions must have 2 empty lines between them, but it will also warn you when you have unused imports. Most code editors have plugins so you can see the output of Flake 8 live in your editor, which is pretty handy. That's what I'm doing here with Sublime. Setting up your editor to do this goes a bit beyond the scope of this course, but I went over how I configured Sublime in a previous section of the course. Now that you know what new packages were added, let's go over a few tests that were written. For that, I'll see you in the next lecture. See you then. In this lecture, we're going to go over a couple of tests that were written in PyTest. If you haven't done so already, please head over to Section Needs folder in your Courses folder and open it up in your code editor. And now let's start Docker Compose. But we can't just run what we've been running in the past. Now we need to run docker-compose space up space -- build. And the reason that we need to add the build flag is because we've added a couple of new packages to the requirements.txt file. So we need to let Docker know that it needs to rebuild the image. So go ahead and hit enter. You'll notice now that it's going to rerun pip install. If we go back over to our code editor, and then check out the Docker file, the build up command started from here because our requirements.txt file changed. So it copied in the new requirements.txt file, then it reran pip install, and then it did everything else. So now let's go to the Snake Eyes folder, and then we'll go to the test folder. Let's begin by looking at the conftest.py file, which is in the root of the test folder. This file is a bit magical, and it's a convention set by PyTest. This is the file where you would define test fixtures, and PyTest automatically loads this file when you run your test suite. A test fixture allows you to define a function, which can then be reliably executed during the lifecycle of running your test suite. If you've ever used other test libraries, they are somewhat comparable to the setup and teardown phase of running tests. These are tasks that would happen before and after each test is ran. Oftentimes, you'll want the same functionality to happen across a bunch of tests, and this allows you to define that functionality in one spot. All you do is simply add a decorator to a function in the conftest.py file, and you're good to go. On line 6, we're setting an app fixture with the scope of session. This means it will only get executed once at the beginning of the test suite. In this case, it saves a lot of computing power because creating a Flask app instance isn't something that we need to do in between each test. Line 29 is the same decorator, except now we're setting up a client fixture that is scoped at the function level. This means every test you run that uses this fixture will get its own isolated Flask test client. Absolutely no test client state will be shared between each test when a fixture is scoped at the function level. This is very important for most tests because you want them to be independent of each other. If you take a look here at line 30, you can also see that you can pass fixtures along to other fixtures. This is a very powerful concept, and we'll see this being used in more fixtures throughout the course. So let's go back to the top of the file now, and we'll check out this app fixture. It starts by setting a few parameters that you would expect to see in a config/settings.py file. In this case, debug is set to false and testing is set to true. Then on line 18, we're creating a new app instance, and are passing in these parameters to the settings_override argument. As students may have realized that this parameter does not exist in our create app function in our app.py file, and you would be correct. Also, in case you missed it, this function is being imported here on line 3. Let's head back over to our app.py file and take a look at a small adjustment that was made to this file. You can see now that the create app function takes a settings override parameter, and down here, if that parameter has been sent in, then we go ahead and update our app.config settings with that parameter. Now let's go back to the conf_test.py file. When testing is set to true, exceptions will be bubbled up to the test client. Then down here on lines 20 to 26, we're just setting up a Flask application context. We haven't talked about that yet, and now isn't the best time to really get into it. So for now, just assume it does something magical. So when this app fixture gets executed, it's just creating a Flask app, except it has a few settings that are different, such as testing being equals to true. Before moving on to the tests themselves, let me just go over what the test client is on line 37. This test client allows us to trigger requests to a certain route endpoint programmatically and also keep track of cookies. You can think of it as a watered-down, headless browser. Since the tests aren't being ran in a browser, we need some way to navigate our application, and that's exactly what the test client allows us to do. So now that you have an idea of what this file is about, let's go to the page folder here in the tests folder and start looking at some tests. Go ahead and open up test_views.py. In the future, we'll be testing code that doesn't belong to our views, so I decided to namespace the file by what type of code is being tested. Also, you'll be happy to know that this file is very straightforward compared to conf_test.py. All we're doing here is creating a class. It's a convention to prefix the class name with test, followed by whatever you're testing. So in this case, we have 3 separate tests, and each one has the client fixture passed into it. Then each function uses that client to go to a specific route endpoint and then assert that the status code is 200, which is a success. So let's see how this all works by heading over to our terminal. You'll want to go ahead and open up a new tab. Now what we're going to do is run the test suite, and we'll do this from inside the Docker container. Luckily for us, Docker and Docker Compose has a very nice way to handle this. So go ahead and type in docker-compose space exec. The exec command lets us run a command inside of a Docker container. This functionality is part of Docker, and Docker Compose simply wraps it. Next up, we need to supply the container's name. So go ahead and hit space, and then type in website. And the reason that we're using website here is because that's what we have defined in the docker compose.yaml file. The last thing that we need to do now is supply the command that we want to run. So go ahead and hit space, and we're going to run pytest. So go ahead and type py.test space snake eyes, and don't forget the double E's there in the middle, /tests, because that's where our test directory is located. So go ahead and hit enter. Whoops, it looks like we have a couple of failing tests. The error it gave us is very meaningful, and this is part of what makes PyTest so good. We only have to write very little test code, but it will inform us where things went wrong and what was expected. The error says that we should probably set the server name config variable, and it's right. So to fix that, let's head back over to our code editor. Once we're here, open up the config/settings file. Then just go ahead and add a new line and type in capital server _name space equals space quotes. And if you're running Docker natively like me, go ahead and type in localhost. Otherwise, use your Docker machine IP address and then go to port 8000. Once you save the file, head back over to your terminal. Then just hit the up arrow once and rerun the test. Now you should see 3 passing tests. So that's basic testing with Flask and PyTest. We'll be adding many more fixtures, custom assertions, and more in future lectures, but for now things are working pretty well as is. I'll see you in the next lecture where we explore the codebase's test coverage. See you then. In this lecture, we're going to check out the code coverage of our application so far. If you haven't done so already, please head over to Section 8's folder in your Courses folder and then open it up in your code editor. You'll also want to go ahead and run docker-compose space up. Lastly, if you haven't done so already, open up a new terminal tab. The next command that we're about to run is going to run the test coverage tool. And this command is going to start off like the last one, where we would type docker-compose space exec space website space py.test space And now this is where things are going to get different. Go ahead and type --cov -report space term -missing, and this cov report flag allows us to provide many different types of output. We could choose to output the coverage in HTML, XML, and more. We've chosen to output things to the terminal, and missing means that it's going to provide the line numbers of the code that isn't covered by a test. Next up, hit space, followed by --cov space snake eyes. And that's going to be the location of what we're going to run the test coverage on. In our case, that will be the snake eyes folder because we want to test the code base itself. So go ahead and run that command. After a second or so, you should see what I see, and that we have 3 passing tests, and our coverage is 100%. It's only going to go downhill from here. Now let's hop back over to our code editor. Then open up the test_views.py file. Then just go ahead and comment out the second test. If you're using Sublime, you can just select that text and then type in Ctrl/. Then save the file and head back over to your terminal. Once here, just hit the up arrow and rerun the test coverage. You'll notice this time that the coverage is 97% instead of 100, and that's because we no longer have a test for the terms page. Also over here, we can see that line 13 is missing test coverage in the views.py file. Let's go back to our editor now and check out that file. The views file is located in the blueprints folder, under page, and then views.py. We can see here that line 13 does a render template on the terms.html file. So it looks like our test coverage tool is proving to be very helpful. So now let's go back to the test file and remove that comment. Again, if you're using Sublime, just select the text and then hit Ctrl// and save the file. As our codebase and test suite grows, the value of this tool goes up by a lot. For now, I'll see you in the next lecture where we go over running Flake8 on the codebase. See you then. In this lecture, we're going to run Flake8 against our codebase to see if there's anything wrong in terms of code formatting or other issues that may not cause Python to crash, but is still technically wrong or a cause of concern. If you haven't done so already, please head over to Section 8's folder in your Courses folder and then open it up in your code editor. Then make sure that the Docker container is running by typing docker-compose -up. Also, if you haven't done so already, please open up a new terminal tab. Then we're going to go ahead and run Flake8 from within the container. So, like before in a previous lecture, we're going to type docker-compose -exec -website and now we're going to run Flake8. And we can do that by typing Flake8 period, then hit enter. And that's going to run Flake8 in the context of the current directory within the Docker container. You'll see here that we got a warning that we imported page, but it's unused. This is a very common warning to see because it's in the init.py file. This is one of those warnings that's safe to ignore. Typically, your init.py files will be empty, so it's pretty safe to tell Flake8 that it's safe to ignore this file. We can do that by rerunning Flake8 by hitting the up arrow and then hitting space --exclude space __ init __ .py, and then rerun that by hitting enter. This time you'll notice that there's no warning. Now let's go ahead and purposely wreck a file. So go back to your code editor, and then just go to the app.py file in the snake eyes folder, and add an extra line here on line 5, and then save the file. Then head back over to your terminal, and rerun the same command by hitting the up arrow and pressing enter. You'll see here that app.py on line 7 has too many blank lines 3, and that's because it expects 2 blank lines, not 3. So now let's go back to our code editor one last time. You'll notice here in Sublime, I have things configured to work on the fly. If you look at my status bar on the very bottom here, you'll see error too many blank lines 3 on line 7, column 2. You'll also see a little orange icon here in the gutter. That's pretty handy to have. So let's remove that new line and save the file, and you'll see that the warning goes away. Flake8 is very handy to have when working on open source projects because you can have it run automatically when people create pull requests on your code, and that's going to ensure your codebase is formatted in a consistent way. It's also very useful for solo developers too, because it'll help you create more maintainable code. With that said, that brings us to the end of this section, and now it's time to clean up our mess with Docker. So for that, head back over to your terminal. Then go to your first tab here and hit Ctrl+C to stop Docker Compose. Then go ahead and type docker-compose space stop. Then we just need to remove our stopped containers by running docker-compose space rm space -f, and then hit enter. Also, go ahead and run docker space images, and then hit enter. You'll notice here that we have a dangling image, and we can detect that it's dangling because it says none surrounded by brackets. This is something that we should be removing on a regular basis. We can do that by running the docker rmi command that we ran in a previous section. Instead of me typing that out on camera, I recommend that you copy and paste it from this lecture's notes. With that said, I'll see you in the next section where we create a CLI script which will help us run these commands in a more friendly way. I'll see you there. In this section, we're going to go over the CLI script's components. First, we'll go over why we need a CLI script. Then we'll go over what changed in the project since the last section. After that, we'll go over the CLI script's code. And lastly, we'll run a few CLI commands to see how it all works. Let's begin by going over why we need a CLI script. I'll see you then. In this lecture, we're going to go over why we need a CLI script. Up until now, we've only had to run a couple of commands. And to recap them, we've ran pytest, which runs our test suite, pytestcov, which runs the test coverage against our codebase, and then we ran flake8, and that does static analysis against our codebase. Some of those commands, such as the test coverage one, had a few flags and paths. It's going to get super annoying if you always have to type them out. It's also really easy to forget the flags or paths for each command. Wouldn't it be nice if we could run snake eyes from within the Docker container and get a list of all commands associated to the project? Then from there, we could run a specific command. Perhaps one of them could be snake eyes test or snake eyes cov. In future sections, we'll want to add more commands to see the database with fake data, interact with the billing backend, and much more. Without the CLI script, we would have no unified way of running these commands. Let's continue to the next lecture, where we'll go over what changed in the codebase since the previous section. I'll see you then. In this lecture, we're going to briefly go over the new files that have been added to the project's codebase. So please head over to Section 9's folder in your Courses folder, and then open it up in your code editor. Let's begin with the requirements.txt file. Over here on the bottom, we've added a new package called Click. Click's author is the same author who created Flask, and he defines Click as a Python package for creating beautiful command line interfaces. Click is also going to be integrated with Flask 1.0 and beyond, so it's a very good idea to get familiar working with it now. One of my favorite things about Click is how easy it is to compose a multi-command CLI script. It also writes out very helpful menus without having to write a ton of boilerplate code. So now let's check out the other new file in the root of the project called setup.py. This file is responsible for building a proper Python package, and this is what's going to allow us to use the Snake Eyes CLI as a proper binary. In other words, we'll be able to just run Snake Eyes as if it were installed in our system, except in our case, we're not going to install it on our system. This has nothing to do with Docker or Flask, but it's the Pythonic way to create a CLI script. It's also recommended by Click. It's not too important to understand each line in this file, as it's mostly boilerplate code that links Click to the CLI folder that we haven't gone over yet. The other new addition to the project is the Snake Eyes egg info folder. To set up a Python package for active development, you would typically run pip install space --editable space dot. And when you run that command, it would have automatically created the egg folder that you're looking at right now. In our case, that new pip install command has been added over here in the Docker file. However, since we're mounting in our application code in Docker Compose, that folder would get overwritten. So now we need to include it in our project's source code too. This way, every single time we start up the application, the egg info folder will exist inside the container. Lastly, there's a new CLI folder in the root of the project. This is where the code for the CLI lives, and it's what we'll go over in the next lecture. I'll see you then. In this lecture, we're going to go over the contents of the CLI folder. If you haven't done so already, please head over to Section 9's folder in your Courses folder, and then open it up in your code editor. Now let's take a look here at the CLI folder. You'll notice the double_init file here because it's a Python module. Then we have a CLI.py file and a commands folder. If we open up that commands folder, you'll notice that there's a number of commands. We have one for test coverage, flake8, and running tests. I think it's going to be easier to explain how Click works if we take a look at these files before looking at the main CLI.py file. So go ahead and open up the cov command file. So over here on line 3, we're importing the Click module. Then down here on line 6, we've added a Click command decorator, which tells Click that the function below it will be a Click command. In this case, there's also an argument decorator with a name of path that defaults to Snake Eyes. With Click, you can add as many arguments or options as you'd like by simply adding more decorators. Click's documentation goes into great detail on this, and if you want to expand your knowledge on how Click works, then check it out in this lecture's notes. Okay, so on line 8, we're just creating a CLI function with an argument of path. The reason that we're passing in this path argument here is because we have it defined as a Click argument. That's going to allow us to access the path from within our CLI function. The path argument allows you to optionally override the default Snake Eyes path with your own path. This could be very useful if you only wanted to test the code coverage of a specific path, such as a single blueprint. Then on line 15, we have the command's logic, which is going to just run pytest, which we ran before, along with the cov report flag with term missing, and then we're passing in the path. Then finally, it uses the Python subprocess module to run the actual command. This is effectively the same as running the command from a shell manually. So now let's go ahead and take a look at the test command. This file is nearly identical to the test coverage command, except line 16 is running a different command. Also, the default path has been adjusted because we need to point it to the test directory. Other than that, it's about the same. So now let's take a look at the flake8 command. As you can see, this one is a little bit more complicated. Really though, it's not that much different than the test command. However, it does introduce using Click options, and we can see that over here on line 7. You can think of options as command line flags. In this case, there is a Boolean option that allows us to skip or not skip running flake8 against init files. It defaults to true, which means it's going to skip init files, and then there's also custom help text associated to the option. Notice on line 10 that we're passing in the option to the CLI function. The argument's name is skip_init, and that lines up to the option name here, which is skip-init. In this case, the dash is going to always be replaced by an underscore. Also, Click is smart enough to convert skip-init into a proper Python boolean because we have the type defined over here. Then down here on line 20, if we're skipping init files, then we just add that exclude flag that we ran in a previous lecture. Finally, we wire up the flake8 command and then run it. So that's all the commands that we currently have. Let's go ahead and open up that CLI.py file, which is in the CLI folder. This file is nearly the same as Click's documentation on how to set up a multi-command Click app. All you really need to know here is that this is the entry point of the CLI app. On line 5, we're telling Click that all of our commands will live inside the commands folder, and that's going to be relative to this file's path. Line 6 sets up a file name prefix to only look for files that begin with cmd_. Then we have the main CLI class, which inherits from Click's multi-command class. Then to satisfy the requirements of that multi-command class, we create both a list commands and get command function. The list commands function scans the commands folder, and then it looks for files that end with .py and begin with cmd_. This avoids picking up extra files that we wouldn't want checked. Then it just sorts them alphabetically and returns that list. This means that adding a new Click command is as simple as adding a new file to that folder. That's pretty cool. The get command function will determine which command it needs to run. The implementation details of this function isn't important. Just understand that this function gets ran when you run a specific Snake Eyes command. Then in turn, the CLI function of that command will get executed. So, for example, if you were to run Snake Eyes test, it's going to go ahead and run the CLI function in the command test file, which is over here. Finally, the last couple lines here is the entry point of the CLI application. This is the code that gets ran when we run Snake Eyes with no arguments. So that's the entire CLI script so far. I'll see you in the next lecture, where we run most of the commands that we just talked about. I'll see you then. In this lecture, we're going to run a few CLI commands. If you haven't done so already, please head over to Section 9's folder in your Courses folder. Then let's go ahead and build and run Docker Compose, and we can do that by typing docker-compose space up space --build, and then hit enter. And the reason that we added the build flag is because we added a new package to requirements.txt. Then go ahead and open up a new terminal tab, And the first thing that we'll do is run the snake eye script with no arguments. So go ahead and run docker-compose space exec space website. And we're doing this because we're going to be executing the snake eyes command within the Docker container. Then go ahead and type in space snake eyes and hit enter. As expected, we see a list of all of our commands. We get a very nice help menu, which is rendered by Click for free. In this case, the help messages are all based on comments that we had in our Click scripts. So now let's go ahead and run Flake8 against our codebase. So go ahead and hit the up arrow, and then type in space Flake8. So that's pretty good. We have no warnings in our codebase. Now let's rerun the same command, but this time we're going to add --help just to show the help message for Flake8. So hit the up arrow, and then type in --help and hit enter. Click took all of our comments and applied them to the help text. We can even see the options here with a little bit of help text that we saw before in the previous lecture. So now let's hit the up arrow, and we'll backspace out the --help, and instead we'll do --no, -skip, -init, and then hit enter. And as expected, now it warns us about the unused import, which is okay to ignore. So that's the end of this section. As an optional homework assignment, go ahead and run the cov and test commands on your own. And since this is the last lecture of the section, let's go ahead and stop Docker Compose here in our other tab, which we can do by typing Ctrl+C, and then running docker-compose space stop. Also, let's clean up our Docker mess by typing docker-compose space rm space -f and hit enter. At this point, you know the basics of Flask, you know how to write tests, and you even know how to create a helper CLI script to manage your project. You're also becoming an expert at working with Docker in development. I'll see you in the next section where we add in a popular Flask extension to the project. I'll see you there. In this section, we're going to go over how to use custom Flask extensions. First, we'll take a look at the requirements.txt file to see what changed. After that, we'll go over what the debug toolbar extension does and how it's been added to our app. I'll see you in the first lecture where we go over the requirements.txt file. See you then. In this lecture, we're going to go over a new package that was added to the requirements.txt file. So please head over to section 10's folder in your courses folder, and then open it up in your code editor. Once here, then open up the requirements.txt file. The new package is at the bottom, and it's the Flask debug toolbar. If you've ever used Django before, it's pretty much a direct port of the Django debug toolbar. If you haven't used Django, don't worry. Basically, it's a helpful toolbar that gets injected into your Jinja 2 templates automatically in development mode. It allows you to see useful stats about the page, such as how long it took to render, and even gain insight on how many database queries have been executed. I would consider this a must-have package that belongs in any Flask project. Let's continue to the next lecture, where you'll see how to initialize the debug toolbar extension. I'll see you then. In this lecture, you'll see how the debug toolbar extension works, and also how to add Flask extensions to your application. So if you haven't done so already, please head over to section 10's folder in your courses folder, and then open it up in your code editor. Then go ahead and build our Docker container and run it by typing docker-compose space up space --build, and then run that command. Once everything is up and built, then head over to your browser. Then just go to localhost port 8000 like we did before. Our home page didn't change, but now we have the debug toolbar sitting on the right-hand side. You can also click into most panels, such as time, and then get a breakdown of how much CPU time is being used to render this template. You can even get a list of all available routes by clicking the route list down here. Here we can see the homepage route, the privacy route, and the terms route. Now that we know what the debug toolbar does, let's go over the code changes to make it work. For that, head back over to your editor. The first file that we're going to take a look at here is in the config folder and then settings.py. In order for the debug toolbar to work, we must set a secret key value. At the moment, it's set to a pretty insecure key, but in production, you'd likely want to make this a complex random token. This key will be used to sign your cookies, among other things. We'll get into working with cookies when we introduce the user registration component to the website. But for now, just understand that the secret key has nothing to do with the debug toolbar. It just so happens to require it to function properly. Next up, let's go to the Snake Eyes folder. And then down here, we have a new file, extensions.py. So let's check that out. Since our application will eventually have many extensions, I think it's a good idea to load them in a separate file. This will avoid cluttering up the app.py file. As you can see here, this file is pretty basic. You simply import the extension that you want, and then you call it while saving the result to a variable. This is a very common pattern in Flask, and you would know which things to import and call because Flask extension authors would typically include this information in their README file. So now let's head over to the app.py file. Over here on line 4, we're importing the extension that we just assigned in the extensions file. Then down here on line 28, I created an extensions function. This function takes a Flask app instance as an argument, and then it goes ahead and initializes each extension onto the app. This is also a very common pattern in Flask, and typically extension authors will have a help snippet in the README file explaining how to do this. If we take a look up here on line 23, we're just calling the extensions function. So the workflow for adding an extension is 1. Add it to the requirements.txt file and install the package. 2. Import and save the result of calling it in the extensions.py file. And 3. Initialize it onto the Flask app in your app factory function. And in our case, that's going to be done in the extensions function over here. We'll be repeating this pattern for many different extensions, which we'll see soon enough in future sections. Speaking of sections, this one was a quickie and we're done here. So let's hop back over to our terminal now so we can clean up our Docker mess. The first thing we'll do here is stop Docker Compose by hitting Ctrl+C. Then we'll just do a docker-compose space stop. Lastly, we'll delete our stop containers by running docker-compose space rm space -f. So that's it. I'll see you in the next section where we add a contact form. I'll see you there. In this section, we're going to go over creating a contact form. First, we'll look at the requirements.txt file to see what changed. Then we'll go over a few new settings to configure sending emails. After that, we'll review what was created to make the contact blueprint. Then, we'll take a detailed look at the contact views file. After that, we'll investigate all the new templates and also learn about Jinja macros. Once we have that out of the way, we'll take a look into creating the form itself. Then, we'll see how to wire up and use Celery to execute background tasks. Lastly, we'll go over some new tests that were written to confirm that everything works. I'll see you in the first lecture, where we go over the changes to the requirements.txt file. See you then. In this lecture, we're going to go over a number of new packages that were added to the requirements.txt file. So please head over to Section 11's folder in your Courses folder, and then open it up in your code editor. Once here, go ahead and open up the requirements.txt file. This will be the first section that uses Celery. So on lines 15 and 16, we've added packages for both Redis and Celery. In case you don't know what those are, then I recommend going back and watching the application's architecture lecture in a previous section. Then on lines 19 and 20, we have two form-related packages. Flask WTF is a very popular library to use for forms. It allows us to structure our forms in Python while leaving all the visuals to the Jinja templates. WT Forms Components is an add-on library by a different author which gives us extra form field types and validation rules that we can use in our Flask WTF forms. Then finally down here on line 24, we're using the Flask Mail extension. This will allow us to send email through our Flask application. Now that we know which libraries have been added, let's go over configuring Flask Mail, and for that, I'll see you in the next lecture. See you then. In this lecture, we're going to go over a few mail settings and a custom library I wrote to send templated emails. If you haven't done so already, please head over to Section 11's folder in your Courses folder, and then open it up in your code editor. Then let's go ahead and build and run our Docker containers by typing docker-compose space up space --build, and then hit enter. This time it's going to take a little bit longer because not only do we have to install new packages, but we're also going to have to pull down a new Docker image, which is Redis, and we'll go more into that later. For now, I'm just going to pause the video and I'll meet you back when it's done. Okay, so now at this point, you should have 3 different Docker containers running. We have Redis up here, then we have the website, and then we have Celery. And we'll go into this in great detail later on. But for now, let's head back over to our code editor. Once here, go to the config folder, and then open up settings.py. There's been quite a few new additions here, so let's begin with the mail settings. All the values here are heavily documented in Flask Mail's documentation, so I'll leave you to researching them on your own if you want to know the nitty-gritty details, but let's go over them at a high level. If you were to send an email to someone without specifying a specific sender email, then the default sender settings email will be used, and that's what we're looking at right here. In our case, that would be contact@local.host. Of course, that's a fake email address, but for development purposes, it works fine. Next up, the mail server setting is your mail server address. The port and TLS settings will really depend on what mail server you're using. In our case, we're using Gmail, and it's configured for TLS, which is as secure as it gets. In case you didn't know, you can use Gmail's email servers for free up to a couple hundred emails per day. The last two values are for your username and password. Since this file would be commit to version control, it would be expected that you provide your real username and password settings in the instance/settings.py file. So head over to the instance folder and then open up settings.py. In development mode, I'm going to be sending emails through my Build a SaaS App with Flask Gmail account. And yeah, that's my real password, but it's going to be changed when I'm done recording the videos. Since we're here, it would also be a very good idea to supply in a custom server name if you happen to be using Docker Machine. This way you'll override the localhost port 8000 value that was set in config settings.py. In future sections, you'll end up copy-pasting content from this instance settings.py file, so it would be nice to keep all of your custom settings in one spot. The reason that we need to do that is because in each section of the course, we're getting a brand new instance.settings file, and you'll want to carry over your settings from a previous section. Don't worry about that, I'll show you how to do it on camera when the time comes. So that takes care of the config settings. So now let's check out the custom library that will let us send templated emails. For that, head over to the lib folder, which has been introduced to the project, and then open up Flask_Mail+. By default, the Flask Mail package has no concept of sending templated emails. That means we would need to set the body or HTML of the email as a plain string. That's pretty lame, so I went ahead and wrote the Mail+ library. It allows us to pass in any parameter supported by Flask Mail, but it also allows us to pass in a template and a context. The context will contain variables that will be substituted in the template. It's not important that you understand each line of this file, but I just wanted to make you aware of it. You'll see how to use it soon enough. With that said, let's move on to the next lecture where we go over the contact blueprint. I'll see you then. In this lecture, we're going to go over the new contact blueprint. If you haven't done so already, please head over to Section 11's folder in your Courses folder and then open it up in your code editor. Let's begin by heading over to the Snake Eyes folder, Blueprints folder, and then open up the Contact folder. There's a lot going on here. We have forms, tasks, views, and templates. And if we take a look here at the Templates folder and then expand the Contact folder, you'll notice that we have a new Mail folder, and that's going to be the email template. We even adjusted the base layout template to support Flash messages, and we'll take our first look at Jinja 2 macros. This will be all broken up into multiple lectures, but for now, let's start with the basics and check out the app.py file. Since we added a new blueprint, we need to register it, so on line 5, the contact blueprint has been imported. Then if you scroll down a bit here, we'll see that it's been registered on line 55. Also, if you continue to go down here on line 69, we've added a mail extension. Also, on the line below it, we've added another extension, which is a part of the Flask WTF package. The CSRF extension allows you to obtain a CSRF token in any template, but we'll go more into that later. Both new extensions have been added to the extensions.py file, and as a quick homework assignment, I'd like you to take a look at that before heading on to the next lecture. With that said, that's all there is for now. I'll see you in the next lecture where we take a look at the views for the contact page. See you then. In this lecture, we're going to go over the views file for the contact form. If you haven't done so already, please head over to Section 11's folder in your Courses folder, and then open it up in your code editor. Let's begin by heading over to the Snake Eyes folder, and then we'll go to Blueprints, Contact, and then open up Views.py. There's sort of a lot going on here, but the overall shape of this file is very similar to the page blueprint. We have a couple of imports up top, then we create the blueprint, and then we define the route. So if we take a look here at line 14, This route is a bit interesting. It's the first time that we've been exposed to a route that's going to handle both a GET and POST request. In case you're brand new to web development, GET and POST are HTTP verbs. Typically, form submissions are sent as a POST request, while rendering the actual form page itself is sent as a GET request. If you need to brush up on HTTP verbs or would like to learn more, then please pause the video now and Google for that topic. Okay, let's move on here. Since we haven't looked at the form or celery code yet, let's skip most of what this route does. I just want to concentrate on lines 25 and below. Line 25 sets up the flash message, which is functionality provided by Flask. If we scroll back up to the top of the file here, we can see that it's been imported on line 3. This is going to allow us to notify a visitor with a custom message. Flash messages are special because the message is set during the request, but it's not shown until the next request. In this case, we're just telling the user that we received their submission and will contact them soon. They will see this message after they've been redirected. We label it as a success because that's the type of message that we want to send. This will be styled with Bootstrap to be a nice green message. Alternatively, we could throw an error or a warning instead of success. Then, line 26 redirects back to the contact page. This is important because we want the form to be cleared out after the user submits it. We can do this by redirecting to the route endpoint rather than re-rendering the template itself. The URL for a function call that we see here is just rendering the contact blueprint's index route. We've seen this pattern used before in the layout HTML template. Finally, line 28 just renders the template. The form argument is interesting because this is how you send variables to Jinja 2 templates. In this case, we're sending a form object, which is provided by WT forms to the template. And if you look up over here on line 16, that's where it's being defined. Also, in case you're wondering, line 18 differentiates a GET and POST request. The form.validateOnSubmit function is a shortcut provided by WT forms. Basically, it means if the form has been submitted and there are no errors, then everything inside the if block will be executed. In other words, this would be a valid POST request. In this case, the very last action in the if statement is to return a response with Flask. So in this case, line 28 is only going to be rendered for GET requests. We still want to send the form to the render template call because maybe the user forgot to enter in their email address or a message, and we would like to display the form error. So that covers the view files for now. I'll see you in the next lecture where we go over the template files. I'll see you then. In this lecture, we're going to go over the templates and macros to handle rendering the contact form. If you haven't done so already, please head over to Section 11's folder in your Courses folder, and then open it up in your code editor. Before we get into all this, it would help to see the end result first, so make sure that you have everything up and running by typing docker-compose --up. Once everything is up, then head over to your browser. Then once here, just go to localhost port 8000 and hit enter. One thing that you might want to do is hide the debug toolbar. You can always get back to it by clicking this little gray box. The new contact page can be accessed in the footer. You can check out the contact link here by clicking it. It's just a simple form with a text field, text area, and button. By this point, you should have put in your mail credentials in the instance/settings.py file in a previous lecture. So go do that now if you haven't done so already, and don't forget that you need to restart the server when you change that file. Let's try putting in just an email address for now. So go ahead and enter foo@bar.com or something else, and then try to submit the form. You'll notice that it fails to submit, and the text area gets outlined in red. Notice how even after the form failed to submit, the email address is still populated. It's very important to do this in your forms, because otherwise visitors are going to get upset if the entire form gets lost because they incorrectly filled out one field. We get that functionality by sending the form variable to the template. If you remember back in a previous lecture, this is what we did in the views file. So now let's check out the template file to render this form. For that, let's hop back over to our code editor. Then head over to the Snake Eyes folder, Blueprints folder, Contact folder, Templates folder, Contact folder, and then open index.html. There's two new features of Jinja 2 that we haven't covered yet in this file. The first one are macros. On line 2, we're pulling in a form macro. You can think of Jinja 2 macros as functions basically. The as f part of the line just means we'll be able to namespace the form macros with a label of F. You can see that being used down here on lines 11, 14, and 18. Form tag and form group are both macros that we created in the form macro file. The with context on line 2 just means that any context that was sent to this file is available in the macro. In this case, if you go back to the views.py file and then head to the bottom of the file, you'll see that the form is being passed into the Jinja template. This can be defined as the context. So now let's take a look at this macro by heading over to the templates folder down here in the root of the Snake Eyes folder. Then we'll go to the macros folder and open up form.html. There's a lot to take in here, but nothing is super complicated. There's just a few functions to help us render Bootstrap-styled forms. For instance, let's scroll down a bit until we see the form group macro, which is over here on line 38. This macro expects you to pass in a form field as well as an optional CSS class. To see how it's used, head back over to the index.html file that belongs to the contact blueprint. Notice how we're passing in the form.email over here, and then down here on line 18, we're using form.message. Both of these are form fields that I've created with WT Forms. We just haven't looked at that code yet. In both cases, we want to add a little bit of a bottom margin to separate out the fields, so we're passing in a custom CSS class. We also set a custom placeholder on each field. A placeholder allows you to add help text inside of a text box, and that placeholder will disappear as soon as a visitor types anything into the box. We can see that in action by heading back over to our browser. For example, here in the question or issue field, we have the more we know, the easier it will be to help you. That's the placeholder, and as soon as we start typing, it disappears. So now let's go back to our editor. And from here, let's go back to our form macro. Then scroll back down. Lines 39 to 41 will detect if there's an error present in the form field. If there happens to be an error, then it adds a hasError class to the CSS class variable, which is what Bootstrap requires to color up errors with red. Then lines 53 to 50 handle rendering a checkbox slightly different than other field types. Line 47 sets up a standard Bootstrap form group div, and then line 48 calls a macro to render the label. We can take a look at this macro here, which is field label, on line 1. In this case, it either shows the form label as bold or not bold, depending on if the form field has been set as required. This is something that you would do with WT Forms, which again, we haven't looked at yet. So now let's head back over to line 49. The double star kwargs is a special Python trick, and that allows you to forward all extra keyword arguments passed into a function over to the function you're calling with double star kwargs. In this case, it means the placeholder attribute will be passed along to the field macro, even though we don't have it specified here as a keyword argument. So now let's scroll up here to line 26. All this does is set up Bootstrap styling on a specific field. And now let's head over to line 52. This renders any form errors for that field. This would be validation errors that we set up with WT Forms. We can scroll up to the top to find that macro over here on line 14. All it does is check for errors, and if there's an error, then it renders out a Bootstrap list, and for each error, it adds an LI, which is a list item. So now let's go down to line 53. This is a really powerful Jinja 2 feature. If you happen to have experience with Ruby, you can think of the caller macro as a block. If not, don't worry, we'll go over this very soon. For now, let's head back over to the index.html file. The last thing that we need to look at is the form tag macro on line 11. Notice how it, along with the other form group macros, are prefixed with a call keyword, and then each one has their own end call keyword. This allows you to call a macro, but also include custom output inside the call block. But before we get into that, you'll also notice the form tag macro has one argument passed to it. It's the route endpoint that it will be submit to. Notice how the legend, the form fields, and the submit button are all inside the call block for the form tag macro. Let's hop back over to the form.html macro file, and then jump down here to line 63. The caller macro is injecting everything we passed into the call block at this point in the macro. It allows us to pass custom form information to the form tag macro. This is super handy because it means we can use the same form tag to render any form. It also accepts a few arguments. The FID is an optional form ID. This is sometimes handy to pass in case you want to add JavaScript functionality to the form and need to reference the form by ID. It also accepts both a CSS class and method argument. The method defaults to post since most forms will be sent via post requests. Then it just sets up a standard HTML form tag. The action gets mapped to the route endpoint, and the other arguments get passed along as well. In addition to that, line 62 is pretty interesting. It's a shortcut provided by WT Forms, which automatically renders all hidden form fields. This includes a special CSRF token, which protects us against cross-site request forgery attacks. We'll go into that in more detail in a later section. So that was a lot to take in. Let's go back to the web page and submit the form successfully. So make sure that you have an email address and then some type of message, and click Send Email. This redirect screen is something provided by the debug toolbar. Some people love it while others hate it. It allows you to notice when a redirect happens. In this case, the debug toolbar is letting us know that we're about to be redirected to the contact page. This makes sense because if you remember back in the views file, we redirect to the contact page endpoint as the last thing in the function. If this bothers you, you can read the help text here and easily disable it on your own. Keep in mind this will only happen in development mode. So for now, go ahead and click the contact link, and you'll see that the form was submitted successfully and that the green flash message popped up. Let's go over one last template change to see how this was set up. So for that, head back over to your editor, and then go to the Templates folder, Layouts folder, and open up base.html. The first change here is on line 1, and that's where we're importing the Flash macro. Then down here towards the bottom of the file, on line 50, we're rendering it. So let's check that out by going to the Macros folder and then Flash.html. It just renders a Bootstrap-styled alert. The category argument allows you to specify what type of alert will be shown. In this case, we sent in a success, which sets the alert success class, which makes it green because that's what Bootstrap does. If you set it to info, you'll get a blue message, warning will give you orange, and error will give you red. This makes it very easy to notify users of different types of events. Also, if we go back over to the base layout file, there's been one additional change, and that's up here on line 11. We're adding a CSRF token to a meta tag, which will allow you to read in this value easily in case you happen to have an AJAX-powered form. This isn't needed for our contact form because a CSRF token has been already placed into the form itself, but I included it here because in the future, you may want to have an AJAX-powered form that requires this token. If you're wondering why this is needed, you may have a situation where you don't end up rendering a standard form tag, and instead, you may submit the form with JavaScript. You'll still want to include a CSRF token, and this allows you to read it easily. To solidify that, head back over to your browser. If we go ahead and view the source code here, we'll see that we have a CSRF token meta tag, which is what we just spoke about. But if you scroll down a little bit here, we can see another CSRF token, which is rendered as a hidden form field. And that's being supplied by WT Forms. So that wraps up everything related to rendering the contact form. I'll see you in the next lecture, where we go over creating the form with WT Forms. I'll see you then. In this lecture, we're going to go over creating the contact form with WT Forms. If you haven't done so already, please head over to Section 11's folder in your Courses folder, and then open it up in your code editor. Let's begin by heading over to the Snake Eyes folder, then go to Blueprints, Contact, and then go ahead and open up the forms.py file. We'll see that this file is pretty short. We're just importing a few field types and validators that we plan to use. In this case, our form is composed of an email field and a text area field. The email field is not part of WT Forms, and instead, it belongs to the WT Forms _components package. So first off, we define a contact form class, and it's going to inherit from the form class, which is provided by Flask WTF. We could name our class anything we want, but it's a good convention to end it with form since we're going to be importing it from other files. Then we just set our fields. The first one is an email field. The very first argument that we pass to it is the label. Then the next argument is a list of validation rules that we want to apply to the field. In the email field's case, we want to ensure that the field is required and that its length is between 3 and 254 characters long. For the text area field, we're doing the same thing, except the min and max length are going to be different values. It's a very good idea to always limit your form fields by a reasonable max length because it protects you from malicious users. A naughty user could set up a bot to continuously submit hundreds of megs of text, and that may result in your server's performance going way down. So now let's go ahead and take a look at the views.py file. You'll notice on line 9 that we're importing this form class, and then down here on line 16, we're instantiating it. Like we talked about before, line 18 detects if it's a valid submission or not. So let's quickly review the template file once more, and for that, head over to the templates folder, and then open up index.html. I just want to quickly review lines 14 and 18. Here we have the email field and the message field. Both field names match up to what we have over here, which is email and message. In the next lecture, we'll go into how we're using Celery to send the email to our inbox. I'll see you then. In this lecture, we're going to go over configuring and using Celery to send emails. If you haven't done so already, please head over to Section 11's folder in your Courses folder, and then open it up in your code editor. Then make sure that your Docker containers are running by typing docker-compose --up. Once complete, head over to your browser, and then go to localhost port 8000/contact. We'll get back to this later, but for now, let's hop back over to our editor. Once here, then head over to the config folder, and then open up settings.py. In case you forgot from a previous lecture, Celery can be configured to use Redis as a backend. Lines 15 and 16 let Celery know to connect to Redis. In this case, it's connecting with a password of devpassword, and the host name is literally Redis. We can do this because inside of Docker Compose, Redis has been added to the mix and is also part of the same network as our Flask app. We'll get into that in the next lecture, but for now you can use wishful thinking and assume this connection string just works. The 0 at the end is the name of the Redis database. This is the default database name with Redis. It's not important to understand the lower level details of Redis, but I wanted to make you familiar with the connection string since it's something that you may end up changing on your own if you decide to ever deploy your application to production. Lines 18 through 20 tell Celery to accept only JSON data and to serialize it to JSON as well. This is a security precaution because Celery will pickle tasks unless you disable it. You could end up leaking information by accident without limiting it to JSON or other serializers supported by Celery. Long story short, just leave those as is and you're good to go. The last line here on 21 protects Redis from getting overloaded by connections. Celery by default will open a new Redis connection for each task being executed, and this may be an issue on some hosting providers. So this gives us a way to limit the max connections. For development, 5 is plenty. Now that we have Celery configured, let's check out the tasks file in the contact blueprint. So for that, head over to the Snake Eyes folder, Blueprints, Contact, and then open up tasks.py. In a previous lecture, we mentioned the Mail Plus library, and that allows us to send templated emails. So we're going to be using that here. We also import a create Celery app function from our app.py file, and then we go ahead and create an instance of that. We'll go over that function soon, but for now, let's continue unwinding this file. Declaring a Celery task is easy. You just create a Celery.task decorator, and then define the function that you want to run. In this case, it's a deliver contact email function that accepts both an email address and the message. Then we just use the Mail Plus library to send the email. There's nothing too fancy going on here. This is where you would configure the subject, sender, recipients, and so on. You'll also notice that we're referencing a mail template, so let's check that out. If you go to the templates folder over here, then go to contact, mail, and then open up index.txt. It's a very simple template that just provides the sender's email and the message. They're available because we define them in the task file. So let's head back over to that tasks file. You'll see them defined over here in the context variable, which in turn is sent in as an argument to the send template message function. So now let's take a look at the views.py file to see how this function is called. The first thing that we have to do is import the deliver contact email function, and we're doing it inside the actual route here instead of up top. Otherwise, we would get a circular import. Then down here, we're calling the deliver contact email function with a .delay. .delay is a feature of Celery. This just tells Celery that we want the task to happen in the background, and it's going to go ahead and fire it off as soon as it can. After that, we just pass in the form fields, which is the email and then message. So that takes care of wiring up and using Celery. The very last thing that we need to do is go over the create celery app function, which is in the app.py file. So let's check that out. First up, we're importing celery on line 2. And then over here on line 8, we're defining a list of celery tasks. This list is going to grow as we add more background tasks to the application. The create celery app function is over here on line 13. It's a bit deep, but really all it's doing is creating an instance of celery, and then it configures the broker based on our configuration parameters, and then sets up the celery task list. Down here on lines 28 through 35, we're just setting up a context for each task. The implementation details aren't terribly important. Just understand that if you plan to ever access your database in a task, then the app context will need to be set. That's basically what these lines are doing, and it was mainly pulled from a code snippet provided by the Flask author. Now that we know how it all works, let's head back over to our browser. Then go ahead and submit the form. And like before, go ahead and click through here, and at this point, you should receive an email to whatever you have configured as the mail username. If you don't see an email, then make sure that you have the correct login details in the instance/settings.py file for your mail server. If you're not using Gmail, then you will definitely have to change the mail server value, and you may need to change lines 9, 10, and 11 as well. If that's the case, then I recommend copying all 4 settings and putting them into your instance/settings.py file. With that said, I'll see you in the next lecture, where we go over how Redis is being ran with Docker Compose. I'll see you then. In this lecture, we're going to go over a few changes to the Docker Compose file. If you haven't done so already, please head over to Section 11's folder in your Courses folder, and then open it up in your code editor. Once here, then open up the Docker Compose.yaml file. There's a few new concepts that we need to go over. First up, we have a new service, which is for Redis. It's going to pull down the latest Redis 3 build that uses Alpine as a base image. We're using image instead of build because this image already exists for us on the Docker Hub. The Docker Hub is a centralized place to download both official and non-official Docker images. You'll be able to find hundreds of high-quality official images for popular services and tens of thousands of images made by the community. I've linked to the Docker Hub in this lecture's notes if you want to check it out. Think of it like GitHub, but for Docker images. Then going back to the Docker Compose file on line 6, we're overwriting the default Redis service command by running it with a password. It's a very good idea to use Redis with a password for security reasons, however, it's not enabled by default. In this case, the dev password must match the one in your config settings file. Then, just like the website service, we're using the volume and exposing a port. Port 6379 is the default port for Redis. Also, in the case of the Redis volume, we're using a feature of Docker called name volumes. The Redis volume name will be automatically prepended with the Docker Compose project name, which would be Snake Eyes, and that's all going to be managed by Docker. This volume is going to allow data from Redis to be persisted to disk. We need to do this because Docker containers are not persistent. If you start a container and then stop it, any changes that you've made to the container will be lost. Having a volume like this will save the data to your workstation so that the next time you start the container, the data will be loaded into the container. This volume name is tied into the volume's namespace, which we have down here on line 34 and 35. Next up, we have a new Celery service. Celery itself runs as a dedicated process, and it uses the same Docker file as the main application, and instead of running gunicorn, we just override the command to run Celery instead. The L flag just sets the log level, which could be set to info, debug, and more. Then the A flag expects you to pass in a file that contains your tasks. Also, we're using the same environment file as the website because we want Python unbuffered to be set to true. Lastly, we also mount in the app code as a volume, just like the website. So that's all there is to it for configuring Docker Compose to run more than one container at a time. However, there's a couple of things to clarify in the terminal before moving on to the next lecture. For instance, if we go back to the config folder and then open up settings.py, you'll see here that we're referencing Redis by the Redis hostname. This is because we're taking advantage of a networking feature of Docker. Docker Compose automatically created a network for us, and that network allows for services to talk to each other by hostname. The hostname in this case would be the name of the service. So now let's head back over to our terminal. At this point, you could stop Docker Compose by pressing Ctrl-C. Then, like we've done before, go ahead and type docker-compose space stop. So now let's go ahead and check out our Docker network. We can do that by typing docker space network space ls and then hit enter. This command is going to return back all Docker networks on your system. In our case, we have a network called snakeeyes_default, and that's because it's using the same Docker Compose project name as a prefix. The default was added because we're using the default Docker network. The other 3 networks have been created for you by Docker automatically, and we don't have to worry about them. In addition to viewing networks, you can also remove them. I won't do this on camera, but you could run docker space network space rm space, and then you would supply the name of the network that you want to delete. In this case, we would use snakeeyes_default, but like mentioned previously, I won't be running it. So let me just go ahead and clear the screen now. And before moving on to another command, I just want to say that networks are automatically created when you run Docker Compose up. The last thing I want to go over is managing Docker volumes. To list all the volumes on your system, you could run docker space volume space ls and then hit enter. As we can see here, we have our volume for snakeeyes_redis. In a similar fashion to networks, you can also run docker space volume space rm space and then pass in the volume name that you want to delete. Okay, so at this point, we've actually went over everything Docker related in the course. The rest of this course will just be adding to what you've already learned. Let's wrap up this section by going over a few new tests that were written to ensure that the contact form works. And for that, I'll see you in the next lecture. See you then. In this lecture, we're going to go over a few new tests that were written to make sure the contact form works. So if you haven't done so already, please head over to Section 11's folder in your Courses folder, and then open it up in your code editor. Then make sure that Docker Compose is running by typing docker-compose space up. Once everything is good to go, then head over to your editor. The first thing that we'll do is take a look at the new tests. So please go to the Snakeeyes folder, then go to the test folder, then go to contact, and from here, we'll take a look at the test views file. It's pretty similar to the page test that we looked at previously, but this one handles testing the post request. In addition to that, a new test library function was created, which is imported on line 3. But before we go over that, let's take a look at the test contact form function first to see how it all works. Since we need to fill out a couple of form fields, I've placed them all into a single dictionary. Then on line 19, we're using the test client to send a post request to the contact page. The data being sent in is the form fields that we populated in the dictionary above. Finally, we tell the Flask test client to automatically follow redirects. Then we just perform an assertion that the result of the redirect is a 200 and that the response contains the text thanks. Thanks is part of the Flask message that we would expect to see. So now let's take a look at the lib folder, then we'll go ahead and open up test.py. This is a custom assertion called assert status with message. All it's going to do is check to see if a message is contained within a response. The first thing it's going to do is assert the status code. It's going to do that by comparing the response status code to the one that we pass in. Then it's simply going to assert that the message we pass in exists in the response.data. The response.data is the HTML source code. This is a convenience function because oftentimes you'll want to test for a specific status code and a message. So now let's take a look at the test tasks file, and for that, head back over to the contact folder within the test folder. This test case kills 2 birds with 1 stone because it demonstrates on how to test a Celery task and also shows how you can interact with the Flask mail extension's inbox to test for messages. Like before, we're just populating a dictionary with a couple of form fields. Then on line 13, we're reaching into the outbox of the Flask mail extension. Within this, we're delivering the contact email like usual, and then asserting that the outbox's length is 1. This is because we would expect 1 message to be delivered. Finally, we do another assertion, which checks to see if the email address exists inside of the body of the first message in the inbox. So with that said, let's head back over to our terminal. Then from here, go ahead and open up a new tab. Then go ahead and run a test suite by running docker-compose space exec space website space snakeeyes space test, and then hit enter. After a couple seconds, it's going to go ahead and run all the tests, and you should see 6 passing tests. If you get any failures, then chances are your mail server isn't authenticating properly. We can also run a test coverage just to see how much of the contact page has been tested. So go ahead and hit the up arrow, and then backspace out the test, and replace that with cov. Then hit enter. Things are looking pretty good, and we're still at 100% coverage. So now let's go ahead and jump over to the other tab and stop Docker by pressing Ctrl-C. And then like usual, we'll do a docker-compose space stop. Since we're on the last lecture of this section, let's go ahead and clean up our Docker mess. We can do that by typing docker-compose space rm space -f, and then hit enter. Now would be a good time to remove dangling images if you haven't done so already, and for that, please consult with this lecture's notes. So we've covered a lot about Flask, but there's still much more to discover. At this point, we have an excellent, well-tested base application to work off of. I'll see you in the next section where we create a full-blown user system. I'll see you there. In this section, we're going to go over creating a full-blown user system. First, we'll look at the requirements.txt file to see what changed. Then we'll go over a few new settings to configure our database and user blueprint. After that, we'll review what was created to make the user blueprint. Then we'll go over our first database model, which happens to be the user model. Along the way, we'll briefly go over how relational databases work. After that, we'll go ahead and initialize the database. Once we have that out of the way, we'll cover each component of the user system, such as logging users in and out, registering and welcoming new users, and updating user settings along with resetting passwords. After that, we'll go over a few changes that occurred in the home and contact blueprints. Finally, we'll confirm everything works by going over some new tests. I'll see you in the first lecture where we go over changes to the requirements.txt file. See you then. In this lecture, we're going to go over a number of new packages that were added to the requirements.txt file. So please head over to section 12's folder in your courses folder and then open it up in your code editor. Once here, then open up the requirements.txt file. First up, on line 15, we're using psychopg2, which is the de facto standard Python library to communicate with a Postgres database. Next up, on line 16, we have Flask SQL Alchemy. This is a Flask extension that makes using SQL Alchemy a bit easier with Flask. We need both libraries because this will be the first section where we introduce using a relational database. The other new addition is at the bottom of the file. Flask Login is a great little extension that gives us a way to build up a user login workflow. It handles logging in and out, along with session management and cookies. In case you're an experienced Flask developer and are wondering why we're not using Flask Security, it's because that extension has way too many opinions. Most real web applications have a very custom user solution, so rather than hack around limitations imposed by Flask Security, it's much easier to build our own custom user-related workflows on top of Flask Login. Now that we know which libraries have been added, let's go over configuring a few settings, and for that, I'll see you in the next lecture. See you then. In this lecture, we're going to go over a few user settings. If you haven't done so already, please head over to section 12's folder in your courses folder, and then open it up in a code editor. Once here, then head over to the config folder, and then open up settings.py. Our changes start here on line 25 and go all the way to the bottom of the file. In order to use Postgres through SQL Alchemy, we need to let SQL Alchemy know how to connect to Postgres. We're setting up a connection string that's very similar to what we did with Redis, except now it's for Postgres. Postgres has also been added to our Docker Compose file, which we'll go over later. In this case, we're setting the Postgres user to be Snake Eyes, and the password will be dev password. Then we're connecting to the Postgres hostname on the default Postgres port. Lastly, the database name will be called Snake Eyes. The Postgres user and database will be automatically created for us by the Postgres Docker image as soon as we start it. However, it's not going to use these values to set the username, password, and database. The values that it's going to use are stored in the .env file. The Postgres image expects you to provide a Postgres user and a Postgres password. It will also create a default database with the same name as you have supplied for the Postgres user. So it's very important that the Postgres user and password matches up to what you have here in the settings.py file. If you wanted to change your password at a later time, you would have to use Postgres' database management tools, such as pSQL, to do that on your own. I recommend keeping the username and passwords as their default values for this course, and then you can go ahead and use different values on your own projects later. If we go back to the .env file one more time, it's worth mentioning that I've done a little bit of refactoring in the Docker Compose.yaml file. Instead of setting environment variables in the Docker Compose YAML file directly, I've moved them all here to the .env file. So if you head over to the Docker Compose.yaml file, You'll notice that the environment parameter has been removed from the website service, and instead it's been replaced to reference the .env file. Also, since we're here, it's worth mentioning that we have a new Postgres service. As you can see down here on line 7, it's also referencing the same .env file. That's how it's pulling in the Postgres user and Postgres password environment variables. Also, it's pulling in Postgres 9.5, and I've linked to this image on the Docker Hub in this lecture's notes. Before moving on, we also have a Postgres volume, and Postgres' port is 5432. If you scroll down here to the very bottom of the file, we'll see that we have a volume defined for Postgres, just like we did with Redis. One last thing I want to mention is, if you had a ton of environment variables for different services, and you wanted to keep them all separated, you can do that too. You can name these .env files anything you want, and then reference them with env_file. This parameter also accepts a list of files if you want to use more than one. The only thing worth mentioning is the Docker Compose project name must be included in a .env file. With that said, let's head back over to the config settings file. Next up, the SQL Alchemy track modification setting has been disabled. SQL Alchemy has a feature to emit signals when a database object changes. This has a substantial amount of overhead associated to it, and since we won't be using signals in our application, it's a good idea to disable this feature. Future versions of SQL Alchemy will have it disabled by default. In fact, if you don't set it to true or false in your settings, you'll get a warning from SQL Alchemy. So that takes care of configuring the database, but now we also need to configure a few user-related settings. Lines 31 and 32 are for creating an initial user in the system. This is typically referred to as seeding your database, and that term is used in many different web frameworks. You could seed your database with more than just an initial user, but in our case, that's all we're going to do for now. Feel free to change these if you want, but on camera, I'm always going to be using this username and password. However, in production, you would likely put your real email account and a much stronger password in the instance settings file. The last config option that I want to go over is the cookie duration. This setting belongs to the Flask login extension, and we're just saying that we want login cookies to last 90 days by default. This way, if a user signs in, they will be logged in for 90 days unless they manually log out themselves. Okay, so that takes care of this config file, but there's one more thing that we need to go over, and that's the instance/settings.py file. Like I mentioned before, each section of this course has its own source code, so that means your instance/settings.py file will get reset each section. So please head over to your courses folder, and then once here, go to the previous section, which was section 11, and then go to the instance folder, and then open up settings.py in whatever code editor you have on your operating system. Then go ahead and copy the contents of this file, and then paste it in here to replace section 12's instance/settings.py file. Once complete, then save the file. I know, it's a minor inconvenience, but you only need to do this once per section, and when you're coding a project on your own, it's a step that you'll never have to do. So that takes care of this lecture, and I'll see you in the next one where we go over the high-level details of what makes up the user blueprint. I'll see you then. In this lecture, we're going to go over the user blueprint. If you haven't done so already, please head over to section 12's folder in your courses folder, and then open it up in your code editor. Let's begin by heading over to the Snake Eyes folder, Blueprints folder, and then go to the user blueprint. This blueprint has even more going on than the contact blueprint. On the bright side, a lot of functionality in this blueprint should be familiar to you because the overall patterns and ideas are very similar to the contact blueprint. We'll go over all these files in due time, but for now, let's go ahead and open up the app.py file. Line 7 imports the user blueprint as you would expect. Then lines 13 and 14 import a few extensions that we spoke about earlier. And we can see those extensions in the extensions.py file. DB in this case is an instance of SQL Alchemy, and Login Manager belongs to Flask Login. Okay, so let's go back to the app.py file. Since we're going to be dealing with additional Celery tasks, they've been added to the Celery task list. If you jump down here to line 66, we'll see that we're registering the user blueprint. And if we scroll down a little bit more, we'll see that we're initializing the DB and Login Manager as an extension. The last main addition to this file is the Authentication function, and we'll go over that in a future lecture. With that said, that's all there is for now. I'll see you in the next lecture where we go over the user model. See you then. In this lecture, we're going to go over the user model, but before we do that, let's have a quick crash course on what a database schema is and how relational databases work. A database schema defines the structure of your database. For example, if you had a user model, then you would end up with a users table in your database. Then inside of that table, you would have a number of different columns to describe various pieces of information about each user. It would be reasonable to consider saving things like their email address, encrypted password, when they signed up, and so on. Each user would be saved in its own database row. The rows contain your data, and the columns describe what the data is. It gets a lot more complicated because each column can have all sorts of interesting options applied to it. And then there's the whole topic of relating data between tables. This is why Postgres is labeled as a relational database. Imagine a situation where you have a user model and a payment model. It might be reasonable to associate a payment to a user. You would want to be able to answer questions like, give me a list of all payments that belong to a specific user. Or maybe you'll want to answer, show me a specific payment for a specific user. We'll go over how to write database queries to perform queries like this and much more. But for now, let's start by just going over the initial user model. And for that, please head over to Section 12's folder in your Courses folder and open it up in your code editor. Once here, head over to the Snake Eyes folder, and then go to the Blueprints folder, and then finally open up the user blueprint. Once there, open up the models.py file. There's a lot going on here, but we're only going to concentrate on a very small segment of the file for now. Let's begin with line 18. This is where we define the user model itself. Using the power of Python, we're inheriting from a few different classes. Just for now, let's imagine that the user mixin doesn't exist, and instead, only concern ourselves with the resource mixin and DB model classes. If we glance up here at line 15, we can see that we're importing the DB extension, which is how we gain access to this object. It's something provided by SQL Alchemy. Having a model inherit from DB model automatically makes it capable of working with SQL Alchemy. The resource mixin is a special class that I've written to add common functionality to a SQL Alchemy-driven model. If we look up here at line 14, we can see it's being imported from a SQL Alchemy util module. So let's go ahead and open that now. That's going to be located in the lib folder, and then it's going to be down here in util SQL Alchemy. We'll eventually look at that aware datetime class, but for now, let's look at the resource mixin, which is over here on line 28. This class's purpose is to save you time and energy when working with SQL Alchemy. Imagine for a moment that you had 20 models in your project, and you wanted all 20 models to share common column names or functionality. Instead of duplicating that information 20 times, you can just create a class like this and then inherit from it. In our case, we're creating two different columns. The first one will automatically save a timestamp when a record has been created, and the next one keeps track of when a record was updated. They're going to end up as database columns because we're calling db.column and then supplying specific information about the column. The first argument is the data type of the column. There's a lot of column types that you can choose from, such as strings, integers, booleans, and more. In this case, we're using a custom datetime type, and the implementation details are up here in the aware datetime class. But honestly, you don't need to know how this works in great detail, just like you wouldn't care how the string data type is implemented. The only thing that you need to know is that it's a very, very good idea to save your dates in a consistent format. I highly recommend saving your dates in UTC format, and that's what we're going to be doing in this course. It's also really important to save time zone information inside of your datetime types, because that's going to make it easy to localize your dates for users later on. This is actually a pretty complex topic, and it's one of those things that a lot of other training material glance over, but it's super important in my opinion. This aware datetime class is going to handle everything that I just talked about for us automatically. So now let's head over to line 31. This is where we're setting a default value for the timestamp, and it's using a function called tzwhere_datetime. This function is being imported up here on line 6. It's coming from a utility datetime file, which belongs to a library that I've written. We can go ahead and check that out over here. All it does is create a time zone aware UTC timestamp. Now let's go back to the SQL Alchemy file. Then head down here to line 36. Normally, to save a record with SQL Alchemy, you need to add it to the database session and then commit it. I really like how they separate these steps because sometimes you'll want to create an object in memory but not save it to the database. However, most of the time, you'll want to save it to your database. So I've created a save method here that does both adding it to the session and then committing it to the database. Likewise, the delete function follows the same pattern. The only difference is this deletes the record instead of saving it. The last method overrides the Python double_str method, which allows us to define how our model will be output in text if you decided to print it to the terminal. It's not important to understand how it works, but just know that it outputs your model in a human-readable way by showing you the column name for each field along with its value. If this method didn't exist and you tried to print out a user, all you would get back is a Python object ID, which doesn't really help us at all. So now let's continue going over the rest of the user model by hopping back over to the models.py file. Line 24 lets us define the database table name. Out of convention, database table should be plural and lowercase, while the model name is singular and begins with a capital letter. Then down here on line 25, we're setting up an ID column on the table. It's an integer, and it's our primary key. Primary keys are special, and they uniquely identify each row in a table. In most cases, incrementing an integer does the job nicely. But if you're dealing with billions of records or performing complex database operations like sharding, then you may want to use a UUID format instead, but for 99.99999% of use cases, an integer is fine. Then we have a few authentication-related columns. The role is going to let you distinguish certain types of users. In our system, we'll have the notion of a regular member and admins, and this is going to be defined as an enum type. And you can also see the row constant defined up here on lines 19 through 22. We're using an ordered dict, which is a standard Python utility. It's useful to be able to reference a role by key, which is the lowercase version, and then retrieve the value, which is the human-readable version that we see over here. The reason why we're using an ordered dict is because later on we may want to loop over this value to display a drop-down box on the website, and we'll want the order to be kept track of because in Python, dictionaries aren't guaranteed to be output in the same order that you define them. If we head back over here to line 28, we have a lot of options being set. The name, as you would expect, allows us to customize the name of the enum. For enums, it's a good practice to name it a pluralized version of what you're creating the enums for, followed by an underscore types. Then we're telling SQL Alchemy to not use the native implementation of enums because working with native enums in Postgres can be very annoying. For pretty much every use case, this will be fine. We're giving up a very, very tiny amount of performance to not have to deal with headaches in the future if you ever decide to add or remove role types to an enum. The index option allows you to set up a database index. This course would get way too long if we went into extreme detail on all this stuff. Just understand that database indexes are extremely important and you should research them on your own. An index will allow your database to perform a lookup on this column in a very efficient way. The difference between a database having poor indexes and good indexes might be the difference between retrieving data in minutes instead of milliseconds. This course will use a general best practice on setting indexes by indexing columns that you'll likely end up filtering or searching on later. The next option will set nullable to false, meaning the column can never be null. If it were to be null and you tried to save it, then you would get a database error. However, to offset not having to always set this value explicitly, we set a server default value of member, which is one of the role choices which we can see up here. Next up, we have an active field, and we need to rename this database column to isActive to satisfy a requirement of the Flask login extension. Normally, if you don't supply the database name here, it's going to use whatever you have as the variable name as the database column. In this case, we would have a role column, and in this case, we would have an isActive column because we defined it here. In this case, the column type is going to be a Boolean, and it's going to default to true because we want all users to be active from the moment they sign up. If a user were trying to abuse your system or are up to no good, you could disable them from logging in by deactivating their account. That's why this field exists. Then we have the username, email, and password fields. Each of these are strings, and they have different max lengths. For instance, the username can only be 24 characters long, while an email is 255 and the password is 128. You could always set these to different values if you want, but that's what I set them for now. It's always a good idea to set constraints at the database level when you can. The username and email field are both being flagged as unique. This means that the database is going to throw an error if you try to save duplicate usernames or emails. We protect against that error at the form level with validations, and we'll see that in action in a later lecture. In the case of the username, it doesn't have nullable false, which means by default, it will be null if no username is supplied. That's okay for us because usernames are going to be optional. The rest of the columns down here keep track of various sign-in data, such as the number of times a user has signed in, as well as the current and last sign-in times and IP addresses. It's a good idea to track this information because it can help handle disputes in cases where an account is compromised. It's also a good way for you to see if someone is sharing their account. Out of these 5 columns, the only new thing to look at here is the sign-in count column. This one is an integer column, and it's going to default to 0. So that's the user model. It's going to grow in time, but for now it's enough to handle users being able to sign up. We'll go over the rest of this file in due time, but for now let's move on to the next lecture where we initialize and seed the database. I'll see you then. In this lecture, we're going to go over how to initialize and seed the database. If you haven't done so already, please head over to Section 12's folder in your Courses folder, and then open it up in your code editor. Then make sure that everything is built and running by typing docker-compose space up space -- build, and then hit enter. This time it's going to take quite a few minutes to build because in order to connect to Postgres from our Python app, our Docker image will need to compile a few extensions. We can check this out by going back over to our code editor and then heading to the Docker file. The new addition to this file has been added to the end of line 4. This is not really Docker specific because any system would need to install this dependency. The only difference is on non-Alpine based systems, the package name might be different. For instance, on Debian based systems, you typically install libpq-dev instead of postgresql-dev. So, with that said, let's head back over to our terminal and see where we're at. It looks like things are still going, and it's going to have to pull down the Postgres image, which is about 250 megabytes. I'm going to pause the video now, and I'll meet you back when it's done. Okay, great. So at this point, you should have everything running. If we take a look here at the top, we'll see that the Postgres image has created a database as well as created a role for us. In Postgres terms, create role means create user. So now let's go ahead and open up a new terminal tab. And then let's check out the new DB commands that we can run. And we can do that by typing docker-compose space exec space website space snakeeyes space db, and then hit enter. Previously, our commands only had one command associated to it, but the db command is different because it houses 3 separate commands. This is a feature of Click where you can create a group of commands. In this case, we have commands to initialize the database, reset the database, and seed the database. Let's see how all this is implemented by heading over to our code editor. Then from here, go ahead and open up the CLI folder, commands folder, and then open up the db command. Let's look at lines 14 to 17 first. This sets up the group with Click. If we scroll down to the bottom of the file, you'll see how to add the commands to the group. In this case, each of the commands are simply functions decorated by Click commands. This is very similar to what we've seen beforehand. So let's start by going over the init command, which we can see up here on line 20. And this command is responsible for initializing the database. Flask SQL Alchemy allows us to easily drop and create all objects in a database by running these commands. This is going to purge the database and then recreate the database based on our models. If you scroll up here to line 6, we're importing DB from the extensions file. We saw that in a previous lecture. Lines 33 to 37 optionally create a test database for us. By default, this is turned off because we wouldn't want a test database created in production. It's a very good idea to create a separate test database so that you can run tests in development without clobbering over your development data. SQL Alchemy allows us to easily create databases. So all we do is pass in our SQL Alchemy config settings and then append an underscore test to the database name. Next up, let's check out the seed command on line 43. The first if statement checks to see if the seed user already exists. If it does, then it just aborts the function because there's no point recreating it. Otherwise, we set up a few values to set the user. The seeded user is always going to be an admin, and then we pull out the seed admin's email and password from our config settings. Then line 58 just saves the user record to the database. The save method exists because it was created in the resource mixin that we looked at in the previous lecture. Also, just as a reminder, if you haven't worked with Python too much, the double star params means it's going to take the params dictionary and convert them all to keyword arguments. It's a nice little shortcut for saving a dict to a database record, and you'll see this pattern used quite a bit in this course. This works because if we head back over to the user model, which you can find in the snakeeyes folder, blueprints folder, user folder, and then open up models.py, and then head over to the constructor function for the class, which is on line 44. It passes all the keyword arguments over to SQL Alchemy's constructor for this model. It also happens to automatically encrypt the password with a method that exists on the user model. If you scroll down to line 63, you can see the implementation of that. It's just a class method that hashes the password. The generate password hash function is built into the WorkZorg security module and is a part of Flask. It uses the pbkdf2 function to hash the password. If you're wondering why we're not using bcrypt, it's because pbkdf2 is deemed good enough by the National Institute of Standards and Technology. In other words, it's an extremely strong password hashing strategy. Not using bcrypt also means we have one less dependency to deal with because pbkdf2 comes with Flask. So now let's jump back over to the db command file and wrap things up. The last function here is for resetting the database. This has a new decorator that we haven't seen yet, and it allows us to pass in the click context to the reset command. Doing this allows us to invoke a different command directly. It's a very flexible way for us to run commands from another command. And if you take a look here at line 72, we can even pass in click options to the command that we're going to be running. In this case, the reset command just does an init for us, and then it goes ahead and seeds the database. With that said, let's head back over to our terminal. Then go ahead and reset the database with the test database. We can do that by typing docker-compose space exec space website space snakeeyes space db space reset space dash dash with dash test db, and then hit enter. And about 1 second later, we have everything reset. Now that we know how to initialize and see the database, let's look at logging in and out. I'll see you in the next lecture where we tackle that. I'll see you then. In this lecture, we're going to log in and log out as the seated user. If you haven't done so already, please head over to Section 12's folder in your Courses folder, and then open it up in your code editor. Then make sure that everything is running by typing docker-compose space up. Once complete, head over to your browser. Then from here, just go to the home page by going to localhost port 8000. You should see what I see. Check out the top right area of the navbar. There's a few new menu items related to the user system. So go ahead and click the login link, but before we get into logging in, it's important to go over how the base layout has been refactored since the previous section. In case you didn't catch it, the login page has a completely different layout than the main website. Even the footer links down here are different. I'll go back just so you can see the change. Notice how the main homepage has a navbar up here with some menu items in the top right, and then down here we have 3 footer links. If we go back to the login page, you'll see that it has no menu up top, a larger logo in the middle, and only one link down here in the footer. So let's see how that's implemented by going to our code editor. Let's start off by going to the Snake Eyes folder, and then we'll go to the Templates folder, and then Layouts folder. You'll notice now that there's 3 different layouts. We have app.html, login.html, and our original base.html. Let's first go over how the base.html file changed by opening it up. Then scroll down over here to line 29, where I've added a new block called header. Then down here towards the bottom of the file, I've added a new block for footer, which is on line 42. This footer block is embedded inside of the footer list. So now let's go ahead and open up the app.html file. It extends the base layout, and the entire navbar is contained here within the header block. We'll explore that in more detail later, but for now, let's scroll down here to lines 38 and 39. These are the links that we saw in the menu before. Lastly, if we scroll down here to line 47, we can see a couple of footer links. Here we have one for the contact page, privacy policy, and terms of service. We want our app layout to have the main footer links, so that's how they're being injected into the base layout. Now let's take a look at the login layout, which we can find over here in the sidebar. Just like the app layout, it extends from the base layout, and it also has a header and footer. In this case, the header is just a gigantic logo that links back to the homepage. And then down here in the footer, we just have one link, which is sign up today. This gives the login page a very focused feel to it. It doesn't need to be cluttered with information that isn't related to logging in. With that out of the way, let's go ahead and log in as the seed user. And for that, let's go back to our browser. If you didn't change the seed information, then you'll be able to log in as dev@local.host as the email address. Let's first try to log in with an empty password. So just click sign in. You'll see here we have a form validation error that tells us the password is required. So now let's really log in by supplying the password, which if you didn't change it is dev password. Once you have that typed in, then go ahead and try to sign in. Then click through to the settings page. We won't be going into the settings page just yet, but notice the top navigation has changed. Instead of it saying login and sign up, it has an account drop-down menu. If we go ahead and click the logo over here to go back to the homepage, you'll see that the account menu still exists. So go ahead and click that, and then proceed to log out. And that's going to bring us back here to the login page. Now that you know how logging in and out works from the user's perspective, let's go over how it was all implemented. For that, head back over to your code editor. Let's begin by going over the app.py file. We covered just about everything that was new in a previous lecture, but we haven't looked at that authentication function just yet, which was at the bottom of the file. Also, if we scroll up a little bit here, we can see that it's being called on line 68. It expects us to pass in both the Flask app as well as the user model. This model is being imported at the top of the file. So let's go back down here to the authentication function and check it out. The authentication function is required by the Flask login extension. One of the great things about Flask login is that it doesn't care about your database or how you define a user. You could be using Postgres, MongoDB, or even just a Python class to store users if you wanted. One of the requirements of this authentication function is that it contains a load user function with this decorator. This is where you can define how to load a user. In this case, it takes the user model that we pass in and performs a get query on the user ID, and it's going to return a user instance from the database. The implementation of this function is up to you. Since we're using Flask SQL Alchemy, we're just using standard SQL Alchemy features to look up a record in Postgres by the ID, which is the primary key. Then up here on line 98, we're informing Flask login of which view contains our login logic. We haven't looked at the views yet, but just know for now that we have a login view. The last part of this function defines a token loader. Flask login is very flexible, and it allows us to implement what data we want to save in a cookie and how that data is being stored. This token is going to contain a serialized version of a user record. It would be really sloppy to store something like a user's email address or password directly inside of a cookie in plain sight. If we did that, then anyone with access to that user's machine could easily find out their password, which is a big security concern. Instead, the user record will be encrypted into the token that we generate here. Line 107 uses the It's Dangerous package to generate a token. This package is a dependency of Flask, and it's very handy for creating tokens among other things. Notice how it accepts the secret key as an argument. This secret key will be used to sign the token, and this is why it's so important to keep your secret key private and safe. If someone were to gain access to this key, they would be able to decrypt or deserialize what's been saved to a user's cookie. The rest of the function just loads the encrypted data, picks out the user ID, and does a lookup in our database. It returns the user record in the end. All of this is necessary to allow someone to log in with a saved cookie in a secure way. Now that we know how it works, let's head over to the user blueprint and check out the views file. For that, head over to the blueprints folder, user folder, and then go ahead and open up views.py. Let's start with the logout route first, since it's a bit easier to understand. We can find that down here on line 63. The login required decorator is something provided by Flask login, and that's imported up at the top of the file. This decorator protects the route so that it's only accessible if a user is logged in. To demonstrate that, head back over to your browser, and then if you followed along before, you should be logged out. If not, go ahead and log out yourself. Then go up to your address bar, and then try to log out manually by accessing /logout. Once you have it typed out, hit enter. You'll notice that you're going to get redirected back to the login page. In addition to that, you'll see an error notification here saying that you need to log in to access this page. So if you want a route to be protected such that only logged in users can see it, that's all you have to do. So now let's head back over to our code editor, and then we'll check out the rest of the logout function in the views.py file. The logout user function is also provided by Flask login, and it's imported at the top of the file. Calling this function deletes the user session under the hood, then we step in and add a Flask message that informs the user that they've been logged out, while also redirecting them back to the login page. It's impossible to say where the user would like to go after logging out, but it's reasonable to direct them back to the login page. Now that we know how logging out works, let's check out logging in, and for that, scroll up to about line 30. In terms of complexity, it's a little bit more complex than the old contact route that we checked out in a previous section, but at the same time, it's not too different. For example, let's look at the overall shape of the route before going into it in great detail. Just like the contact route, it has both a get and post method. It also has a form and performs slightly different logic depending on if the form submission was valid. Finally, it renders a template along with the form context. So far, that's exactly like the contact form. So now let's go over the new stuff. First up, we have another decorator, which is called Anonymous Required. This isn't included by Flask login, and it's something we had to write ourselves. So now's a good time to learn how to write a custom Flask route decorator. To do that, go ahead and open up the decorators.py file. This decorator is the inverse of the login required decorator. In this case, we're dealing with the login page. It wouldn't make sense to be able to view the login page if you were already logged in. So that's what this decorator prevents. Line 18 checks to see if the current user is already authenticated. And if so, then it just redirects you to whatever URL that you pass into the decorator. If you don't pass in a URL, then it just defaults to the settings page, which seems reasonable enough. The rest of the function is boilerplate to wire up a decorator in Python. At the end of the day, a Python decorator is a shortcut for modifying how a function works without having to go in and modify the function itself. It's sort of a tricky concept, but it's not extremely important that you understand how decorators work to complete this course. I recommend Googling on that topic if you want to learn more. Let's go back to line 18 really quick and go over what current user is. If you take a look here at line 4, it's something provided by Flask login. Basically, it's the end result of calling that load user function that was in the authentication function that we looked at before. In our case, we'll have access to a specific user from our database, and it's going to have a few extra methods attached to it from Flask login. For example, down here on line 18, we're seeing that we're accessing isAuthenticated. That's a custom method supplied by Flask login, and it's going to determine whether or not the current user is authenticated. So now let's head back over to our views file. On line 31, we're accessing a login form, so let's check that out, and that's going to be located in forms.py. It's a pretty simple form that includes an identity, password, and next field. The next field is interesting because it allows us to provide a very nice usability enhancement to the website. Imagine if you went directly to a URL that was protected by a login page. For example, let's say that you had your billing invoice bookmarked. Now, if you weren't already logged in, you would be redirected to the login page. However, if we didn't keep track of this next URL, then after logging in, you would be redirected to the settings page. As a user, now you have to go and revisit that billing invoice page again. That user experience kind of sucks because it puts the burden on the user. The next URL allows us to keep track of where the user wanted to go originally, and then after they log in, they will be automatically sent there. So that's how that works. Next up, we want users to be able to log in by username or email, which is another nice usability enhancement. I would describe this as their identity, which is how I got that name. It's a string field, and it's going to be required and also be restricted by a min and max length. The password field is about the same, except it's a password field instead of a string. This makes it render a password text box in your browser, so you see stars instead of the actual character when you're typing. You'll also see there is a commented out remember field, and that's in case you want to add a remember me checkbox on your own. In our demo application, I think it's a good idea to always remember me by default, and that just allows us to skip adding the checkbox to the web UI. So now let's head back over to the views file, and here we are defining the login form, and then we're passing in a default value for next. In this case, it's going to go ahead and look for a next variable in your URL. This is commonly referred to as a query string. So now down here on line 34, if the form is valid, it's going to go ahead and do a lookup by identity on our user model, and it's going to go ahead and pass in the identity field, which is either a username or email. Let's jump into the user model just to see how that method works. For that, head over to models.py and then scroll down to line 51. You simply provide it an identity, and it's going to go ahead and do a lookup with SQL Alchemy while trying to find either an email or username that matches. Then it's going to go ahead and return the first result. The user.query.filter part is how you can query the user model with SQL Alchemy by one or more columns. The pipe symbol in between the email and username comparison is an OR operator. More details about this can be found in SQL Alchemy's documentation, which I highly recommend going over on your own as needed. I've included a link to it in this lecture's notes. So now let's go back to the views file. Line 36 checks to see if we have a user record, and then also checks if that user is properly authenticated using another custom method that exists in the user model. You have to remember at this point, the user isn't logged in yet, so we don't have access to the current user value provided by Flask login. So let's go back now to the user model once more and check out this authenticated method. It's located down here on line 144. All it does is take a user's unencrypted password as input, then performs the encryption on it and compares it to the encrypted password associated to this user. In other words, it makes sure that the user requesting to log in is using the correct password. The check password hash function is built into the Workzeug security module. It's worth mentioning that supplying a password as input is optional, and if you decide to skip it, it's always going to return true, which means you'll be able to log in as a user without knowing their password. Due to encrypting a user's password, it's impossible for us to ever know a user's password. However, there may come a time where you'll need to log in as a user on their behalf without having access to their password. I don't recommend doing that unless it's an extreme emergency, but with the way things are set up now, you could do it if you have to. So now let's go back to the views file. Notice how we're sending a password in here, because in this case, we do want to check their password. If this check evaluates to false, then we simply flash to the user that their identity or password is incorrect. We can try that out now by heading over to our browser. Then just enter in dev@local.host and then put in a password that you know wouldn't work. After that, click sign in. And then up here, you'll see identity or password is incorrect. Okay, great. So now let's go back to our code editor. Otherwise, if the user does exist and they are using the correct password, then we'll attempt to log in the user with Flask login. I also wrote out some comments here explaining how you could add a Remember Me checkbox on your own, and I'll leave that to you as an optional homework assignment. The rest of this course won't be using that, but it's good to know how to do it. Notice on line 46, we're logging the user in with Flask login and setting Remember to true by default. We're also performing an additional check to make sure that the user is active. If this condition fails, then we'll flash the user with a message informing them that their account has been disabled. Otherwise, we'll just update some tracking information about the user, which we can see here on line 47. We're also passing in the request.remoteAddr, which is the user's IP address. So let's check out this method in the models.py file. It's down here on line 173. It's very straightforward, and all it does is increment or set a couple of values. It increments the sign-in count, and then sets up the correct dates and IP addresses for both the last and current sign-in attempts. Finally, at the very bottom there, it saves the user. So now let's go back to the views file to finish this up. The last step is to redirect the user to the next URL if it exists. Otherwise, we'll just redirect them to the settings page by default. The safe next URL is a custom function in our library folder, so let's check that out too. We can find that in the lid folder and then go to safe next URL. It's extremely simple, but extremely important. All it does is prefix the path with our full host URL. This protects us against an open redirect attack, which you can Google on your own time. The short version is, without doing this step, your application is vulnerable to a situation where a malicious user could redirect other users to untrusted domains. I take security very seriously and don't mind writing a tiny bit of extra code to create a more safe application. That's everything you need to know about logging users in and out. I'll see you in the next lecture where we go over registering new users. I'll see you then. In this lecture, we're going to tackle registering new users. If you haven't done so already, please head over to Section 12's folder in your Courses folder, and then open it up in your code editor. Then make sure Docker Compose is running by typing docker-compose --up. Then head over to your browser. Then head over to the website by going to localhost port 8000. Once here, then head over to the sign-up link. If you happen to be already logged in, then log out first. Once here, go ahead and try to sign up with a seed account. If you haven't touched any of the seed values, then you would be using dev@local.host with a password of devpassword. Then go ahead and try to register. We'll see here that it says already exists. That's a unique validation happening at the form level to provide this functionality. So now let's really sign up. I'm going to put in my personal email address, and in your case, make sure that you put in an email address that you have access to, because we'll be sending automated emails to this account in this section. Then just go ahead and enter in a password. I'm going to go with a password of password because I'm cool like that. And once complete, then go ahead and click register. Then just click through here, and that's going to forward us to the welcome page. We won't be covering this page in this lecture, so let's head over to the Jinja template for the sign-up page. For that, head back over to your code editor. Once here, then go to the Snake Eyes folder, Blueprints folder, User folder, Templates folder, User folder, and then go to the signup.html page. There's really nothing new to see here, as we're just going over stuff that we've seen before. This is just your standard multi-column bootstrap layout with the sign-up form. So let's pop over to the views file here in the user blueprint. Then jump down to line 109. The pattern of this route is very similar to the login route that we just looked at. Here we have two methods and we have a form, and if the form is valid, it does some stuff. Otherwise, we go ahead and render the signup page. Notice how on line 12, we're referencing a signup form, so let's check that out in forms.py. We can see that signup form down here on line 32. And this signup form contains a validator that we haven't seen yet. We've seen this before, and that means that it's going to be required. And in this case, a new validation is it needs to be an email. Also, it needs to be unique. Both the email and the unique validators are not part of Flask WTF, but instead they belong to the Flask_components package. If we scroll up to the top up here, we can see them both being imported on line 4. So let's take a closer look at this form. The unique validator takes two arguments. The first one is the field that we're doing a unique check for, and in our case, that would be the user's email address. And the second argument is the database session for this application. An additional thing to note here is that the signup form is inheriting from model form instead of form. Since our validation requires accessing a database model, the class will need extra functionality added to it. This is a custom class that exists in Flask WTF. However, we had to make a small change to it, and instead, we're using a version that exists in our lib folder. So let's check that out by going to the lib folder, and then we'll go to the utility file for WT forms. The gist of it is, we're using Flask WTF to handle our forms. WT forms is a dependency of Flask WTF, but it doesn't handle automatically dealing with CSRF protection for us like Flask WTF does. To fix this, I've copied their model form class and instead inherit from Flask WTF's form class. That's probably the most confusing thing ever said in the history of the universe, so feel free to read the comments here if you need to review that later. Now let's head back over to the forms.py file. The last field here in the signup form is the password field, which we've seen before. Now that we know what the form looks like, let's go back to the views file. Line 115 creates a new user, and at this point, the form is valid. Flask WTF gives us a very nice way to assign form values to an object. Line 117 fills up our user model with the values from the form. Then, line 118 encrypts the password. And finally, on the next line, we save the user. Then we just log the user in using Flask login and flash a message to thank them for signing up. The very last step here is to redirect them to the welcome page. And with that said, I'll see you in the next lecture where we go over the welcome page. See you then. In this lecture, we're going to review the welcome page. If you haven't done so already, please head over to Section 12's folder in your Courses folder, and then open it up in your code editor. Then make sure that Docker Compose is running by typing docker-compose --up. Once you have that done, head over to your browser, and then head over to localhost port 8000/welcome. This page would normally be loaded right after you create a new account. A welcome page is useful for visitors because it gives you a chance to tell users how to use your website or offer them some type of paid service. Currently, we don't have the billing component set up, but in the future, this would be a good page to try and upsell users into becoming paid members. Over here on the left-hand side, you can start to see that happen. Once we add the billing component later on in the course, we can come back and add a link here which will direct users into how they can become paying members. We're also using this page to optionally let people set a username. Usernames will be important in our application because we'll be displaying users on the leaderboard. It would be very rude for us to display a user's email address, so instead, they'll have the option to create a username. So, users have the option to create the username right now on the spot, or if they're not ready yet, they can do it later. For now, let's go ahead and click Do It Later. And that's going to send you over to the settings page. And from within the settings page, you can always pick a username from here. So let's go ahead and create a username now. I'm just going to use my first name. Once you have it filled out, click Save. Now the settings page shows that I have picked a username and I won't be able to visit the welcome page anymore. If you try to visit the welcome page manually, it's going to redirect you back to the settings page with a warning. Go ahead and try that now by going to /welcome instead of /settings. You'll see here that it says you already picked a username. Now that we know how it works on the front end, let's go ahead and take a look at the code to make it work. So for that, head over to your code editor. Then we'll begin by looking at the welcome template, which is in the Snake Eyes folder, Blueprints folder, User folder, Templates folder, User folder, and then go to welcome.html. Like the previous lecture, this template has nothing new to go over. It pretty much just renders a pick a username form, so let's check that out in the views file. The welcome route is down here on line 130. It's protected by the login required decorator because it wouldn't make sense for it to be displayed without a user being logged in. Then it checks if the current user already has a username created, and if so, we quickly abort and redirect the user back to the settings page with a warning. Otherwise, we just set up the welcome form. So let's go ahead and head over to the forms.py file, then jump down to line 44. The welcome form also inherits from model form because we need to do a unique validation on the username. It also has a new type of validation, which is based on a custom regular expression, and that can be seen down here on line 54. We want to limit usernames to only letters, numbers, or underscores. The regex shortcut for that is to use \w, which is a word character. We also supply a custom validation message in case the user tries to enter a value that fails the regex. So now let's head back over to the views file, and we'll check out the rest of the route. Down here on line 138, we just assign the username to the current user, and then we save it. Finally, we flash the user that they've completed the sign-up process, and then we're done. Next up, let's check out the settings page, and for that, I'll see you in the next lecture. See you then. In this lecture, we're going to review the settings page. If you haven't done so already, please head over to Section 12's folder in your Courses folder, and then open it up in your code editor. Then make sure that Docker Compose is running by typing docker-compose --up. Once complete, head over to your browser, and then head over to localhost 48000/settings. At the moment, this page looks pretty empty, and it's where users can go to change their email or password, as well as pick their username. Later on, users will be able to change their subscription plans and much more. Let's go to the only uncharted settings page here by clicking the Update Email and Password link. It's a good security precaution to enforce that users enter in their current password before changing any of their login credentials. In this case, users can change their email and optionally change their password. Let's change our password, so go ahead and enter in your current password, and then pick a new password. After that, go ahead and click Save, and then go back to the settings page. If everything checks out, you'll be redirected with the success message. Now let's go back to the Update Email link over here, but this time go ahead and put in an incorrect current password. You'll see that it says does not match. So now let's go ahead and look at both the settings and update credentials templates before we see how all of it works. For that, head over to your code editor. Then I'm sure by now you know where to go. That would be the Snake Eyes folder, Blueprints folder, User folder, Templates folder, and then open up the settings.html file. The settings page is very basic, but line 16 is worth looking at, and that's going to check if the current user currently has a username set. If so, it's going to go ahead and output their username. Otherwise, it's going to output a link so they can pick their username. Everything else is old hat to you by now, so let's take a look at the Update Credentials template. This template is also combining elements that we've seen in the past, so I won't be covering it in detail. Let's hop over to the views.py file, since there's quite a bit to go over. Head down to the bottom of the file, down here on line 153. The first line of the function sets up the Update Credentials form, where we pass in both the current user and the user ID of the current user. So let's check that out now in forms.py. We can find that on line 58. The current password field is very interesting because it contains a custom validator, and that's going to ensure that the existing password matches. We can see how that works by going to validations.py. Then head over to line 20. The first thing that we do here is a database lookup on the form object's ID, and that's going to be the user ID. Then it checks if the user is authenticated by passing in the field.data value, and field.data would be the user's plain text password straight from the form. If it's not authenticated, then we raise a validation error with a custom message. Writing custom validators is heavily documented on WT-Form's website, but what we have here is a good working example. Now let's head back over to the forms file. Next up, we have the email and password fields, and in this case, the password field is optional instead of required. And that's because the user is not always going to be changing their password. They might just want to update their email. Other than that, it's stuff that we've seen before. So let's head back over to the views file. If the form is valid, then we store the new password from the form, and then we go ahead and update the current user's email address based on the form's value. Then if there happens to be a new password, we go ahead and encrypt it. We need to protect this with an if statement because without it, then we would end up encrypting an empty password when users decide that they don't want to update their password, and that's going to result in an error. Once we have that set up, then we just save the current user and inform them that their settings have been changed. The last thing I want to go over in this section is in the app layout file, and that's going to be in the templates folder down here. Then open up app.html. Once here, scroll down to line 23. Over here, we have an if statement that checks if the current user is authenticated. If so, then we show the drop-down menu with a link to settings and a way to log out. Otherwise, we show the login and sign-in links. Now that we've explored updating a user's settings, let's move on to the next lecture where we deal with password resets. I'll see you then. In this lecture, we're going to deal with resetting passwords. If you haven't done so already, please head over to Section 12's folder in your Courses folder, and then open it up in your code editor. Then make sure that Docker Compose is up by running docker-compose --up. After that, head over to your browser. Then once here, go ahead and directly access localhost port 8000/login. If you happen to be logged in already, then just go ahead and log out first. Once here, head over to the Forgot Your Password link. All you have to do is put in your username or email address and click Continue, and you're good to go. So go ahead and enter in your email address for the account that you registered. And this is why it's important that you used an email address that you have access to, because this is where the reset password link is going to be sent. So once you have it filled out, click Continue, and then click through to the login page. You should see a Flask message that tells you that an email has been sent. So go ahead and check your inbox. You should notice a password reset email to whatever account you have configured in your instance/settings.py file. You'll see a fairly standard password reset template with a clickable link. So go ahead and click that link now. And now it's going to prompt you to enter in a new password. So go ahead and fill in a new password, and then click Continue. Once complete, then head over to the settings page here, and you'll see that your password has been reset. So the workflow to do this is to 1. Request a new password reset link, 2. Click the link that you got in your inbox, and then 3. Set the new password. It's a 3-step operation. So now let's take a look at the Jinja templates. For that, head over to your editor. Once here, then head over to the Snake Eyes folder, Blueprints folder, User folder, Templates folder, User folder, and then we'll check out the Begin Password Reset template. There's really not too much to go over here. It's a very simple form, and everything you see here is stuff we reviewed in previous lectures. The next template would be Password Reset, and like before, there's really not too much to see here. So now let's check out the views.py file, and then we'll start on line 71. And this is the route responsible for beginning the password reset. This route requires you not to be logged in, so it has the anonymous required decorator. Then we just go ahead and instantiate a begin password reset form. So let's check that out now. It only has one field, and that's for the identity. We've seen everything here except for that ensure identity exists validator. So let's head over to the validations.py file. This validator is very simple. It just does a lookup by identity, and then if it fails, it warns the user that the account couldn't be found. So now let's head back over to the views.py file. Once the form is valid, then we initialize the password reset, which is a custom method on our user model. So let's check that out now in models.py. That can be found down here on line 99. This method is responsible for executing the accelerate task to deliver the reset password email. It starts by looking up the user, and then it serializes a token with the user's email address. Let's see how that's done by heading down here over to line 159. This method creates a token that's valid for 1 hour by default. It uses the app's secret key value to sign the token. Then down here, it uses It's Dangerous again to create a timed token. And finally, it returns the token, which contains a UTF-8 representation of the user's email address in JSON format. We need their email address because this is how we'll look up which user to create a new password for when they click the link. This is a very cool strategy for creating reset password links or any other one-off tasks that you may need to store something for a short period of time. The old school way of doing this may have been to create a reset token column on our user model, and then when the user resets their password, the token would be saved to the database. Then, when the user clicks the reset password link, the token would be read in from the database and then compared to the token in the URL. Once the user creates a new password, then the reset token would be cleared and that model would be saved. From a security perspective, it's the same as our method, except this old school way of doing it would require an extra database write and one extra database read, because our way encodes the email into a token, and that's simply being passed in the URL. Our way is much more efficient and is honestly better in every way possible. So now let's head back up to the initialize password reset function. So after we get the reset token, Then we just go ahead and kick off a Celery task to send the email and return the user object. Let's take a look now at the tasks file to see how that works. This function accepts a user ID and the reset token. Then we just do a lookup to get that user, and then fill out the context, which contains the user object and the token, and then finally we pass that to the password reset email template. It's very good practice to send in IDs rather than full objects to a background task. In our case, we're passing in the user ID instead of the user object. Sure, we need to do one more database lookup, but think about it from a production environment standpoint. Imagine if we sent in the user object instead. For starters, when Celery queues up the task, it's going to have to serialize and deserialize the entire object, and that's going to be pretty inefficient and a waste of space because it's going to need to be saved in Redis. Secondly, and more importantly, we don't have full control over when the task is going to get executed. It's probably going to get executed within a few seconds, but what happens if the user somehow manages to remember their password and then they change their email address before the task gets executed? This would create an edge case where the password reset link gets sent to an old email address that's no longer associated to the account. So, to combat both issues, we simply do the lookup on the user at the point where the task is executed, which in this case is over here on line 19. With that said, let's finish up by going over the email template, and for that, head over to the mail folder and then go to passwordreset.txt. Since we have access to the user object, we can access any field we want. Notice how we're also able to use URL for even in a mail template. This is what builds up the link. The URL for function allows you to supply additional arguments to set query strings in the URL. The query string is what comes after the main URL and is separated by a question mark. You just pass in a keyword argument and its value, and that becomes a query string automatically. The underscore external parameter forces the link to open in a new browser. Most email clients will do this automatically, but it doesn't hurt to add it here. So now let's head back over to views.py and check out the second half of resetting a password. This is located on line 87. We're calling the password reset form while passing in the reset token that's part of the URL. We've seen this before, but the request.args.get allows you to retrieve a query string with Flask. In this case, it's looking for a reset token query string. So let's go ahead and investigate this form in forms.py. It's on line 27, and it has a hidden field for the reset token along with the password field. So now let's go ahead and jump back to the views file. This route is a bit longer than the other one, but it's just doing things that we've done previously. After the form has been deemed valid, it deserializes the token, which returns a user instance. Let's check out that method now in models.py. We can see that method up here on line 81. You just pass in a token, and then it uses It's Dangerous again, along with your secret key to create the private key. Then we decode everything by using the private key along with the token passed in. If everything is in order, we look up the user by the email address that's stored in the payload and then return the user. Otherwise, the token has either expired or was tampered with, so we capture that as a general exception and return none. So now let's head back over to the views.py file. Now we just do a check here to see if user is none, and if so, we just let the user know that their token has expired or maybe it was tampered with. Otherwise, we just populate the user object with the form value just like we did in a previous lecture. After that, we encrypt the new password and save the user. Then, as a convenience, we just log in the user and tell them that their password has been reset. So, that's all there is to it for handling a robust password reset system. I'll see you in the next lecture, where we briefly cover small changes that were made to the other blueprints. I'll see you then. In this lecture, we're going to quickly go over a couple of changes that were made in the previous blueprints. If you haven't done so already, please head over to Section 12's folder in your Courses folder, and then open it up in your code editor. Then, like usual, make sure that Docker Compose is running by typing docker-compose --up. Then head over to your browser. Once here, head over to localhost port 8000. In a previous section, these sign up buttons were dead, but now that we have a user system, we can go ahead and click sign up. That change is in the page's blueprint under the home page template. I'll let you look at that change on your own as an optional homework assignment. The goal of this assignment is to make sure you know how to navigate the codebase, so please pause the video now and take a few seconds to check it out. Okay, so the next change here is on the contact form, but before we check it out, make sure that you're logged into an account. So go ahead and go to Login, and then log in as the seed user. Then, once you've been logged in, head over to the contact page. You'll notice that it autofills in your email address. I'm all for adding in usability enhancements whenever possible, and you'd be surprised at how many websites forget to do this. In the case where you're not logged into an account, it will just be empty. So now let's head over to our Contact Blueprints Views file to see how that was done. And for that, please open up your editor. Then just head over to the Snake Eyes folder, Blueprints folder, Contact Blueprint, and then open up views.py. The only change that we had to do to make this work is on line 18, and we're just passing in the current user to the form. If it happens to not exist, it will just silently fail and use nothing. So that's it for this lecture, and I'll see you in the last lecture of this section, where we go over a few new tests. I'll see you then. In this lecture, we're going to review the new tests that were written for this section. If you haven't done so already, please head over to Section 12's folder in your Courses folder, and then open it up in your code editor. Then make sure that Docker Compose is running by typing docker-compose --up. After that, head over to your code editor. Then once here, head over to the Snake Eyes folder, and then go to the test folder. And then we'll check out the conftest.py file. The first change is going to involve the app fixture. Since our test will be connecting to a database, we need to configure SQL Alchemy to connect to a separate test database. This database was created beforehand in the Initializing the Database lecture. This is a very important step to take because if we continue to use the development database in our tests, then it's going to get cleared every time we run a test. The next change is down here on line 46, where we've added a new DB fixture. The first thing that we do here is reset the database, and then we go ahead and seed it with a test user. It's scoped to session because we only have to do this once per test run. There's going to be a lot of tests that just read in this user without modifying it, so it's safe to do this. Then if you scroll down here to line 74, we have a new session fixture. This fixture will quickly reset the database in between each function by taking advantage of a feature in Postgres. You can research that on your own as an optional homework assignment if you're interested in how it works. Finally, we have two more fixtures related to the user blueprint. The first one ensures that we have a consistent token to work with in our tests. And the other one is a users fixture, which is going to first clear out all the test users in the database, and then it's going to add two users. The first user will be an admin, while the second one happens to be a deactivated non-admin account. Having these users available will allow us to write a combination of tests that will cover just about all the user blueprints codebase. Let's begin exploring some of these tests by heading over to the user folder in the tests folder. You'll see that we have some tests here for models, tasks, and views. Let's begin by looking at the model tests. We just set up a couple of tests that ensure that we can serialize and deserialize a token correctly. These tests are responsible for nothing other than that. All three tests use the token fixture that we talked about before. In the case of the third test, it makes sure that we can't successfully deserialize a token that has been tampered with. There's really not much to go over in these tests. Although the first test is a bit magical looking because you need to know how a JWS is formatted to understand it. First off, JWS stands for JSON Web Signature, and it's responsible for encoding data into a token. It happens to contain two periods, so we just check to make sure that it has two. Then in the second test, we deserialize it and look up a user based on that token. If you remember back in the conf test file, our test user has an email address of admin@local.host, so we just make sure that it matches. So now let's move on to the tests for the tasks file. This is very similar to the Contact Blueprints task test, so I won't bother going over it. Finally, let's take a look at the views tests. This file is quite large, and it's nearly 300 lines long, but we won't be going over every single test in detail. However, there are a couple of new big additions that we'll go over, so let's begin on line 7, where we're subclassing a view test mixin. This is a custom class that I've created to test view code in an easier way. Let's begin by looking at that class, which is located in the test library that we created in a previous section. To do that, head over to the lib folder and then open up test.py. Then scroll down here to line 21. This mixin's goal is to provide common functionality for testing view code. Firstly, on line 27, we're creating a special type of fixture which automatically uses both the session and client fixtures. It's special because of the auto-use property being set to true in the fixtures decorator. This means that we don't need to explicitly use this fixture in our tests. Any test that inherits from this class will have it attached automatically. Then we have two methods for handling logging users in and logging users out. These make it very easy to log a user in and out during our tests. The login method defaults to the user that we created in the users fixture before. We can see how both methods are being implemented by scrolling down here to lines 49 and 68. In the case of the login method, it just makes a post request to the login form with the login credentials being passed in. Imagine if we had 20 tests that required logging in a user. It wouldn't be very fun to write these 4 lines of code every single time, so that's why this method exists. The logout method is very similar, except it visits the logout route as expected. So now let's head back over to the test views file. So to use this mixin, all we have to do is import it up here, and then inherit from it from our view classes. Let's take a look at a few tests now to see how it all works. Take a look here at line 13, where we test if we can log in. All we have to do is call self.login, and it's going to log us in. Then, the test is as simple as ensuring the status code is a 200. The next test on line 18 does a lookup on the user, and then it gets the current login count. After that, it logs in the user, gets the new sign-in count, makes sure that the response is a 200, and then makes sure that the old count plus 1 equals the new count. This test ensures that the sign-in count is working as intended. This test login class continues to go on by testing other aspects of the login codebase. I recommend reading the source code for each test on your own, just to get used to seeing how tests can be written. Now let's scroll down to line 51. Here we can see a couple of tests for the password reset code. There's nothing that we haven't seen before, so I won't be reviewing these tests. Let's head over to line 129. And here we have a bunch of tests related to signing up. If we scroll down a little bit more here and go to line 59, there is one test to go over that's pretty interesting, so let's hop down to line 159. It covers the entire flow of signing up a new user and ensuring that the user count gets incremented by 1. If it gets incremented by 1, we can be sure that a new user was successfully saved to the database. Line 174 is pretty cute because it also ensures that the user's password was encrypted by making sure it doesn't continue to be password, since that's the password we defined up here on line 163. Now let's continue on by jumping down to line 203. We just make sure the settings page gets rendered for users who are logged in. There's really not much going on here. Then finally, we have a couple of tests here on line 212, which go over updating user credentials. I'm not going to be going over any of these tests, but I recommend that you take a look at them on your own. With that said, let's wrap up this section by running the test coverage tool against the codebase. So head over to your terminal. Then go ahead and open up a new terminal tab. And like before, we'll run docker-compose space exec space website space snakeeyes space cov, and then hit enter. After a couple of seconds, it's going to run through all of our tests, and we'll see here in about 5 seconds, we have pretty high test coverage. My line's a little bit wrapped here because the font is too large, but it's 97% total. The user component of our website is very important, and I would be quite happy with 97% test coverage. If you scroll up here, you can see which lines don't have test coverage, but I feel like it would be a lot of extra work to test these lines for very little benefit. So with that said, let's go ahead and stop our containers by heading over to the other tab, and then pressing Ctrl+C. Then like before, we would type in docker-compose space stop, and that's going to guarantee the containers are stopped. Then we can just clean up our Docker mess by typing docker-compose space rm space -f, and then hit enter. Also, as a reminder, it may be a good idea now to remove some dangling images if you haven't done so already. Please check out the lecture notes to see how that's done. I just want to close this lecture by saying great job at getting this far. You've been exposed to a lot of new concepts in this section, and future sections of this course will be a bit easier, since for the most part, we'll just be building upon what we've learned already. But don't worry, there's still plenty of new stuff to learn. I'll see you in the next section, where we create a custom admin interface. I'll see you there. In this section, we're going to go over creating a custom admin dashboard. First, we'll go over why I didn't choose to use the Flask admin extension. Then we'll go over what was created to make the admin blueprint. After that, we'll sidestep the admin and go over how to create fake users. This way we'll be able to properly test the admin backend's look and feel. Then we'll go over listing users, and after that we'll go over searching and sorting users. And then finally, we'll wrap up the user component of the admin dashboard by editing and deleting users. Then finally, we'll go over the main admin dashboard. I'll see you in the first lecture where we go over why Flask admin wasn't chosen. In this lecture, I'll go over why the Flask admin extension isn't being used in this project. Flask admin is an extension that gives you a pre-built admin dashboard without requiring too much effort on your part to set it all up. And that sounds great on paper. You could inform Flask admin of which models you want to be editable in the admin, wire up how authorization should take place, and you'd have a somewhat working solution. This is awesome until you really want to customize things, in which case now instead of just adding in your own functionality, you need to go read Flask admin's documentation and figure out how to override certain things. Before you know it, you have a solution that's not only more complicated, but it's also more prone to error because you're pulling in tens of thousands of lines of code from another project. I'm a big fan of not reinventing the wheel, but the Flask admin wheel is just too broken to use as a base. I really appreciate the effort that the author put into creating the project, but the problem isn't so much Flask admin. It's just that in any real-world application, your admin interface is an extremely intimate thing. It's something you'll be looking at all the time, and you should be able to fully understand and customize it based on your exact needs. The last thing you want to be doing is opening issues on a third-party library or reading thousands of lines of code written by somebody else. And that would be all because it's not possible to do something that you could normally do on your own in about 20 lines of code. Our custom admin isn't even going to be that hard to build up. We already have the user authentication and authorization in place, and we know how to lock down routes so that only specific users can access them. We just need to create the templates and forms and then wire up the views. Then, as our application grows, we'll just keep adding to it. If patterns happen to emerge, then we can create abstractions to remove code duplication. In the end, we'll have a fully custom approach that you can fit to your exact needs with the least amount of trouble. With that said, I'll see you in the next lecture where we go over adding the admin blueprint. See you then. In this lecture, we're going to go over the admin blueprint. So please head over to section 13's folder in your courses folder and then open it up in your code editor. Then head over to the instance folder and open up settings.py. Then just head back over to section 12's folder and go to the instance folder, and then open up settings.py. Then, like we did in a previous section, go ahead and copy all the contents here, and then paste it over into section 13 settings.py. After that, save the file. Then from here, let's go ahead and go to the Snake Eyes folder and open up app.py. This file really hasn't changed too much since section 12. First, we just import the new admin blueprint, then down here on line 65, we just register it. So now let's head over to the blueprints folder, and then open up the admin folder. The admin blueprint is less complicated than the user blueprint. All we have is a forms file, models file, and views file, as well as a templates folder. We'll take a look at these files throughout this section, but for now let's move on to the next lecture where we go over the main admin dashboard page. I'll see you then. In this lecture, we're going to go over the main admin dashboard. If you haven't done so already, please head over to section 13's folder in your courses folder, and then open it up in your code editor. Then make sure that Docker Compose is running and built by typing docker-compose space up space -- build, and then hit enter. This is going to run for a bit, and I'll meet you back when it's done. Okay, great. Once things are up and running, head over to your browser. Then head over to localhost port 8000/login. And once you're here, log in as the seed user, which would be dev@local.host, and then go ahead and enter in your password, which would be dev password if you didn't change it. After that, go ahead and sign in, then go to the settings page. If you take a look at the links up top here, you'll see two new links here, one for the dashboard and one for users. Let's go check out the dashboard link now by clicking it up here. Currently, we don't have too much data to manage in our admin, so it looks a little bit empty, but it will fill out as we progress throughout the course. The dashboard page will be where you'll find useful stats about various components of your app. For example, right now it's showing us how many users we have, and is breaking down the percentage of users who are admins or members. Since we only have the seed user and the account that we made before, there's really not too much to see. So now let's check out the views file in the admin blueprint and see how it works. For that, head over to your editor. Then, once here, go to the Snake Eyes folder, Blueprints folder, Admin folder, and then open up views.py. Down here on line 20, we're creating the blueprint, and this is the first time that we're assigning a URL prefix to the blueprint. This means that every single route in this blueprint will be automatically namespaced with /admin. This is a very handy feature to have because it makes changing the prefix across many routes very easy. Now let's take a look here at lines 24 through 29 because we have a new Flask concept to cover. Line 24 attaches a before request decorator to this blueprint, and this means whatever function we supply below will happen before the request for every single route in this blueprint. In our case, we want to make sure that the user is logged in, so it's going to go ahead and use the Flask logins decorator of login required. But more importantly, we also want to make sure that the user has a role of admin. We certainly wouldn't want regular members of the site to be able to access the admin area. This is done through a custom decorator, which we can check out over here in the user folder, and then go to decorators.py. That new decorator is down here on line 28. This decorator allows us to whitelist one or more roles. Line 38 is where the magic happens, and it's quite straightforward. We just check the current user's role against a list of roles, and if it doesn't find anything, rewarn the user and redirect them. Otherwise, things continue onward as planned. So now let's head back over to the admin blueprints views file. So, with just a few lines of code, we can ensure that everything is protected. Let's move down to line 33, where we have the main dashboard page. Its route endpoint is empty, which means it will exist at the root of the URL prefix, which in our case is /admin. It looks like we're calling a dashboard class method, and then that just renders a dashboard template while passing in the result of that class method. So let's check out the models file to see what's going on. This class will help us perform logic like counting and grouping various models in our database. Line 8 does a group and count users, which in turn calls a private method to implement the actual logic of doing that. Python doesn't really have private methods, so it's a common convention to prefix method names or function names with an underscore when you want to let people know it should be private. This method takes a model to work on, as well as the field that you want to group and count on. We'll be reusing this method for many different models as our database schema grows in complexity. So let's see how this method is implemented, and we can do that by scrolling down here to line 17. The first thing that we do here on line 27 is assemble a count query with SQL Alchemy. Then line 28 does the group by, which is a type of query you can do with relational databases. In our case, we're passing in the user role as a field, so this query will look through all the users in our database and give us a result back which contains a user count for each role. You'll get a better understanding of that once we see the dashboard again in a future lecture. Then lines 30 to 33 set up a dictionary to store both the result of that query as well as the count. Then on line 35, we just return the results dictionary. If you remember back here in views.py, that's the result that we're sending over to the Jinja template. So let's look at that now. We can find that by going to the templates folder, admin folder, and then head over to the page folder and open up dashboard.html. Down here on line 12, we're accessing the user total, which is the count. And that .total corresponds to what we have here, which is the total of the results. Then lines 16 through 29 loops through the query result. And for each item in that query, it calculates the percentage of users for this role. Then it outputs how many there are, along with the percent in a nice little Bootstrap progress bar widget. So let's go back to our browser for a moment. In this case, we have one member, which is the member that we signed up with manually, and that's half the total of all the users that we have. The other user is an admin, which is the seed user. Like mentioned previously, this dashboard page will grow in time, but for now let's go to the next lecture where we list users out in a table. I'll see you then. In this lecture, we're going to go over listing users in a table. If you haven't done so already, please head over to Section 13's folder in your Courses folder and then open it up in your code editor. Then make sure that Docker Compose is up and running by typing docker-compose -up. Once it's up and running, then head over to your browser. Then just head over to localhost port 8000/admin. Then once here, head over to the users section of the admin by either clicking this link over here or up here in the navbar. There's quite a few things to look at here. This pattern of listing users will be repeated for other models in our database in future sections. If we break down the page, we have a couple of main components. The first thing we have up here is a search box. Then towards the middle of the page, we have a table that will list out all of our users. Then we have checkboxes to perform actions on one or more items in the table. Lastly, on the bottom, we have pagination. Right now there's only 2 records, so there's only 1 page, but with a bigger dataset, you would expect to see many pages. Pagination is a good idea simply because you wouldn't want to load 1,000 users on one page. That would stress out your server and also be very slow in your browser since there would be so much to display. We'll be going into each component that we just talked about in following lectures, but for now, let's take a look at the Jinja template for this page. For that, head back over to your editor. Then once here, head over to the Snake Eyes folder, Blueprints folder, Admin folder, Templates folder, Admin folder, User folder, and then open up index.html. Right away, we can see that it's pulling in a few macros, and some of these we haven't seen before, and we'll get to those in due time. For starters, I just want to go over the main shape of the file. Line 9 is where we're going to render our search form, which is just a macro. Lines 12 through 19 handle the case where the total number of records might be 0. If it's 0, we display a message instead of the table of users. This is a decent usability enhancement because it even recommends to search for a different term if you happen to find no results while supplying a search term. Then down here, we render the table, which is composed of the bulk delete form and sortable table headers. Then down here on line 53, we loop over all the users and display them as table rows. Lines 61 through 64 are interesting because if we remember back on the page, which we can check out now, we have times being displayed in relative time, such as 3 days ago or 2 days ago. If we mouse over one of these relative times, it shows a very human-friendly version of the full date. So now let's head back over to the template code. Over here on line 63, we're outputting the ugly UTC format straight from the database. You might be thinking, well, Nick, how did you make it so friendly looking? And that's a great question. And for that, let's head over to the Templates folder, Layouts folder, then open up base.html. Once here, scroll to the very bottom of the page. If you take a look here at line 51, there's a very popular JavaScript library called Moment.js, and it's awesome for dealing with dates, so I've added it to the project. It's located over here in the static folder, under scripts, and then vendor, and here it is, moment.min.js. I also added a main.js file, which we can take a look at now. We'll go over this file in due time, but for now, just take a look at line 16. We're going to be using jQuery, and this is a standard way to execute code when the browser is ready to rock. This is typically known as the DOM-ready event. Lines 18 through 31 both handle Moment.js related code. We're using jQuery CSS selectors to pick out a couple of elements in the DOM. If you need to brush up on some JavaScript, I recommend Googling on that topic now. However, you won't have to go too crazy because the code is here to look at. The FromNow function is Moment.js's way to show relative time, and that's going to show the 3 hours ago or 2 hours ago type of format. Then over here on line 22, we're setting the title attribute of the element to do the format that we want, which is a nice human-readable format on the full date time. Feel free to read Moment.js's documentation on your own if you want to know how all of this time formatting works. One last thing I want to go over here is lines 19 and 23. We're wrapping this all up into a function here, which is a nice usability enhancement. That's going to allow the page to update itself in real time as time progresses. For example, if you happen to see 5 minutes ago in the output, then it will change to 6 minutes ago by itself after about a minute. So that's enough JavaScript for now. Let's head back over to the index.html file. The next thing that we do is render a bit of data about the account, such as the username and email. We also distinguish admins from members with a different font awesome icon. Let's take a look now at the macro powering line 69. We can check this out by going to the macros folder and then the user.html file. It expects us to pass in a user, and then we just check to see if the user is an admin, and if so, we render a shield icon. Otherwise, if they're not an admin, then we just show the regular user icon, and we mute it by doing text muted, which is a bootstrap class. Just to review what that looks like, head back over to your browser. And what that's going to do is create a red shield icon if we're an admin. Otherwise, it's going to produce a gray member icon, which looks like a little user. So now let's go back to our editor. Then from here, we'll go back to the index.html file, and we'll jump down here to line 91. This is another macro that handles pagination. Let's wrap up the template-related part of this lecture by taking a look at that. It's located over here in the main templates folder, under macros, and then open up items.html. Then scroll down here to line 34. It's not super important that you understand this in great detail, because you can think of this code as a library that you'll use. Just understand that the pagination widget has a few different states, and it keeps track of setting up proper links. The double star args that you see in a few spots here ensure that the pagination links keep track of other unrelated values, such as search terms and column sorting. We wouldn't want to switch pages and lose those values. With that said, let's head back over to the admin views file. Then jump down here to line 42. There's a lot of new things going on here, and we'll break those down in future lectures, but for now let's go over the high-level pattern. Lines 42 and 43 set up the pagination URL parameters. Setting name parameters and default values are both features of Flask. The page itself is an integer, which is why we have it prefixed with int over here. Then we just set up both the search and bulk delete forms. After that, we assign a couple of values for sorting, and prepare to return our paginated users. And finally, we render the index template while passing in everything that our template needs. Phew, that's a lot to take in. Let's wrap up this lecture by breaking down lines 52 through 55 at a high level. Line 52 does a user.query, which sets up SQL Alchemy to query the user model. We've seen that before in previous sections. Likewise, we also have seen the .filter method here, and in this case, we're passing in a function call, which is going to do a search on the user model. And don't worry, we'll go into that later on. Line 54 handles sorting things, and we'll go over that later as well. Finally, line 55 handles the actual pagination, and this functionality is provided by the Flask SQL Alchemy extension. All we have to do is pass in the current page, how many users we want per page, and the true arguments will tell SQL Alchemy to throw an error 404 page in case the page that we're seeking doesn't exist. For example, if we only have one page of results like we do for now, if we try to access page 10, you'd expect to get an error not found page, so that's why we set the last argument to true. So that handles pretty much everything about the index page. This is definitely one of the most complicated pages we've seen yet because it's introducing a lot of new concepts. I'll see you in the next lecture where we go over editing users. I'll see you then. In this lecture, we're going to go over editing users. If you haven't done so already, please head over to Section 13's folder in your Courses folder, then open it up in your code editor. After that, make sure that Docker Compose is running by typing docker-compose --up. Once you've done that, then head over to your browser. Then once you're here, go to localhost port 8000/admin. Then go ahead and head to the user section. Then once here, go ahead and click the seed user. That will lead us to this page where we can edit a user's details and also obtain specific information about them. On the left-hand side, we can see when they signed up and with what email they are using. I'm a big fan of security, which is why I didn't even allow admins the ability to edit a user's email address. You'll also see there's no way for an admin to change a user's password too. If your user has trouble signing in, your goal as an admin should be to get them to reset their password on their own. Personally, I would feel uncomfortable if I knew customer support had an ability to change my login credentials. If a really crazy edge case happened, you could always handle it directly at the database level, such as changing a user's email address if they happen to lose total access to it. Then we have an optional username field that we can change. It's a good idea to be able to change a user's username because this information is publicly viewable within your application. As an admin, you definitely need a way to deal with offensive usernames quickly. Then we have a privileges field, which is where you can promote or demote users to and from admins. Lastly, you can toggle whether or not a user is allowed to sign in. If you disable this, then their account will still be there, but they won't be able to log in. I've even gone the extra mile here and added precautions to prevent the last admin account from being able to demote itself or disable login access. You can try that now by attempting to demote the seed user to a regular member. You'll notice here that it says you are the last admin. You cannot do that. This is a good way to protect yourself from accidental mistakes. So now let's head back over to the Edit User page. On the right-hand side, we just see their login activity. Being able to see such activity is pretty handy because you'll be able to see if people are sharing their account with their friends. For example, if you notice that someone is currently logged in from an IP address that's located in New York, but their previous sign-in was from Boston 15 minutes ago, then you can be pretty sure that this user is sharing his account with someone else. You could even go as far as writing a Celery task that analyzed each day's worth of login data and emailed you when it detected different IP addresses from outside a certain radius. This goes a bit beyond the scope of this course, but if you had a very popular application, it might be worth setting that up to help protect your content from illegal account sharing. So that's what the Edit User page does. Now let's check out the Jinja template to see how it's rendered. For that, head over to your editor. Then once here, head over to the Snake Eyes folder, Blueprints folder, Admin folder, Templates folder, Admin folder, User folder, and then go ahead and open up edit.html. This page does nothing except set up a couple of blocks and then include the form. So let's check out that _form.html template. You can find that over here in the User folder. This is a bit interesting because the form template will be used for both editing users and potentially creating new users. It would be a massive amount of duplication if we had to copy and paste everything for both cases. Instead, we just set up a couple of variables on lines 3 to 13. By using the set keyword, we can create variables in Jinja and then use them later on in the template. We adjust the endpoint of the form, any form arguments, as well as the legend and button text. In this specific case, there's no way to create a user through the admin because if you wanted to create a new user, you would just register them through the main site. However, I included this pattern here because it's something you'll probably end up wanting to do on your own for other database models in your custom apps. Other than that, the rest of this template is similar to what we've seen in the past. There is one exception though, and that's on line 17. We're passing in the form's keyword arguments, and in the case of editing a user, it would be expected that you pass in the user's ID. We can see that being defined up here on line 10. This is how we know which user we need to update, because in the views file, we'll be passing in this user object. So with that said, let's go check out that views file. Then once here, head over to line 62. We're setting up the edit user route, and it expects an int ID to be passed in. Then line 64 does a lookup on that user, and the next line populates the form with the user's data. With that said, let's go ahead and check out this user form in forms.py. There's a couple of new things that we need to look at. For instance, the role field is using a custom choices from dict function that I wrote. It's what allows us to convert the dict role in the user model into a select box in the form. Let's see how that's implemented by heading over to the lib folder and then opening up the utils file for WT forms. Then scroll down here to line 22. This function is heavily documented and includes example use cases. If we scroll down here, we can see the source code for it. Basically, it optionally prepends a please select one value to the select box, then it loops through the dictionary, and it sets up a list that's compatible with WT forms. WT forms expects you to provide a list of tuples, and if you look up here at line 37, you can see what this function will output. If we scroll up just a little bit more here, we'll see that it converts a dictionary like this into the output of that. With that said, let's head back over to the forms file. The last thing that we should go over here is that it has an active field, which is the first time we've seen a Boolean field. It's very straightforward, so really there's not much to go over. All you do is supply the label for the field. Now let's head back over to views.py. If the form happens to be valid, then we do a check to see if the user is the last admin. It expects us to pass in a user, the role, and whether or not that user is going to be active. So now let's head over to the user model to see how this works. For that, head over to the user folder and then open up models.py. Then scroll down to line 137. There's actually a fair bit of logic that needs to happen to successfully protect against a sole admin accidentally locking himself out. Lines 149 and 150 keep track if the user is changing from an admin to a non-admin, or if they're changing from active to not active. When a checkbox is not checked in a form, its value is none, not false. So that's why we're checking for none here on line 150. Then we're just testing here to see if either condition evaluated to true. If one of them did, then we know a user is trying to either be demoted to a member or is being deactivated. At this point, we run 2 database queries to get the admin and active counts. Then on line 156, if either of these return 1, then we know that this user is the last admin, so we return true. Otherwise, we just return false because the user is not in danger of being locked out. So now let's head back over to the views file. So if they are the last admin, then we just flash them and redirect with an error. Otherwise, we fill up the user object with the forms values, And line 76 is interesting because the username is optional, but we don't have nullable set to false in our database schema for this column. Without line 76, you would end up saving an empty username, which is much different than null. So if the username is empty, then we just set it to none, which will properly set it to null at the database level. Then we just save the user here and redirect them back to the admin users page. Notice here on line 84, we're passing in both the form and user values to the edit form. So that takes care of editing users. The next lecture will sidestep looking at the admin and instead show you how to automatically generate fake users. I'll see you then. In this lecture, we're going to go over generating a bunch of fake users with the CLI. If you haven't done so already, please head over to Section 13's folder in your Courses folder, and then open it up in your code editor. Then make sure that Docker Compose is running by typing docker-compose --up. After that, go ahead and open up a new terminal tab. Now we're going to run a command to see the new addition to the CLI script. So go ahead and type docker-compose --exec --website --snakeeyes --add, and then hit enter. That's going to show us what we can add. This is a new command that's going to be built up over time, and it'll let us generate fake content to fill up the database. This is an excellent way to see how your website looks and feels with somewhat real data. The best part about it is, we'll be able to generate this fake data in about 1 second by simply running one command. So now let's go ahead and generate some users now by hitting the up arrow, and then type --users and hit enter. You'll see that it added 100 users. If for some reason you get an error, then you're the most unlucky person in the world because you hit about a 10 million to 1 edge case where a randomly generated username happens to be a duplicate. So go ahead and rerun the command. And now let's head over to our browser. Then head over to localhost port 8000/login. We need to log in here because we just generated 100 users, which deleted our old seed account and recreated a new one. So go ahead and log in as a seed account with a password of devpassword, and then head over to the settings page, and then once here, head over to the users page. You'll notice now that we have a bunch of users, and a small percentage of them happen to be admins while the rest are members. They all have different register dates, and some of them have random usernames. It looks very similar to how the app would look if you really had 100 users. If we scroll down here to the very bottom, we can even see that the pagination is working because now we have 2 pages. If we go ahead and click into one of the users here, we'll see that we even have fake IP addresses and sign-in dates. So let's head over now to our code editor. Then once here, go to the CLI folder, commands folder, and then open up the add command. We're using a package called Faker, which is what gives us an ability to generate random dates, email addresses, and much more. If you go over to the requirements.txt file, we'll see that it's been added down here on line 25. So now let's head back over to that add command file. Then jump down to line 57. You'll see that it's pretty similar to the db command that we looked at in a previous section. It's a group command because we're going to add in a few subcommands over the rest of this course to generate a bunch of fake data. Then go ahead and scroll down to line 139. This command is going to allow you to generate multiple things at once. We've seen this before in the db reset command, and in this case it's going to be more useful when we have more things to add. So now let's check out the users command on line 64. It's a pretty large function, but it's setting up all the random data for each user. It's worth noting here on line 71, this is how you can print output with click. Then we generate about 100 random email addresses using Faker, which we can do by typing fake.email, and that's going to return one single unique email address. Then we just make sure that the seed admin is always included in that random emails list. Converting it to a set and then back to list will ensure that we have a unique list of emails. Then down here on line 80, we're just setting up an infinite loop, and when we run out of emails, then the loop stops. Here we're just using Faker to set up a random date between 1 year in the past to right now. And once we have that fake date time created, we go ahead and set that as the created on field for our user model. We need to format it in such a way because that's what our database expects. Then we just use Python to generate a random number, and then we'll say that 95% of the users being created will be members, otherwise they'll be admins, and that'll leave us with about 5% admins. Then we just pop an email from the list and store it. This is also why the while loop works. Eventually our list of emails will be empty, and that's the break condition on our infinite loop. Then over here we just set another fake date time for the current sign-on date. After that, we just populate a whole bunch of parameters that will make up our fake user. You can see all the fields here, as well as encrypting some passwords, setting a random sign-in count, and even setting up fake IP addresses. Then down here on line 128, we just make sure that the seed admin always has the correct password of whatever we set in our config file. We also ensure that the seed user is always an admin. After that, we call a bulk insert function and pass it everything it needs to write all of this to the users table in the database. Let's scroll up to see how this function works by going up to line 34. Instead of adding each record to the database one by one, instead we're going to use a bulk insert, which is much more efficient. We're talking upwards of 20 to 30 times faster, and that number is going to grow if you wanted to add more data. The first thing that we do is take the model and then go ahead and delete all the model's contents. Then we bulk insert the list of users. Then we call the log status function, which is going to echo it with click, and we can see that up here. We'll see that we're just doing click echo, and then we're saying that we're going to create X amount of some model. In this case, that would be 100 users. Now that we have a means of creating fake data, let's continue on to the next lecture where we go over searching and sorting users in the admin. I'll see you then. In this lecture, we're going to go over searching and sorting users. If you haven't done so already, please head over to Section 13's folder in your Courses folder, and then open it up in your code editor. Then make sure that Docker Compose is up and running by typing docker-compose --up. Then once you have it up and running, open up a browser. Then head over to localhost port 8000/admin. Once here, then click the users link up top. And now that we have 100 users to play with, we can go over searching. So go ahead and do a search for Hotmail and hit enter. Chances are you'll see a few search results for all users who happen to have Hotmail in their email address. Searching is a very important aspect of the admin dashboard because you need to be able to find what you're looking for very quickly. In addition to being able to search for a user's email address, you can also search for their username. Your results will differ, but try searching for something like 21. This will return users who have 21 in their username as well as their email address. You can also clear the search results by just emptying the search box and then pressing enter. Now that we know how search works on the site, let's see how it's implemented. And for that, head over to your code editor. Let's begin by checking out the Jinja template for the user's index page. We saw that before, and that's going to be located in the Snake Eyes folder, Blueprints folder, admin, templates, admin, user, and then index.html. Notice here on line 9 that we're calling the search macro, and that macro is being pulled in from the form macro. So let's go ahead and go to the templates folder over here, then we'll go to macros and open up form.html. Then scroll down to line 69. The first important difference between previous forms is that this method is get instead of post. That's going to allow you to bookmark and even share search results because the search term will be included in the URL. This is a very basic search form that has an input field and a button. In this case, the search term's ID is going to be Q, and the value will be either the search term or an empty string. It's also worth mentioning here that we're using a Bootstrap feature that allows us to use an input group. That's going to allow us to have the Font Awesome search icon right next to the text box, and we can see that over here by going back to our browser. Notice how the search button is connected to the text field. Okay, so let's go back to our editor. Now that we know what the search form looks like, let's go back to the views file, which we can find over here in the admin blueprint. Once here, head down to line 45. This is where we're accessing the search form, so let's go ahead now and take a look at forms.py. It's very simple. It takes an optional string field with a length of 1 to 256. So let's head back over to views.py. Then take a look at line 53. This performs the filtering on the search results. Notice how we're passing in the Q value to it, but to understand how the search works, let's go over to the user folder and then open up models.py. Then scroll down to line 119. The first thing that we do here is return an empty string if there's no search query. Otherwise, we start to build up a search chain. It's going to search through the email and username columns. This pattern here on line 126 tells SQL Alchemy that we want to be able to search for partial words. If you were trying to find my last name in the search results, which is Genotakis, you would only have to type JAN to find it. In fact, you could even search for ETA and also find it because we have the percent signs on each side of the term. The SQL keyword that allows for this is called like, and in our case, we're using a slight modification of it called ILike, which does the same thing, except it's case insensitive. Line 134 uses the OR function, and that's supplied by SQL Alchemy. We're just importing it at the top of the file. This allows for the match to happen on the email, username, or both. If we used AND instead of OR, then it's going to only return results where a match was found on both the username and email. So that takes care of how search works. This method works really well for searching small fields of data. Now let's head back to our browser and go over sorting. You may have noticed that admins are always shown first in the list. That was done on purpose. In the future, when we have paying customers, they're going to be shown in between admins and regular members. So now let's jump back over to our index template, and for that, head back over to your code editor. Then open up the index.html file. Over here on line 2, we're pulling in the items macro, which contains all the sort logic at the template level. If we take a look down here at line 30, we can see how it's being used. All we do is supply the column that we want to sort on, and optionally a label for the header. In this case, our database column name is created on, but it's much more friendly to label that as registered. We also have a few other columns defined below over here on lines 33, 36, and 39. So now let's head over to the items macro to see how sorting works. To do that, head over to the templates folder, then go to macros, and then open up items.html. The first thing that we need to do is set up some variables for the sort, direction, and search query. The goal here is to set up sane defaults. We need to keep track of the search query just to make sure that we don't lose the search term when sorting. Lines 7 through 11 take care of setting a custom title header. If nothing is supplied, then it simply uses the column name. It uses the built-in Jinja title filter, which will capitalize the first letter of each word automatically. Then lines 13 through 17 handle swapping the sort direction. If we happen to be sorting in ascending order, then we want the link to sort in descending order. This allows you to alternate directions by clicking the link. Then down here on lines 19 through 23, we just handle setting up a specific CSS class depending on the order. To take a look at that, head over to the static folder, then go to styles, and open up main.css. Once here, then head down to line 99. The sort class uses the light gray up and down sort icon from Font Awesome. Then the ascending and descending classes both use a different icon. So now let's head back over to the items macro, which is items.html. Once we have all those variables set up, then we just build up the link. The first thing we pass in is the request endpoint, which is going to be the URL of the search form. Then we pass in the search term, the sort field, the sort direction, and then finally request.views_args. That last argument is going to allow us to forward the pagination pages, and that's because we have them defined as keyword arguments in the route. For example, if you head back over to views.py here, we have the page value defined as a named parameter. While we're here, let's take a look at lines 48 and 49, and this is where it all comes together. We're using a custom sort by method, which is provided by the SQL Alchemy util library. All we have to do is pass in the sort as well as the direction. In this case, it's going to sort on created on by default, and that's going to be sorting that in descending order. That's going to put the newest members up top. So now let's go ahead and check out that sort by method by going to the lib folder and then going to the SQL Alchemy util file. We could find that down here on line 37. The first thing that we need to do is protect against database errors by just defaulting to created on if the field doesn't exist. This shouldn't happen unless the visitor messes around with the URL manually, but it's good practice to protect against things like this. When developing a web application, you should always try to assume that every person visiting your site is malicious and will try to do as much harm as possible. Then we just do a sanity check on the direction to make sure it's only ascending or descending. Finally, we just return the field and direction in a tuple. So now let's hop back over to the views.py file. Line 50 takes that tuple and builds up an order by string to prepare sending it to SQL Alchemy. Then line 54 performs the actual ordering through SQL Alchemy. We pass in the roles column first because we want the list of users to always be sorted with admins on top. Then we just perform a text-based search on the order values. This is why the sign-in count and registered dates can't be sorted properly as is. We're trying to sort an integer or datetime field with a text sorting algorithm. Now, we could work around this by adding additional logic to determine the type of field, but I didn't bother doing it in this course. I think this is a great way to step outside of your comfort zone and implement a bug fix for a codebase that wasn't written by you. Think of it as an optional homework assignment to do once you've completed the entire course. It's not a ton of code to fix the bug, but you'll likely have to practice looking at SQL Alchemy's documentation on how to handle order by for non-string fields, and also think how to implement it in a reusable way. With that said, that brings us to the end of this lecture. I'll see you in the next one, where we go over deleting users. See you then. In this lecture, we're going to go over deleting users. If you haven't done so already, please head over to Section 13's folder in your Courses folder, and then open it up in your code editor. Then make sure that Docker Compose is running by typing docker-compose --up. Once you have it all up and running, then open up your browser. Once here, then head over to localhost port 8000 /admin/users. I'm a big fan of minimizing distractions in my designs, so instead of cluttering each table row with a delete icon, I've decided to come up with a solution that supports both deleting one or many users with the same UI. To delete a user, just click off the checkbox next to the user. You'll notice that the table headers disappear, and now you have the option to delete the selected item. As you select more items, you'll see here that the count for that goes up. You can even click the checkbox here, and that's going to select all the items on the page. However, you also have the option to click this drop-down box over here, and instead of deleting the 50 selected users, you could go ahead and delete all the search results. In our case, that would delete all of our users, even if they span across multiple pages. In this case, the currently logged in user, which is the seed account, would be ignored automatically. Not enough admin interfaces support doing things like this, and it's a shame. For example, Flask Admin doesn't support this functionality. You would have to go through every single page one by one and select each page individually. That sounds really tedious and annoying. So now let's go ahead and pick all search results here and then click delete items. And we'll see here that 99 users were scheduled to be deleted. As expected, our current user here, which is the seed admin, was left untouched. This is pretty cool because it makes it impossible to accidentally delete yourself. Now that you have an idea of how it all works, let's take a look at the code. And for that, head over to your code editor. Let's begin by taking a look at the main JavaScript file first. So head over to the Snake Eyes folder, static folder, then open up the scripts folder, and then open up main.js. The JavaScript is going to be responsible for updating the dropdowns text based on the number of selected items, and it also deals with selecting and unselecting all the checkbox items. Then lines 7 through 14 set up a couple of jQuery selectors. Here we can see some for the select box, the checked items, the column headers, and so on. And now let's head over to line 58. This just listens for the change event on the select all checkbox. Then line 59 saves the check status of the select all checkbox. Then on line 61, we're looping over every single checkbox item on the page. The next line sets the value of the checkbox based on what the value is for the select all checkbox. So if the checkbox is checked, then all the checkboxes will be checked. If the check status happens to be unchecked, then all the checkboxes will be unchecked. Finally, we trigger a change event for each checkbox. So let's check out what that does by heading up over here to line 34. Line 35 sets up a jQuery selector for all checked items. Then we get the current count of all the checked items, and then over here we have a very simple inflection library that pluralizes a word. We can see the implementation of that up here at the top of the file. It simply adds an S to the end of the word, and for us, it's good enough. This way, if we have one checked item, it'll say one check item, but if we have two checked items, it'll say two items with the S at the end. Now let's head back over to line 38. This just sets up the text for the drop-down box based on the variables above. Then lines 40 to 53 control hiding and showing the bulk delete form. If a checkbox is checked, then it shows the bulk delete form and hides the column headers. Otherwise, it swaps it by showing the column headers and hiding the bulk delete form. It also handles adding and removing a CSS class to each row, because it's a nice effect to have a highlighted selected row with a soft yellow color. If we go back to our browser really quick, we can see that here when we select the item, we get that nice little pale yellow. So now let's go back to our editor. Then down here on line 55, we just update the drop-down text with the new text. So that takes care of handling the UI logic. Let's take a look now at the user index template. And for that, head over to the blueprints folder, admin folder, templates folder, admin folder, user folder, and then open up index.html. Line 21 sets up the bulk delete form. Then over here, we have our select all checkbox, and our column headers all have the class col header, and that's set up to match up to what we have in the JavaScript file as a jQuery selector. Next up, we have the bulk actions column on line 41. It's set to span 4 columns because we have 4 column headers as long as you ignore the checkbox itself. Then we just render the form fields as you would expect. If you take a look here at line 57, we can see each checkbox item. Each checkbox has the same name because this checkbox will end up being a list. This is valid HTML, and this is how a single field can contain many values. For each checkbox item that we check, it's going to add the ID to the list. That ID is being set over here on line 58. So now let's check out the CSS code really quick. For that, head over to the styles folder and then open up main.css. Down here on line 86, we're setting up a CSS selector for the bulk actions as well as the scope. The bulk action is hidden by default, which is why you don't see it initially. With that out of the way, let's take a look now at the views file to see how it's all implemented on the server side. So open up views.py in the admin blueprint. Then scroll down to line 44, which is our good old index route for the users. We can see here on line 46 that we're rendering the bulk delete form. This bulk delete form is also passed through to the template down here on line 58. So let's take a look at this form here by opening up forms.py. If we take a look here, it just has one field, and that's the scope. It's very similar to the role field that we took a look at before. All it does is take a dictionary of 2 items here, and it creates a select box. It does that through the same choices from dict function that we took a look at before. So now let's hop back over to views.py. Once here, then jump down to line 87. It's a simple form-based route that we've seen before. In this case, it only accepts a post request. It also happens to use the same form that we just looked at, and if that form happens to be valid, then it calls a getBulkActionIDs method on the user. This is a custom method that exists in the SQLAlchemy utils file. It expects you to pass in the scope, which is either all of the selected items or the entire search results. Then you'd pass in all the selected checkboxes, and notice how we're using request.form.getList because it expects a list. Then we can optionally omit certain IDs, which in our case we're going to be skipping the current user. And then finally we pass in the search term, because we'll need to know which users should be deleted. So now let's check out how this method works by going to the lib folder and then opening up the util file for SQLAlchemy. Then scroll down to line 56. This method is pretty heavily commented because it's a little bit tricky. It uses a number of Python features to augment a list. It's not really that important that you understand exactly how it works. Just understand that in the end, it simply returns a list of IDs. What you do with those items is up to you. In our case, we're going to delete them. So now let's head back over to the views.py file. Once we have that list of IDs, then we just call the bulk delete method on the user and flash the user with the number of items that we plan to delete. Also, if the form happens to have issues, we warn the user that something went wrong. This could happen if someone went into their dev tools and started to hack around with the checkbox IDs. If you tried to delete an ID that didn't exist, then it would throw some type of error at the SQLAlchemy level. So let's see now how this bulk delete method works by heading back over to the SQLAlchemy utils file. We can find this over here on line 88. This performs a highly efficient bulk delete with SQLAlchemy. It's much faster than deleting the items one by one. Now that you know how to perform bulk deletes, let's finish up this section by reviewing a few tests that were written to ensure that everything works. And for that, I'll see you in the next lecture. See you then. In this lecture, we're going to review the new tests that were written for this section. If you haven't done so already, please head over to Section 13's folder in your Courses folder, and then open it up in your code editor. Then make sure that Docker Compose is running by typing docker-compose --up. Let's begin now by opening up a new terminal tab, and from here, we'll just do a test coverage on the codebase. So go ahead and type docker-compose --exec --website --snake eyes --cov, and then hit enter. There's been 5 new tests that were written, so let's go ahead and check them out in our code editor. Once here, just head over to the snake eyes folder, and then open up the test folder. Then just go to the admin folder and open up the test views. There's really nothing new to see here, but I do want to go over one test on line 45. This test proves that we can't accidentally delete ourselves. I wanted to show it to you because the checkboxes being rendered for each item in the actual HTML table is a list. So line 49 expects you to provide a list of IDs, just like it would be if you were to submit the form. Everything else is material that you've seen in a previous section. So now let's head back over to our terminal. Then once here, go back to your first tab and shut everything down. By now, you should know you can do that by pressing Ctrl+C. Then go ahead and type docker-compose space stop. The last thing that we need to do here is clean up our Docker mess. So go ahead and run docker-compose space rm space -f and then hit enter. And that wraps up this section, so great job at getting this far. This section was pretty deep and it covered a lot of advanced topics. Future sections will add to the admin blueprint, but now that you know how it all works, we'll be able to breeze through that material when we get to it. In the next section, we're going to tie up a few loose ends with Flask and go over how you can set up custom logging and handle errors. I'll see you there. In this section, we're going to tie up a few loose ends with Flask. First, we'll go over how to measure response times for all requests. Then, we'll cover configuring log levels with Flask. After that, we'll play around with adding log entries to our application. Then we'll switch it up a bit and see how to integrate Google Analytics. After that, we'll see how to fix IP address reporting by learning how to use middleware. Then we'll see how to create and use custom error pages. And finally, we'll go over emailing exceptions in production. I'll see you in the first lecture where we go over measuring response times. See you then. In this lecture, we're going to go over adjusting gUnicorn to include the response time for each request. Please head over to Section 14's folder in your Courses folder, and then open it up in your code editor. Then pop back over to your Courses folder and go to Section 13, and then go to the Instance folder and open up settings.py. Then copy all of your settings from settings.py here, and then go to the Instance folder for Section 14 and open up settings.py. Once here, replace the old values with the new values and save the file. Then head back over to your terminal. Once here, go ahead and make sure that Docker Compose is built and running by typing docker-compose space up space -- build, and then hit enter. Once everything is up and running, then head over to your browser, and then go to localhost port 8000. Then just go ahead and refresh the page a couple of times. After that, hop back over to your terminal. You'll see a bunch of log output like usual, except now if you look very closely at the end of each line, you'll see how long each request took in microseconds. You might be wondering why I chose to use microseconds and not milliseconds, and that's a fair question. gUnicorn allows you to gain access to the response time in seconds, microseconds, or seconds in decimal format. Long story short, there was no option to choose milliseconds, and seconds with decimal points looked more confusing than microseconds. To convert microseconds to milliseconds, you just need to divide by 1,000. So in this case, one of the response times took 2,844 microseconds. If we divide that by 1,000, we'll see here that the response was complete in 2.8 milliseconds. So now that you've seen the log file, let's head back over to our code editor. There's been a couple of small changes here. For starters, go to the config folder, and then open up gunicorn.py. The access log format is responsible for the custom log formatting, and there's around 20 different variables that we can access. All of these variables are documented on gUnicorn's website, which I've linked in this lecture's notes. I won't be going over each one of them here because their documentation does an excellent job at explaining what each one does. It's also worth mentioning now that I've done some slight refactoring of how we run gUnicorn in the Docker file and Docker Compose files. You may have noticed that in previous sections, we had to duplicate most of the commands in both files, but now I've moved all the common config values to the gUnicorn config file. You can see here that we're setting the bind address as well as the access log value. If we go ahead and take a look here at the Docker file, you'll see a new C flag here, which is going to load in the gUnicorn config. Then if we go ahead and check out the Docker Compose.yaml file, you'll see that same flag being used here. In addition to the config file being loaded, we're also passing in the reload flag, which is for development only. Everything works the same, but we no longer have to duplicate the config flags, and that's a big win. With that said, I'll see you in the next lecture where we go over configuring the Flask logger in our settings file. I'll see you then. In this lecture, we're going to go over a new config setting. If you haven't done so already, please head over to Section 14's folder in your Courses folder, and then open it up in your code editor. Once you've done that, then make sure that Docker Compose is up and running by typing docker-compose space up. Once complete, then head over to your editor. Then from here, go to the config folder and open up settings.py. The new config setting is located on line 4, and it's going to control the log level. It's currently set to debug, which will produce the most amount of logs. When set to debug, all 5 types of log levels will be shown. If you were to set the log level to warning, Then you would only see log entries for warning, error, and critical. Flask makes it very easy to write log entries at a specific level, and that's what we're going to experiment with in the next lecture. I'll see you then. In this lecture, we're going to go over using Flask's logger. If you haven't done so already, please head over to Section 14's folder in your Courses folder, and then open it up in your code editor. After that, go ahead and make sure that Docker Compose is running by typing docker-compose space up. Then once you have it all up and running, open up your browser. Then go to localhost port 8000 and make sure that you're signed out of your account. Once you've done that, then head over to your code editor. Now let's go to app.py, which is in the Snake Eyes folder. Once here, head over to line 70. This line has been added to configure Flask's logger with a log level set in our config settings file. If we didn't do this, then Flask will automatically set the log level to debug when the debug setting is true. In most cases, that's exactly what we want, but when debug is set to false, which is what it should be in production, then Flask will only show log output at the warning level or higher. That might be okay, but in a lot of cases, you may want to enable debug logging in production to help troubleshoot an issue. With our strategy, that would be as simple as changing one config setting and restarting the server. Now that we know how it's all wired up, let's experiment with logging a few things together. I highly recommend following along because we're going to be adding and then removing the log entries in this lecture. However, I did include some examples of logging in the notes just so you have a reference of these commands. So let's head over to the user model file, which is in the blueprints folder, user folder, and then models.py. If you remember back in a previous section, we imported the current app from Flask. Let's jump down here to the find by identity method, which is on line 52. Maybe for some reason, you decide that it's a good idea to log sign-in attempts. So let's do that together now. And for starters, go ahead and hit enter twice, and then go to line 60. The first thing that we need to do here is reach into the current app. So go ahead and type current_app, and this is where the logger has been configured onto by Flask. Then you would access the logger object by typing .logger, and then you would set the log level to one of the 5 types that we spoke about before. In this case, we'll use debug, so go ahead and type .debug. Then go ahead and add some parentheses here, and the log type is going to expect you to provide the log output as an argument, which will be a string. So let's log the user's identity when they try to log in. We can do that by typing quotes, and then open curly brackets, 0, close curly brackets, and then we'll do space has, space tried, space 2, space login. And then outside of the closing quotes, go ahead and type .format. And then add some parentheses there, and within format, we'll pass in the identity. And that identity is up here in the function as an argument. Then go ahead and save the file. Once complete, head over to your browser. Then head over to the login page, and try to sign in with some gibberish credentials. Feel free to use some email that definitely doesn't exist, as well as an invalid password, and then sign in. And if you're wondering why we're logging in with an invalid account, it's because it's much faster than logging in with a valid account and then having to log out every time to test the logger. So once you've done that, head back over to your terminal. You'll see a nice debug log message here, and it even points to the file and line where the log entry occurred. Then below it, we can see the message that we output. Now let's go back to our code editor. Then from here, go to the config folder, and then open up settings.py. Then change the debug logger to info, and make sure that it's in caps. Then save the file. Now head back over to your browser. And then once here, just try to log in once more with an invalid account, and then head back over to your terminal. This time there was no log output because our log was set to debug, but our log level was set to info. So that's how you can use the Flask logger in your app. You would just import current app, and then add logs wherever you want. So now let's clean up our mess by heading back over to our code editor. Then go ahead and revert your changes in settings.py and save the file. Then go to models.py and remove the log line that we just added. Once you've done that, then save the file. Before wrapping up this lecture, I just want to mention that logging is a very good way to debug things, so don't feel afraid to add a bunch of log entries. However, at the same time, you should think very hard about each log entry that you add. If it's not absolutely necessary to add, then you probably shouldn't add it. Also, I want to mention that by default, Flask will log everything to standard out. In addition to that, gUnicorn has also been configured to log to standard out, which we went over in a previous section. That means no log files will be written to disk. You might be thinking that's crazy, because then how could you look through your log output if it's not saved anywhere? Well, you have a couple of options. You could use a system-level log manager like syslog to handle your logs for you. You could configure that to take output from a process and then either write logs to disk or even push them to a remote server or third-party logging service. This way, log management itself is decoupled from Flask, and that's the way to do it. With that said, I'll see you in the next lecture where we integrate Google Analytics into the app. I'll see you then. In this lecture, we're going to go over integrating Google Analytics. In case you're new to web development, GA is a platform created by Google to view various stats and metrics about how users interact with your website. You can see how many visitors you've gotten, which pages they are viewing, and much, much more. We won't be going into GA in this course, but to integrate analytics onto your site requires pasting in a code snippet provided by Google. With that said, if you haven't done so already, please head over to Section 14's folder in your Courses folder and open it up in your code editor. Then make sure that Docker Compose is running by typing docker-compose --up. After that, head over to your browser. Then once here, go to localhost port 8000 to hit up the homepage. Then jump back over to your editor. The first thing that we'll check out here is the base template layout file. So please go to the Snake Eyes folder, Templates folder, Layouts folder, and then open up base.html. Then scroll down to line 28. And don't worry, you don't need to understand this because it's something you would typically copy and paste from Google. In our case, we won't have to copy and paste it because it's already here. The only thing that you would need to provide is your Google Analytics Universal ID, and you would set that in the instance/settings.py file, and you would be good to go. The reason that we want to put it in the instance folder instead of the config folder is because you don't want your requests in development mode to be tracked. You also wouldn't want to commit your Google UA code to version control because then multiple developers will all be broadcasting info to your account. If we look here at line 28, this demonstrates how you can read in a config value from Flask. This config object is automatically passed into all Jinja templates, and that's provided by Flask. So in this case, the if statement prevents the snippet from being output when that config value is empty or doesn't exist. The only difference between this snippet and the one provided by Google is line 35. We're referencing the config value that would contain the ID rather than hard-coding the ID itself. So let's go ahead and test this now by heading back over to our browser. Then just go ahead and go to View Source. You should notice that there's an empty space right above the closing head tag. Now let's head back over to our code editor. Then open up the instance folder and go to settings.py. Then just add a new line to the file and go back to base.html. Then just copy the config value and head back over to settings.py and paste the value. Then go ahead and type in space equals, space quotes, and then just put something like foo. After that, save the file. Then head back over to your terminal, and then once here, hit Ctrl+C to stop the server, and then do a docker-compose space stop. Then go ahead and do docker-compose space up. And we needed to manually restart the server because the instance folder isn't set up to be monitored for code changes. Now let's head back over to our browser. Then go ahead and close out your View Source window and reload the page. Then just go ahead and view the source code again. This time you'll see that the snippet has been included. And we can even see our fake foo value here, which Google is going to ignore. So that's all there is to it for integrating Google Analytics. Before moving on, you'll want to go back to the instance/settings.py file to remove the fake code. So head back over to your code editor, and then just remove this line and save the file. With that said, I'll see you in the next lecture where we configure custom middleware onto our Flask app. I'll see you then. In this lecture, we're going to go over hooking up custom middleware with Flask. If you haven't done so already, please head over to Section 14's folder in your Courses folder, and then open it up in your code editor. Then make sure that Docker Compose is running by typing docker-compose space up. Once you've done that, then head over to your code editor. Then go to the Snake Eyes folder and open up app.py. Once here, scroll down to line 127. This is a new function that's going to handle registering custom middleware onto Flask. But before we go into fixing the IP addresses with middleware, let me first explain what middleware is. Middleware is something that sits in between your WSGI server and Flask app. It allows you to augment details sent from your WSGI server before it reaches Flask. By the time it reaches Flask, you'll have access to the changes and Flask will be none the wiser. A common use case might be to add or remove HTTP headers, or maybe to set up a specific path to serve static assets. These are things that don't really belong in Flask, but are too custom to be included into most WSGI servers. So, that's why middleware exists. We can create our own custom middleware But Workzeug also includes quite a few pre-made middlewares. One of the built-in middleware classes that we can use from Workzeug is ProxyFix. When running your Flask application in production, you'll most likely end up putting Nginx or a load balancer in front of Flask. Since this isn't a course on deploying to production, I won't be going into great detail on what Nginx is, but just understand that it's a web server and you would typically use it to proxy requests back to Flask. That means in a production environment, users will be in contact with Nginx, and then Nginx will forward that request to Flask. If our Flask application tries to read in a user's IP address, and it happens to be proxied by Nginx, then Flask is going to think the request originated from Nginx, which in turn means it will use our web server's IP address instead of the user's IP address. That means your IP address values will be the same for everyone, which is clearly not the intended result. The ProxyFix middleware steps in and fixes this by looking at a few specific headers that should be set in Nginx or whatever you use as a proxy. It will then take those values and place them where they need to be so that Flask can read in the real user's IP address when accessing request.remote_adder. If you remember back in the user section, we do store the user's IP address when they sign in, so this middleware is very important to us. Now, I should warn you that if you don't plan to use a proxy, then you'll want to remove this for security reasons, but honestly, in production, you should always be using a proxy, such as Nginx. For development mode, it doesn't matter, so we'll just keep it enabled. So that takes care of explaining what middleware is. Now, if you take a look here at line 135, we're just passing in the Flask SAP WSGI app to the ProxyFix class. Then we just set the result of that to app.wsgi_app. This pattern is how you would register any custom middleware with Flask. Now, if you scroll up here to line 72, you can see that we're calling this middleware function while passing in the app. Also, in case you're curious, the ProxyFix class is imported directly from Workzeug, which is at the top of the file. If you're still not 100% clear on when to use middleware, don't worry. It's one of those things where you'll know when you need to use it when a specific use case pops up. With that said, I'll see you in the next lecture where we go over setting up custom error pages. I'll see you then. In this lecture, we're going to go over creating custom error pages. If you haven't done so already, please head over to Section 14's folder in your Courses folder, and then open it up in your code editor. Then make sure that Docker Compose is running by typing docker-compose _up. After that, head over to your browser. And then once here, go to localhost port 8000/ASDF and hit enter. Instead of showing the default Flask 404 page, we're seeing a custom 404 template. There's also a separate template for error 500 pages, but there's nothing set up at the moment to view it. Let's see how this works by going over to our code editor. Then once here, go to the Snake Eyes folder and open up app.py. Then scroll down to line 73. We're calling a new function called error templates, and that function is defined here on line 140. Since we want to capture errors across all of our blueprints, we need to set things up at the app level rather than at the blueprint level. An alternative way of supplying error templates would be to use an error handler decorator, and this method is documented in Flask, but we need to come up with a better way, and we have. Well, I haven't, but someone on Stack Overflow did, and they posted a very nice solution for creating app-level custom error templates. Line 159 forces all types of error 500s to get normalized to a 500, and after that, we just render a template for that error code. Then on line 162, we inform Flask that we want to render custom error templates for both errors 404 and 500. You can add more status codes to the list if you want, but these two are good enough for most cases. Line 163 associates the error code to the template. So now let's take a look at the templates, and for that, head over to the Templates folder, Errors folder, and over here you'll see templates for both 404 and 500. Let's open up the 404 template and take a look. It's extremely basic, and at the end of the day, it's a regular template. The 500 template does the same thing, except it says error 500 instead. I purposely left them as being pretty bland because I think it will be a fun exercise for you to create your own unique error pages once you finish the course. Before we wrap up this lecture, let me show you how you can raise a custom error in Flask to test your error templates. For that, head over to the Blueprints folder, then go to the Page folder and open up views.py. Then go over here to the home route and add a couple of new lines, and from here we'll type from space Flask space import space abort. Then add a new line, and after that type abort, open parentheses, close parentheses, and within those parentheses add 500, and then save the file. Now head back over to your browser. Then just click the Snake Eyes logo to go back to the home page. And now you can see here that we're rendering the error 500 template. So let's go back now to our editor, and we'll just remove a couple of lines that we added, then save the file. The last thing I want to go over here is in the test folder, and then go to the page folder, and then go to test views. Then scroll down here to line 22. I just wanted to make sure that the error 404 page is working as expected. So we're going to navigate to a page that will never exist in the application. It's kind of a silly test, but it works. And that's all there is to it for creating custom error templates. I'll see you in the next lecture where we go over how to email full stack traces in production. I'll see you then. In this lecture, we're going to go over handling exceptions in production. If you haven't done so already, please head over to Section 14's folder in your Courses folder, and then open it up in your code editor. Then make sure that Docker Compose is running by typing docker-compose --up. After that, head over to your browser. Then just go to localhost port 8000 and hit enter, and that's going to load up the home page. And now let's jump back over to our editor. Then from here, go to the Snake Eyes folder and open up app.py. Then scroll down to line 74. This is where the Flask app factory calls out to a custom exception handler function, which is defined at the bottom of the file. Let's go ahead and check that out now. It's going to be really important that you get notified when an error happens in production. You shouldn't have to manually check your log files in the off chance that your application throws an error. So the easiest way to get notified of errors is to have them get emailed to you when they happen. There's more fancy third-party services that you can use for keeping track of errors, but email works just fine. This function sets things up so that any type of error 500 will get emailed to your mail's username. It's going to include all the details about the error so that you can properly troubleshoot it. Flask is smart enough to not send this email out when debug is set to true, so we won't get bothered in development mode. Let's go ahead and test it now by heading over to the config folder and then opening up settings.py. Then once here, replace the debug true to be debug equals false. Then save the file. Then let's go to the blueprints folder, page folder, and open up views.py. Then go ahead and purposely wreck the render template function by cutting out some of the characters and then saving the file. Once you've done that, head over to your browser. Then just reload the home page and see what happens. You'll notice that it throws the error 500 template, but in about a second or so, you should receive an email with the exception. Inside the email, we can see the time, the message type, where it happened, and even a full stack trace. Over here, we can see global name late is not defined, which makes sense because that function doesn't exist. With that said, let's head back over to our editor. Then from here, just revert the changes and save the file. Then head back over to the config folder and open up settings.py. We'll want to change false to be true again, and then save the file. Before we wrap up this section, let's go ahead and clean up our mess with Docker, and for that, head over to your terminal. Then from here, just go ahead and press Ctrl+C, and then like usual, we'll do docker-compose --stop, and then hit enter. After that, we'll do the usual docker-compose --rm --f. And that concludes this section. Our Flask application is now in awesome shape. In the next section, we'll add a few quality of life improvements to the CLI script. I'll see you there. In this section, we're going to create a few new CLI scripts to improve our quality of life. First, we'll see how we can easily generate secure tokens. Then we'll go over outputting all of our route endpoints through the CLI. And lastly, we'll see how to count the lines of code in our project. I'll see you in the first lecture, where we learn how to generate secure tokens. See you then. In this lecture, we're going to generate a secret token with a CLI script. Please head over to Section 15's folder in your Courses folder, and then open it up in your code editor. Then go ahead and build and run your Docker containers by typing docker-compose --up --build, and then hit enter. Then once everything is up and running, open up a new tab. Then let's go ahead and run the new secret command. We can do that by typing docker-compose --exec --website --snakeeyes --secret, and then hit enter. Each time you run this command, you'll get a new random token that's suitable for cryptographic use. In other words, you can run this command to generate a secure secret token. You would want to do this when creating your secret key for production use. The token that gets generated by default returns 128 bytes. If you want, you can also use the secret command to generate shorter tokens for other use cases. You can do that by optionally supplying in the number of bytes as an argument. So, for example, go ahead and hit the up arrow, and then type in space 64, and hit enter. You'll notice now that the token that was generated is half the size of the previous one. Then hit the up arrow once more, backspace out the 64, and type in foo, then hit enter. Since the argument is defined as an integer, Qlik is smart enough to parse it and perform validation for us automatically. Not a single line of code was written to get that error message. Okay, now that we know how it works, let's see how we did it. And for that, head over to your editor. Then once here, go to the CLI folder, Commands folder, and then open up the secret command. I bet it's a quite bit less complicated than you thought it would be. Python has a few libraries that helps us create secure tokens. The first one is os.urandom, and this will return back a string of random bytes. In this case, the bytes amount is configured by the bytes argument. The output of urandom is not quite usable as a secure token, so then we use the binASCII library to convert the binary output to hexadecimal. In case you are curious why you end up with double the number of characters in the output, that's because every byte of data is being converted into a 2-digit hexadecimal representation. So if you pass in 4 bytes as an argument, then you'd end up with 8 hexadecimal characters. Anyways, just run the command without arguments to create a very secure secret token when you're ready to deploy your application to production. And with that said, I'll see you in the next lecture where you'll learn how to output all of your route endpoints from the command line. I'll see you then. In this lecture, we're going to output all the route endpoints with the CLI script. If you haven't done so already, please head over to Section 15's folder in your Courses folder, and then open it up in your code editor. Then make sure that Docker Compose is running by typing docker-compose --up. After that, open up your browser. Then head over to localhost port 8000. Once here, open up the debug toolbar, and then go down to the route list. That's going to show you every single route endpoint in your application. It even shows you which HTTP methods are available for each route. This is a very simple and useful way to get a high-level overview of what your application does. It would be pretty cool if we could reproduce this output on the command line. One day, you may want to script something out that generates documentation based on your app's routes or something along those lines. So let's head over to our terminal, then open up a new tab. And before we run any commands here, I just want to say that I've bumped down my font size on the terminal just to make sure that it fits nicely. Hopefully you can still read it, but if not, you'll be able to read it on your own in your output. With that said, go ahead and type docker-compose --exec --website --snake eyes --routes, and then hit enter. You'll see a nicely formatted list of routes. It even omits showing the debug toolbar routes because those are not part of our application. In addition to getting the path, we also have access to the blueprint name. So now let's head over to our code editor. Once here, head over to the CLI folder, Commands folder, and then open up the routes command. Then scroll down to line 17. Flask gives us a way to access all the URLs of an application by accessing app.urlmap.iterrules. All we have to do is loop through each one, then do a little bit of string parsing to differentiate the blueprint, path, and methods. Line 25 figures out how many characters of padding we need so that we can get everything to align nicely in the terminal. Since each route name is a different length, things would look really messy in the terminal if we skip this step. Then on line 27, we sort the routes alphabetically, and then output each route while ignoring the debug toolbar entries. Line 29 does a bit of formatting magic to left pad the route names with spaces. And that brings us to the end of this lecture. I hope you enjoyed it because not only did it show you how to get the route information from Flask, but it also shows you how to parse strings in Python. I'll see you in the next lecture where we go over counting lines of code in our application. I'll see you then. In this lecture, we're going to run a new command against our codebase, and it's going to report back how many lines of code were written for our application. If you haven't done so already, please head over to Section 15's folder in your Courses folder, and then open it up in your code editor. Then make sure Docker Compose is running by typing docker-compose --up. After that, go ahead and open up a new terminal tab, and then let's go ahead and run the command. We can do that by typing docker-compose --exec --website --snake eyes --loc, and that stands for lines of code. Then hit enter. This is going to analyze the source code and count the lines of code for each type of programming language in the project. It's configured to ignore new lines and comments in the total count, but in the case of Python, it will include docstrings as lines of code. At this point in the course, we've gone over 1,800 lines of Python code. Considering how much the site does already, that's really not too bad for a micro framework. Don't forget too that it's counting not only the Flask app, but also the CLI script and all of our tests. Let's see how this was done by heading back over to our code editor. Then once here, go to the CLI folder, commands folder, and then open up the LOC command. In terms of click knowledge, there's nothing new to look at. All I did was hack together a few Unix commands to find files of a specific type. Then I used sed to filter out lines that are comments, and then finally used word count to count the lines. It then uses check output to store the results of running this into a variable. Then down here on line 31, I set up a couple of file types to get the line counts on. Then over here on line 40, we just loop over each one and call that count locks function that we just went over. There's likely better ways to do this, but for a few lines of code, I think it was a reasonable investment to include in the project. I know that there is a dedicated tool called clock, but that would require installing a dependency inside of our Docker image, and I didn't want to do that. Also, I don't like using lines of code as a metric to determine how complex or large a project is, but having a general idea of how many lines of code your project is does have some value. It's going to help you estimate future projects at a very high level. With that said, let's end this section by going back to our terminal. Then go back to your first tab and shut everything down by pressing Ctrl+C. After that, we'll do the usual docker -compose stop. Then we'll clean up our Docker mess by typing docker -compose rm -f. At this point, I would consider the base application to be done. This would be an excellent starting ground for any new application that happens to require users. In the next section, we're going to build on top of this by introducing the reoccurring billing system. I'll see you there. In this section, we're going to go over the entire reoccurring payment system. This is the longest section in the course, and we're going to be covering a lot of ground. First, we'll go over why Stripe was picked as a payment gateway. Then we'll go over the new libraries that have been added to the project, and see how to configure the application's billing settings. After that, we'll visualize how all of the billing data models work together. Then we'll go over how to create subscription plans and pick them on the site through a pricing table. Then we'll walk through subscribing to a plan, as well as how to update and cancel that subscription. Next up, we'll extend the admin blueprint with the new billing details. Then we'll go over viewing a billing history, which will include pending payments and a complete billing history. After that, we'll go over configuring webhooks with Stripe so that our application can react to push notifications from Stripe. Finally, we'll go over how to view sales charts, issue refunds, and explore the rest of Stripe's dashboard. I'll see you in the first lecture, where we go over why Stripe was chosen. I'll see you then. In this lecture, we're going to sign up with Stripe. Rather than store and process credit cards in our own system, we can offload that task to a third-party payment gateway, such as Stripe. The reason why I chose Stripe is because their API is really good for handling reoccurring payments, and that's exactly what we need to bill users at regular intervals. In addition to reoccurring payments, they also support one-off payments, coupon codes, and so much more. Their API is very large, but it's also very well documented. Another great perk of using Stripe is that they support a ton of different currencies, and their uptime is very impressive. In return for this, you'll pay Stripe 2.9% plus 30 cents for each successful credit card transaction. There's no monthly or hidden fees. That's it. There's other payment gateways like Braintree who don't charge you anything until you've made $50,000 USD, but their API is quite a bit worse. However, the upside to Braintree is that they also support PayPal, which is kind of a big deal in some cases. You may want to look into that on your own if PayPal support is necessary. However, in this course, we're going to be using Stripe. Now that we know a bit about Stripe, let's register a free account by heading to stripe.com. Then down here, go ahead and click the Sign Up button, and here we have Stripe's registration page. It does give you an option to skip this step, but soon enough we're going to need to create API keys, and for that you'll need an account. So go ahead and sign up now. I already created an account off camera, so please pause the video and sign up on your own. Then once you have an account made and are logged in, then resume the video. Okay, great. So now that you have an account and you're logged in, you should be looking at a screen that's pretty similar to mine. This is the Stripe dashboard, and it's where you can easily track details associated to your account. Notice how there's a live and test switch up top. One of the nice things about Stripe is being able to develop your app with test API keys. This means we can create as many users and credit card transactions as we want without having to worry about being billed. All of the API calls and codebase will be identical to the live version. The only difference is the API keys that we use in our settings. With that said, please head over to your Accounts drop-down box over here, and then go to Account Settings. Then head over to the API keys section. It's extremely important that you keep these API keys private, because if these leak out to anyone, then they can interact with your account. I'm showing my keys on camera because as soon as I finish recording everything, I'll be re-rolling them. In case you do ever misplace your keys, you can just click the refresh icon to roll a new key. That's going to allow you to deactivate the old key and create a new one. Since we're dealing with the test version, we'll want to copy the test keys. Stripe makes it very easy to determine which mode you're in because the keys themselves contain test or live in them. For example, we can see here that it says skey_test, but for the live version, it says skey_live. For now, just keep your browser open because we're not ready to copy them just yet. I'll see you in the next lecture where we go over what changed in the requirements.txt file. See you then. In this lecture, we're going to go over a few new packages that were added to the requirements.txt file. So please head over to section 16's folder in your courses folder, and then open it up in your code editor. Then once here, open up requirements.txt. The first change is over here on line 26. This is the official Stripe library for Python. It's responsible for allowing you to connect and interact with Stripe's API. It's maintained by the Stripe team and it's very well tested. If you're curious, you can find it on GitHub, and I've linked to it in the course's notes. Another pretty cool thing about Stripe is their API's documentation includes Python code samples, so you'll be able to see how to make any API call using the Stripe library. We'll be going over that later on in this section. The other addition is over here on line 9, and this is going to introduce the mock test library. Stripe's API is very well tested because the Stripe developers have tested it. However, we want to test our application code, which may use Stripe's API, but we don't want to actually call out to Stripe's API in our tests. Instead, we want to test our own code, and we can do that with the mock library. This library will let us set up JSON responses from Stripe and then use those in our tests. This will not only make our tests execute way faster, but it's a good way in general to test code that depends on third-party services. This notion of replacing real data with stubbed out data or fake data is called mocking. I'm a big fan of using real data when possible, but when it comes to third-party code like Stripe's API, it's a no-brainer to mock out the results. With that said, now that we know which libraries have been added, let's go over configuring a few settings, and for that, I'll see you in the next lecture. See you then. In this lecture, we're going to go over a few billing settings. If you haven't done so already, please head over to section 16's folder in your courses folder, and then open it up in your code editor. Then let's go ahead and copy over our instance settings file from the previous lecture. So open up your courses folder, and then go back to section 15, and open up the instance folder, and then open up settings.py. Once here, copy all the settings, go back to your code editor, then go to the instance folder, open up settings.py, and then replace the email settings up top. You'll notice now that there are some Stripe API keys here, but don't worry about them just yet. We'll get to those soon enough. Instead, let's head over to the config folder and then open up settings.py. Then once here, head down to line 49. First off, lines 50 and 51 contain settings for our API keys. They're set to none here because it's going to be expected that you would set these in your instance settings.py file since they contain sensitive data. So now's a good time to hop back over to your browser, and then go ahead and copy the secret key, and hop back over to your editor, then go back to the instance settings.py, and then paste in the secret key. Make sure that you have no leading or trailing spaces. Then go ahead and repeat the same thing for the publishable key. So just copy that, and then head back over to your editor, and then go ahead and paste it in, and save the file. And once you've done that, then go ahead and close the instance settings.py. The next value here is on line 52, and it's going to let the Stripe Python library know which version of the Stripe API to use. I really like the idea of versioning your API by date rather than something like version 1 or version 2. It allows you to quickly iterate and release new API versions, and consumers of your API can lock into a specific version if they don't want to stay on the bleeding edge. To put things into perspective, I have a few projects that use Stripe with an API version that's over a year old and they still work great. Stripe's documentation provides you a changelog for each version, and if your version is less than the newest version, it's going to show you a list of changes since then. That makes it very easy to see what changed and allows you to quickly update your codebase as needed. With that said, let's leave the API version as is. The next setting is how we'll store our plans. It's pretty common for a software as a service application to provide multiple payment tiers. In our case, we're going to let users pick from 3 different tiers. We have a bronze plan, a gold plan, and also a platinum plan. Storing them like this will allow us to easily sync the plans to Stripe. We'll go into great detail on this in a future lecture, but for now let's wrap things up here. And I'll see you in the next lecture where we go over how the API keys are being used in our application, as well as get a high-level overview of the billing blueprint. I'll see you then. In this lecture, we're going to go over the billing blueprint. If you haven't done so already, please head over to Section 16's folder in your Courses folder, and then open it up in your code editor. Then once here, head over to the Snake Eyes folder, Blueprints folder, and then open up the Billing folder. There's a lot of stuff going on here. We have a Gateways folder, because in theory, you could support more than one payment gateway. Then within here, we have the Stripe gateway. It has com added to the file name, because the official Stripe library is called Stripe, and we wouldn't want our module name to conflict with theirs. Then in the Models folder, we have a number of different payment-related models, and we'll take a look at these in more detail in the next lecture, where we go over the data model in detail. Then we have a few templates and macros, which we'll see soon enough. Then there's a View folder, and within there, we have 2 View files. The billing.py file is for the billing blueprints, while the other one is for another feature of Stripe called webhooks, and we'll explore all of that throughout this section. Lastly, in the root of the billing blueprints, we have a couple of files. Most of the files here should look familiar to you, but the template processors file is new. This will be the first blueprint that we use where we end up creating our own custom Jinja filters and functions. Now let's finish off this lecture by reviewing the app.py file. Then once here, scroll down to line 79. Line 79 handles in reading the Stripe secret key, and then line 80 is for setting the API version. Then, like usual, we just register our blueprints. In this case, we have 2 new blueprints. One is for billing, and the other is for the Stripe webhook. There's also a new template processors function, which is where we'll register the custom filters and functions, but we'll go into that later. Now that you have a general idea of the scope of the billing blueprints, let's take a deeper look at how all of the models relate to each other. And for that, I'll see you in the next lecture. See you then. In this lecture, we're going to visualize our current data model. This will help get an idea of how the billing and user model data come together. First up, we have our user's model. There's been 3 new fields added to it since the previous section, and those are name, payment ID, and canceled subscription on. The name is going to store the billing name of the customer. The payment ID will store the customer ID from Stripe's end. You could say this is the payment identifier associated to a user, and we need this value to perform modifications to a user's plan, such as upgrading, downgrading, or canceling their plan. This lets us act on behalf of a customer without requiring their billing information again. Then we have the canceled subscription on field, and that's going to tie in when a user happened to cancel their subscription. This is handy to know because it lets us determine if a user was a subscriber in the past and when they canceled. Then we have 4 new models. The subscription model stores data about the subscription. It has a reference back to the user model. This is how we can relate a user to a subscription. It also happens to store the plan that they're subscribed to, as well as the coupon code. The coupon code is a string instead of a reference to the coupons model, because it's possible for a subscription to be using a coupon that's been deleted since the subscription was started. Speaking of coupons, let's take a look here at the coupons model. Stripe's coupon system is very nice. We can provide the coupon name, if the coupon should last once, repeat for a certain amount of time, or last forever. We can also choose to adjust the price by providing an amount off or a % off. We can also choose the currency and how long the coupon lasts for. The duration in months is really cool because it would be possible to make a coupon that gives someone 50% off for the first 3 months of their subscription. That's pretty powerful. Next up, we can set a max redemptions, which is going to allow the coupon to expire after a certain amount of people have used it. We can also set a redeem by date that expires the coupon automatically once a certain date has passed. Lastly, we'll just keep track of how many times the coupon was used and whether or not it's still valid. Next up, let's take a look at the credit card model. Like the subscription model, it also has a relation back to the user. It seems valuable to be able to answer questions like, show me this user's credit card information, and that's why it's related to a user. Keep in mind that we're not actually storing the full user's credit card information. We're just going to store which brand they use, which would be Visa, Amex, MasterCard, and so on. Then we store the last 4 digits of the card, as well as the expiration date and whether or not the card is going to expire soon. Having this information locally allows us to display certain bits of billing-related information back to the user without having to look it up from Stripe's API. We want to eliminate as many API calls as possible because it's very slow to contact Stripe's API versus looking up a value in our database. The difference might be as much as 500 milliseconds, which is quite noticeable. Having all of this card information locally also lets us run recurring daily tasks that check to see if a user's credit card is about to expire. If it's going to expire soon, we can notify the user that they need to update their payment information. That's a very nice usability enhancement and will help improve your revenue because users will have a 2-month notice to update their card details. Lastly, we have the invoice model. It's going to be important that users are able to see their previous invoice history, and that's why we store this data locally. As you'll eventually see later on in the section, we do need to hit Stripe's API to get upcoming invoice information, but there's no way to get around that. Like a few of the other models, this one also relates back to the user. I won't be going into the details of all these fields here, but just understand that we'll be displaying a nice table of billing history back to users. So that's how everything connects together. As you can see, our user model is the center of attention, and most of our billing components are isolated from each other. Throughout the rest of this section, we'll see how all these relationships and models are implemented in Flask. Thanks for watching, and I'll see you in the next lecture where we go over creating subscription plans. I'll see you then. In this lecture, we're going to go over creating and syncing subscription plans. If you haven't done so already, please head over to Section 16's folder in your Courses folder and open it up in your code editor. Then make sure Docker Compose is up and built by running docker -compose -up -build, and then hit enter. This command is going to take a couple of minutes, so I'm going to pause the video now and I'll meet you back when it's done. After that, go ahead and open up a new terminal tab. Our database schema changed since the previous section, so we need to reset and see the database once more. We can do that by running docker -compose -exec -website -snakeeyes -db -reset -with -test db, and then hit enter. Then let's go ahead and generate a whole bunch of fake data. So go ahead and hit the up arrow, and then backspace out all the way to the db. Then go ahead and run add all, and hit enter. And that's going to create 100 users and a couple hundred invoices. And we'll go into the invoices later on. Once that's done, head back over to your editor. Then go to the config folder and open up settings.py. And once here, head down to line 53. We'll be sending this dictionary of plans to Stripe using the CLI. And we'll also use this dictionary to render the pricing table, which is what allows a user to pick a plan. Since setting up plans is something you'll very rarely do, it doesn't make sense to add a fancy front end for this in the admin dashboard. However, you could easily extend the admin to make a front end for this if you wanted to. And don't worry, there's going to be a nice front end for managing coupons, since that's something you'll likely be modifying on a regular basis. Before we go into the CLI code, I just want to go over the values for each plan. Every field that you see here is detailed on Stripe's API documentation, which I've linked to in this lecture's notes. The ID field is how you'll reference the plan, and it needs to be a string. Next up, we have the name, and that's going to be the display name of the plan. Next up, we have the amount, and the amount is going to be in cents. Our plans will cost $1, $5, and $10. In our case, we're charging customers in USD currency, but Stripe supports over 130 currencies. I've included a link that you can check out in this lecture's notes, which goes over every single currency that Stripe supports. Next up, we have the interval, which is set to month in this case, but Stripe also lets you choose by day, week, or year. The interval count is how many intervals should pass before a customer gets charged again. In our case, they're going to be billed once per month. This is a genius way to set up billing intervals because it allows you as a business owner to bill customers at nearly any reasonable interval. For example, if you wanted to bill people every quarter, you could just set the interval to month and then set the interval count to 3, and that's going to bill your customers once every 3 months. Then we can optionally set a trial period in days, and in our case 14 days seems reasonable. This means customers won't be billed for the first month until 14 days passes. The statement descriptor is what customers will see on their bank statement. Next up, we have metadata, and this is Stripe's way of allowing you to save arbitrary data to a plan. For example, in our Gold plan, we have a non-empty metadata dictionary. In this case, we set recommended to true. When our website displays the pricing tables, it will make the recommended plan a different color and slightly larger. The goal here is to bring this plan to attention so that visitors are more likely to choose this plan over the others. Now that we know all about setting up plans with Stripe, let's see how we do it through the CLI. And for that, head over to the CLI folder, Commands folder, and then open up the Stripe command. This file is responsible for performing 3 different tasks. The first one will sync the plans to Stripe. The next one allows us to delete plans by passing in a plan's ID. And then finally, the last one allows us to contact Stripe to get back a list of existing plans. Let's see how the sync plans command works by heading up over to line 19. The first thing that we do here is exit out and return nothing if the Stripe plans are empty. Otherwise, it loops through each item in the dictionary, and the underscore here is to denote that we don't care about the key. In this case, the key is going to be 0, 1, or 2. Then for each plan, we do a lookup by ID. If it exists, then we update the plan. Stripe doesn't let you adjust an existing plan's price, which is why we can only update a few fields for the plan. So in this case, if the plan already exists, then we do an update, otherwise we create the new plan. This payment class is being imported at the top of the file, and it's part of the Stripe Gateway implementation. So let's see how that works. And to do that, head over to the Snake Eyes folder, Blueprints folder, Billing folder, Gateways folder, and then open up StripeCom. Then once here, scroll down to line 185. This class basically wraps the Stripe library, and we do that because we want to keep our application code, such as the CLI or the web application, oblivious to which payment gateway we use. This will allow you to switch the payment gateway without having to make a million assorted changes in your codebase. So now let's take a look here at the retrieve method. It simply calls out to Stripe's API to retrieve the plan, and if an error happened to occur, then it just prints it out. If you remember back in the CLI code, we called payment plan update to update an existing plan. So jump down to line 262 to see how that's done. It just looks up the plan like we did before, and then goes ahead and sets a couple of fields that we're allowed to edit. Finally, it goes and saves the plan. Now is also a good time to note that each method that calls out to Stripe has pretty elaborate documentation attached to it. I even include links to Stripe's API for easy reference. Let's scroll up a bit here and take a look at the create method. It too just calls out to Stripe's API and passes in all the plan's fields. Now that we know how to sync a plan, let's go ahead and actually do it. So for that, head over to your terminal. Then go ahead and hit the up arrow, and backspace out up until the add. The sync plan command is going to belong to the Stripe command, so go ahead and type out Stripe, space, sync, underscore plans, and then hit enter. That's going to take a couple of seconds to run, so don't be alarmed if it hangs for a bit. If you happen to get an error instead of no output, then double check your API keys. Make sure that you're using the test keys and you have no white space before or after the key. With syncing plans out of the way, let's go ahead and try to list the plans. We can do that by pressing the up arrow, and then backspace out sync plans, and replace that with list underscore plans, and then hit enter. You should see a JSON response with all the plans that we just synced. So now let's head back to our code editor. Then from here, go back to the Stripe command, and then scroll down to line 58. All it does here is print out the value returned by calling the list command on our payment plan class. So let's check that out now by heading back over to the StripeCom file. We can see that method down here on line 204. All it does is call plan.all on Stripe's API. Let's wrap up this lecture by heading back over to our terminal. Then from here, we're going to go ahead and delete a plan, and we can do that by hitting the up arrow, and then backspace out list plans, and go ahead and type delete underscore plans space bronze, and then hit enter. Then let's go ahead and relist our plans by hitting the up arrow twice and hit enter. If we scroll up here in our output, we'll notice that there's only 2 plans now because the bronze plan was deleted. You can see here we have a plan for platinum and a plan for gold, but bronze is not there. So let's hit the up arrow a couple of times now and rerun the sync plans command, which again is going to take a couple of seconds. Seeing that request no such plan bronze is completely fine, so don't worry about that. If you remember from a few minutes ago, the sync method will try to do a lookup by the plan ID first, and in this case the bronze plan won't exist, but it'll go ahead and recreate it. For example, if you hit the up arrow twice to relist the plans, you'll notice now that the bronze plan is back in action. So now let's go back to our editor. The last thing that we need to do is check out the delete command, so head back over to the stripe command file, and then go up here to line 45. If we go up one line here, we'll see that this command takes a list of IDs. It's interesting to note here that the nargs -1 lets Qlik know that we're expecting an unknown amount of plan IDs. You could pass in 1 plan or 100 and it wouldn't matter. All we do here is loop over each plan and then call paymentPlan.delete. Let's finish things off now by taking a look at that method in the stripecom file. You can see it down here on line 292. This plan is very simple. It just does a lookup on the plan and then deletes it. And if it happens to get an error, then it prints it out. So that's everything there is to it for managing plans. If you were to deploy your application to production, it would be expected that you sync your plans once and then you're good to go. With that said, I'll see you in the next lecture where we go over the pricing table on the website. I'll see you then. In this lecture, we're going to take a look at how the pricing tables work. If you haven't done so already, please head over to Section 16's folder in your Courses folder, and then open it up in your code editor. Then make sure that Docker Compose is running by typing docker-compose --up. Once you've done that, then open up your browser. Then once you're here, go to localhost port 8000. You should now see a pricing link next to the logo, so go ahead and click that. This is the pricing table, and it's being mostly generated by the plans that we defined in the settings file. Here we can see the plan name, and down here you can see the price, and it's been converted from cents to dollars. And in the middle, we have the gold plan, and that's noticeably bigger in red, which as you may have guessed, is the recommended plan. The lorem ipsum text is just a placeholder for real benefits that you would add for your service. If you have no idea what lorem ipsum is, I recommend Googling for it later. All the benefits that you see here are being inserted with a Jinja macro, which we'll see soon. But before we get into that, notice here on the bottom that the pricing tables say to sign up. It says that because we're not logged in. So let's log in now as the seed user. So head over to the login page, then you could log in with dev@local.host, and the password will be dev_password. After that, go ahead and sign in, and then head back over to the pricing table. Now instead of saying sign up down here, it says continue. We'll go into this in a bit, but for now, let's go back to our code editor. First up, let's go to the Snake Eyes folder, and then we'll go to the static folder, styles folder, and open up main.css. Then scroll down here to line 47. There's been a number of helper classes that I've added. Feel free to look at them on your own time. However, let's take a look here at line 62. And this one is to transform an element by a certain scaling. In this case, we're scaling things up by 5%, and that's how we make the gold plan a bit larger. Now let's check out the template for the pricing page. And for that, head over to the blueprints folder, then go to billing, templates, billing once more, and then open up pricing.html. It has the same shape as most other templates. We just have our extensions up top along with imports, and then we have a couple of blocks. Let's scroll down here to line 37. This is where we render each plan's column. Here we have the bronze plan, then the gold plan, and the platinum plan. We're using a Jinja macro for this, and it's also using the caller feature that we looked at in an earlier section, and that allows us to attach custom benefits to each plan. So now let's take a look here at that plan macro, and for that, head over to the macros folder, and then open up billing.html. Then scroll down here to line 16. This macro is responsible for rendering sign up, continue, or change plan buttons depending on the state of the current user. Line 50 is using a custom Jinja filter to convert cents to dollars. Let's go over how custom filters can be added to Jinja by heading over to the app.py file. Over here on lines 19 through 22, we're importing a couple of template processors from the billing blueprint. Let's go ahead and take a look here at the template processors file. And for that, go back over to the billing blueprint and then open it up. The format currency function will pad currency with 2 decimal points as well as add commas and optionally even convert cents to dollars. We can see how that works here just by using the Python string interpolation. Here we're saying that we want to have 2 decimal points as well as commas when it makes sense. Then if you want to convert to dollars, we call another function here that goes ahead and converts cents to dollars on the amount. This cents to dollars function is being imported up here, and we can see that it belongs to the library money. So go ahead and open up the lib folder and then open up money.py. We can see the function here, which just converts cents to dollars by taking the amount of cents, dividing it by 100, and then rounding it off to 2 decimals. In case you're curious here, we're dividing it by 100.0 just to make sure that the return value is a float. In Python, if you do an operation on an integer and a float value, then the return value will be a float. If we didn't add the 0.0, then it's going to divide an integer into another integer, and then we wouldn't get any decimal places. Since we're done looking at the pricing template, let's check out the view file that renders it. That can be found over here in the views folder, and then open up billing.py. Then scroll down to line 28. We're not ready to look at the update subscriptions part yet, but notice line 35. We're passing in the plans variable to the template, and it's just the plans that we defined in the settings file. With that said, at this point, we're ready to subscribe to a plan. But for that, let's move on to the next lecture. I'll see you then. In this lecture, we're going to subscribe to a plan and go over the front-end code to make it all work. This will consist mainly of looking at the Jinja template and a lot of JavaScript. If you haven't done so already, please head over to section 16's folder in your courses folder, and then open it up in your code editor. Then from there, make sure that Docker Compose is running by typing docker-compose --up. Once that's up and running, then head over to your browser. Then head over to localhost port 8000 and go to the pricing page. Once here, then pick a plan that interests you. I'm going to go with the Platinum plan because hey, you only live once. At this point, we're in a position to enter in our payment information and subscribe to a plan. Notice the URL on top contains the plan name as a query string. This allows you to easily link potential customers to a specific subscription plan. In general, it's a good idea to limit what a user can do on each page. As you can see here, this page is very focused on getting a user to input their payment information. This page tells them everything that they need to know, such as which plan they're subscribing to and how much it costs. There's even a spot here for an optional coupon code. After that, it's just straight up billing information that's required to process their payment. On the bottom here, it also tells them which credit cards are supported and that their data is safe. So let's try processing the payment now without entering in anything. We get immediate feedback saying that we need to enter in a name. So let's go ahead and enter a name. Feel free to use anything. It doesn't need to be a legit billing name. Then go ahead and click Process Payment. This time the button did an animation, and after about a second, we get an informative error. In this case, it says the credit card number is not valid. That error is being provided by Stripe, and it happened without doing a full page refresh. We used JavaScript to contact Stripe's API, and then it reported back why it failed to be processed. Now, since we're using the test API keys, we can enter in a number of fake credit cards that Stripe supports, and things will just work. The easiest one to use is a credit card number of all 42s. So go ahead and enter 4242. Then what I like to do is copy that, and then paste it 3 times. So now we have a 16-digit card number, which is technically correct in terms of digits, but is fake because it actually doesn't exist. Then go ahead and try to process the payment. We'll see that after a second or so, it says our card's expiration year is invalid. So now let's go ahead and just choose any type of expiration date. Doesn't matter what you pick. Okay, so let's try to process the payment once more. And now it's saying that our card's security code is invalid, and that's the CVC. That's the number that you would commonly see on the back of your card. So go ahead and enter 123. After that, click Process Payment. Then from here, click through to the settings page, and it should have successfully subscribed you. In this lecture, since we're dealing with the front-end code, let's go ahead now and take a look at the JavaScript responsible for the payment form. We'll begin by doing that by heading back over to our editor. Before we go into the JavaScript, let's go ahead and head over to the Snake Eyes folder, Templates folder, Layouts folder, and then open up base.html. Then scroll down to line 32. In order to contact Stripe's API over JavaScript, we need to pull in their JavaScript code, so that's what we're doing here. Now, before we go into the meat of the JavaScript, let's go ahead and just check out that payment forms Jinja template. And for that, head over to the Blueprints folder, then go to Billing, then go to Templates and Billing, and then open up the Payment Method template. This template is responsible for creating and updating payments, and that's why we have lines 4 through 14. These exist to change the output of certain terminology on the page based on the address that we're at. We've seen this pattern being used in the custom admin to differentiate new and edit templates. The rest of this template just renders the form. I'm going to go over a few key lines with you, then you can take a look at the rest on your own. Let's scroll up here to line 21. Line 21 defines a form, and it happens to set a form ID of payment_form. Line 34 sets up an alert div to show the errors that we saw before. Then if we scroll down here to line 60 and take a look all the way down to line 75, These are the select boxes that are responsible for drawing out the expiration date. You can see here on lines 62 through 66, we're outputting the months. This little bit here, where we do %O2D, is going to make sure that each month value is prepended with a 0. Then down here, we're doing something very similar for the year. The really cool thing about doing it this way is you'll never have to come back and edit this form when the year changes. The drop-down box will always contain a year range that starts with the current year and goes up to 15 years in the future. The current year function is a custom Jinja global that we've added. We'll go over that in a second, but for now let's continue onwards with the file. If we scroll down here just a little bit, we'll see on line 91 that we're rendering an animated spinner GIF. It's hidden by default because it has a spinner class attached to it, and in our CSS rules, we've defined that to be display none. So that takes care of the interesting things in the payment template. Now let's take a look at the JavaScript file. And for that, head over to the static folder, and then go to scripts and open up main.js. This file shape has changed a lot since the previous section, so let's go over that first. We'll begin by going down to the very bottom of the file. In a previous section, there was a lot of code inside of that document ready event, but now that code's been moved out into their own functions. This cleans up the code base quite a bit and allows us to encapsulate certain functionality into specific functions. For example now, if you hop over to line 19, it does exactly what it did before, except now it's wrapped up into a function. This way, none of the code responsible for the Moment.js code leaks into the other code that has nothing to do with Moment.js. If we scroll down here a little bit to line 40, that same pattern is being used here for bulk delete. In this lecture, the function that we're interested in looking at is down here on line 119. At a high level, this handles overriding the form's default behavior, contacting Stripe to initiate the subscription, and even handles making an AJAX call request to our Flask server to see if a coupon is valid. In this lecture, we won't cover the coupon-related code because we'll be tackling coupons at a later time. So let's unwind most of the Stripe function by tracing its execution from the start. To do that, head down to line 251. When you submit the form, this is the code block that's going to get executed. Lines 252 and 253 just save a couple of variables. 255 prevents the form from submitting if an invalid coupon code is present in the coupon code field. We'll see that soon enough in a later lecture. Line 259 shows the spinner GIF, and then down here on the next line, we just hide any form errors. Both the spinner and payment errors variables are defined near the top of the Stripe function. They're simply referencing various jQuery objects. Line 263 adds some custom logic to show the missing name error before it even attempts to call Stripe. If the name's text box is empty, then it populates the missing name error, shows the error text, and hides the spinner. It also returns false, which is enough to prevent the rest of the function from executing. The name error is also defined up near the top of the Stripe function. You can take a look at that on your own if you want. At this point, if we get down to line 271, then we know that their name is valid. If that's the case, then we go ahead and disable the submit button, and that's going to stop people from accidentally submitting the form multiple times. Then we just call out to Stripe's API. The createToken function expects us to pass in a form as well as a response handler. This response handler is the function that's going to get executed after we get a response from Stripe. Prior to calling this function, it also expects us to authenticate ourselves first. We do that up here on line 135. All we do here is configure the JavaScript to use our Stripe key value, which is also defined up here on line 125. The Stripe key ID is being populated in a hidden form field that's being sent from Flask, and we'll see that in the next lecture. For now, just understand that the key is safe to share, and it's being sent from the server, which is based on our Stripe API key settings. Also, don't worry about exposing this key to the world. Their documentation uses a very similar workflow for setting up a custom form. Okay, so at this point, the form has been submitted to Stripe, and Stripe knows that the form originated from our API key. Line 138 is what gets executed after we get a response from Stripe. The first thing that we do here is hide any payment errors. Then, if the response contains any errors from Stripe, the first thing that we do is hide the spinner GIF. Then we enable the submit button because remember we disabled it before, and then we just show the error to the user. Otherwise, if there's no error, then we save a token that we get back from Stripe. Then we take that token and save it to a hidden field and append this field to the form. After that, we show the spinner graphic and submit the actual form itself. This form is the payment underscore form, which we can see up here on line 122. And this payment form ID corresponds to the payment templates ID, which we set over here. At this point, the subscription hasn't been created yet, but we have everything we need from Stripe to create the subscription on the server side. Also, in case you're wondering, this token is a one-time use token provided by Stripe. It proves the user's credit card details are valid and that they're interested in creating a subscription which is associated to our Stripe account. When it comes time to create the subscription on the Flask end, we'll need to provide Stripe this token, among other things, to go through and create the subscription. That's what we're going to do in the next lecture, and I'll see you then. In this lecture, we're going to review the backend code to create a subscription. If you haven't done so already, please head over to Section 16's folder in your Courses folder and open it up in your code editor. Then make sure that Docker Compose is running by typing docker-compose --up. After that, head over to your code editor. Then once you're here, let's head over to the billing blueprint by going to the Snake Eyes folder, Blueprints, Billing, and then open up the Views folder and open up billing.py. Then scroll down here to line 53. And this is the route responsible for creating a subscription. This route also includes a new decorator, which is handle Stripe exceptions. The implementation of this can be found in the decorators file in the billing blueprint. So let's go ahead and check that out. We can see that down here on line 24. Stripe is a third-party service, which means there's a lot of ways for things to go wrong, most of which are out of our control. This decorator protects our application from throwing a 500 back to the user if Stripe raises an error. To protect our app, we just capture a bunch of different Stripe exceptions and act accordingly. For example, check out line 42. If we put incorrect API keys in our settings file, we'll end up flashing an authentication error to the user. In theory, this should never happen in production, but if it does, this is much friendlier than just throwing an empty error 500. Perhaps Stripe's API server is having connection issues, in which case line 45 handles that. The best we can do is inform the user that our payment gateway is having issues and they should try again soon. Any route that talks to Stripe will be protected by this decorator, and all of the exceptions that you see here are heavily documented on Stripe's website. With that said, let's head back over to the Views file. The first thing that we do here is check if the user is already subscribed. If so, we redirect them back to the settings page with a bit of help text. If you head back over to your browser now, we can try that out now. You can do that by going to localhost port 8000 /subscription/create $plan equals gold. Once you do that, click through here to the settings page, and we'll see that we have an information flash that says you already have an active subscription. Okay, so now let's go back to the Views file. Next up, we pick out the plan from the URL, and then we do a lookup on it by its ID. The getPlanById method will return back a dictionary that contains information about the plan. Let's head over to the subscription model to check that out now. So head over to the models file, and then open up subscription.py. It's down here on line 34. All it does is loop through our Stripe plan settings, and if it finds a match, then it returns that plan. Otherwise, if nothing is found, it returns none. So let's go back to the Views file once more. Line 65 checks if we have a plan, and if the HTTP method is a GET request. This is important because we only want to run this check if the user is viewing the subscription page, not submitting the actual form. If they submit the form, then the request.method would be a post, not GET. If the plan happens to be invalid, then we just inform the user and redirect them back to the pricing table so they can pick a valid plan. This protects our application from users manually messing around with the URL parameters because we would never link to an invalid plan on the website ourselves. If the plan is valid, then we look up the publishable key from Stripe. In this case, we're using a special function called current_app. This function is being provided by Flask, and it's imported near the top of the file. This is how we can reach into the app that was created with our app factory, and it's a common way to access the current application settings. Once we have that key, then we pass it into the credit card form along with the plan ID from the URL. So now let's go ahead and check out this credit card form by going to forms.py. We can see here that it has two different hidden fields. The first one is for the Stripe key, and the other one is for the plan ID. This is how we passed the publishable key to the JavaScript file in the last lecture. Then over on line 11, we have an optional coupon field, as well as a name on line 13. We want to store the user's real name in our database, which is why it's part of our form. Now let's go back to the Views file. At this point, if the form submission is valid, Then we go ahead and create a new subscription. This method expects us to pass in a user, their name, which plan they're signing up for, a possible coupon code, as well as the Stripe token field, which was passed in by the Stripe JavaScript in the previous lecture. Then if the subscription was created, we let the user know that things went as planned. Otherwise, if it failed, then it's very likely due to the user not having JavaScript enabled in their browser. It would fail because the Stripe token would be empty. I'm all for progressive enhancement and only using JavaScript to make the user experience better, but in this case, we have no choice but to require JavaScript to process a payment. It's just how Stripe and many other payment gateways work. Nowadays, I wouldn't be too worried about running into users who have JavaScript disabled for reasons out of their control. Before smartphones, you might run into a situation where someone was at work and their IT department disabled JavaScript in all browsers. If that were the case, then your website would not be able to take a payment from this user. However, now that pretty much everyone has a smartphone, he or she could just load up their page on their phone and make the purchase without issues. For power users who run JavaScript blocking extensions, we'll inform them that they need JavaScript to process the payments. I feel like most people in this spot would have no problem enabling JavaScript for your website. With that said, let's see how the create subscription method works. To do that, head over to the subscription model. But before we look into the create method, let's quickly review the database schema for both this model and the user model. It has an ID primary key as expected, but it also has a user ID, which is how we deal with the relationship to a user model. It just happens to be an integer field with a foreign key, and that foreign key points back to the user's ID column. A foreign key is a special type of field in one table that uniquely identifies a row in another table. In our case, the user ID value will end up being a user ID integer that points to a specific user in the user's table. The onUpdate and onDelete attributes are set to cascade because if we delete the user, we want the subscription to also be deleted. Since a relationship between a subscription and a user exists, it wouldn't make sense for a subscription to linger around if it has no user associated to it. Instead of cascade, we could put set space null, which will insert a null value in the user ID field instead of deleting the subscription row. This could be handy in other types of data modeling examples where you don't want to lose the related rows on delete. If that were the case, you would also want to remove the nullable equals false because nullable defaults to true. Then down here, we have the plan and coupon fields. They're both strings and there's not much else to talk about here because we've seen string fields before in previous sections. Now let's quickly go over the changes to the user model before proceeding. So head over to the user folder and then open up models.py. Then scroll down to line 34. This is often referred to as the other side of the relationship. In the subscription model, we have the user ID field, but in the user model, we don't have any additional columns in the database itself. This db.relationship is just a way to let SQL Alchemy know that the user can have a subscription. We do this by passing in the model, along with whether or not this resource is going to be a list or not. In our case, it's not going to be a list because a user can only have one subscription. A good example of a list would be invoice items, which we'll go over later. Next up, we have the backref, which in this case is users, because that's where the relationship takes place on. Finally, we have passive deletes set to true. Passive deletes is an optimization that tells SQL Alchemy not to bother loading in the related object before deleting a user. For example, let's say that we go ahead and delete a user. SQL Alchemy will load the user, then delete the user, which in turn will also delete the subscription because we have cascading deletes set to true. Without passive deletes, then SQL Alchemy would load the subscription object before deleting the user. So that's how you can deal with both sides of a database relationship. Also, if you scroll down here to line 49, we can see the three fields that we talked about in the previous lecture when we visualized the data model. Here we have the name, the payment ID, and the canceled subscription on. Now that we have a better idea of our new database schema, let's go ahead and head back to the subscription model. Then scroll down to line 66. This function is sort of long, but it's also straightforward. First, if there's no token, then we know right away that it's not going to work, so we just return false. Then if there happens to be a coupon, we just make sure that it's converted to uppercase. We do this because we want all of our coupons to be normalized to be uppercase. Then we create a new subscription by calling out to the Stripe gateway. Let's check that out now by going to the Gateways folder and then opening up StripeCom. And then we can scroll down to line 112. All it does here is take in a couple of parameters, and if there's a coupon, it attaches the coupon, and then it contacts Stripe's API with all the parameters that we set. Technically, we don't have to give Stripe access to the email field, but it's a good idea to include it just so we can look up users on Stripe by email if we need to. It's also worth noting here that when you create a customer with a token, then Stripe is going to automatically create the subscription for us. Lastly, this is going to return back a Stripe customer. Keep that in mind when we go back to the subscription model now. At this point, we have a Stripe customer defined. Then what we do here is we take the customer ID and assign it to the user.payment ID. That's going to associate the Stripe customer's ID to our payment ID in our database. Then we also set their name, and we also make sure to reset canceled subscription on. Then on the subscription model itself, we just assign the user ID as well as the plan. Then if there happens to be a coupon, we just go ahead and redeem it, and we'll go over that in more detail later on. Next up, we create a credit card entry for this user. We do that by passing in the user ID as well as extracting the card parameters from the customer object from Stripe. Then finally, we just commit the user, credit card, and subscription all to the database and return true. But let's rewind a bit now and review that credit card line. When creating a new credit card, it expects us to pass in the user ID as well as the parameters that get extracted from here. Let's take a look now at the credit card model to see how this all works. The first thing that we'll take a look at here is the database schema. As expected, it has a primary ID field, and it also has a relationship that's similar to the subscription. In this case, we're saving the user ID, it's an integer field, it's a foreign key, and everything else is the same as the subscription foreign key. Then if you look down here, we have a couple of things relating to the card details. We save the brand, the last 4 digits, as well as the expiration date, and whether or not it's going to be expiring soon. And we'll go more into the expiring functionality later on. You can also review the user model to see how it handles the backref to the credit card on your own as an optional homework assignment. For now, let's head over to line 62. This is where we extract the card details from a Stripe customer. Stripe returns back a heap of data when it returns a new customer. All we're doing is reaching into a sources list and then grabbing out the first data element. And that's going to return a dictionary that has all the card details. Then we just build up an expiration date, and then we just return back a new dictionary that has everything we want. We'll tackle this credit card expiration in a different lecture, so don't worry about line 77 just yet. And that concludes subscribing a user to a plan with Stripe. As you've just seen, there's actually quite a bit involved to get the job done. I'll see you in the next lecture, where we'll learn how to update the payment details. I'll see you then. In this lecture, we're going to go over updating a user's payment details. If you haven't done so already, please head over to Section 16's folder in your Courses folder and open it up in your code editor. Then make sure Docker Compose is running by typing docker-compose --up. And then once it's up and running, head over to your browser. And once here, go to localhost port 8000/settings. As you can see here on the right, we're subscribed to a plan, and we can even see a couple of details about it, such as the plan name and which credit card was used. There will come a time where one of your customers will need to update their payment information. Ideally, we'd want to do this without disrupting their current subscription, and lucky for us, Stripe makes it really easy to do this. Let's go ahead and click the Update Payment Info link and see what happens. We're presented with a similar form to what we saw in the previous lecture. The only difference here is there's no field for entering in a coupon code. Let's try changing our card information. For most people, they'll just enter in their current card number and then update the expiration date, but you're not limited to just that. For instance, you could completely change cards if you'd like. Go ahead and enter in a new name, and this time we'll use a fake MasterCard instead of a fake Visa. And to do that, go ahead and type in 5555, 5555, 5555, 4444. Then go ahead and pick any expiration date that you want. And for the CVC, make sure you pick 123, otherwise Stripe is going to complain. Once you have all that set up, click Update Payment Method. Then go ahead and click through to the settings page, and you'll see here that the payment method has been updated. And if we take a look down here, we'll see that MasterCard is our card with the expiration date that we chose. Also, if we go back to the Update Payment Info link here, you'll see our new information. I also want to add here that the same card validation rules are applied to this form as they were to the Create Payment form. For example, if you try to submit the form without a card, then Stripe is going to report back that the card number is wrong. So now let's go ahead and take a second look at the Jinja template for the payment form. And for that, head over to your code editor. Then once here, go to the Snake Eyes folder, Blueprints folder, Billing folder, Templates folder, Billing folder, and then open up payment method.html. Since we're not creating a new subscription, it's going to load this side of the if statement instead. In this case, we're going to be updating the payment information. Also down here on line 23, we're not going to be outputting stuff about the plan, and instead it's only going to output the title. And if you scroll up here to take a look at the title, that will be update payment info. So now let's head over to the views folder and we'll open up billing.py. Then scroll down to line 148. This is the route responsible for updating the payment method, and it uses the same decorators as the create payment method route that we looked at in a previous lecture. The route starts by checking to see if a user doesn't have a credit card already on file. Obviously, we can't update a user's card details if they don't have a card to begin with. So if that's the case, we just redirect them back to the settings page. This situation should never happen in the real world, but we protect against it in the off chance that the data in your database gets into an unpredicted state. I also want to point out here that we're able to access the credit card method on the current user due to the DB relationship that we have set up on the user model. SQL Alchemy makes it very easy to access related models like this. If you ever run into an error in the future where you try to access a related model and it fails, then it's probably because you forgot to set up the backref in the model. Anyways, let's move on. Line 156 gets the current user's active plan, which, as we just saw, reaches into a related model on the user and then picks out the plan from the subscription model. We already know what the getPlanById method does from the previous lecture as well. Then we just store the current user's credit card because we'll be using it shortly. After that, in a similar fashion to the previous lecture, we get the Stripe API key and set up a few default values for the credit card form. Then, if the form happens to be valid, we just call the update payment method on the subscription model. And that's going to expect you to pass in a user, a credit card, their name, as well as the Stripe token. If the update was successful, then we just let the user know everything was awesome. Otherwise, we know it failed because JavaScript wasn't enabled. Also, as a side note, if it happens to fail due to Stripe having issues, then our handle Stripe exception decorator will step in and provide the real error. The last thing I want to mention here is on line 182. We're passing in the card's last 4 digits to the template so that we can render them in the card numbers text field. Since this is normally an integer, we first need to convert it to a string. So that takes care of the route. Let's head over now to the subscription model and see how it gets updated. So head over to the models folder and then open up subscription.py. Then once here, head down to line 175. Just like the create method, it instantly fails if no token is present. Otherwise, we call out to Stripe and update the customer's card by passing in the payment ID along with the token. Notice the class we're accessing now is payment card, not payment subscription. So let's go ahead and check that out now in the Stripe gateway. So head over to the gateways folder and open up StripeCom. We can find the card class down here on line 73. Then the update method is over here on line 75. All it does here is look up the customer on Stripe's API, and then it uses the new token to update their billing information. This will seamlessly update their card info without affecting the subscription. Okay, so now let's head back over to the subscription model. After we have access to the customer object once again, we just go ahead and update the customer's name in case they changed it, and then down here we update their credit card information. After that, we add the user and the credit card to the DB session and commit it to the database. So that's how you handle updating payment information. I'll see you in the next lecture, where we go over informing users if their credit card is about to expire. I'll see you then. In this lecture, we're going to go over informing users who have credit cards that are about to expire. If you haven't done so already, please head over to Section 16's folder in your Courses folder, and then open it up in your code editor. Then after that, make sure that Docker Compose is running by running docker-compose --up. Once everything is good to go, then open up your browser. Then head over to localhost port 8000/settings. Then once here, go to update payment info. Then go ahead and enter in some card number. I recommend going with the 42 one simply because it's easier to enter in. And then go ahead and choose this month as the expiration date. In the case of recording this video, that's going to be May 2016, but in your case that may be different. Then enter in your CVC and go to update. You'll notice now at the top here, we have a site-wise warning that says your credit card is going to expire soon, so please update it. This banner is going to be visible no matter where you go on the website. It'll eventually go away if you update your card. So to see how this works, let's go to our code editor. Then go to the Snake Eyes folder, Templates folder, Layouts folder, and open up base.html. Line 2 is importing a billing macro, and if we scroll down here to line 49, we can see that we're calling billing.cardExpiringWarning. Let's check out the billing macro to see how this works, and for that, go to the Blueprints folder, Billing folder, then go to Templates, Billing, Macros, and open up billing.html. We'll see this warning function up here on line 1. All it does is it checks to make sure that the user is authenticated and subscribed, and their card is expiring, and if so, then it outputs the div that we see here, which is the warning. If you remember back from a couple of lectures ago, the credit card model has an isExpiring field in it. So now let's head over to the credit card model by going to the Models folder, and we'll open up creditcard.py. We can see down here on line 24, that's the isExpiring field. Now let's scroll down here to line 77. This extract card params method gets called when a new user creates a subscription. It also gets called when a user updates their payment information. At this point, we check if the card is going to expire soon by passing in the current expiration date, and that's going to be the expiration date of the card returned by Stripe. We'll take a look at the isExpiringSoon method soon enough, but before going over this function, we should first decide how we're going to determine if a card is about to expire. Well, an expiration date is based on time. Let's go ahead and scroll up to the top of this file here, and then go to line 9. This is the expiration threshold in months. Basically, we're saying that a card should be expiring soon if it's within 2 months of the expiration date. That makes sense, right? If it's May 2016 right now, then we want credit cards that are set for May, June, or July 2016 to be expiring soon. So now let's head over to line 31, just so we can see how the isExpiringSoon method works. It compares the expiration date to a time delta that expects you to pass in a threshold in months, along with an optional date to compare it to. If no data is supplied, then it's going to default to none. The time delta months function can be located over here in the lib folder, and it's going to be in the util file for datetime. If we scroll down here just a little bit, we can check it out. You don't need to understand the full details of it, just understand that it returns a brand new datetime with a threshold added to it. For example, if you passed in May 2016 with a threshold of 2, then it's going to return back July 2016 because that's 2 months after May. With that said, let's head back over to our credit card model file. So if the expiration date is less than or equal to the result of the time delta months, then we know that the card is going to be expiring soon. In the case of this function, it returns a boolean, so it's going to return true or false. So that takes care of setting the isExpiring field on the card, but this only gets set when a user creates a new subscription or they update their payment information. We need a way to check and set the isExpiring field on a regular basis. One way to do this would be to compare the user's credit card expiration date to the current time every single time that they load the page. And then, if it's about to expire, we would update that attribute of their card in the database. I don't like this approach because it means we need to hook into Flask and run that date-time comparison every single time a user loads any page of the site. Honestly, the date comparison code isn't very complicated, so it's not like I'm worried about the performance of the site suffering due to this. We're already looking up the user to get access to the current user, so it's not like we need to even do extra database work. However, my spidey sense is tingling that it's a poor decision to do this calculation on every page load. It just feels like a dirty hack to mark and check the credit card expiration like this. I feel like a better approach would be to run a reoccurring task every single day, which quickly runs through the credit cards in our database and then marks them as isExpiring if they happen to be expiring soon. Something like that would only take a few milliseconds to run, even if you had tens of thousands of credit cards in your database. Then we could update each card that needs to be set in one simple database query that finishes almost instantly, even if many updates need to happen. You could schedule something like this to run every single day at midnight, and that's the approach I went for in this course, so let's check that out. From here, go to your credit card model, and then go to line 45. This is the function that marks credit cards that are going to expire soon or have already expired. Over here on line 53, we're just calculating today's date with a delta applied. Then on line 56, we're using SQL Alchemy to do a date-based query to return only cards that are about to expire. We do that by comparing the expiration date of the card to today with a delta applied. The filter aspect of this query is going to return all cards that need to be updated. Then we just run an update on those cards and set is expiring to true. This is going to update all the cards in one query, and then finally we just commit the changes to the database. So that takes care of the logic to mark and save them, but now we need to set up the reoccurring task to run every day at midnight. For that, open up the tasks file in the billing blueprint. Then we'll take a look here at line 16. Here we have a very simple celery task that just runs the method that we looked at in the credit card model, and that's going to mark the old credit cards. Now, Celery is awesome at running tasks on demand, but it's also capable of running tasks on a schedule. For that, head over to the config folder here, and then open up settings.py. Then scroll down to line 28. This is where we configure Celery to run one or more tasks on a set schedule. It's going to repeat this task until the end of time. All we have to do is name the task, in which case I recommend naming it something that makes sense. In our case, that would be mark soon to expire credit cards. Then you need to supply the task that's going to get ran. In our case, that's the mark old credit cards task. And then finally, we need to set the schedule. You may have heard of the tool called cron or crontab, but don't be fooled by the crontab function on line 31. While it does say crontab, it actually doesn't require cron to be installed on your system. This function is being imported from Celery, and it allows you to define your schedule in a format that's similar to how you would define schedules in a cron job. In our case, we want this task to run every day at midnight. Midnight is hour 0, while hour 23 would be 11 p.m. Celery's documentation for periodic tasks give you many examples to look at. It's a very, very flexible way to run tasks on a schedule. You could go as far as doing things like execute something every 10 minutes, but only during certain hours on certain days of the week. Basically, you can set any type of schedule that you can possibly imagine. Now, there is one more change that we had to make so that all of this works, and that change is in the Docker Compose file. So let's go ahead and check that out. And that change is on line 34. We need to modify the Celery worker to do slightly more work than it did previously. In this case, we added the B flag, which stands for beat. You can think of that as a heartbeat. That's all we need to do to configure Celery to run tasks that are reoccurring. But before wrapping things up, I also want to mention that you can run the Celery beat worker as an independent process. Right now it's embedded into the main Celery worker because we're in development mode and we're only ever going to run one Celery worker. In a high traffic production environment, you may end up having multiple Celery workers, but in this case, it wouldn't be a good idea to equip each one as a beat server as well. It would make way more sense to run one beat worker and let's say 5 Celery workers. I've included a code snippet in the notes associated to this lecture that shows you how you can break the 2 Celery components apart and run them independently. It's actually very simple, and the only reason why I didn't do it here is because I wanted to make sure you knew how to run the beat worker in both ways. And in development mode, using the B flag with one worker uses less system resources. With that said, that's everything related to expiring credit cards. I'll see you in the next lecture where we go over updating subscription plans. I'll see you then. In this lecture, we're going to go over updating subscription plans. If you haven't done so already, please head over to section 16's folder in your courses folder, and then open it up in your code editor. Then after that, make sure that Docker Compose is running by typing docker-compose *up. Once complete, then head over to your browser. Then from here, go to localhost port 8000/settings. Then once here, check out the change plan link. That's going to render our good friend the pricing table, but with a couple of differences. First off, we have the option to enter in a coupon code, and the reason it's on this page is because of the warning notification right above it. And that says your plan will change immediately after clicking Change Plan. Stripe will allow us to modify subscriptions on a user's behalf. All we have to do is provide the customer's ID and the new plan information, and Stripe will do the rest. So let's try changing plans. Feel free to pick any plan that you want. After a second or two, you'll get redirected to the settings page, and then you'll see that the new plan has been activated. If we go back to change plan again, you'll notice that the new plan is now the current plan. Also, in case you're curious, Stripe will prorate plans by default, which means that users won't get billed anything extra if they change plans in between billing cycles. I've included a link in this lecture's notes that explain how that works. Now that you know how changing plans work, let's see how it's done. So head back over to your editor. Then once here, head over to the Snake Eyes folder, Blueprints folder, Billing folder, Templates folder, Billing folder, and then open up pricing.html. In a previous lecture, we took a look at this template, but now that we're a subscriber, we can quickly go over what happens when you're subscribed. For example, down here on line 10, if a user is subscribed, then it's going to say you're about to change plans instead of ready to start winning. Also down here on line 26, if the current user is subscribed, then we go ahead and show the coupon code field. The rest of the differences can be seen in the billing macro, which controls rendering the columns themselves. So let's head over to the macros folder and open up billing.html. Then scroll down here to line 24. We just have an if statement here saying if the current user is subscribed and their plan equals the active plan, then we'll just go ahead and output current plan. And if that's not the case, then we go ahead and render the change plan button. So now let's head over to the billing views file. For that, head over to the views folder and then open up billing.py. Then jump down to line 91. This route is a little chaotic because we need to do quite a few things. The first thing that I want to go over here is the new decorator, which ensures that a subscription is required. So for that, head over to the decorators.py file. The subscription required decorator is very similar to the anonymous required decorator that we looked at in the user section. Line 16 just sees if a user does not have a subscription, and if they don't, then it redirects them back to the pricing table so they can pick a plan. That makes sense, right? You couldn't update your subscription plan without already having a subscription, so that's why it's protected by this decorator. Okay, so let's go back to the views file. Line 96 grabs the current user's plan, and then we look up that plan's info to get the full plan information. We covered that in a previous lecture. After that, then we get the ID of the new plan, which is found by passing in a list of form keys to the getNewPlan method, which figures out whatever plan the user is switching to. For that to make sense, we'll need to go back to the billing macro, so let's check that out. Then head down here to line 30. Notice how the ID and name of the change plan buttons include the plan ID. For example, the button name for the bronze plan would be submit_bronze, and for the gold plan, it would be submit_gold. So with that said, let's go back to the views file. Request.forms.keys will include all the form field names in the list. That means you would expect to have submit_bronze in this list if you happen to change to the bronze plan. That's because when you submit a form, the button name is included in a list of fields. With that said, let's go to the subscription model and check out the getNewPlan method. So head over to the models folder and then open up subscription.py. Then scroll down to line 49. The first thing it does is loop through all the form keys that you pass in. Then for each key in the list, it splits the key on the submit_string. Then line 60 makes sure that the split key is in the list, which means the key had the string submit_ in it. It also makes sure that the length is 2, just to be extra sure that we're dealing with the correct type of form field. The purpose of that is to ignore any other form fields. Once we're sure that we're dealing with a plan name, we do a lookup on the plan by the second item in the split key list. For example, split key 1 will be bronze if you click the change plan button for the bronze plan. Then if we find a match, we just exit the function and return the plan name for now. All in all, the purpose of this is to determine which plan the user submit in the form. Now let's go back to the views file. The next thing that we do here is just get the plan. Once we have both their active plan and the new plan, we can guard against invalid situations that might happen if a user is trying to screw around with the form data in the browser's DevTools. We need to protect against the new plan not existing, and also protect against someone trying to change plans to the plan that they're currently subscribed to. That sums up what lines 103 to 106 are doing. Then line 108 just populates the update subscription form with an optional coupon. So let's check out that form now in the forms.py file. It's extremely basic. All it does is set a coupon field, so let's go back to the views file once again. Once the form has been submit and it's valid, then we update the subscription by passing in the current user, an optional coupon code, as well as the new plan ID. If it's all good, then we let the user know that everything worked. Also notice how we're passing in all of the plans and the active plan to the Jinja template. Now let's check out the update subscription method in the subscription model. You can find that on line 119. The first thing that we do is call out to Stripe with the customer's payment ID and an optional coupon as well as the plan ID. Let's check that out in the Stripe gateway file. We'll do that by going to the Gateways folder then open up StripeCom, and then we'll scroll down to line 141. To begin, we just look up the customer by ID, which calls out to Stripe's API. Then we pluck out the subscription ID and do a second call on Stripe's API, which is going to look up the subscription. Once we have that, we set the new plan onto the current subscription. Then if there happens to be a coupon, we attach that to the subscription as well. Finally, we save the new subscription. So now let's head back over to the subscription model. After the subscription is set up on Stripe's end, we go ahead and sync it into our database by updating the plan, and then redeem a coupon if it happens to exist. Then after that, we just save and commit the subscription to our database and return true. So that's how Stripe lets you update a subscription without the user even needing to re-enter the billing info. At this point, we've created and updated subscriptions. The last thing that we need to handle is canceling a subscription. I'll see you in the next lecture where we tackle that. See you then. In this lecture, we're going to go over canceling a subscription. If you haven't done so already, please head over to section 16's folder in your courses folder and open it up in your code editor. Then make sure that Docker Compose is running by typing docker-compose --up. Once you've done that, then head over to your browser. And from here, just go to localhost port 8000/settings. You'll notice here on the bottom that we have a cancel subscription link. So go ahead and click that. Rather than instantly cancel the user's subscription, we just inform them what will happen when they cancel. When performing something destructive, it's usually a good idea to let users change their mind. In this case, we have an option to either cancel it or click Nevermind, which will bring you back to the settings page. Let's go ahead and cancel it now by clicking the button. It's going to contact Stripe and then cancel the subscription. After that, we'll get redirected to the settings page. At this point, the user still exists, but they're no longer subscribed. Let's take a look now at the cancel Jinja template, which we can do by going back to our code editor. Then go to the Snake Eyes folder, Blueprints folder, Billing, Templates, Billing, and then open up cancel.html. There's really not much to go into, but this is what the template looks like. So let's head over to the Views file by going to the Views folder and then opening up billing.py. Then jump down to line 126. Like the create and update routes, it expects you to be logged in, and the route is also protected by the Stripe exception decorator. This route is also pretty straightforward. If the user isn't subscribed, then we just warn the user that they have no subscription to cancel. Since admins will be able to cancel subscriptions, there could be an edge case situation where a user tries to cancel their subscription after an admin cancels it for them. It's a very simple fix to prevent this issue, so that's why we do it. Next up, we instantiate the cancel subscription form, and we're not even going to look at it on camera because it does absolutely nothing. It's just an empty form. Then if the form is valid, we just call the cancel method on the subscription instance while passing in the current user as the user to be canceled. Then if things work as planned, we just guilt trip the user by saying sorry to see you go. So let's check out the cancel method in the subscription model. For that, head over to the models folder and then open up subscription.py. Then scroll down to line 146. The first thing that we do here is cancel the subscription on Stripe's end by calling out to the Stripe gateway. So for that, head over to the gateways folder and then open up StripeCom. Then scroll down to line 168. It's pretty similar to what we did to update a subscription, where we just do a lookup on the customer, then we pluck out the customer ID, and in this case, instead of updating the subscription, we just delete it. So now let's head back over to the subscription model to finish things up. Once things are deleted on Stripe's end, then we just set the payment ID to null on the user that was passed in. Then we also update the canceled subscription on date by passing in the date time for right now. After that, we just save the user and delete the subscription. Then by default, we'll also delete their credit card. There may be a special situation where you'd want to delete a user's subscription but keep their card on file, and handling that is easy enough. So I added in the discard credit card parameter to toggle that ability. If it's enabled, then we just go ahead and delete the user's credit card as well. If we scroll up here just a little bit, we can see that it's enabled by default. Then the last things that we do here is commit it to the database and return true. With that said, we're making a lot of progress towards finishing up the billing aspect of the website. There's still a lot left to do, but we're getting there. In the next lecture, I'd like to go over the changes to the admin dashboard. I'll see you then. In this lecture, we're going to go over extending the admin dashboard. If you haven't done so already, please head over to section 16's folder in your courses folder, and then open it up in your code editor. Then, like usual, make sure that Docker Compose is running by typing docker-compose --up. Once you've done that, then head over to your browser. Then once here, go to localhost port 8000/admin. You'll notice now that there's a billing column on the left. It looks a little empty for the time being, but it will show you which subscription plans your users are signed up for, as well as show you what percentage of your subscriptions have coupons applied to them. You'll be able to glance at the output and see how many users are signed up for a specific plan in seconds. We'll revisit this page in a later section when it's a bit more filled out. But for the time being, let's go over how it works by heading back over to our code editor. Then from here, we'll go to the Snake Eyes folder, Blueprints, Admin, Templates, Admin, Page, and then open up dashboard.html. The billing column is very similar to the user column that we looked at way back in a previous section. We just do a group and count on both the plans up here, which are the subscriptions, and then we do a similar thing for coupons. So let's go to the views file to see how it works. Then scroll down to line 39. We're just calling the group and count function for both the plans and coupons, just like we did for users. As you would expect, we pass them into the template as well. Let's go over how these things work by going to the models.py file. The group and count plans method is the same as the user method above, except we're acting on a different model and field, so there's nothing new to go over. However, if we scroll down here to line 27, the group and count coupons method is a little bit different. So let's look at that. The SQL Alchemy query on line 33 returns a count on the number of subscriptions returned, where the subscriptions coupon is set to none. In other words, it's counting all the subscriptions that have a coupon applied to them. SQL Alchemy has amazing documentation, so I recommend reading it in great detail if you want to do a deep dive on what types of queries are available. This query is very composed. First, it queries the subscription model, then it filters it by a certain criteria, which in this case is coupons that are not none, and then finally it counts the results. It's very natural looking. Next up, line 35 just counts all of the rows in the subscription model. We've seen this before in the user section. If you're wondering what the difference is between using func.count and just calling count over here, the second one over here on line 35 is more efficient. Then the if statement in the middle calculates the percentage of subscriptions that have coupons by just dividing the not null value into the total. Of course, we need to guard this against a division by zero error, which is why we hardcode the percent to 0 if the total happens to be 0. Then we just return a tuple with all the values we want, and then use them in the template. With that out of the way, I'll see you in the next lecture where we go over managing coupons in the admin. See you then. In this lecture, we're going to go over the front-end aspects of managing coupons in the custom admin. If you haven't done so already, please head over to section 16's folder in your courses folder and open it up in your code editor. Then, like before, go ahead and run docker compose by running docker-compose --up. Then after that, head over to your browser. Then once here, go to localhost port 8000/admin. Then either click the Add button next to the coupon label, or go ahead and click Coupons up here. At this point, we have no coupons, so let's go ahead and create one. When creating a coupon, we can choose to create either a percent or fixed amount coupon discount. Percent-based coupons are nice because if the base price of your service changes, then you can continue to use the same percent-based coupons to provide a relative discount. On the other hand, fixed amount coupons have their place too, which is why we have both options. Then we have the coupon code itself. By default, it generates a unique code for you, but you can edit it with whatever you want. Then we have the currency of the coupon, but for most people, it's going to be USD. Next up, we have the duration, which has 3 options. Forever means that the coupon will be applied on each billing interval until the end of time. For example, if someone signs up for 2 years and they are billed 24 times, then this coupon's discount will be applied 24 times. The next option is once, and that means the discount will be applied on the first bill and that's it. If that same person signed up for 2 years, then the discount will only be applied to the first month's bill. The last option is repeating, and this allows you to set the number of times the discount happens. If we go ahead and pick this option, you'll see that a duration in months text box appears below it. This allows you to set a custom duration. In our example, if you set this to 12 months, then that same person who signed up for 2 years will have the discount applied for the first year of their subscription. Then we have an optional max redemptions field, which lets you cap out the number of times a coupon can be redeemed. This is great for promotional offers because you can set a coupon to expire after 50 people redeemed it. And in your marketing text, you can say that this coupon is only available to the first 50 people who sign up. The last field is also optional, and it allows you to expire the coupon based on time rather than quantity. It also uses a nifty JavaScript library to pick a date and time. If you click the little clock icon down here, it allows you to set a specific time. Time-based expiration is also great for certain types of promotions. Being able to say that a coupon is valid for the next 5 days will help fire people up to make a purchase. So now let's go ahead and create a coupon. Feel free to choose any options that you want. I'm going to go with 42% off with a custom code of FUBAR, then I'll set the duration to forever and also make sure that it expires after 10 redemptions. Once you have it all filled out, then hit the add button. And here we can see quite a bit of information about the coupon. Notice the redeem column over here says 0 of 10 coupons used. Now let's go ahead and create one more coupon. This time I'm going to go with $5 off. I'll use the default coupon. Then I'll set the duration to repeating, and then I'll say it's going to be valid for 5 months. And now we can see our new coupon that was added. In this case, the redemption value is infinity because there is no maximum amount. Just like users, we can also search for coupons. For instance, I can do a search on foo, and then we get the FUBAR coupon being returned. We can also bulk delete coupons by checking off the ones that we want to delete. The bulk delete method for this is a little bit different because not only does it delete the coupon from our local database, but it also calls out to Stripe to delete the coupon. Since we're making a third-party API call for the delete, it would make a lot of sense to do this in a background job with Celery. We need to do that because imagine if you tried to delete 100 coupons at once. If each one took 1 second to finish, then it would take 100 seconds to get a response back from the server. So if you're messing around now with the admin dashboard and you happen to delete a coupon, but it doesn't show that it's been deleted yet, then that's because it's being scheduled to be deleted. If you were to refresh the page here, chances are it would be gone. Now, you might be wondering if we're able to edit a coupon, and the answer to that is no. Stripe does not let you adjust an existing coupon's price or details. So before we get into looking at the templates and views, let me just go over the JavaScript-based datetime picker. For that, head over to your editor. Then go to the Snake Eyes folder, Templates folder, Layouts folder, and open up base.html. If you scroll down here, you can see the CSS being imported here on line 27. And if you continue scrolling down here, you'll see the JavaScript being included over here on line 74. Both the CSS and JavaScript files are located in the vendor folder for the static files. For instance, if we go to the scripts folder and then vendor, we can see the datetime picker over here. Now let's open up the main.js file. Then once here, head down to line 83. This function handles the coupon-related JavaScript for the admin page. If you take a look here at line 92, we're hiding or showing the number of months text box depending on if the repeating option is selected. Then line 101 handles showing the datetime picker. The datetime picker is very flexible. By default, it uses Bootstrap's icons, but since we're using Font Awesome instead, we can easily supply our own icons for various actions. The format option on line 104 is really important. This is the datetime format that our database expects. If you don't stick to this format, then it's going to fail to be inserted. Line 103 is also how we associate the datetime picker to a certain field. In this case, it expects a text box to have the class DT on it. Let's head over to the Ginger template for the coupon form. And for that, head over to the Blueprints folder, Admin folder, Templates folder, Admin, Coupon, and then go to _form.html. Then once here, scroll down to line 51. Here we can see that DT class being applied to the Redeem By field. I won't be going over the rest of this file because everything you see here has been covered in a previous section. However, let's quickly go over to the index template. One difference here is that the search box is balanced out with a Create Coupon button rather than taking up the full width. Bootstrap makes it really easy to set up a custom grid for each layout, and that's one of my favorite features of Bootstrap. If you scroll down here to the bottom of the file, we'll see that we're using quite a few billing macros, so let's check those out in the billing blueprint. Head over to the billing folder, then go to Templates, Billing, Macros, and open up billing.html. Then head over to line 76. This macro controls setting a Bootstrap label depending on the duration. It's really straightforward and just checks the duration value of the coupon passed into it. For instance, if it's forever, then we show the label forever, otherwise once, otherwise info. Now let's go over to line 89. And this macro controls the expires column by either showing a date, a double dash, or never, depending on when the coupon will expire. Then head down to line 103. This controls the redeemed column. In the case of a coupon not having a maximum redeem value, it will just show the infinity sign instead of the max value. Lastly, down here on line 109, we have the coupon discount macro, which displays a fixed amount coupon or a percent coupon. This is being output underneath the coupon code on the index admin page. Now that we know how the coupon pages are set up in the admin, let's see how they work, and for that, I'll see you in the next lecture. See you then. In this lecture, we're going to go over the back-end aspects of managing coupons in the custom admin. If you haven't done so already, please head over to section 16's folder in your courses folder, and then open it up in your code editor. Then go ahead and run docker compose by running docker-compose --up. After that, head over to your code editor. Then once here, head over to the Snake Eyes folder, Blueprints folder, Admin folder, and then open up views.py. Once here, scroll down to line 149. This is going to be pretty similar to the user views that we saw before, so I won't be stepping through each route in great detail. Instead, we'll go over anything that's new. For example, the index route has nothing new to go over. It's exactly the same as the user's index route that we saw before, except it's operating on coupons instead of users. Now let's scroll down here to line 170. The new coupon route happens to contact Stripe, so it's going to be using the handle Stripe exceptions decorator. As you would expect, there's a coupon form associated to the route. But before going into what the form looks like, let's head over to the coupon model to check out its database fields. To do that, head over to the billing folder, models folder, and then open up coupon.py. Like usual, we have our primary key ID, and then we just have a whole bunch of fields that are related to the coupon. Pretty much every field that you see here was being used in the admin page when we created a new coupon. The only new field that we haven't been exposed to yet is the valid field on line 40. We'll be marking coupons as valid or invalid based on if they've been expired. In the admin page that lists coupons, you'll see invalid coupons as being faded out. With that said, let's head over to the admin blueprint and then open up forms.py. Then scroll down to line 64. This coupon form is pretty beefy, but most of it has been covered in previous sections. You'll notice that a lot of these fields have a number range associated to them, which allow us to set a min and max value on the field. For example, let's look at the duration in months field. It's locked down to only accept numbers between 1 and 12. The next new thing to look at here is the redeem by field, which expects you to provide a date time that matches this pattern. This pattern is documented in WT Forms documentation under the date time validator. Basically, it formats the date in a way that makes our database happy. The last really big change here is on line 88. WT Forms allows you to overwrite its validation method to provide your own custom logic. We want to make sure that people can only choose % off or fixed off as the coupon discount type. If people happen to pick both or neither, then we want to throw a different error. Line 89 is necessary because it's what WT Forms expects. If the form isn't valid, then it's going to immediately return false. Then it has this notion of a result, which by default is set to true. This is the result of whether or not the form is valid. Next up, we just store the values for % off and amount off straight from the form. After that, we have our custom validation logic. If both fields are empty, then we append a custom error to both fields that say you need to pick one. Also, on line 100, since this case would be an invalid form, we're setting the result to false. Otherwise, if someone filled out both fields, then we just say that they cannot pick both, and we set the result to false. The last case here is no error, so we just pass through, in which case the result is going to be true, because that's what we have set up over here. Finally, line 109 just returns the result of the result. Now let's head back over to the views.py file. So if our form is valid, then we populate the coupon model with the form's values. Then we just prepare to create a coupon by setting all the fields that we need to set, and then we go ahead and create the actual coupon itself. Let's go ahead and check that out now in the coupon model. And before we take a look at that create method, let's scroll down a little bit here and check out line 42. This is the constructor for the coupon form, and in this case, if a coupon code is supplied, then we just convert it to uppercase. Otherwise, if no code is supplied, then we just generate a random coupon code. Let's go ahead and take a look at that on line 82. It first gets a character set to create the coupon code out of. String.digits and string.ASCII uppercase are both features of Python, and that's going to return 0 through 9 for the digits and A to Z for the ASCII uppercase. Then I just remove certain characters that are difficult to distinguish depending on what font you use. For example, an O and a 0 look very similar, as do a 1 and an uppercase I. After that, line 93 generates 14 random characters from the character set. Then we just break up the characters by hyphens, and the end result is a human-readable coupon code. With that said, let's head over to line 119 for the create method. This method is a little complicated, but it's mainly because we need to adjust the coupon parameters that were sent in from the form into a format that both Stripe and our database understands. Line 127 uppercases the coupon code because at this point, the coupon hasn't been created locally yet, so it hasn't been normalized from our constructor. Then if the amount off is set, we just convert dollars to cents on it because we want to save the amount in cents on Stripe and in our database. At this point, we're ready to create the coupon on Stripe, so let's check that out in the Stripe gateway file. Head over to the gateways folder and then open up StripeCom. We can see the create method down here on line 23. The comments are a bit long since we have a million options to pass in, so we can take a look at the code over here. All we're doing is calling Stripe's API with a whole bunch of parameters that we set. With that said, let's hop back over to the coupon file. Lines 135 through 137 make a quick adjustment to one of the parameter names. Stripe will save the coupon code to an ID field, but in our database, we want the coupon code to be saved to a code field. Then lines 139 through 142 convert a Unix timestamp to a datetime format that our database expects. We're doing this because Stripe expected a timestamp while our database expects a datetime format. Once that's done, we create the coupon on our end and commit it to the database. So that concludes creating a coupon. Now let's head back over to the admin views file. And the last thing that we need to take a look at here is the bulk delete route. This also calls out to Stripe to delete the coupon, and this method is slightly different than the bulk delete method for users. We're still calling the getBulkActionsID method to get a list of IDs to delete, but now we're calling a celery task instead of the normal bulk delete method. So let's take a look at this task. We can do that by going to the billing blueprint and then open up tasks.py. Then scroll down to line 42. You can see here that we're just calling the bulk delete method on coupons by passing in the ID. Let's go take a look at that now in coupon.py. Then scroll down here to line 152. Our generic bulk delete method, which was in the SQL Alchemy utils file, is super efficient for deleting local records. But now we have a totally different situation. We need to delete the coupons one at a time on Stripe, and if the delete was successful, then we'll go ahead and delete it in our database too. That workflow is what's been created in the custom bulk delete method, and it overrides the generic bulk delete method that was in the SQL Alchemy lib file. It expects you to pass in a list of IDs to be deleted, and then it loops through each ID. It starts by looking up a specific coupon in our database, and then moves on to the next one if it happens to not exist. Otherwise, it deletes the coupon on Stripe by passing in the coupon code. Let's jump over to the Stripe gateway file to check that out. We can see that down here on line 59. All it does is retrieve the coupon over Stripe's API, and then it goes ahead and deletes it. Now let's go back to coupon.py. Now, if Stripe successfully deleted a coupon, it's going to contain a deleted key in the JSON response, so we check for that. If it exists, then we go ahead and delete the coupon locally, and then increment the delete count. Finally, we respond with the total number of coupons that were deleted. So that's everything we need to know about managing coupons in the admin backend. The next lecture will go over both expiring coupons and subscribing with coupons. I'll see you then. In this lecture, we're going to go over how coupons get expired, as well as subscribe with a coupon code. If you haven't done so already, please head over to section 16's folder in your courses folder and open it up in your code editor. Then go ahead and make sure that Docker Compose is running by typing docker-compose --up. Then head over to your editor. Once here, go to the config folder and then open up settings.py. Then jump down to line 33. We have another scheduled task with Celery, which runs every day 1 minute past midnight. Its purpose is to expire old coupons. Let's check out the billing tasks file to see how it's done. Head over to the Snake Eyes folder, Blueprints folder, Billing folder, then open up tasks.py. Then take a look here at line 26. It just calls an expire old coupons method on the coupon model. This pattern is very similar to how we marked old credit cards before. So let's head over to the coupon model by going to the models folder and then opening up coupon.py. Then head over to line 102. If the compare date for the coupon method happens to be none, then we just use today as the comparison date. Then we just query the coupon model, and then we filter out coupons whose redeem by date is less than or equal to the compare date time, and that's going to return a list of coupons that are expired because their redeem date is in the past. Then we just update them by flagging them as invalid, and finally, we commit the changes to the database. So every day this task will run, and it's going to keep our database updated. Now, there is a chance that a coupon will have expired before this task gets a chance to run, but that situation is covered elsewhere, so don't worry. It will be impossible for a user to subscribe with an expired coupon. With that said, let's go over subscribing now with a coupon code. The first thing we'll do is open up our browser. Then from here, go to localhost port 8000/admin/coupons. If you haven't done so already, please go ahead and create a coupon code now, and then copy that code to your clipboard. You can do that by just copying the code and then right-clicking it and going to copy, or whatever it is for your browser. Then head over to your account and go to the settings page. If you've been following along, then chances are you don't have an active subscription. If you do, then go ahead and cancel it now, then come back to this page. At this point, click the Learn More to subscribe. Then pick whatever plan that you want. Now let's go ahead and try entering in a coupon code that you know doesn't exist. Shortly after typing, you should see a warning that says the code wasn't found. Now clear out the field and then paste in the existing coupon code that we just copied. If it also happens to say not found, you may need to trim out a trailing space at the very end for it to register as a valid coupon. This label down here is going to let you know the details of the coupon too. If it happens to not last forever, it'll tell you how long it lasts as well. Now go ahead and fill out whatever you want for the card name. Then for the card number, go ahead and put in all 42s. Then pick whatever you want as the expiration date and use 123 as the CVC. After that, click Process Payment. After a second or so, then redirect yourself to the settings page, and you'll see that now we're subscribed and we used a coupon. Now from here, go ahead and go to the coupon admin page, and we'll see here that the coupon that we picked has one redemption. If more users were subscribed with additional plans, you'd see each of those plans listed there as well. You can also go back to the admin dashboard to see what the billing column looks like when you have some data. If more users were subscribed with additional plans, then you'd see each of those plans listed here as well. It makes it super simple to see which plans are the most popular. Now let's head back over to our editor. Then from here, let's go ahead and open up the main JavaScript file. So go to the static folder, scripts folder, and then open up main.js. Then we'll trace the code to see what happens when you start typing into the coupon code box. For that, jump down to line 232. This listens for the key up event on the coupon text box. Then if the coupon box is empty, we hide the status message and exit because there's no point moving forward. Otherwise, we check the coupon code, which is wrapped in a typewatch function. If we didn't have this typewatch function, then every single time a user presses a key, it would make a request to the Flask server and check if the coupon is valid. The problem with that is, let's say you had a 10-character coupon code. It's going to report that the coupon code is invalid 9 times while the user is typing it. The typewatch function adds a delay so that there's only one lookup, and that's going to happen after a certain amount of delay. We can see here up on line 229 that we have a delay set to 300 milliseconds. So after the user stops typing for 300 milliseconds, then the check coupon code function will be executed. We also have to pass in the CSRF token, which is defined up here on line 230. If you remember back many sections ago, this is why we included it as a meta tag. It allows us to protect the form without actually registering a WT form. It's not too important that you understand how the typewatch function works, but it's implemented up here on line 9 if you're interested. So now let's go ahead and take a look at that check coupon code function, which is down here on line 196. It uses jQuery to make an AJAX request to the Flask server. This is how we're able to refresh the coupon code status message without doing a full page reload. We can see here that it's going to make a post request to the subscription coupon code endpoint. And in this case, the data that we're going to be sending to it is the text box's value for the coupon code. We're also flagging the data type as JSON. Then, before the AJAX request is sent, we're adding the CSRF token to the request and also reset the status message and CSS classes. Lines 207 to 213 handle the case where the function finishes, and then we just output the details about the coupon in the status label. There's a couple of function calls here, such as lines 209 and 210, which format the coupon status depending on what type of coupon it is. Those functions are both defined up here on line 161. There's not much to go over here because they are extremely basic. The discount type function would show you either 30% off or $5 off, depending on if there's a percent or amount off passed in. The discount duration function just lets the user know how long the coupon will last for. Now let's continue on in the check coupon code function by going to line 214. This handles the failure case, which could be anything from the coupon code not existing to there being a problem with the Flask backend. Lastly, this code block starting on line 222 handles all cases where we always show the status label and return the coupon code value. This pattern of sending an AJAX request is very common in the web development world and is heavily documented on jQuery's website if you want to learn more. Now let's jump over to the billing views file to see how it works on the Flask end. For that, head over to the views folder and then open up billing.py. Then scroll down to line 38. First off, this route only accepts post requests. Then it starts by getting the coupon code from the form. This coupon code is the value of the text field because when the form was submitted via AJAX, this form field was sent over in the data attribute. If the code is empty, then we just return a JSON response that the coupon code cannot be processed. The render.json function is a little helper utility that I put together and can be found in the lib folder. So let's go ahead and check that out and then open up utils_json. All it does is use Flask's JSONify function and allows you to easily set a status code with the response. The JSONify function creates a JSON response by setting the correct MIME type and will also convert Python objects into JSON. Now let's head back over to the views file. In case you're curious, 422 is the HTTP status code for an unprocessable entity. If the code is empty, that means we can't process it, thus we return 422. Otherwise, line 46 does a database lookup for the coupon code, and this find by code method can be found in the coupon model. Let's go ahead and check that out now by heading back over to the coupon.py file, then scroll down to line 180. First up, we just uppercase the coupon code, and then filter coupons that are redeemable and match the coupon code passed in. After this query is executed, then it just returns the coupon. Coupon.redeemable is a special hybrid property on the SQL Alchemy model. We haven't covered hybrid properties yet, so let's scroll up to line 52 to check it out. First off, let's go over what a property does. The docstring that I've written out here fully explains it, but the gist of it is it only returns coupons that can be redeemed. In this case, that would be coupons who have no redeem date, in which case the redeem by would be set to none, or coupons whose redeem date is sometime in the future compared to right now. Then finally, we do an AND filter on it if the coupon's valid field is true and it's redeemable. Long story short, this saves us from having to contact Stripe to see if the coupon is valid. Now, as for this thing being a hybrid property, if you happen to be familiar with Ruby on Rails, you can think of hybrid properties as model scopes. They're a way for you to compose filters and they don't get executed until they need to. It's just a way to abstract some of your queries into isolated functions. This will allow you to reuse them in multiple areas of your codebase. Now that we know how that works, let's head back over to the views file. Line 47 checks to see if the coupon was returned. If there is no coupon, then we can be sure that the coupon doesn't exist, in which case we throw in error 404 and set an appropriate error message. Otherwise, the coupon is good to go, so we return a 200, which is a success, and then we convert the coupon to JSON. So let's go ahead and jump over to the coupon model to check that out. Once here, head down to line 208. All this does is create a new dictionary which contains a few fields that we want to send back to the user. In this case, that would be the duration in months, and then either an amount off or percent off. The user doesn't need to know anything else. For instance, we shouldn't just return back the entire coupon because we don't want to give the user access to the ID field and the other fields that aren't necessary to render the form. With that said, that handles displaying whether or not the coupon is valid, but it doesn't go over using the coupon itself, because at this point, we haven't created the subscription yet. Let's go back to the main JavaScript file to deal with that. Then head down to line 251. We went over this in a previous lecture, but now let's deal with line 255, which makes sure that we can't submit the form with an invalid coupon. We can look up that function up here on line 186. It checks the coupon status to see if it's visible, and if it is, then it checks to see if the alert class isn't a success. That means there was an error validating the coupon code, so line 189 selects the field, and then after that we return false. This way the user knows how to deal with the field because they'll have focus into that text box. Otherwise it returns true and things continue on as planned. At this point, the subscription was created with or without a coupon. Let's go to the subscription model now to see what happens when a subscription is created with a coupon. So head over to subscription.py, then jump down to line 66, which is the create method, and then we'll scroll down a little bit more to take a full look at this function. We'll take a look here at line 103, and that handles the case where a coupon does exist. All it does is look up the coupon, which returns back a coupon instance, and then it goes ahead and redeems it. The redeem method is located in the coupon model, so let's take a look at that now. So head over to coupon.py, and then scroll up here to line 194. First up, we just increment the redeem count, and then if the max redemptions happens to be set, and the redeem count exceeds the max redemptions, then we go ahead and mark the coupon as invalid and save it. So that takes care of subscribing with a coupon code, but now let's head back over to our browser. Then once here, go to the account menu and go to settings. Let's see what happens when we try to change plans with an active coupon. We can do that by going to change plan. And since we have a coupon on our subscription already, it presents it to us in the text box. Technically, we don't have to do this because Stripe will automatically carry over coupons to subscription plans, but it hints to the user that when you change plans, the old coupon code will go into effect. It also gives the user the option to provide a new coupon if they happen to have one. So now let's go back to our editor, and then from here, we'll go to the views file. Then let's go down to line 108. All we do here is pass in the coupon code to the update subscription form, and that's going to add the coupon code to the form automatically. Now let's head back over to subscription.py. Then we'll scroll down to line 119. And if you look down a little bit below that, we can see that if there's a coupon, then we just go ahead and attach the coupon to the update method. Then we just go ahead and look up the coupon, and if it's there, we redeem it. And that's all there is to it. You now know everything there is to know about managing and applying coupons to a subscription. I'll see you in the next lecture, where we go over exploring subscriptions in the custom admin. I'll see you then. In this lecture, we're going to go over managing subscriptions in the admin. If you haven't done so already, please head over to Section 16's folder in your Courses folder, and then open it up in your code editor. After that, make sure that Docker Compose is running by typing docker-compose --up. Once you've done that, then head over to your browser. Then once here, go to localhost port 8000/admin. Then from here, go to the user's admin page. Then go ahead and find the user account that you use to create a subscription. Chances are that's going to be the seed user, so that would be dev@local.host. Go ahead and click that user. You'll see now on the right-hand side that there are subscription details to look at. We can quickly see when a user is subscribed. We can view their billing details. We can also see which plan they subscribe for, if they used a coupon or not, as well as checking out some details about their credit card. We can also cancel their subscription on their behalf. So go ahead and cancel your own subscription now by clicking the button. Then just click through here to admin users, and you'll see here that the subscription has been canceled. So now let's see how that was done by heading back over to our editor. Then once here, go to the Snake Eyes folder, Blueprints folder, admin, and then open up views.py. Then scroll down to line 130. This is the route that handles canceling a user's subscription through the admin. The cancel subscription form is empty, so we don't need to check that on camera. Then, if the form happens to be valid, which it is on a post request, then we just do a lookup on the user that we're going to edit, and then if the user exists, then we go ahead and cancel the subscription for the user. We don't need to go into details on how this works because we went over it in a previous lecture. Now, let's head back over to our browser. Then from here, go to the account settings, and you'll see over here that it's really been canceled. Now let's head back over to the user's dashboard. If we go back here to the seed user, or whoever you canceled the account on, you'll see over here that we have a canceled on date. Now let's go back to the user's admin page, and then we'll click one of the users here who isn't an admin. It doesn't matter who you pick. You'll notice here it says the user has never been subscribed. So now let's go ahead and log in as this user. So go ahead and copy their email address here, and then go to Account Logout. Then on the login page, just paste in their email, and make sure that you trim out any leading or trailing spaces. And the password for all the generated accounts is password. So go ahead and type PASSWORD, and then sign in. Then go ahead and sign up. Then go ahead and pick any plan that you want. You can avoid using a coupon for now, just go ahead and pick any name. Then put in the credit card information, pick whatever expiration date you want, and then use 123 as the CVC. After that, process the payment, and then go back to the settings page like so. Then go to the account menu and log out. Once here, log back in as the seed user, And this time the password is going to be dev password in case you forgot. Then once here, go back to the user's admin page, and you should see a nice little green star for whoever you subscribed with. It's also loading in between admins and regular members. That's because this guy isn't an admin, but he's a paid member. Then if you want, you can go ahead and click into them, and we'll see their subscription details over here. Notice in this case, the plan doesn't show any coupon information because we didn't sign up with a coupon. So now let's go ahead and take a look at the updated user Jinja template in the admin blueprint. For that, head over to your editor, and then go to the templates folder for the admin, and then go to admin, user, and then go to _form. Then scroll down to line 61. And this is where most of the changes occurred. There's really nothing to go over here because we've seen everything here in some way or another. Also, the admin views for this page didn't change much too, so there's nothing to go over there as well. However, there was a big change made to how bulk delete works. Previously, we deleted all users in one shot, but now that we're able to cancel a user's subscription, things need to change so that our bulk delete method will cancel their subscription on Stripe before deleting their account. So let's take a look at that now, and we'll start by going to views.py. Then we'll scroll up here to line 107. And this is the user's bulk delete route that we took a look at before. It now looks similar to the bulk delete method that we used on coupons because now it's calling out to a celery task. So let's take a look now at the tasks file for the billing blueprint. So head over to the billing folder and then open up tasks.py. Then scroll down towards the bottom of the file here and we'll see our task here on line 30. It just calls out to a bulk delete method now on the user model. So let's check that out by going to the user folder and then opening up models.py and then scrolling down to line 177. Then we'll just scroll down a bit here so I can fit it all on one screen. In a similar fashion to the bulk delete method for coupons, we pass in a list of IDs and then we do a loop over them. First of all, we look up the user, and if the user is none, then we just skip to the next ID in the list. Then we do a check here to see if a payment ID exists. If it doesn't exist, then we just delete the user on its own. Otherwise, we know that the user has a subscription, so we just go ahead and cancel it for that user, and if that was successful, then we delete the user. After that, we just increment the delete count and then return it. Since this happens in a background task, it doesn't matter if it takes 1 second or 100 seconds to finish. Eventually, all the bulk deleted users will have their subscriptions canceled, and then they'll get deleted. That takes care of managing subscriptions in the admin for now, and the rest of this section will concentrate on keeping track of the billing history. I'll see you in the next lecture where we generate a bunch of fake invoices so that we have something to look at. I'll see you then. In this lecture, we're going to go over generating a bunch of fake invoices. If you haven't done so already, please head over to section 16's folder in your courses folder and then open it up in your code editor. Then make sure that Docker Compose is running by typing docker-compose --up. Once everything is good to go, then go ahead and open up a new tab. Now let's go ahead and add a bunch of invoices, and we can do that by doing docker-compose --exec --website --snake eyes --add --invoices. And once you have all that typed out, hit enter. After a couple seconds, it's going to generate a few hundred random invoices. So now let's check out how that was done by heading to our editor. Then from here, go to the CLI folder, commands folder, and then open up the add command. Then scroll down to line 143. When designing the user billing history templates, it would be really useful to have a bunch of invoices in our database to read from. They don't need to be real, but they just need to exist. So that's what this function is doing. We can assure that every user has fake invoices associated to them by first getting a list of every user as seen on line 150. Then we just loop through each user, and we generate between 1 and 12 random invoice items. The rest of this function just uses Faker and the Python random library to fill out all the fields. But there's really nothing too interesting to look at. In case you're new to Python, you can define a list of items here, and then use Python's random utility to pick a random choice from the list. Other than that, we've seen everything here in previous lectures. With that said, let's head over to the invoice model to take a look at the database fields. So head over to the Snake Eyes folder, Blueprints folder, Billing folder, and then go to Models and open up invoice.py. As expected here, we have an ID primary key, and then we also have a relationship back to the user. This relationship is identical to the other ones that we've seen before. It just points back to the user's ID, and then we have Cascade for onUpdate and delete. Then after that, we just have a bunch of invoice details that Stripe supplies us. These are useful to know as a user because it breaks down all of the payment details. We also store a bit of information about the credit card used for the invoice because there may be a time where a user cancels their subscription, which in turn will delete their credit card from our system. That would be a problem because then we couldn't look up their credit card information for the invoice. This concept of duplicating data across tables is called denormalization, and that just means you're keeping a copy of some data in a different table. A normalized version of this table would have kept a foreign key linking to the credit card entry instead of saving the fields directly into this table. In our case, the denormalized version makes it convenient to retrieve the credit card details along with the invoice regardless of a user's subscription state. Now, let's head over to the user model to see the other side of the relationship. For that, head over to the user folder and then open up models.py. Then scroll down here and we'll take a look at line 36. It's very similar to the other relationships, except this one has useList equals true, which happens to be the default, which is why it's not here. We do this because a user can have many invoices, so it's a list. This way, when we access invoices on a user, we can just type user.invoices, notice the plural, and we'll get a list back of all the user's invoices. Alright, so now that we have plenty of fake invoices to work with, and we know the details about the invoice model, let's move on to the next lecture where we check out the billing history. I'll see you then. In this lecture, we're going to go over the billing details. If you haven't done so already, please head over to section 16's folder in the courses folder, and then open it up in your code editor. After that, make sure that Docker Compose is running by typing docker-compose --up. Then from here, open up your browser. Then go to localhost port 8000/settings. Chances are that you don't have a subscription set up, so go ahead and create one now. Now that we have a subscription, head over to the billing details page. Up here on the first table, we have the upcoming invoice item. The next billing date is when the user is going to get billed. In your case, it should be 14 days past the time that you subscribed because it accounts for the 14-day free trial. If you happen to have subscribed with a coupon, then you'll see the price adjusted for the coupon here as well. The upcoming invoice item is actually calling out to Stripe's API to obtain that information. Then underneath that, we have the billing history. It's going to report back the 12 latest invoice items. It contains everything mentioned in the invoice model from the previous lecture. You can also mouse over the tax to see the amount, and you can mouse over the total to see the currency. There's also a button on the bottom of the page that brings you back to your account settings. Now let's head over to our editor so we can check out the Jinja template. Once here, go to the Snake Eyes folder, Blueprints folder, Billing folder, Templates folder, Billing folder, and then open billing details.html. It's a pretty small template because most of the billing details have been extracted to macros. So let's go ahead and check out the macros by going to the macros folder and then billing.html. Then head over to line 118. There's 3 components to the billing details, and the first one is the subscription details. If the user signed up with a coupon, this shows the user information about the active coupon if it exists. The next component is the upcoming invoice item, which is on line 134. First, we do a check to make sure an invoice item exists. If not, then we just tell them that they're not currently subscribed, so there's nothing to see. Otherwise, we render out this table, and this table contains all the information about the upcoming invoice item. All of these fields are part of Stripe's API. Now let's scroll down to line 168, and this renders the recent billing history from our database. This too renders a table, and then down here it loops through each invoice item. There's really nothing new to go over here, but it's worth looking at line 207. Jinja allows you to write one-line if statements like this, which in my opinion is very easy to read. We're saying here, if there is a tax on the invoice, then we just go ahead and show the tax amount. And since we're here looking at a custom Jinja filter, now's a good time to show you how you can modify Jinja to support custom filters and functions. And for that, head over to the app.py file. Then scroll down to line 114. First up, we're just modifying the Jinja environment to add a new filter, which is format currency. This format currency is being imported at the top of the file, and we went over this function in a previous section. Then in a similar fashion, we're adding a new global function here, which is the current year, which we saw in a previous section as well. This template processors function is also being called up here in our application factory. So now let's head over to the billing views file to check out the route. For that, head over to the views folder up here, and then open up billing.py. Then scroll down to the bottom of the file. And this is the route for the billing details. Since we're interacting with Stripe's API, the route is going to be handled by the Stripe exceptions decorator. The first thing that we do here is look up the billing history for the current user. This is being done through a custom method that I've added to the invoice model. So let's go to the models folder now and open up invoice.py. Then scroll down to line 40. The first thing that we do here is run a filter to make sure that we only show invoices for the user being passed in, and then we order them by date, descending, which is going to put the newest ones on top, and then finally we limit it to 12 to only show the latest 12 entries. Then here on line 53, we just return that list of invoices. Now let's go back to the views file. Next up, if the current user has a subscription, then we call the upcoming method on the invoice model while passing in the payment ID for that user, in which case that's the Stripe customer ID. So now let's go back to the invoice model and check out this upcoming method. We can find that down here on line 135. All it does is call out to Stripe's API and then parse out the invoice items that we're interested in. Let's quickly hop over to the Stripe gateway file to check out this upcoming method on the payment invoice. For that, head over to the gateways folder and then open up the StripeCom file. Then scroll down to line 94. Like most of our other API calls to Stripe, it's pretty straightforward. We're just calling the invoice endpoint and passing in the customer ID. So let's head back over to the invoice model. And now let's take a look here at this parse from API method, which expects you to pass in an invoice item. We're calling parse from API because we're getting this invoice item back from Stripe's API. Let's scroll up here and find out that method, which is over here on line 86. All it does is parse out various invoice fields from whatever Stripe returns back when we ask for the upcoming invoice item. All of these fields are documented on Stripe's website. In our case, this is the only information that we're interested in. Let's head back over to the billing.py file, which is the view file. After we get the upcoming invoice item, we just do a lookup here for an optional coupon. If one happens to not exist, then the coupon will be none, which is fine because our billing macro handles that for us. Otherwise, if there's no active subscription, then both the upcoming and coupon variables are set to none. Finally, we render the template and pass in everything we need to the Jinja template, and that takes care of dealing with billing details. However, there is one more thing I'd like to go over in this lecture, so head back over to your browser. Then once here, go to the admin user section, then go ahead and find your seed user and check out that user. Once here, click the View Billing Details link, and that's going to show a Bootstrap modal dialog which presents the billing details for that user. Everything we just went over before is included here. Part of the reason why the 3 invoice components were put into macros was to allow us to reuse them in the admin. So now let's go back to our editor to check that out. Once here, go to the admin blueprint, and then open up views.py. Then scroll down to line 73, which is the edit user route. Lines 77 through 84 do the same thing we just did in the invoice route, and down here on line 104, it's expected that we pass those into the template. So now let's go to the form template for edit user. For that, head over to the templates folder, admin folder, user folder, and then open up _form.html. Then scroll down to line 63. We can see here that we're including a file _billingdetails.html. We're also passing in the context, and that's going to provide us with all the template variables to this inclusion file. Let's go ahead and check that out now by opening up the billing details file. This file is responsible for providing the Bootstrap modal code. All of this is documented on Bootstrap's website if you want to learn more about how to format a modal dialog box. All we're doing is calling the same 3 macros we did in the billing details template from before. So now let's go back to the form.html file. Lines 74 to 76 show you how you can set up a link to a modal dialog box. Basically, the link and data target need to match the ID field in the modal dialog. There's also another reference to it down here on line 112. This handles the case where a user might not be currently subscribed, but you would still want the ability to look at their old billing history. This functionality was also added to the user settings page. So let's go back to our browser now. Then from here, you can close out this modal dialog and go to your account settings. Then go to cancel subscription and go ahead and cancel it. Once you do that, you should now see this new area that shows previous subscription information. If you click Billing Details, then you'll see what we just saw before in the admin. In this case, we have no upcoming payments because we're not subscribed. And that's going to conclude this lecture on dealing with invoice items. I'll see you in the next lecture where we learn how to set things up so that Stripe can contact your Flask app for push notifications. I'll see you then. In this lecture, we're going to learn how to make the Flask app accessible to the outside world, as well as configure Stripe to contact the Flask app for certain events. First off, let me explain why we need to do this. When a user subscribes to a plan, Stripe will immediately create an invoice item and attempt to charge the user. This initial invoice will likely have no charge because it's still part of the free trial. However, in the future, Stripe will need to keep billing this user a certain amount, and our Flask app needs to know when this happens because that new invoice needs to be saved to our database. Now, we could set up a scheduled task with Celery, which loops through all users and then requests all invoice items for today by contacting Stripe's Invoice API. But that would be extremely inefficient. It would work, but man, that's a super ugly solution. Lucky for us, Stripe has a feature called webhooks. You might be familiar with this term if you've used GitHub before, because they also support webhooks. If not, don't worry. Basically, a webhook allows you to subscribe to a certain event, such as creating an invoice, and then the service you're using will contact your website whenever this event happens. You can think of it as a push notification. All you have to do is tell the service which URL to hit when the event happens, and it will do the rest for you. Then it's on you to do whatever needs to be done when this webhook reaches your server. Stripe has webhooks for dozens of different events, but the one that we're interested in is the invoice created event. Up until now, our app has been running inside of Docker on our local network. For webhooks to work, we need to do something so that the outside world can connect to our site. Lucky for us, there's an awesome tool that we can use to do this. This tool is called ngrok. It's a command line tool that you can run. All you have to do is tell it the IP address and port of a service that you want to make public, and it will create a public web address for you instantly. The tool is completely free and safe to use. It doesn't even require you to sign up anywhere or fiddle with port forwarding in your router. ngrok is also great for sharing projects with your friends because you can run ngrok to make your site public and then they can check it out. Of course, you wouldn't want to do this in production because it depends on your app running on your workstation, but it's perfect for brief demos with friends or clients. It's also perfect for dealing with webhooks, which is why we're using it. With that said, if you haven't done so already, please head over to Section 16's folder in your Courses folder, and then open it up in your code editor. Then go ahead and make sure Docker Compose is running by typing docker-compose --up. Then from here, open up your browser. Then head over to ngrok's website, which is ngrok.com. Once here, go ahead and click the download button, and then download ngrok for your platform. In my case, I'm using Linux, and I already have it installed, so please pause the video now and download it on your own. At this point, you should have ngrok installed, so go ahead and open up a new terminal tab, and you can start ngrok by running ngrok http localhost:8000. Now, if you're using Docker machine, then you're going to have to replace localhost with your Docker machine IP address. Also, if you're on Windows and ngrok doesn't provide a command line, then you may need to run it graphically. In either case, go ahead and run ngrok. Near the middle of the output, you'll see both an HTTP and HTTPS version of your Flask app. Go ahead and copy the HTTP version by selecting it and then going to copy. Then head over to your code editor. Then go ahead and go to the instance folder and open up settings.py. Then make a new line and type out server_name equals ... Then paste in the ngrok URL. Once you've done that, strip out the http://. If you already have a server name here because you're using Docker machine, then go ahead and replace that server name with your ngrok server name. Then go ahead and save the file. After that, head back over to your terminal, go to the first tab, and now just hit Ctrl+C to stop Docker Compose. We're going to need to restart it. So go ahead and type docker-compose --stop, and that's going to make sure everything is stopped. Then just go ahead and do docker-compose --up. Now head back over to your other terminal tab here, and then copy the ngrok address once again. Now head over to your browser, and then just paste in your ngrok address and hit enter. And after about a second, you'll see the Snake Eyes page. Go ahead and hide the debug toolbar, because now we're accessing the page on a different domain, so you have a different cookie. Also, it's worth mentioning, if we didn't put the ngrok address in our config file, then Flask would throw an error 404 when we try to access the ngrok URL. So this takes care of getting your application set up in such a way that it's accessible to the outside world. If you were to share this address with a friend, then they would be able to access Snake Eyes. The next thing that we need to do here is configure Stripe to contact the ngrok URL when the create invoice event happens. To do that, head over to your Stripe dashboard by going to dashboard.stripe.com. Then go to your account settings up here, then head over to the Webhooks tab, then go to Add Endpoints, then head back over to the Snake Eyes tab, copy your ngrok URL, then go back to the Stripe tab, and paste it in. Then after the / here, go ahead and add Stripe _ webhook / event. Then change the mode from live to test, and then go to select events, and scroll down until you find invoice.created. Make sure that you choose invoice.created, not invoice item.created, and once you have all this set up, click Create Endpoint. After that, head back over to the Snake Eyes tab, then go ahead and log in as the seed user. You can do that by logging in with dev@local.host. Then go ahead and enter in the password of dev password and sign in. Then go to subscribe and pick whatever plan that you want. Then fill out whatever you want for the card name. Then for the card number, go ahead and use all 42s. Pick whatever expiration date that you want. Then enter in 123 for the CVC and process payment. Then just redirect yourself back to the settings page. And now head over to the billing details. And you'll see here that a few seconds ago I signed up for the Platinum plan, and that service period is the trial period, which costs $0. Now, if you don't see the invoice item yet on your end, try waiting about 30 seconds and then refresh the page. Stripe doesn't guarantee that webhooks are delivered instantly, and sometimes it does take a minute or so. If it's been a while and you don't see anything, then you might be using the wrong ngrok URL. One downside to the free version of ngrok is that the ngrok URL changes pretty frequently. It's only going to change if you stop the server, so don't worry about it changing on the fly. However, you should double check the ngrok URL in your instance settings file, as well as the webhook in the Stripe dashboard, and make sure that it matches up to the ngrok URL in the ngrok terminal. If it's still not working, then head over to the Stripe dashboard and try sending a test webhook. The event that you want to test would be invoice.created. Then make sure that you choose the March 7th, 2016 API version. Then click Send Test Webhook. You'll notice that I got an error of 422, and that's actually good. Our application has extra protection in place to only process real webhook events. And in this case, the test webhook uses a fake event ID that doesn't really exist, so it fails. If you still don't see it locally and you get an error of 422, then be patient because Stripe didn't send it yet. You could also try canceling your subscription and then trying again. If you get a different error, such as a 404, then something is wrong with the ngrok URL, or you may have typoed the webhook URL endpoints in the Stripe dashboard. So make sure that it's /stripe_webhook/event. If you get an error 500, then something must have happened to the webhook specific code for this section. Please re-download the source code and make sure it matches my copy. Okay, so that's how webhooks work. Now let's see how we're doing it. For that, head over to your editor. Then from here, go to the Snake Eyes folder, Blueprints folder, Billing folder, Views folder, and then open up Stripe_webhook. The webhook for Stripe is a separate blueprint. It also has something new here, which is the CSRF exempt decorator, because by default, Flask WTF will expect all post requests to have a CSRF token. In this case, we need to skip that, and we'll confirm that the webhook is legit using other means. The first two conditions just make sure that we have a proper JSON request, and that it contains at least an ID field, because a Stripe invoice.created event will always have an ID field included. Then we try to retrieve the event directly from Stripe. Let's head over now to the Gateways folder and open up StripeCom to see how this works. It's right here at the top on line 18. The purpose of this function is to protect your application from malicious users trying to send you fake webhook events. You can imagine how big of a disaster it would be if anyone could add invoice items to any of your customers. Stripe is really smart when it comes to webhook events and will save these events on their end before sending them out to you. All we have to do here is look up that event by ID and make sure it exists on Stripe before we use it. So now let's head back over to the Stripe webhook file. Next up, we parse the invoice from the event, and then if successful, we prepare and save the invoice to our database. Let's check out both of those methods now in the invoice model, so head over to the models folder and then open up invoice.py. We'll start with the parse from event method, which is down here on line 56. This method is very similar to the parse from API method, except it's gathering and normalizing all the fields that we want to save to our database. The invoice dictionary contains all the fields that we want to save. Now let's head down to the prepare and save method, which is over here on line 106. First up, we look up the user by their payment ID. Then if it's a valid user and they have a credit card, we grab all their credit card information from that event. After that, we just create a new invoice item locally and save it to our database. So now let's head back over to the Stripe webhook file. If all of that was successful, then we respond with a 200 along with success true. Stripe expects us to return a 200 for a success, otherwise it will keep pushing this event out until it eventually gives up. Over here we capture a few common errors, such as if we can't process the event, then we render an error 422 with the error that occurred. That's why the test webhook was telling us that the event ID didn't exist. Then down here we catch other exceptions and respond with a 200 along with the error. It might feel weird to send a 200 with an error, but that's the only way we can tell Stripe to stop sending this event. If this happens, then we have a serious problem with our backend code, and we want Stripe to stop sending this event to us because we need to fix something on our end. So that takes care of processing webhooks with Stripe. If you're done experimenting with webhooks for now, go ahead and stop ngrok and then revert the server name value in your instance settings file back to its original value. I'll see you in the next lecture where we go over testing the billing blueprint. I'll see you then. In this lecture, we're going to review the new tests that were written for this section. If you haven't done so already, please head over to Section 16's folder in your Courses folder, and then open it up in your code editor. Then make sure that Docker Compose is running by typing docker-compose --up. Then go ahead and open up a new terminal tab, and from here we're going to run our test suite. So go ahead and type docker-compose --exec --website snake eyes --test, and then hit enter. While this runs, let's head over to our editor. Then from here, go to the Snake Eyes folder, Tests folder, and then open up the conf-test.py file. Let's begin by going over a couple of new fixtures that have been added. Once here, scroll down to line 152, and this is a fixture that sets up a few credit cards. It starts by hard-coding a few dates because we want our tests to run in the exact same way, regardless of when we run them. Then it just populates a couple of credit cards and saves them to the database. If we scroll down here, you'll see another new fixture for coupons. It's very similar to the credit card fixture that we just saw above. We just hard-code a couple of dates, add a couple of coupons, and save them to the database. Now let's continue scrolling down here until we see the subscriptions fixture. And this fixture is a little bit longer, but still pretty straightforward. The first thing that we do here is unsubscribe the test user, and then create a new user that's a subscriber. We can see here that their email is going to be subscriber@local.host. We also set them up with a fake payment ID. Then we just create the subscription itself, and we take the subscriber's ID, which is the user ID, and assign it to the subscription's user ID column. Then we just go ahead and create that subscription, and then finally we create a credit card for that subscriber. Now let's take a look here at the last new fixture, which is on line 278. This one is really interesting because this one mocks out any API calls to Stripe. We're able to do this because of the mock library that we installed in this section. That means whenever our test code happens to call the Stripe gateway, this mock library will step in, intercept the call, and instead of calling out to Stripe, it will return back a JSON response of our choosing. Lines 284 to 290 are most of the Stripe gateway calls, and what we're doing here is we're setting a return value of an empty JSON response. Most of our code doesn't actually care what Stripe responds with, we only care if it was successful. However, for the upcoming invoice API call, we do need some mock data to work with. So in this case, I went to Stripe's API documentation and copy-pasted what an invoice JSON response would look like. Then, for example, on line 357, I set a fake subscription ID, which we can see here as sub_000. Lastly, down here on line 366, we're setting things up so that the dummy response gets used. Now that we're aware of the new fixtures, let's review some of the new tests. For that, head over to the billing folder in the tests folder, and we'll start with the tests for the models. We start off here by testing the money library by providing a couple of different values to test against. We want to make sure here that cents become dollars for all positive amounts as well as 0 and negative. Then we test all the credit card expiration related code. There is really not too much to look at here, but I encourage you to look at it on your own later on. Next up, we have tests for generating random coupon codes and also to make sure that coupons get invalidated correctly. Like before, I recommend that you check these out on your own later. Lastly, we have a test to make sure that we can parse an event. The first thing we do is set up a fake event to use. This could technically be a fixture, but since we're only using it in one test, it's not unreasonable to put it here. Then if we scroll down here, we parse the event and make sure that all the values that we care about are properly set. The last test uses our mocked Stripe fixture and makes sure that the upcoming invoice item includes all the fields with their correct values. So now let's head over to the views tests, but basically everything that you see here is code we've gone over before in previous test sections. For example, here we're just logging in, setting up a couple of parameters, setting up a post request to the billing.create endpoint, passing in those parameters, and then making sure that we redirect. Then we're just asserting that we get a 200 and that JavaScript must be enabled. It would be pretty boring if I went over every single function here, so what I recommend is pausing the video now and then going over some of these on your own just to get used to seeing some test code. So that wraps up testing the billing blueprint. Let me just hop back over to my terminal now, and as expected, we have 80 tests now and they all pass. I'll see you in the final lecture of this section where we go over handling refunds and being able to view sales charts. I'll see you then. In this lecture, we're going to quickly go over Stripe's dashboard to see how you can view nifty charts to display sales figures, deal with refunds, and more. But before we get into that, the first thing that we should do here is clean up our Docker mess, since we won't be running anything in this lecture. So if you haven't done so already, please head over to section 16's folder in your courses folder, then make sure that Docker Compose is stopped by running docker-compose stop. Then go ahead and remove your containers by running docker-compose rm -f. Now let's begin by opening up a browser. You actually don't need to follow along here because I'm just going to give you a high-level overview of Stripe's dashboard. I'm also going to be doing this from a different account that was created in this course so that we have some data to look at. All the data that you see here is test data, so I don't mind sharing it. The revenue amounts and customer data is not real. So let's go over the main dashboard first. Stripe gives you a very nice little dashboard to work with for free. You can see your gross volume, successful charges, as well as customers created. Now let's say that a customer wanted a refund. You can do that by going to the payments link up here. Then you can see here a list of all your payments. If you wanted to refund, let's say this one, all you would have to do is click it, and then go to refund payment. Then from here, you could do a full refund or a partial refund where you can choose the amount. Then you would just click refund and you're good to go. I'm going to cancel this for now because I won't be doing a refund on test data. Next up, let's talk about transfers, and for that, you can go over here to the transfers link. And this is where you would see a transfer list of payments made to your bank account. For some reason, Stripe likes to show your bank account even in test mode, so I've blurred out my number. You can also click into a specific transfer and then see some details about it. Lastly, you can scroll back up here and go to the Balance tab, and that's going to show you a full transaction log of incoming and outgoing payments. You also have the option here to export this data, and then Stripe will email it to you. There's a couple of other pages that you might be interested in too, such as the plans and coupons. I'll let you check those out on your own account. Another point of interest is the customers link up here. This is where you can see all of your customers, and if you click into one, then from here, you can see a whole bunch of information about that customer. You can see their email address, what card they're using, any type of payments or subscriptions, as well as any invoices that were sent out. Also down here in the sidebar, the events and webhooks is very cool too. It's a feed that contains everything about your account activity. If you go ahead and click into one, you can see the event in JSON form and even the details about the webhook. This is a great spot to go to if you're encountering webhook failures and need to debug things. Lastly, over here in the sidebar, there is a log section, and that's going to contain the raw API endpoints that you've hit for each event. If you click into one, then you can get the full details. We can even see which API version was used and which client was used to issue the API request. In this case, we're using the Python bindings, which is the Stripe package for Python. So Stripe gives you a lot to look at to help you debug issues and also find out some metrics about your business. I have to admit, Stripe's dashboard is pretty great for figuring out what's happening with your account. The best part about it is, you get it without having to code anything yourself. However, let's say down the line, you pick up a client and they want you to develop a SaaS application for them. If that person isn't very tech savvy like yourself, the Stripe dashboard might be too confusing or overwhelming for them. We've only scratched the surface of Stripe's API, and you could build out your own sales chart and activity logs in your own custom application if you wanted to. In fact, the entire Stripe dashboard that we've been looking at was developed with the very same API that they allow people like you and me to use. The only exception to that is the search functionality, but generally everything else is available. With that said, I'm really happy that you've made it to the end of this section. This was a monster of a section and covered so many things, but now in the end, you are a master of handling reoccurring billing. In case you didn't know, Stripe also supports creating one-time payments in addition to subscriptions. I feel like given what you've learned here, you could easily incorporate one-time payments on your own. Actually, when I first released this course, it was on my own custom platform, and I was selling my course through Stripe. It took about an hour to get everything set up to accept single payments instead of subscriptions. All it really involved doing is accessing different API endpoints on Stripe. I was able to get everything up and running so quickly because a lot of the code that you just learned about was used as a base. I just wanted to throw that out there because this course's material can be a great guide for selling things that aren't subscription-based. In fact, we're going to be covering that in a couple of sections from now. With that said, let's move on to the next section, where we'll develop the Snake Eyes application. I'll see you there. In this section, we're going to go over building the Snake Eyes dice game. First, we'll go over the new libraries that were added to the project, and see how to configure the application's betting settings. After that, we'll do a high-level overview of the betting blueprint. Then we'll explore the bet and user models. Next up, we'll go over how subscribers can gain coins, which is our betting currency. Then we'll cover placing bets on both the front and back end. After that, we'll go over how to generate fake random bets. Then we'll go over a few changes to the custom admin. After that, we'll make sure everything works by going over the test suite. Finally, we'll wrap things up by going over a couple of coding exercises to test your Flask knowledge. I'll see you in the first lecture, where we go over the package changes. See you then. In this lecture, we're going to go over a new package that was added to the requirements.txt file. Please head over to Section 17's folder in your Courses folder, and then open it up in your code editor. Then once here, open up the requirements.txt file. Then scroll to the bottom of the file. The new addition is the Flask limiter extension, and it's going to be used to rate limit certain route endpoints. For example, you wouldn't want someone to be able to hold down the enter key and spam 20 bets in 1 second. So we're going to use this extension to ensure that no one can bet more than 3 times per second. With that said, let's go over configuring a few new settings, and for that, I'll see you in the next lecture. See you then. In this lecture, we're going to go over a few betting-related settings. If you haven't done so already, please head over to Section 17's folder in your Courses folder, and then open it up in your code editor. The first thing that we need to do here is copy over our instance settings file from the previous section. So head back over to Section 16's folder, then go to the instance folder and open up settings.py. Then go ahead and copy all the values and head over to your editor. Then once here, go to the instance folder, settings.py, and overwrite the settings for this section and save the file. So now let's go to the config folder and go to settings.py, and we'll take a look here at the new settings that were added for this section. And then from here, scroll down to about line 53. The first change here is to the Stripe plans. I've added a coins value to each plan. This will be the amount of coins you gain when you subscribe to a plan. So in the case of the bronze plan, you'll gain 110, then for gold, you'll get 600, and finally for platinum, you'll get 1500. Now let's scroll down here to line 97. The dice roll payout setting controls the payout multiplier. For example, if you roll a 2 or a 12, the payout is going to be 36 times because those are the rarest outcomes. If you're going to be rolling 2 dice, there's only one way to roll a 2 or a 12. In the case of a 2, that would be a 1 and a 1, and a 12 would be a 6 and a 6. On the flip side, rolling a 7 is the most common outcome, so the payout is only 6 times. Going by the odds alone, these payout values make the game fair. Since the player is not against the house, there's no reason to rig the game to offer slightly lower payouts than average. The next 3 values configure the rate limiter. It uses Redis to store the rate limits for each user, so we're passing in the Celery broker URL, which contains the Redis connection string. The Flask limiter extension offers 3 different types of rate limiting strategies. In our case, we'll be using the fixed window elastic expiry one, and this one does a good job at protecting you against burst attacks. I've linked to the extension's documentation in case you want to read up on the 3 different rate limiting strategies. The last option sets certain headers in the response. This way, if you wanted to go the extra mile in your user interface, you could build a page to let the user know how many more attempts they can try before being blocked, as well as when they will get unblocked if they were limited. These headers would be more important in a public API situation, where consumers of your API would need to know the details. We'll get more into rate limiting later on in the section. For now, I'll see you in the next lecture, where we get a high-level overview of the betting blueprint. I'll see you then. In this lecture, we're going to go over the betting blueprint. If you haven't done so already, please head over to Section 17's folder in your Courses folder, and then open it up in your code editor. Then head over to your editor. Once here, head over to the Snake Eyes folder, then go to the Blueprints folder, and then open up Bet. We have a Models folder, which contains a few models related to betting, and then we have a Templates folder with a couple of bet templates. Other than that, we have a Decorators, Forms, and Views file. This blueprint is a lot smaller than the billing blueprint, so that's good news. Now that you have a general idea of the betting blueprint, let's take a look at the bet and user models, and for that, I'll see you in the next lecture. See you then. In this lecture, we're going to go over the bet and user models. If you haven't done so already, please head over to Section 17's folder in your Courses folder, and then open it up in your code editor. Let's start by going over the bet model, and for that, head over to the Snake Eyes folder, Blueprints folder, Bet folder, Models folder, and then open up bet.py. First up, we have the primary key, which is the ID. Then we have a relationship here that's pointing back to the users table, and that's because a user is going to be responsible for placing a bet. Then we just have a few fields associated to what a bet consists of. The guess is what the user thought the dice roll would be. Die 1 and 2 are the individual dice rolls, while the roll is the combination of both. Then we have a wagered amount, which is a number of coins wagered, aka the bet. This is a big integer column type because in theory there might be someone who's diehard enough to win more than 2 billion coins, which is about the max value of a regular integer. Next up, we have the payout, which stores the multiplier to determine how much someone should win. This gets multiplied by their bet. And finally, we have the net, which is the net result. This will either be an amount larger than their bet if they win, or a negative value which equals their bet if they lost. There's also quite a few methods on this model, but we'll go over them all as we use them. Now let's head over to the user model by going to the user folder and then opening up models.py. There's been a few minor changes here, and first up we have a list-based relationship back to bets. This is exactly the same type of relationship that we used for invoices. Then down here on line 54, we have a new field under the billing comment, and this one is the previous plan. This will keep track of a user's previous plan and will help us determine if a user is eligible to receive more coins if they decide to upgrade their plan. Then as we look down here, there's 2 new fields for betting. The first one is coins because that's the virtual currency that people will be betting and winning. The other new field is last bet on, which will keep track when a user last placed a bet. Having that value saved could allow you to gain valuable business intelligence in the future. Lastly, if we jump down to the constructor on line 72, we can see that we're giving all new users 100 coins to start with. That means when a user signs up, they will have 100 coins automatically. So that takes care of the model changes in the project to support the concept of coins and betting. I'll see you in the next lecture, where we go over giving subscribers coins. I'll see you then. In this lecture, we're going to go over giving subscribers coins. If you haven't done so already, please head over to Section 17's folder in your Courses folder, and then open it up in your code editor. Then once here, head to the config folder and open up settings.py. There's going to be 4 ways that users of our application can obtain coins. We already went over the first way, and that's during the user sign-up process because all new accounts get credited 100 coins. This will allow users to get a feel for the system without having to commit to a monthly subscription. The second way will be signing up for one of the plans. As we spoke about earlier, people who sign up will get anywhere between 110 and 1500 coins depending on which plan they sign up for. And there's a pattern to these numbers too. The bronze plan costs $1 per month, but bronze subscribers will receive 110 coins per month. If we value our coins at 100 per $1, the bronze plan gives you 10% more coins than what they're worth. The gold plan gives 600, which would be 20% more. And finally, we have the platinum plan, which gives 1500, which is a whopping 50% more. So every single month, a user will be credited that many coins. Let's head over to the subscription model in the billing blueprint to see how this is done. So head over to the Snake Eyes folder, Blueprints folder, then go to the Billing Blueprints, Models, and open up subscription.py. Once here, head down to line 97. There's been a bit of extra logic added here. First off, we're storing the previous plan onto the user. Since this is the first time they are subscribing, we'll attach the current plan as the previous plan. That's because right now we're inside of the create subscription method. Then we'll call a new function called add subscription coins, and we pass in a bunch of values such as the amount of coins the user has, their previous plan, as well as their current plan, and finally if they've canceled their subscription. The result of calling this function will return a new coin amount, and that new amount will be set as the user's coin value. Before looking at that function, let's scroll down here to the update subscription method. We're storing the previous plan before we set the new plan, and then we're also adding subscription coins here too. This will handle a situation where a user upgrades plans. For example, if they buy the gold plan and then upgrade to platinum, it would make sense for them to be credited the difference in coins. Lastly, let's scroll down here to the cancel method, and in this case we store the previous plan upon cancellation. So that's the underlying changes to the subscription model. We didn't have to change anything in the views, because our application is designed pretty well. This is a good example of being able to change your business logic without having to update your view layer. Now let's head over to the coin model so we can see how the add subscription coins function was implemented. For that, head over to the bet folder, then go to models, and open up coin.py. This function looks way longer than it really is because there's a billion comments. I'll let you read them on your own, but just understand that this function protects you from sneaky users trying to cheat coins. For example, if a user signs up for the bronze plan for the first time, you would expect them to get 110 coins. However, during the free trial, if they cancel their plan and then try to sign up again, you wouldn't want them to get an additional 110 coins. If they did, then they could just sit there signing up and canceling plans to cheat the system. This function protects against that situation. Another situation would be a user signing up for a specific plan and then downgrading to a worse plan. You wouldn't want this user to gain additional coins, so it protects against that case as well. Lastly, if a user upgrades to a better plan, then they will be credited the difference in coins for the upgrade. Now, this does allow users to cheat you slightly. For example, if they start at bronze and then upgrade to gold, they will be credited the difference. Now, if they upgrade to platinum, they'll be credited once more. In my opinion, this is an edge case, and I'm pretty sure almost no one will do this, and if they do, it's only a small amount of coins and they won't be able to repeat this pattern again. Well, the code that you're looking at now just implements all that we spoke about, and that takes care of initially supplying users with coins on subscription. But we also want users to gain coins every time they're billed per month. So for that, head over to the billing blueprint and then go to the views folder and open up the Stripe webhook file. Then once here, scroll down to line 30. If the invoice's total is greater than $0, then we get the user's subscription plan and add coins to that user. We need the $0 check because we wouldn't want to credit users for free trial invoices. This is the perfect spot to add coins for a user because we know for sure that they've been billed successfully by Stripe. However, we do need to add coins during the subscription process because otherwise users would have to wait 14 days to get their coins, which is really lame. With that said, let's jump over to the user model to check out the add coins method. So head over to the user folder and then open up models.py. Then scroll down to the bottom of the file. All this method does is add the plan's coins to the user's existing coin count and then saves it. So that wraps up the second way to obtain coins. I'll see you in the next lecture where we go over the third way, which is betting on dice rolls and winning. I'll see you then. In this lecture, we're going to go over placing bets on the site and then reviewing the Jinja template and JavaScript code responsible for placing those bets. If you haven't done so already, please head over to Section 17's folder in your Courses folder and then open it up in your code editor. Then make sure Docker Compose is up and built by running docker-compose space up space --build and then hit enter. This is going to run for a couple of minutes, so I'm going to pause the video now and I'll meet you back when it's done. Now that things are up and running, go ahead and open up a new terminal tab. Since our database schema changed since the previous section, we need to reset and see the database once more. We can do that by typing docker-compose space exec space website space snakeeyes space db space reset space with test db and then hit enter. Then go ahead and press the up arrow once and backspace out everything to the db and replace that with add space all and then hit enter. Once you have all that done, then head over to your browser. Then once here, make sure that you're signed in as the seed user. And once you've done that, head over to the place bet button, which is next to the logo. When we seeded the database, it generated a bunch of random bets for us, which is why we see a whole bunch listed on the right. We'll go over generating fake bets in a later lecture. This recent bet table shows you everything you would expect to see. We can see what you guessed, as well as the roll outcome, how much you wagered, the payout, and what the net result was. This page is also where you'll be able to buy more coins, but that functionality hasn't been added yet in this section, so for now, the Buy Coins button does nothing. The main attraction to this page is the bet form. You can select your guess and then wager an amount of coins. Go ahead and try to wager more coins than you have left. In this case, we have 100 coins, and I'm going to try to wager 500,000. You should have noticed an alert error saying that you can't do that. Also, if you try to enter in a non-number or a negative value and try to place a bet, you'll be blocked by your browser. That's because the input type of the HTML element is a number. Now, let's say that you were a sneaky user trying to break the site. You might be inclined to right-click the element and then go to Inspect Element. Then you would go to the type field and replace number with text and hit enter. And now suddenly your browser won't protect you anymore. but let's go ahead and try to place the bet. You'll see here a new error pops up saying you need to wager at least 1 coin. The form even protects against users trying to hack in a guess that's technically impossible by fiddling with the drop-down value for the guess field. Now that you've seen the validation in action, let's try betting a legit amount. I recommend betting a small amount of coins just so you don't run out quickly. I'll go with a guess of 7 and I'll wager 2. After that, I'll go ahead and click place bet. You'll see that the dice gets rolled and your outcome is alerted below. In my case, I actually rolled a 7 and it says congrats you won, and up here on the right, you can see the 7 there as well, and the payout is 6 times, which will net us 12 coins. We wagered 2 and we won 12, so now we have 112 left. So let me just go ahead and try my luck once more. Uh-oh, it looks like I lost because I rolled an 8. In that case, my net was -2, and now I'm down to 110 coins. Now, if you try to place bets too quickly by pressing that button as fast as you can, you'll see here that it says you've been temporarily rate limited. Our bet form is completely locked down from attackers and cheaters. You'll also notice that various aspects of the page are getting updated without the entire page reloading. That's because we're making AJAX requests back to the server and then are updating components of the page when we get a response. All the validation and dice rolls are happening on the server side, so people can't just edit the JavaScript locally and cheat the system. Before we go into the JavaScript, let me just go ahead and open up my DevTools, and then I'll go to the settings here, and then I will disable JavaScript. When JavaScript is disabled, you'll notice a warning that says we need to enable it to place bets. If you tried to place a bet without JavaScript, then it would just reload the page and it wouldn't work. Now that we know how placing bets looks and feels, let's go over to the Jinja template, and for that, head over to your editor. Then once here, go to the Snake Eyes folder, Blueprints, Bet, Templates, Bet, and then open up placebet.html. And there's actually not much to go over here. We're just rendering the bet form in one column, and then down here in the other column, we're rendering the recent bets. In the case of recent bets, the recent bets value is being sent into the template from the view. We've seen that pattern used before with invoices and the index views in the admin. Now let's head over to the JavaScript file, which handles most of the front-end logic. For that, head over to the static folder, scripts folder, and then open up main.js. If we scroll down here to the very bottom, you'll see that we're calling a bets function here on line 380. Let's go ahead and check that out now. You can find that on line 283. This function is very similar to the coupon detection function that we went over in the billing section. If we jump down here to line 360, we're taking action when the placebet form is submit. In this case, it shows the spinner, disables the submit button, and then it calls the placebet function while passing in the CSRF token, which is defined up here on line 361. Now let's go ahead and scroll up here to line 292. It's pretty long, but the pattern is exactly the same as the coupon detection code that we looked at before. First, we just make a post request, then we're making that request to the bet place endpoint, and in this case for the data field, we're passing in both the guess and wagered fields. That's the bet related information being sent from the client to the server. Then like before, we're just doing the same stuff on before send. Then we can scroll down here to the always promise, which is down here, which just hides the spinner, disables the button, and then shows the outcome. Then we can scroll up a little bit here to take a look at the fail case, where we just set a message saying you're out of coins, you should buy more. And in this case, it's going to take a look at the JSON response and then output that error, or if we happen to be rate limited, then we'll just output that instead. And then down here, we just show the outcome status. Then if we scroll up a little bit more here, we can take a look at the done function, and this is how we update various areas of the page. Line 304 stores the JSON response from calling the placebet endpoint. For this to make sense, let's quickly look at the bet model by heading over to the models folder and then opening up bet.py. Then from here, scroll down to the very bottom of the file, and we'll take a look here at the toJSON method. These are all the values that get returned. As you can see, we have enough information to populate the recent bets table, but we're not leaking out information such as the bet ID or user ID. So now let's go back to the main.js file. And with that said, the parse data variable is going to return all the fields that we just looked at in the bet model. Lines 305 to 307 just set up a couple of initial variables. Then 309 calculates the new amount of coins left and updates the label. This is okay to do on the client side because it's only client-side text. It has nothing to do with what's on the server. Then if the bet was a winner, then we show the congrats icon and message, otherwise they lost, in which case we say a different message, and use a danger class which is going to make it red instead of blue. Lines 319 and 320 are pretty fun. This sets a specific Unicode value based on each dice's roll amount. In this case, it's going to subtract 1 from the dice roll to ensure it lines up to the correct symbol. For this to make sense, check out the wiki page that I'm looking at here. The 268 value that we have in our JavaScript file partially matches the die face 1 value. In the case of the first one, it expects a 0 to be the last digit to show a dice roll of 1. Then in the case of a dice roll of 2, it expects a 1, and so on. That's why we need to subtract 1 from our dice roll value. I've included a link to this page in the notes for this lecture in case you want to check it out on your own. Now let's go back to our editor, and then down here we just show the dice roll. Lines 325 to 331 takes care of creating a recent bet entry for the recent bet table on the right. Then down here we ensure that we only ever show a maximum of 10 bets. The newest bets will load on top while older bets fall off the bottom. Then finally we just show the outcome of the bet. So that takes care of the front end for betting. I'll see you in the next lecture where we go over the back-end views and forms. I'll see you then. In this lecture, we're going to go over the back-end related code to placing bets. If you haven't done so already, please head over to section 17's folder in your courses folder and then open it up in your code editor. Then make sure that Docker Compose is running by typing docker-compose --up. Once you've done that, then head over to your code editor. Then from here, go to the Snake Eyes folder, Blueprints folder, Bet folder, and then open up views.py. If we take a look here at lines 15 through 19, the entire Bet blueprint is protected by a login. We saw this pattern being used before in the admin, except it also included roles to be admin instead of just being logged in. Then if we scroll down a little bit here to line 22, this is our place bet route, and there's 2 new decorators to go over. The first one is coins required, which we can take a look at here in decorators.py. All it does is make sure that the current user has at least 1 coin. Otherwise, it's going to warn them and redirect them back to the settings page. So now let's go back to views.py. The next decorator is provided by the Flask limiter extension, and in our case, we're rate limiting this route at no more than 3 requests per second. Let's go ahead and demonstrate this now by going back to our browser. Let's try to break the limit on the actual place bet page rather than submitting the form. If you're using Windows or Linux, you can just hold down F5 on your browser to rapidly refresh it, so go ahead and try it now. You'll see a custom rate limited error page, and this is being rendered because the Flask limiter extension is returning back an HTTP status code of 429. That's the official status code to return when you're rate limited. So now let's hop back over to our editor, and then let's open up app.py to see how it's done. You can scroll down here to line 192, and in this case, all we had to do was add a 429 error template. If we actually went to the templates folder here, and then went to errors, you'll see that we have a 429.html. Okay, so now let's go back to the bets views file. Then the first thing that we do here is make sure that it's a GET request. If so, we just get the 10 most recent bets, and then render the bet place template. Otherwise, we must be dealing with a post request, so we go ahead and set up the bet form. This could be found in forms.py. All it does is take your guess, which is an integer field, as well as the wagered amount, which also is an integer field. In this case, we have some server-side validation to make sure that we have at least 1 as the wagered amount, and for the guess, it can only be between 2 and 12. So now let's head back over to views.py. Then we just make sure that the form is valid, and if we scroll down a bit here to see the else side of that, if it's not valid, then we just return some JSON here with an error 400, saying you need to wager at least 1 coin. This error shouldn't happen too often, basically only when a user is messing around with their dev tools and trying to break the site. So now let's scroll up here to the top of the good side here when it is valid. The first thing that we do here on lines 35 and 36 are to typecast the guessed and wagered amount into integers. Then we detect here if the wagered amount is greater than the current coins, then the person is trying to bet too much, so we just return a different error. Otherwise, we get the payout, which looks up the payout value from the config settings that we went over before. After that, we just go ahead and roll the dice. And roll is a function that's being imported from the dice model, so let's check that out. You can head over to the models file and then open up dice.py. It's extremely simple, and it just uses the Python random library to roll a 1 to 6. So now let's go back to the views file. Next up, we determine if the bet is a winner or not. We'll take a look at this method in a second, but let's continue onwards first. Then line 47 calculates the payout value, and it expects you to pass in the payout amount as well as if it was a winner or not. Both of those variables are defined up here. Then on line 48, we just calculate the net and pass in everything needed to figure out that value. So now let's head over to the bet model to check out these 3 methods, and that would be isWinner, determine payout, and calculate net. So head over to the models folder and then open up bet.py. And then let's start with line 30, which is the isWinner method. So we just pass in a guess as well as the roll. If the guess equals the roll, then we return true because they're a winner. Otherwise, we return false. I don't know about you, but simple methods like this make me really happy to look at. It's so descriptive, yet so simple. Now let's go ahead and take a look at the next one, which is the determine payout method. That one takes the payout and whether or not the user was a winner. If they happen to win, then we just return the payout that's being sent in, otherwise we return 1. That makes sense, right? Because if you lost, then the payout is going to be the amount that you bet. So if you bet 10 and you lost, then the payout would be 1, which means you're going to lose 10. Now let's go ahead and continue onwards to line 62, where we do a calculation on the net. That expects you to pass in a wagered, a payout, as well as is winner. If they happen to win, then all we do is multiply the wagered amount by the payout and return that as an integer. Otherwise, we just return a negative wagered amount. So now let's head back over to the views file. So now that we have all those variables defined, we can just go ahead and build up the record that's going to be saved as a bet. So we just populate the user ID, which is the current user ID, and all the values that we just spoke about. Then we just go ahead and create the actual bet, and then save and update the user. Let's go ahead and check this out in the bet.py file. We can see that down here on line 79. First, we just save the actual bet to the database, and then we go ahead and update the user's coins by taking the bet's net and adding it to the coins. If the net happens to be a negative, then it's going to subtract coins, because if you add a negative, that's going to do a subtraction. Then all we do here is update the last bet on by taking a time zone aware date time of right now. And lastly, we just save the user record. So that takes care of placing the bet from start to finish. In an earlier lecture, I mentioned there's 4 ways that a user can obtain coins, and winning bets was the 3rd way. The last way they can gain coins is by purchasing them with a credit card, and this would be separate from any subscriptions. That's what we'll handle in the next section, but we're not quite ready for that yet. Instead, I'll see you in the next lecture where we go over generating random bets. I'll see you then. In this lecture, we're going to go over generating random bets. If you haven't done so already, please head over to section 17's folder in your courses folder, and then open it up in your code editor. Then make sure that Docker Compose is running by typing docker-compose --up. Once you've done that, then head back over to your editor. Now go to the CLI folder, commands folder, and then open up the add command. Once here, jump down to line 206. This command is very similar to adding invoices. First, we just get a list of all the users, then we loop through them, and in this case, we're going to be generating between 10 and 20 random bets. Then as we scroll down here, we're just setting up some fake data and rolling some dice. Everything done here has been seen in previous lectures. The code here is also very similar to what we just saw in the views. With that said, let's go ahead and run the command now by heading back over to our terminal. Then from here, open up a new tab, then go ahead and type docker-compose --exec --website --snake eyes --add --bets, and then hit enter. In a second or two, you'll notice a ton of random bets have been added. And I'll see you in the next lecture where we go over viewing the betting history, which is where we'll get to see the bets we just generated. See you then. In this lecture, we're going to go over viewing the betting history. If you haven't done so already, please head over to section 17's folder in your courses folder, and then open it up in your code editor. Then make sure that Docker is running by typing docker-compose --up. Once you've done that, then head over to your browser. Then from here, make sure that you're logged into the seed account and go to localhost port 8000/settings. You'll notice now on the bottom left that there's a new betting section. These settings can be seen in the settings template in the user blueprint, and I'll leave checking that out up to you because it's very minor. More importantly is the betting history link in the betting section, so go ahead and click that now. That will give you a paginated view of all of your bets. It includes more information than the recent betting history on the bet page, but it's basically the same. In this case, it shows the bet date, as well as each individual roll. The full betting history can also be accessed from within the Place Bet page. So head up here to the Place Bet button, and then down here, you'll see the View Full Betting History. So go ahead and click that. And this is the same page that we were just looking at. Now that we know what it looks like, let's go ahead and check out the Ginger template. For that, head over to your editor. Then from here, go to the Snake Eyes folder, Blueprints folder, Bet folder, then go to Templates, Bet, and finally open up history.html. It's very similar to the invoice history page where we just render out a table of bets. That's really all there is to look at here. Let's head over to the views file now to check out the route. So open up views.py. Then scroll down to line 70. All we're doing here is building up a paginated list of bets, and we've seen this before in the admin index pages. In the case of line 74, we only want to show bets for the current user. This is very similar to what we were doing for the invoices page. With that said, I'll see you in the next lecture where a few small adjustments were made to the admin user details. I'll see you then. In this lecture, we're going to go over a couple of betting-related changes to the admin. If you haven't done so already, please head over to Section 17's folder in your Courses folder, and then open it up in your code editor. Then make sure that Docker Compose is running by typing docker-compose --up. After that, open up your browser. Then from here, go to localhost port 8000 /admin/users. Previously, we just had a last seen column here, but now it's been renamed to activity, and it includes both the last seen date as well as the latest bet date. This makes it easy for you to see which users are actively logging in, as well as betting. If you go ahead and click into a specific user, you now have access to the last bet date in the form, as well as have an ability to adjust their coins manually. Let's check out both changes now by heading to our editor. Then from here, go to the Snake Eyes folder, Blueprints folder, Admin, then head over to the Templates folder, go to Admin, go to User, and then open up index.html. Then head down to line 36. That's the change here for the column header. It's now labeled as activity. And then down here you can see the last sign-in and latest bet dates. Now let's take a look at the user form template. So open up the form.html file. The main change was down here on line 46, where I just added a coins field. This new coins field was also added to the form, which means if we go to forms.py and then scroll down here to line 44, we'll see that we have a new coins field. Now let's head over to our browser for a second. The other change here to the admin was in the dashboard page. There's a third column that shows us all of the bet payouts. This is much more useful than just showing winners and losers, because now you can break down each win type. We already know a payout of 1.0 is a loser. However, keep in mind that we artificially set 25% of the random bets to win when we generated them. In other words, what you see here is not an accurate representation of the payout odds. I'll leave looking at these changes to you, because it was nothing other than adding a new dashboard model item to group and count payouts, and then that was hooked up through the dashboard view as well as the dashboard template. With that said, I'll see you in the next lecture where we go over a couple of new tests that were written. I'll see you then. In this lecture, you're going to be exposed to a few coding exercises. All of these exercises are optional homework assignments, and the goal of them is to test your knowledge of Flask and also test you as a web developer. In my opinion, there's no better way to learn than actually getting your hands dirty and do the thing that you're trying to learn. This course has been fairly passive so far. Sure, you've been navigating around the codebase with me and running commands once in a while, but I want you to leave this course as a Flask master, not a code monkey who can just follow exact instructions. So I have 2 homework assignments for you to do. I'll go over them here, but they're also included in written form in this lecture's notes. The first one is to extend the custom admin so that you can see all bets placed. You shouldn't be able to edit or delete bets because they are essentially transactions, but you should be able to view them all in a paginated list. It would also be a good idea to include a search box so you can filter down bets by a user's email address or username. This will double as being a way for you to track down all bets by a specific user in case a dispute arises between you and a customer. Obviously, there won't be a dispute here, but if you ever ship a real-life application, it would be useful to filter data by a specific user. I also recommend that you include a link somewhere in the admin user's details, which links you to the new bets admin page with that user's email or username filled out already. This way you have a shortcut link to access a specific user's bets. The second homework assignment is to create the leaderboard, and this one is going to be quite a bit more challenging. You may even want to finish the rest of the course before trying this one out. That's not because you'll learn new information that's required to finish this assignment, but if you're fairly new to web development, I could see this feature taking quite a few hours to complete. I've written out a basic feature list for both homework assignments in the notes. Remember, while these homework assignments are optional, they do serve a purpose. I didn't come up with them because I was too lazy to implement these features myself. I left them out to help you grow as a web developer because practice makes perfect. Lastly, I would be very interested in seeing your solutions, but please don't publicly distribute the source code of this course on GitHub or anywhere else. This course's material is meant for students who purchase the course, such as yourself. The notes include instructions for submitting your assignments. With that said, congrats on finishing this section. The next section will handle accepting one-time payments with Stripe. I'll see you there. In this lecture, we're going to review some new tests that were written for the section. If you haven't done so already, please head over to Section 17's folder in your Courses folder, and then open it up in your code editor. Then make sure Docker Compose is running by typing docker-compose --up. Then go ahead and open up a new terminal tab, and we'll go ahead and run the test suite by running docker -compose space exec space website space snake eyes space test, and then hit enter. While that runs, let's head back over to our editor. There's been quite a few new tests that were written, so let's head over to the snake eyes folder and then go to the test folder and then open up the bet folder. Let's begin by checking out the model tests. The first test is to test the dice roll. It just makes sure that the dice roll is an integer, then it rolls it 100 times and expects that each roll falls in between 1 and 6. It's kind of a silly test since we're using the Python random library to generate the dice roll, but one main benefit of testing it is to give you free rein on being able to refactor code without having to worry. If down the line you decide to rig the game or use a weighted dice algorithm, then it's useful to have this test to ensure that the rolls fall within range. Next up, we have a couple of coin-related tests. These tests ensure that a user is correctly credited or denied credits when it comes to subscribing to different plans. The last set of tests make sure that we can properly pick winners, determine payouts, and calculate nets. And now let's head over to the views file. There's been just a few tests added here to make sure that betting works. You can go over all this stuff on your own because there's nothing new to go over. So now let's wrap up this lecture by heading back over to our terminal and we'll clean up our mess with Docker. Notice now that we have 95 passing tests. So head over to your first tab here and then stop Docker by pressing Ctrl+C. Then make sure that it's really stopped by typing docker -compose space stop. Then we'll go ahead and do our cleanup by typing docker -compose space rm space -f. And that almost brings us to the end of this section. The final lecture of this section will go over a few coding exercises that you can do as an optional homework assignment. See you then. In this section, we're going to go over processing microtransactions. This will show you how to accept one-time payments. First, we'll go over a few new configuration settings. Then we'll go over both the front and back-end content responsible for handling one-time payments. After that, we'll go over the changes to the billing history page. Then we'll go over new additions and changes to the custom admin. And finally, we'll wrap things up by going over a few new tests. I'll see you in the first lecture where we go over a few new settings. See you then. In this lecture, we're going to go over a few new betting and billing settings. Please head over to Section 18's folder in your Courses folder, and then open it up in your code editor. The first thing that you'll want to do here is go back to your Courses folder, and then go to Section 17. Then open up the Instance folder, and then open up settings.py. Then like before, copy all of your settings, then head back over to your code editor and go to the Instance folder, settings.py, and overwrite all the values. Then go ahead and save the file and close it. Now let's go ahead and take a look at the new settings in the config folder. Then open up settings.py. Once here, scroll down to line 53. The first thing I did was add a new Stripe currency setting, which is now used in all the Stripe plans. We can see them down here on lines 59, 72, and 86. The Stripe currency value is also used when creating a new payment. If we scroll down here a little bit more, you'll see a new setting called Coin Bundles. Our payment form will let users buy a certain amount of coins for a certain amount of money. They're going to be presented with a select box that shows them how many coins they'll get for a certain amount of dollars. This setting controls all of that, so if you wanted to add or remove bundles, you would modify this setting and restart your server. That's all you would have to do. So that takes care of the new settings, and I'll see you in the next lecture where we go over the front end for accepting payments. See you then. In this lecture, we're going to go over accepting payments and then reviewing the Ginger template and JavaScript code responsible for that. If you haven't done so already, please head over to Section 18's folder in your Courses folder and then open it up in your code editor. Then make sure Docker Compose is up and built by running docker -compose space up space -- build, and then hit enter. That's going to run pretty quick this time because there's no new packages to install. Once everything is up and running, then head over to your browser. Then once here, head over to localhost port 8000/settings and make sure that you're logged in as the seed user. Then go ahead and click the Buy More Coins button down here in the bottom left. We're reusing a large portion of the subscription payment form. The only addition here is the select box up top where we can pick how many coins we want to buy. Feel free to pick any amount that you want. I'm going to go with 5,000 for $40. Then just fill out the credit card details as we did before. Pick whatever name that you want. Then for the card details, go ahead and put all 42s. Then pick whatever you want for the expiration date and put 123 for the CVC. Then process the payment. After that, go to the Bet Place page, and we'll see here that we have 5,000 coins added to our account. In your case, it's going to be the amount that you picked. And down here, you can see your coin balance. You can purchase coins from the settings page, which we just did before, but you can also buy more coins from here. All you would have to do is press this button, and here you are, ready to purchase coins. You can buy coins as often as you'd like, and it's not tied into a subscription. You can also use coupons when buying coins to get a discount. Now that we've seen how it all works, let's take a look at the Purchase Coins Jinja template. Then go to the Snake Eyes folder, Blueprints folder, Billing folder, then go to Templates, Billing, and then open up the purchasecoins.html file. This template is fairly small because the entire payment form has been refactored into its own macro. We can see that being included here on line 16. It's also worth noting here that the form tag on line 10 has its own ID now of payment form. Before looking at the macro, let's go ahead and open up the payment method template that we looked at in the billing section. And that can be found inside the payment method.html file. Then scroll down here to line 35. You'll see that it's calling the same macro as the previous template. Line 22 is also using a different form ID. This one used to be called payment form, but now it's been renamed to subscription form. That's because in the purchase coins template, this one is now called payment form. So let's go ahead and check out that macro by going to the macros folder and then open up billing.html. Then hop down to line 224. It just renders the form fields that you should be familiar with. So that's how we're reusing most of the payment form in two different forms. Now let's go ahead and check out the main.js file to see what changed there. So head over to the static folder, scripts folder, and then open up main.js. Then scroll down to the bottom of the file. Notice lines 379 and 380 where we're calling the stripe function twice, but now the function accepts an ID selector. In this case, we want to process both the subscription and payment form with the same bit of JavaScript code. So now let's go back up to line 118. The only thing that changed here is the function now accepts a form ID. That form ID is being used down here on line 122. And all we're doing here is getting a handle on the form. With that said, I'll see you in the next lecture where we go over the Flask-related code to make it all work. See you then. In this lecture, we're going to go over the backend code responsible for accepting payments. If you haven't done so already, please head over to Section 18's folder in your Courses folder, and then check it out in your code editor. Let's begin by heading over to the Snake Eyes folder, Blueprints folder, Billing folder, then go to the Views folder, and open up billing.py. Let's head down to line 207, which is the route for handling purchasing coins. This route only requires that a user is logged in, because we want non-subscribers to be able to purchase coins. The first thing we do here is grab the stripe key like we did with the subscription form, and then we go ahead and pass that into the payment form. This payment form is new, so let's check it out now in forms.py. Then we can just go to the bottom of the file, and here we have the stripe key as well as the bundles, a coupon code, and the actual name on the card. It's nearly identical to the subscription form that's up here on line 23. Previously, this form was called the credit card form, but now it's been renamed to subscription form in this section since we're dealing with two types of payments. Over here on line 46 in the payment form, this is the new field that allows us to select the coin bundles. It uses a custom function called Choices from Coin Bundles to fill up and select the box. This function is defined up here on line 8. All it does is loop through the coin bundles, and then it picks out the coins and the label. The coin amount gets passed back to Flask in the post request, and the label is the human-readable text that explains what you get. Now let's go back to the views file. If the form is legit, then we go ahead and reference the coin bundle setting. We also get the coins from the form, and this is the amount of coins that the user is requesting to buy. Line 217 is a Python generator to loop through the coin bundle setting and return the bundle for the amount of coins. It returns the dictionary that includes the coins, price in cents, and label. Basically, what it's doing here is it's taking the coin amount from the form, and then it's looping through the dictionary, which is the coin bundles, and then returning the bundle that's associated to the coins passed in through the form. Then we double check to ensure that the bundle is not none. Flask WTF will already protect us by throwing a validation error if the user tries to hack in a custom coin amount, because it won't find that coin amount in the coin bundle. But I feel more safe with the extra check here. Then we just create an invoice and pass in everything we need to make the actual invoice item. Then if that was successful, we redirect them to the place bet page because chances are if they're buying coins, they want to play the game. Now let's head over to the billing invoice model to see how this method was created. For that, head over to the models folder and then open up invoice.py. Then scroll down to line 159. Then since there's a lot of comments here, let's go ahead and scroll down a bit more. This method is pretty similar to other methods that call out to Stripe's API. If there's no token passed in, then we know it's going to return false, so we go ahead and do that. Otherwise, on line 181, we create a customer on Stripe. Let's hop over to the Gateways folder to check that out, and then open up StripeCom. Then scroll down a bit here, underneath the customer class, we have a create method on line 23. And if we scroll down a little bit here, we can check that out. This class didn't exist previously, but this create method was under the subscription class before. I've refactored it into its own class because it's technically a customer, not a subscription. It didn't seem like a problem to have it namespaced under subscription until we had to use it to create both a subscription and payment customer. Now let's head back over to the invoice model. Then if there's a coupon for this payment, we go ahead and look the coupon up, and then on the next line, we apply the discount to the amount. We need to do this because Stripe doesn't let you attach a coupon to a one-time payment. Instead, we have to factor the coupon in before sending the final amount to Stripe. Let's head over to the coupon model now to check out the apply discount to method. So we'll head over to coupon.py and then scroll down here to line 208. If the coupon is a fixed amount off, then we simply deduct it from the amount. Otherwise, it must be a percent, so we go ahead and remove the percentage from the base amount and just return the new amount. Then finally, we just convert it to an integer and return the amount because that's going to be in cents. Now let's head back over to the invoice model once again. Now that we know how much to charge, we can call out to our payment gateway to create the charge. And in this case, we're passing in the customer ID, the currency, and the final amount. Let's head back over to the StripeCom file to check this out. If we scroll down a little bit more here, we'll see on line 56 we have the create method to create a charge. As expected, we just call the charge endpoint on Stripe and pass in all the values that we need to pass in. The statement descriptor is hard-coded in here because it's extremely unlikely to change. If you really wanted to put this into the settings file, you could do so on your own. Now let's go back to the invoice model again. Now that we have the charge done on Stripe's side, we'll go ahead and redeem a coupon if it happens to exist, and then we add the coins to the user's account. After that, we need to manually create an invoice item because Stripe charges do not get invoiced automatically. So all we do here is assign a bunch of fields that exist on our invoice model. All this information is taken from what the charge returned here over on line 188. If we scroll back down here, we can see that we're accessing a whole bunch of different fields on the charge. Then finally, once we have all this in place, we just commit everything to the database. At this point, the user's coins have gone up and they've been charged and invoiced. That wraps up this lecture, and I'll see you in the next one where we go over viewing the new invoice history. I'll see you then. In this lecture, we're going to go over viewing payment invoices. If you haven't done so already, please head over to Section 18's folder in your Courses folder, and then open it up in your code editor. Then make sure that Docker Compose is running by typing docker-compose up. Once you have that up and running, then head over to your browser. Then once here, go to localhost port 8000/settings. Then head over to the billing details. There's been a few changes here, but it's still the same billing history as we saw before. However, now it includes individual payments for coins. If you made a payment in a previous lecture to buy coins, you should see at least one entry. In the case of the service period, it's the date of the purchase. The other change is it's no longer the recent billing history. Previously, we only showed the latest 12 entries, which would have been enough to show you a year's worth of invoices, but now it paginates through every invoice item. Let's see how this is done by heading back over to our editor. Then go to the Snake Eyes folder, Blueprints folder, Billing, Views, and then open up billing.py. Then scroll down to line 185. Not too much has changed. The billing details have been upgraded to support pagination. Also, the billing details template hasn't changed that much either. But there was a slight adjustment to the invoices macro, so let's check that out now. We can do that by going to the templates folder, billing folder, macros folder, and then open up billing.html. Then scroll down to line 189. It's been slightly changed here to loop over the paginated results. And if we scroll down a bit here, we'll see that it also outputs the pagination links. These changes are a good example of how you can add useful new features without having to change too much code. By normalizing both subscription and single payments to the same invoice format, that allowed us to reuse what we had to display both payment items. With that said, I'll see you in the next lecture where we go over the new invoices section to the custom admin. I'll see you then. In this lecture, we're going to go over the new additions to the custom admin. If you haven't done so already, please head over to Section 18's folder in your Courses folder, and then open it up in your code editor. Then make sure Docker Compose is running by typing docker-compose --up. Then once it's up, head over to your browser. Then go ahead and visit localhost port 8000/admin, and then make sure that you're logged in as the seed user. Nothing has changed in the dashboard, but there's a new invoices link up top in the navbar, so go ahead and click that. Instead of just seeing a brief billing history for each user, we can now see all invoices across all users. This is important because if we have users creating individual microtransactions, it would be useful to us to be able to see them. You'll also notice that there's no way to delete invoices or even edit them. However, you can click the user that's associated to the invoice to get the details on that user. This page also introduces a new SQL Alchemy pattern, which allows for us to search fields inside of a related record. For example, right now we're looking at invoices that belong to the invoice model, but we can filter invoices by a user's email or username. For example, if we do a search for dev and hit enter, you'll only see invoices for that user. One interesting thing to note here is, if you did the coding exercise from the previous section to add bets to the custom admin, then what you came up with should be pretty similar to the new invoices section. It's basically the same thing, except you're displaying invoices instead of bets. Let's go over one other change here to the user's details page, which you can access by clicking one of the users. Previously, we were using a Bootstrap modal dialog to show the latest billing history, and that worked great when we only showed 12 items. But now we need to show a lot more. So now if you click the View Billing Details, it just forwards you to the dedicated invoice page and automatically searches for that specific user. That's all the changes to the admin, so now let's go to our code editor and see how it's done. For starters, let's go to the Snake Eyes folder, Blueprints folder, Admin folder, then go to Templates, and then go to Admin and open up menu.html. You can see here we've just added invoices to the list. Now let's go to the User folder, and then open up the form.html file. Then scroll down to line 88. Instead of linking to the modal dialog, we're just linking to the invoices page where we pass in the email address as a search parameter to the link. We can do that by just supplying the endpoint that we want to link to, followed by a comma, and then supplying the query string name as well as the value. To make that concrete, let me just hop back over to my browser. Notice how when I mouse over the user, if you direct your eyeballs to the bottom left, you'll see that we're linking to localhost port 8000/admin/users/edit/2. Next up, let's go to the invoice folder and then open up index.html. This template should look familiar to you. Its pattern is very similar to the other index pages, and it's nearly the same as the billing history macro. The only real difference here is we're outputting different fields, such as the user ID. So now let's head over to the admin views file to check this all out. So go ahead and open up views.py. Then scroll to the bottom of the file. It looks about the same as the other index routes. But the main difference is the addition of the join method after the query. In this case, we're joining the user model to the invoice model. This is a relational database concept. If you want to learn more about this, I recommend Googling for SQL Alchemy joins. This is what allows us to gain access to the related user models fields. Everything else is the same except here on line 226. Without joining a second model, we could just access the models fields directly when sorting. But now that we have joined the user model, we have a slight situation. Both the user and invoice model have a created on field, so we need to tell SQL Alchemy that we want to sort on the invoices fields, not the users fields. Lucky for us, that's really easy to do. As you can see here, all we have to do is prefix the sort field by the table name, which in our case is invoices. Next up, I want to quickly go over the search method to see how you can reach in and search on a related field. So head over to the billing folder and then go to the models folder and open up invoice.py. Then scroll down to line 48. It's pretty similar to the other search methods. The key difference is we're accessing the user models fields instead of the invoices fields when setting up the search chain. So it really is as simple as that to search a related field. That takes care of the changes to the custom admin, and since we're talking about administrating your site, I want to take a brief look at the Stripe dashboard to show you one more thing related to one-time payments. So go ahead and check out dashboard.stripe.com. Then go to your account settings here, and then from here go to the Emails tab. You have the option here to get notified by email every time someone makes a payment. You can do that by just checking off the successful payments. You can also optionally email customers for successful payments and refunds. For some use cases, that's really handy, and it saves you the trouble of having to set up the email yourself. Over here, you even have the option to customize the receipts by clicking this link. They don't really allow you to do much, but at least it's something. And that brings us to the end of this lecture. I would feel comfortable moving into production with the amount of information that we have available to us between our custom admin and Stripe's dashboard. I'll see you in the last lecture of this section, where we go over a few new tests. I'll see you then. In this lecture, we're going to review the new tests that were written for this section. If you haven't done so already, please head over to Section 18's folder in your Courses folder, and then open it up in your code editor. Then make sure that Docker Compose is up and running by typing docker-compose --up. Then go ahead and open up a new terminal tab, and we'll execute our test suite by running docker-compose --exec --website --snakeeyes --test, and then hit enter. Then hop back over to your editor, and we'll start by going to snakeeyes. Then we'll go ahead and open up the views tests. Once here, head to the bottom of the file. There's only been one simple admin-related test, which ensures that the invoices index page loads. Now let's go to the billing folder, and then we'll go ahead and open up the billing views tests. Then go to the bottom of the file. This test ensures that the purchase coins page loads correctly and warns people without JavaScript that they need to enable it. Since this doesn't end up testing the invoice create method, we should write a separate test for this, which in this case is located in the models file, so let's go ahead and check that out. Then scroll to the bottom of the file. This uses the mock Stripe fixture because when we create an invoice, it does call out to Stripe's API to make the charge. Down here we want to assert that the user's coins get incremented by the amount we added. Let's wrap up this lecture by looking at the conf test file because a new concept has been introduced. Then head down to line 293. The new concept here is that we need to mock out the Stripe API call to create a customer. To do that, we've done what we did in the past, and that's to include a few mocked out values that the API would have returned. However, the new concept is we need to be able to access them as attributes. To see what I mean, go to the Blueprints folder, then go to Billing, Models, and open up invoice.py. Then scroll down to line 188. We'll see that we're referencing the customer's ID as an attribute, not a JSON field. So we need a way to convert JSON to proper Python attributes. For that, head back over to the conf test file, and then take a look here at the A to D class on line 295. This is a pretty common problem, so Googling for it resulted in a quick answer. If you take a look down here at line 313, we're using the Python JSON library to load in the string representation of the JSON values, which is the customer API variable up here. Notice how it's not just a dictionary, it's actually triple quoted, which makes it a string. The JSON loads function allows you to optionally provide a custom class to decode the JSON values. In our case, we're using a class that will create Python attributes out of each field, so that's how we're doing that. The last thing I want to go over here is at the bottom of the file. This is where we mock out the create_charge API call. There's nothing new to see here, and the mocked out variable can be seen in the charge create API variable. If we hop back over to our terminal, you should see 101 passing tests, and that concludes this section. Let's go ahead and head over to the other tab here and stop Docker Compose. Then we'll do the usual docker-compose --stop. After that, we'll clean up our Docker mess by running docker-compose --rm --f. And at this point, our application is feature complete, and the rest of the course will go over things like how to run database migrations and internationalization, or I-18 for short. Congrats on getting this far, and I'll see you in the next section where we learn how to perform database migrations. I'll see you there. In this section, we're going to go over database migrations. First, we'll go over what a database migration is, and then learn why they're useful. After that, we'll go over the changes to the requirements.txt file. Then we'll go over configuring Alembic, which is the database migration tool that we'll be using. Next up, we'll create our first migration script. Then we'll take a brief sidestep and learn how to use pgadmin3 to explore our database visually. After that, we'll run our first database migration, and then we'll run a second migration to ensure we fully understand how Alembic works. Then we'll go over viewing our migration history, and finally we'll go over how to auto-generate migration changes in the migration script. I'll see you in the first lecture, where we go over what a database migration is. See you then. In this lecture, we're going to go over what a database migration is and why it's essential to use them. Wikipedia describes a database migration as the management of incremental, reversible changes to a relational database. But what does that mean in plain English? Imagine for a moment that you're a few months into the future and you've released your software as a service application to the world. Things are going really well and you have 50 people signed up and have thousands of pieces of data stored in Postgres. After looking at some analytical data, you decided that the next big feature should be adding XYZ. After some time, you code up this new feature, and it required adding a column to your user model and also required adding a new SQL Alchemy model. Up until now, our strategy would have been to completely reset the database and recreate our database from scratch. This works great, except it deletes all your existing data. Obviously, we can no longer use this strategy because losing thousands of pieces of data about your customers is unacceptable. So we need to do something else. This is where database migrations fit in. They're not exclusive to Flask and SQL Alchemy. Other frameworks such as Ruby on Rails support migrations too. We're going to use a SQL Alchemy specific tool that will let us modify our existing database without having to clear out the old data. This tool is going to let us both apply and revert changes. With that said, I'll see you in the next lecture where we go over changes to the requirements.txt file. See you then. In this lecture, we're going to go over a new package that was added to the requirements.txt file. Please head over to section 19's folder in your courses folder and then open it up in your code editor. Then from here, open up requirements.txt. Then head over to line 18, which is under the data and workers section. Alembic is the new package that was added, and it's the official database migration tool for SQL Alchemy. In fact, it was created by the same team who made SQL Alchemy. It is a command line tool that allows us to create and run our database migrations. It is also heavily documented, and since we're using Alembic directly, it will be easy for you to figure out things because you can follow their documentation exactly. I've linked to the main documentation in this lecture's notes. Also, since we're here, head back over to your courses folder and then go to section 18. Then go to the instance folder and open up settings.py. Once here, select all of your settings, then go back to your editor and open up the instance folder. From here, open up settings.py and overwrite all the values. With that said, let's go over configuring Alembic for this project. For that, I'll see you in the next lecture. See you then. In this lecture, we're going to go over configuring Alembic to work with our app. If you haven't done so already, please head over to section 19's folder in your courses folder and then open it up in your code editor. Typically, you would run an Alembic init command to initialize it into your current project. But since I've modified a few of the files that it would have created, I just went ahead and initialized it for us. The first file that we'll look at here is alembic.ini, and it's located in the root of the project. This file is nearly exactly what was generated by Alembic by default. The only change here is on line 5, where we set up a location of where the migrations will be stored. In our case, we want everything migration related to be placed inside of a Snake Eyes folder, and then within that, a migrations folder. We don't need to go over the rest of this file, but if you're curious, all the options are in Alembic's documentation. So now let's head over to that migrations folder, which we can find over here in the Snake Eyes folder. The versions folder is where our custom migrations will be stored. It has a .keep file in it to ensure that this folder exists inside of a Git repo. In case you didn't know, Git will remove empty folders. This folder is empty for now because we haven't created any migrations yet. Next up, let's take a look at the script.py.macro file. When we eventually create a migration in this section, it's going to use this file as a template. Macro is another popular Python templating library, but we don't need to learn too much about it. Just understand that if you're not happy with the default file that Alembic creates for you when you create a new migration, then this is the file that you would edit. In our case, I've made a couple of changes. Since we're in the habit of using time zone aware datetimes, I've went ahead and imported these helpers for you automatically. Not all of your database migrations will need this, but it's a lot easier to delete 2 lines of code than it is to remember writing out these imports. The other small change is I rearranged things so that the imports are included at the top of the file rather than under the initial doc string that you can see over here, and that's going to make Flake8 happy. Other than that, it's basically the same as the default template supplied by Alembic. Lastly, let's take a look here at the env.py file. The main goal of this file is to let Alembic know where our Postgres server is located. We do this by creating an app instance, and then we read in the SQL Alchemy database URI config setting. This setting is used at various points in the script. Another important thing that this file does is configure Alembic in such a way that it can auto-generate migration files for us by comparing the current state of the database to whatever you have defined in your database migration script. We'll see how that works soon enough, but before we get into auto-generating migrations, let's first create one by hand because you'll need to get used to doing this in the end. For that, I'll see you in the next lecture. See you then. In this lecture, we're going to create our first database migration. If you haven't done so already, please head over to Section 19's folder in your Courses folder, and then open it up in your code editor. Then make sure that Docker Compose is up and built by running docker -compose --up --build, and then hit enter. This is going to take a few minutes to run, so I'll meet you back when it's done. Okay, great. Now that things are up and running, let's go ahead and open up a new terminal tab, and now we're going to create a migration revision file with Alembic. Like usual, we'll be running docker compose exec, so let's go ahead and type docker -compose -exec. But now we need to do something slightly different. This will be the first time we're running a Docker command that's going to result in a file being created on our workstation. If you're running Docker natively like me, you're going to have to pass in a user flag to ensure that the files being created are owned by your workstation's user. If you don't add this flag that I'm about to type, then the file would be owned by root. Also, just as a reminder, this only needs to be added if you're running Docker natively. If you're using Docker Machine with OS X or Windows, then you can skip adding this step. So if you need to run this flag, let's go ahead and do it by typing --user double quotes, and within those quotes, go ahead and type $, open parentheses, close parentheses, and then within those parentheses, go ahead and type ID -u. Then go outside of those parentheses and type a colon, $, open parens, close parens, and within those parens, ID -g. And at this point, everyone can follow along. We're going to be doing our exec on the website image, so let's go ahead and type website, and now we need to supply the Alembic command that we're going to run. For that, go ahead and type ALEMBIC revision -m double quotes, and within those quotes, and now we need to describe our migration. In our case, we're going to create a foo table, so let's name it create foo table. We can name this whatever we want, but what you type here will end up being used as part of the file name, so it should be related to what the migration will do. So go ahead and run this file now by pressing enter. And now you should see what I see, except in your case, this hash is going to be different. You can also see over here that the file name is create_foo_table. That matches up to what we wrote over here. You'll also notice here that it's been written out to the migrations versions folder, so let's go ahead and check that out now by heading to our editor. Once here, go to the Snake Eyes folder, migrations folder, versions folder, and then open up the file that we just created. This file has been formatted based on the macro template we went over in the previous lecture. Also, at this point, our database has not yet changed. All we did was create the migration script. There's also a couple of things to note here. The first is, each revision that we generate will have its own unique hash. This is defined up here in the revision ID as well as line 18, where we actually set it to the revision variable. This hash is really important because there's two parts of a database migration. The upgrade is what will happen to your database when we run the Alembic upgrade command. You can think of this as moving forwards. For instance, when we create our foo table, the upgrade part of this file will do everything we need to do so that the table gets created in our database. On the flip side, the downgrade part will revert those changes. In our case, that's going to drop the foo table from the database. Typically, you would always fill out the upgrade part of the migration, while the downgrade is optional. However, you should try to include a downgrade method because if things go wrong with the migration, you can get things back to normal quickly. The revision and down revision IDs are how Alembic keeps track of the ordering, which is why those IDs are important. We'll see how these revision IDs work together very soon. Let's go ahead and create the foo table in the upgrade method now. I've went ahead and prepared the code for us to use in this lecture's notes, so please take a moment now and pause the video, then head over to the notes for this lecture. Then just go ahead and copy over the revision upgrade downgrade code snippets. Once you have them copied to your clipboard, just replace what you see here on lines 24 through 29. Okay, great, so now your migration file should look like mine. In the upgrade method, we're just creating a brand new table called foo's. Remember, it's a good idea to use the plural form for a table name. Then within this table, there's going to be a couple of columns. Most of the syntax should look familiar to you. In all of our models, we have code that looks nearly exactly like this. The only difference is the column names are being passed into the SQL Alchemy column function instead of being assigned to a variable. In our case, we want an ID column, a created on column, an updated on column, and a bar column. Since we're creating this table through Alembic, we need to add these two columns ourselves because our resource mixin won't be used. In the case of the bar column, I've also added an index just to show you how closely things would match your SQL Alchemy model. The downgrade method just deletes the foo's table, so that's straightforward enough. With that said, that takes care of defining the migration script, and the only thing left to do is run it, but before we do that, let's move on to the next lecture, where we look at a tool that will let us take a look at our database visually. See you then. In this lecture, we're going to take a look at a tool that's going to let us check out our database visually. If you haven't done so already, please head over to section 19's folder in your courses folder, and then open it up in your code editor. Then make sure Docker Compose is up and running by typing docker-compose --up. Before running the migration, I just want to let you know about a tool called pgadmin 3. It's free software that works on all major platforms, and it's going to allow you to connect to your Postgres database and interact with it visually. If you've ever used phpMyAdmin before, it's similar to that, except it's a native application rather than a web app. It's not essential that you download this tool, but it's useful to have. I've included download links in this lecture's notes, so please pause the video now and take a minute to download and install it on your own. Then resume the video when you're able to run it. At this point, you should have the application running. If you're on OS X or Windows and it looks slightly different than what you see here, that's okay, but for the most part, things should be about the same. The first thing that you want to do here is go to the plug icon, which is going to allow us to add a new server. Then we just need to fill out a couple of properties here. For the name, let's go ahead and use Snake Eyes. Then for the host, if you're running Docker natively, you can use localhost, otherwise use your Docker machine IP address. You can leave the port, service, and maintenance DB to what you see here. Then for the username, we'll just keep it as Snake Eyes, and for the password, go ahead and enter in dev password unless you changed it on your own. Once you have all that filled out, go ahead and click OK. Then just go ahead and click through this dialog here about saving passwords. Now you should see Snake Eyes over here in the sidebar. Go ahead and click on it, and then expand the tree view. Then go to the database item and expand that. Then go ahead and click Snake Eyes. Then go to the schemas item and expand the public schema, and from here go to tables. And at this point, now you can see all of our tables in the database. There's the bets table, the credit cards, and so on. As expected, our foo's table isn't there because we haven't ran the migration yet. Before we get into that, I just want to take a second here and let you know that you can right-click on any table, and then go to View Data, and then go to View All Rows. Within this window, you can view, edit, and delete specific rows in your database. That's pretty handy to see once in a while in development mode. pgadmin 3 is a pretty handy tool to have at your disposal. With that said, let's go ahead and close out this window, but let's keep pgadmin open because we'll be using it in the next lecture when we run the migration. See you then. In this lecture, we're going to run our first database migration script. If you haven't done so already, please head over to section 19's folder in your courses folder, then open it up in your code editor. Then make sure Docker Compose is running by typing docker-compose --up. After that, go ahead and open up a new terminal tab. Then we can run our migration by typing docker-compose --exec --website --alembic --upgrade --head. The upgrade command is tied into the upgrade method of the migration script, and head is a shortcut to use the latest revision, so go ahead and run that command now by pressing enter. The output that you see here is due to the logger that was pre-configured for you in the alembic.ini file. The last line of output references the revision that was in the migration script. Yours will be different than mine since the hashes won't be the same. The order of operations here is that Alembic first checked to see if an Alembic version table existed in your database. If it didn't exist, then it's going to be created. If it did exist, then Alembic will calculate the path from the current revision to the revision requested. In our case, we used head, which is a shortcut to the latest revision. Finally, it runs the upgrade method and applies those changes to the database. Now let's go ahead and head back over to pgadmin 3. Then once here, go ahead and right-click on the tables entry and go to refresh. You should now see an Alembic version table as well as the foo's table. Go ahead and right-click the Alembic version table and then go to View Data, View All Rows. If you get this message here about editing a table without a primary key, then just click OK. You should see your revision hash here as a database row. And now you can go ahead and close this window. Then if you go over here to the foo's table and expand it, and then go to the columns item, you'll see all the columns that we have here. If we expand the indexes field here, you'll also see that we have our index on bar. Lastly, if you go ahead and right-click on any other table, then go to View Data, View All Rows, you'll see that all of our data is still here. Nothing was deleted. Now, keep in mind that you would still need to go back into your Flask application to add the foo model to your codebase to actually use it. The migration only updates your database schema, not your source code. In a later lecture, we'll learn how to auto-generate migration scripts to help prevent having to duplicate your database schema in 2 spots. That would be in your Flask app as well as the migration script. Before moving on, let's hop back over to our terminal. And now we'll go ahead and run the downgrade migration, and we can do that by pressing the up arrow, then just backspace all the way to the upgrade, and instead of doing an upgrade, we'll do a downgrade, space, -1. Then go ahead and press enter. And that -1 means we're going to roll back 1 revision. We could also choose to downgrade to a specific revision ID, but in this case, if we use the revision ID, it wouldn't do anything. Now let's hop back over to pgadmin. Then we can just go ahead and right-click the tables item and go to refresh. You'll notice now that the foo's table is no longer here, but we do still have an Alembic version table. If we go ahead and explore that table by right-clicking it, then going to View Data, View All Rows, you'll notice now that there's nothing here. From your database's point of view, it's like the previous migration never happened. So now let's go back to our terminal once more and rerun the migration. Go ahead and hit the up arrow twice and then hit enter. It should run successfully, and if you went back to the pgadmin tool on your own, you'd see that the foo's table is back again. You might be wondering what would happen if you ran the upgrade twice without downgrading in between, and that's a good question. Go ahead and hit the up arrow now and try to run it again. This time you'll notice that it didn't apply the migration because Alembic already knows it was already ran. So in the end, it will be a no app, which means nothing happened. With that said, I'll see you in the next lecture where we create and run a second migration. See you then. In this lecture, we're going to create and run a second migration just to get a better feel for how Alembic works. If you haven't done so already, please head over to section 19's folder in your courses folder and then open it up in your code editor. Then make sure Docker Compose is running by typing docker-compose --up. Then once that's going, go ahead and open up a new terminal tab. Then we'll go ahead and write out the command to create a second migration script. Go ahead and type docker-compose --exec and now if you're running Linux natively, go ahead and do the -- user. If not, you can skip this step, --, within those quotes, $ open and close parentheses, within those parentheses, ID --u. Then outside of those parens, do a colon, $ open close parens, and within those parens, do an ID --g. Then space, and at this point, everyone can follow along, website, Alembic, revision, -m, quote, and within those quotes, add, column, to, foos. And this time, instead of creating a new table, we're just going to add a column to an existing table. Once you've done that, go ahead and hit enter. Then head over to your editor. Then once here, go to the Snake Eyes folder, Migrations folder, Versions folder, and this time go ahead and open up the Add Column to Foos file. Not only does this migration script have a revision ID, but it also references the previous revision in 2 spots. The first one is over here in the doc string, and then down here we have it set for the down revision. In both cases, this revision should match your first migration's revision ID, which you can verify by looking at the file name. If you're using Sublime, take a look here at the sidebar, you'll see that 5460 matches the 5460 here, as well as here. Of course, in your case, that's going to be different, but it should match. Anyways, this is how Alembic keeps track of the order for your revisions. Please take a moment now to pause the video so you can copy and paste the upgrade and downgrade snippets from this lecture's notes. Once you have those methods copied to your clipboard, go ahead and select lines 29 through 29 and paste it in. Then save the file. At this point, we're ready to run the migration, and we can do that by heading over to our terminal, and then we can run docker-compose space exec space website space alembic space upgrade space head, and then hit enter. You'll notice now that we just upgraded from the previous revision to the next one. Then if we head over to pgadmin, and we just right-click our tables entry here and go to refresh, then check out the foo's table, and then go to columns, you'll see that we have a new column here called hello_on. Then if we go to the Alembic version entry here and right-click it and go to View Data, View All Rows, you'll see here that we have the latest revision. Now that we have 2 revisions here, you could experiment with downgrading to a specific revision and then upgrading again. I'll leave this for you to do on your own if you want to continue playing with the upgrade and downgrade commands. With that said, I'll see you in the next lecture where we go over viewing the history of our migrations. See you then. In this lecture, we're going to cover viewing the history of your migrations. If you haven't done so already, please head over to section 19's folder in your courses folder and then open it up in your code editor. Then go ahead and make sure Docker Compose is running by typing docker-compose space up. Once that's running, go ahead and open up a new terminal tab. Having the changes applied to our database is great, but it would be nice to be able to see the current migration status of the database. We can do that by running docker-compose space exec space website space alembic space current. Then hit enter. That's going to report back the current revision that matches up to the state of the database. We can also take a closer look at the history by running a different command. Go ahead and press the up arrow, then backspace out the current, and this time run history space -- verbose, and then hit enter. The verbose flag is optional, but it's going to give you more details back. The log is going to show the newest items on top. It's nice because it shows not only the revisions, but which file the revision belongs to. The history command also supports ranges of revision IDs. I recommend checking out the help menu, which you can run by pressing the up arrow, and then go ahead and backspace out verbose, and replace that with help, then hit enter. With that said, that covers the basics of Alembic. You could start applying migrations to your own projects with ease. However, there is one more thing I'd like to go over, and that's auto-generating migration scripts. And for that, I'll see you in the next lecture. See you then. In this lecture, we're going to see how Alembic can help you generate migration scripts automatically. If you haven't done so already, please head over to section 19's folder in your courses folder, and then open it up in your code editor. Then make sure that Docker Compose is up and running by typing docker-compose space up. Once that's good to go, then go ahead and open up a new terminal tab. Before we proceed with this lecture, please make sure that your database has been downgraded to a state where the foo's table does not exist. If you didn't experiment on your own in the previous lecture, you can do that by running docker-compose space exec space website space alembic space downgrade space -2. If you did experiment, that's fine, but you'll need to adjust this command on your own. Once you're happy with the command that you're about to run, then run it. Okay, so at this point we've successfully upgraded and downgraded migration scripts. But in a real-world scenario, you would not only change your database schema, but you would end up going into your Flask code and making the changes in your SQL Alchemy models. That means you would be responsible for adding the changes in 2 separate places. You would first create the migration and make your changes there. Then you'd also make the change in your Flask code. That's a little bit annoying, and lucky for us, the team responsible for Alembic coded in a neat feature that will look at your SQL Alchemy models and then determine the difference between your current database's state and those models. Then it will attempt to generate a migration script for you. It's not perfect, but it will save you a lot of time, so let's practice using it. For that, head back over to your code editor, and then from here go to the Snake Eyes folder, Blueprints folder, User folder, and then open up models.py. Let's imagine for a moment that we wanted to add a new column to the user model. Go ahead and scroll down to line 51. Then select that line and copy it. Then go ahead and add a couple of new lines here and paste it in. Then rename the column from name to foobar and save the file. If you try to access foobar at the moment, you would get an error because it doesn't exist in the database yet. So let's fix that by creating a new migration script. And for that, head over to your terminal. Then from here, run docker-compose space exec space, and if you're running Docker natively, go ahead and type --user space, double quotes, and within those quotes, we'll do a $, open parens, close parens, colon, $, open parens, close parens. Then in the first set of parentheses, go ahead and type ID space -U, and in the second set of parentheses, do ID space -G. Then hit the space here after the quotes, and at this point, everyone can follow along, and we'll run website space alembic space revision space -- auto-generate space -M space quote, and within those quotes, we'll go ahead and type add space foobar space column space to space users, and then hit enter. You'll notice here that we got an error that says the target database is not up to date, and that's Alembic being pretty smart. Right now we're trying to create a migration, but the database is still a little bit too far behind. We can fix that by upgrading to the head version first. Go ahead and hit the up arrow twice, then backspace out to the downgrade, replace that with upgrade, and then type in space head, and then hit enter. That's going to get us up to date, and now we can hit the up arrow twice and rerun that migration script. This time you're going to see a lot of output, and a new file was created at the bottom. Let's go ahead and check that file out now by going back to our editor. Then once here, go to the migrations folder, versions folder, and then go ahead and open up the migration that we just created, which was add foobar column to users. Then go ahead and scroll down here so we can see both the upgrade and downgrade commands. You'll notice now that Alembic created quite a few things for us automatically. It took a look at our SQL alchemy models and came to the conclusion that our user model was missing the foobar field in the database, so it auto-generated both the upgrade and downgrade code for us. It also happened to pick up the foos table here, so let's go ahead and remove those lines, and that would be deleting lines 26, as well as deleting lines 35 through 42. Then we can save the file. Now we just have our changes here to the user model, which was going to add the foobar column as well as an index. We can see here in the downgrade that it's doing the same thing. First it'll delete the index, then it's going to delete the column. It's worth noting here that Alembic's auto-generate is very nice, but it's not quite perfect. It'll certainly save you time in the long run, but I always recommend double-checking everything that it generates. I've linked you to Alembic's documentation in this lecture's notes, and that's going to cover what it does and does not detect automatically. Now let's go back to our terminal and apply this migration. I'm just going to clear my screen here, and then we can just run docker-compose space exec space website space alembic space upgrade space head, and then go ahead and hit enter. And we can see here that our upgrade was ran. Then if you want, head over to pgadmin and refresh your tables. If we go down here to the users table and then expand the columns here, and we scroll down just a little bit, we'll see that we have the new foobar column. Finally, let's go ahead and clean up our mess by going back to our code editor. Then we'll go back to models.py, then we'll just remove the foobar column, and then we'll save the file. After that, we'll go back to our terminal, and we'll hit the up arrow a couple of times here, and then we'll go ahead and do a downgrade -3, and that's going to revert our database back to a state before we started the section. Then we can go back to our code editor. Then from here, we can just select the 3 migration files that we created, right-click them, and delete. We're doing all of this now so we can avoid resetting the database in the next section. The last thing that we need to do is clean up our Docker mess. So let's head over to our terminal. Then we'll go back to the first tab here and kill off Docker Compose. Then we'll do a docker-compose space stop. And like usual, we'll do docker-compose space rm space -f, and then hit enter. And that wraps up this section on database migrations. At this point, you should feel comfortable upgrading, downgrading, and auto-generating migration scripts. You have all the tools you need to apply as many migrations as you want to your own real-world projects. I'll see you in the last section of this course where we go over internationalization. I'll see you there. In this section, we're going to go over internationalization, which is commonly referred to as I-18N. First, we'll go over what I-18N is, which in a nutshell means preparing your application to support multiple languages. After that, we'll go over the changes to the requirements.txt file. Then we'll go over configuring the app to support multiple languages. Next up, we'll go over updating both the user and billing blueprints to support multiple languages. After that, we'll go over how to generate translation files and also go over how to add new languages. And finally, we'll go over a few tests to ensure it all works. I'll see you in the first lecture, where we go over what I-18N is. See you then. In this lecture, we're going to go over what internationalization is. Internationalization is typically defined as designing a product or service in such a way that you can support multiple languages without having to make large changes in your application's code. Internationalization is often referred to as I-18N because there's 18 characters in between the first I and the last N of the word. The goal of I-18N is to be able to output text in a user's native language. You can choose to make every last bit of your application capable of being rendered in one or more languages, or you can choose to enable this feature for select pieces of text. Ultimately, it's up to you to decide if it's worth it or not. In our case, we're going to support multiple languages for the payment form. This will be enough to exercise using the package that we're going to use to enable I-18N, so that in the future, if you decide to support more than one language, you'll be well equipped to do so. With that said, I'll see you in the next lecture, where we go over the changes to the requirements.txt file. I'll see you then. In this lecture, we're going to go over a new package that was added to the requirements.txt file. So please head over to section 20's folder in your courses folder, and then open it up in your code editor. Then once here, open up requirements.txt, then head to the bottom of the file. Flask Babel is the new package that was added, and it's the de facto standard package for dealing with I-18 in Flask applications. It was originally created by the same author who created Flask. Most of the heavy lifting of this package is done by the Babel and PyTZ packages, but we don't need to concern ourselves with that. It exposes and installs everything we need to get I-18 working in our application. So let's move on to the next lecture where we configure it. I'll see you then. In this lecture, we're going to go over configuring the application for I-18N. If you haven't done so already, please head over to section 20's folder in your courses folder, and then open it up in your code editor. Then from here, go back to your courses folder and head over to section 19's folder, then go to the instance folder and open up settings.py. Once here, copy all the values, then head back over to your editor, go to the instance folder, open up settings.py, and replace them here. Then close this file. Now that we have our previous instance settings, let's go ahead and check out the config folder and open up settings.py. Then we'll scroll down here to line 21. First off, we have a new dictionary that includes the languages that we want our application to support. In our case, that's going to be English and Klingon. I'm not cool enough to actually know Klingon, but I translated a few phrases using a web-based translator. In this languages dictionary, the key is the abbreviated language code, and the value is what users will see in the select box when picking a language. The second setting controls the default locale, which in our case is going to be English. This value must match one of the keys in the languages setting. So that's all the configuration settings. I'll see you in the next lecture, where we go over adding I-18 support to the application. See you then. In this lecture, we're going to add support for I-18N to the application. If you haven't done so already, please head over to section 20's folder in your courses folder, and then open it up in your code editor. The first file that we'll take a look at here is the extensions file in the Snake Eyes folder. Since Flask Babel is an extension, we initialize it just like every other extension. So now let's head over to app.py. Then jump down to line 99. You'll see now that we're calling a new locale function inside the application factory. We're also initializing the Babel extension down here on line 117. The locale function can be found over here on line 161. And this function is responsible for selecting the locale so that a visitor of your site can read it in from their language of choice. It first detects if a user is logged in, and if so, it uses the current user's locale setting. This is a new field that was added to the user model, and we'll go over that in the next lecture. Otherwise, if a user is not logged in, it gets a list of supported languages from our config settings, and then it tries to determine the best match by looking at the visitor's HTTP headers to see which language they prefer. This works because most major browsers add these headers to all requests. In either case, this sets the locale for the visitor of the website. Next up, let's take a look at the Babel config file in the root of the project. This configures Babel to look for translation entries in all Python and HTML files. It also enables a few Jinja extensions so that Babel can find the translations in the Jinja templates. The last thing that we'll take a look at for now is the translations folder inside the Snake Eyes folder. This is where all our translations will be stored, and we'll go into that in upcoming lectures. That covers setting up Flask to handle I-18 with Flask Babel. And in the next lecture, we'll go over how the user blueprint changed to support picking a locale as a user. See you then. In this lecture, we're going to go over the updates to the user blueprint to support I18N. If you haven't done so already, please head over to Section 20's folder in your Courses folder, and then open it up in your code editor. Then make sure Docker is up and built by running docker-compose --up --build, and then hit enter. This is going to take a minute or so I'm going to pause the video now, and I'll meet you back when it's done. Also, since our database schema changed since the previous section, we need to reset and see the database again. So let's go ahead and open up a new terminal tab, and then we'll run docker-compose --exec --website --snakeeyes --db --reset --with --test db, and then hit enter. Then hit the up arrow and backspace out the db reset and replace that with add all, and then hit enter. With that out of the way, let's go ahead and open up a browser. Then head over to localhost port 8000/settings and make sure that you're logged in as the seed user. If you take a look here underneath the settings, we have a new settings link to choose from. Go ahead and click that link now. You can now choose between setting your language to English or Klingon. Feel free to choose Klingon for now if you'd like, but you won't see any changes on the site until the next lecture. I just wanted to show you how a user will be able to change their language settings. So now let's head back over to our editor. Then go to the Snakeeyes folder, Blueprints folder, User folder, Templates folder, User folder, and then open up the Update Locale file. It's a very simple one-field form, so there's not much to go over. So now let's head over to the Views file for the user blueprint. Then scroll down to the bottom of the file. This route introduces a new Update Locale form, and it sets the locale to be the current user's locale. This is a new model field that's been added. So let's go to the models file now to check that out. We can see that over here on line 68. All it does is store the shortcode for a specific language which matches up to the key in the language setting. It also defaults to English. Now let's quickly go over to the forms.py file. Then we'll scroll down to the bottom of the file. All we have here is the update locale form, which is a select field that reads in the values from our language settings. If you take a look here at line 77, the language variable is defined up here on line 6. So now let's head back over to views.py. If the form happens to be legit, then we just populate the current user based on the form's data. Then we just save the current user. Then we just do the usual by flashing them that things are looking pretty good, and we redirect them back to the settings page. So that takes care of letting users pick and save their locale, but now we need to update our payment form to use Babel so that it supports multiple languages. That's what we're going to do in the next lecture, and I'll see you then. In this lecture, we're going to go over the updates to the billing blueprint to support multiple languages. If you haven't done so already, please head over to Section 20's folder in your Courses folder, and then open it up in your code editor. Then make sure that Docker Compose is up and running by typing docker-compose --up. Then open up your browser and go to localhost port 8000/settings. Once here, go to Update Language, and then if you haven't done so already, pick and choose Klingon. Then go ahead and create a new subscription. If you have one already, then you can skip following along or try updating or canceling your subscription first. I just want to show you that not only is the payment forms fields in Klingon, but the flash messages are too. You can try that out by picking a name and then filling in your credit card details. Apparently there's no Klingon word for subscribing or awesome, that's why it's in English. To see how all this works, let's head over to our editor. Then we'll first check out the payment methods template in the billing blueprint. So go to the Snakeeyes folder, Blueprints, then go to Billing, Templates, Billing, and then open up the payment method.html. Not too much has changed, but check out line 8. Instead of just outputting the text normally, it's been wrapped into a function call. The underscore function is a convenience function provided by Babel, which allows us to mark certain text to be translated. We have this being done here on line 10, 12, 14, and a couple other places. The text within the quotes is the default English value for that text. If you wanted to add more translations on your own, you would wrap them in the underscore function just like you see here. There's additional steps that you would need to do, but before we get into that, head over to the billing views file. That's going to be located in the views folder and then billing.py. Then take a look here at line 12. This is where we're importing a function from Flask Babel. It allows us to translate Flash messages, and as a convenience, we're going to alias that to underscore. Now let's head to the bottom of the file to see how it's used. For example, if you take a look here at line 235, we're translating the JavaScript warning Flash message. It's been wrapped up in the underscore function. In the case of line 232, we're translating a message that happens to contain a variable. All we had to do was supply the variable as a second argument to the underscore function, and then provide a placeholder in the translation text. We can see here that the variable name is amount, and there's the placeholder. If you were to scroll up on your own, you would notice more translations, but there's nothing new to look at. But now let's go ahead and check out the forms.py file. If we scroll down here, you can take a look and see that the form labels are all being translated with the underscore function. But there is something new going on here, and for that, head back over to the top of the file and take a look at line 1. Previously, in the views file, we were using the getText function, but now we're using lazy underscore getText. The key difference here is that getText can only be used in the context of a request. If you try to use it outside the context of a request, then it will use the default text. In the case of the form fields, we want them to be translated on the fly when they're accessed. That's where lazy getText comes into play, and it will only make the translation when the text is actually used. So that takes care of how you would mark translations in your templates, views, and forms. Now we need to go into how these translations are put to use, because we can't just mark them. In our case, they worked out of the box because I've ran a series of commands for us which generated multiple files in the translations folder. I'll see you in the next lecture, where we go over how to make a primary translation file. See you then. In this lecture, we're going to go over generating the primary messages.pot file. If you haven't done so already, please head over to section 20's folder in your courses folder, and then open it up in your code editor. Then make sure Docker Compose is running by typing docker-compose --up. Once that's up and running, then open up a new terminal tab. And we'll get to this in a second, but for now let's go to our code editor. Then head over to the Snake Eyes folder, Translations folder, and open up messages.pot. This file is the accumulation of every translation mark that was found in all the Python and HTML files. This file was created by running a specific Babel command. Each translation has one or more references to it as a comment. This is useful for tracking down where a translation is being used. The message ID is the English translation, and the message string is empty, which means it's going to use the ID's value by default. If we were to add more translation marks to our project, this file would get out of date, and we would need to run a command to generate a new file. And let's start going into that now by going to the CLI folder, Commands folder, and then we'll open up the Babel command. The first few lines here just set up a couple of paths, and then we have a few commands. But let's go over the extract command because it's the most fundamental out of the 4 commands that we see here. So let's head up over here to line 19. Let's imagine for a moment that we only supported English, but we still marked all of our translations. If you were to change any translation, you would need to run the extract command. This command writes out the messages.pot file that we just looked at. And under the hood, that's going to be running the pybabel extract command. Then we're also passing in the capital F flag, which allows you to pass in the config file that we went over before. We also pass in the K flag, which stands for keywords. We want to extract translations from lazy getText calls, so we need to include it here. Then we finally supply where the file will get written to. As you can see, this pybabel command is pretty long, so that's why we wrapped it up into our own extract command. So let's go ahead and run it now by heading back over to our terminal. Then inside of your second tab, go ahead and run docker-compose -exec space, and now if you're running Docker natively like me, we'll need to supply the user flag, otherwise you don't have to supply it. So let's go ahead and type --user space quote, and within those quotes we'll do $open close parens, $, open close parens, and within the first set of parentheses we'll do ID space -u, and in the second set we'll do an ID space -g. Then outside the quotes we'll do a space website, space snake eyes, space babel, space extract. And once you have that all typed out, hit enter. And that's going to run through all of our files, look for the markings, and then write out a new messages.pot file. Now, since we're dealing with a second language, we need to do additional steps to ensure that it gets updated too. For that, I'll see you in the next lecture. See you then. In this lecture, we're going to go over updating translations for multiple languages. If you haven't done so already, please head over to section 20's folder in your courses folder, and then open it up in your code editor. Then make sure Docker Compose is running by typing docker-compose -up. And once you have that up and running, head back over to your editor. Then once here, go to the CLI folder, Commands folder, and open up the Babel command. Let's say for a moment here that we added more translations and we've ran the extract command to update the messages.pod file. The next step here is to add the new translations to each language's message.po file. We can do that with a single command, and this one is called update, which you can see down here on line 56. The update command expects you to pass in a path to the main messages.pod file and also the translations folder. So let's head over to the Snake Eyes folder, translations folder, KL folder, LC messages folder. So let's go ahead and open up that messages.po file. This file is very similar to the messages.pod file that we looked at in the previous lecture. The only difference is it expects you to fill out each translation for each message. In our case, all the translations are already filled out, but if you had recently added new translations, then you would see a few new entries and they would have an empty message string. Then it would be up to you to fill in those values. So in this case, our message ID is plan, but the Klingon version of that is nab. If we went back over here to the messages.pod file, we can see here that the message ID is plan. So that's how all these values line up. So now let's say that you've added all your translations here to the messages.po file. Now you would head back over to your terminal, and in our case we're going to open up a new tab. And at this point, now we're ready to run the update command. And we can do that by typing docker-compose space exec space, and now you know the drill here. If you're running Docker natively, we'll pass in the user flag, space, quote, then we'll just do $ open close parens, colon, $ open close parens, and within the first set of parens we'll do an ID space -u, and the second set we'll do an ID space -g. Then everyone can follow along, and we'll do a space website, space snake eyes, space babel, space update, and then hit enter. At this point, you're almost done. The last command you need to run will compile the translations into a format that Babel understands. To do that, go ahead and hit the up arrow, and then backspace out the update, and replace that with compile, and then run that command. Notice how the update command wrote out a messages.po file, but the compile command wrote out a messages.mo file. So now let's head back over to our editor. Then we'll go back to the Babel command, and then we'll scroll up here to line 45 and take a look at the compile command. All it does here is call out to PyBabel's compile command, and then it expects you to pass in the translations folder path. So that takes care of updating translations for one or more languages. The last thing we need to go over is adding a brand new language, and for that, I'll see you in the next lecture. See you then. In this lecture, we're going to add a new language together and go through all the commands we talked about in the previous lectures. If you haven't done so already, please head over to Section 20's folder in your Courses folder and open it up in your code editor. Then make sure Docker Compose is running by typing docker-compose space up. Then head over to your editor. Once here, go to the config folder and then open up settings.py. Then scroll down here to line 24. The first thing that we need to do here is add the new language. So let's go ahead and add Spanish to the list. We can do that by just adding a comma here, then we'll indent once and add some quotes, and within those quotes we'll do ES, because that's the two-letter language code for Spanish. Then we'll do colon space quotes, and within those quotes we'll just write out Spanish. Then save the file. Now that we have the language defined, we need to create it with Babel. But before we do that, let's go to the CLI folder, Commands folder, and open up the Babel command. The last command that we need to go over is the init command, and this is what will allow us to create new languages. We can see it over here on line 32. It just calls PyBabel init, and then we're expected to pass in the main messages.pot file, as well as the translations folder and the language code that we want to add. So let's go to our terminal now and run it. In this case, let's open up a new terminal tab, and then we'll do the usual docker-compose space exec space, and if you're running Docker natively, we'll do --user space double quotes, and within those quotes, we'll do $ open close parentheses, colon, $ open close parentheses, and within the first set of parens, we'll do an ID space -u, and within the second set, we'll do an ID space -g. Then outside the quotes, we'll do space website, space snake eyes, space babel, space init, space -- language, space ES. Then once you have all that typed out, hit enter. That's going to generate a new ES folder, which is in our Snake Eyes translations folder, and it's going to generate a messages.po file. This file is now ready for us to step in and start translating each entry ourselves. So for that, let's go to our code editor, and then we'll go to the Snake Eyes folder, translations folder, ES folder, LC messages, and we'll open up messages.po. I don't speak Spanish, and it would be really boring to watch me translate each item with Google on camera, so let's just go down to line 39. And then we'll just make pretend that we know Spanish by setting el name encardo, the name on card. Actually, I remember something about Spanish in high school, like mi amo, something like that. Whatever, we'll just put in that and then save the file. Now we'll just head back over to the terminal, and at this point, all we have to do is compile it, and we can hit the up arrow, then we'll just backspace up to the Babel, and then we'll just run compile, and then hit enter. You'll notice now that it output 2 compiled files. We have one for Spanish, and we have one for Klingon. So now let's go ahead and open up our browser. Then if you haven't done so already, head over to localhost port 8000/settings. Then we'll go to update language, and then in the drop-down box, we'll now see Spanish. So let's pick that and save it. Then from here, we'll just go to update payment info, and if you don't have a subscription, just go ahead and create a new subscription. And as expected, we would see el name encardo. And that's all there is to it for adding new languages. Assuming you have a couple of languages defined and you're actively developing your application, then a common workflow would be to extract, update, and compile. That wraps up dealing with I-18 and Flask. I'll see you in the final lecture of this section, where we go over a new test. See you then. In this lecture, we're going to review the new tests that were written for this section. If you haven't done so already, please head over to Section 20's folder in your Courses folder, and then open it up in your code editor. Then make sure Docker Compose is running by typing docker-compose --up. Then open up a new terminal tab. Then we'll just run the test suite by doing docker-compose --exec --website --snake-eyes --test. And once you have that typed out, hit enter. And while that runs, let's go back to our code editor. And from here, we'll go to the snake eyes folder, tests folder, user folder, and then we'll go to the views tests. Then jump down here to line 303. There's been 3 additional tests, and they're all straightforward. They just ensure that the update locale form works, and that if you attempt to access the payment form in Klingon, that you're going to see Klingon text. Now let's hop back over to our terminal to see our test results. And we can see here that we have 104 tests, and they're all passing. Let's go ahead and jump over to the first terminal tab and kill Docker Compose. Then we'll do the usual docker-compose --stop. Then we'll clean up our mess by doing docker-compose --rm --f. And that brings us to the end of the main course. Congrats on getting this far, and you should be really proud of yourself for making your way through the whole course. You're now a Flask master and are ready to expand your knowledge to other fields related to web development, such as how to deploy your application to production and more. The next section of this course will give you tips on where to go next and also informs you on how to share this course if you enjoyed it. I'll see you there.